everyone and welcome to the MLOps full course. This course gives you a clear and practical introduction to MLOps, the bridge between machine learning and DevOps. You will learn how machine learning models are built, deployed, monitored and continuously improved in real-world production environments. From managing data and models to ensuring scalability, reliability and collaboration across teams, this course helps you understand how successful AI systems are maintained end-to-end. Whether you're new to MLOps or looking to strengthen your foundation, this course prepares you to work confidently with production-grade machine learning workflows. So before we begin, please like, share and subscribe to Edureka's YouTube channel and hit the bell icon to stay updated on the latest tech content from Edureka. Also, check out Edureka's MLOps certification training course. It provides a well-rounded introduction to MLOps with a strong focus on deploying, managing, and scaling machine learning models in real-world production environments. The course covers the complete ML lifecycle, from data preparation and model development to deployment, monitoring, and retraining. You will gain hands-on experience with modern MLOps and agentic tools such as LangChain, Crew AI, AutoGen, and Retrieval Augmented Generation, along with core technologies like MLflow, Docker, Kubernetes, and major cloud platforms. Check out the course link given in the description box below. Now, let us get started by understanding what MLOps is. MLOps, short for Machine Learning Operations, is the practice of combining collaboration, automation, and best practices to streamline the lifecycle of machine learning models from development to deployment and maintenance in production environments. It bridges the gap between data science and operational teams, ensuring that ML models are reproducible, scalable, and reliable in real-world use cases. Now that we understand what MLOps is, let's dive deeper to explore its relationship with DevOps. Well, DevOps focuses on the development and deployment of software applications, emphasizing continuous integration, continuous delivery, and infrastructure management. Whereas MLOps extends these principles to machine learning systems, addressing unique challenges such as handling large and evolving datasets, managing model drift and data drift, and ensuring reproducibility in training and inference. However, similar to DevOps, MLOps emphasizes several key principles that streamline machine learning workflows. Automation plays a central role, enabling the automation of tasks such as data pre-processing, model training, testing, and deployment to improve efficiency and consistency. And the collaboration fosters teamwork among data scientists, machine learning engineers, and IT professionals, ensuring alignment across roles for successful project execution. Additionally, MLOps supports continuous processes such as continuous training, testing, and monitoring of ML models to maintain their performance and adaptability over time in dynamic production environments. This alignment enhances the scalability and reliability of ML solutions. Now, with an understanding of how MLOps relates to DevOps, let's see how it is driving the scaling of AI solutions. First, we have the producibility. It ensures that models can be retrained and evaluated consistently even with changing datasets. Next, efficiency. Speeds up the transitions from experimentations to deployment with automation. Then, scalability, which handles the complexity of deploying models to production across diverse environments such as cloud, edge, etc. Next, reliability, which monitors and updates models to maintain performance over time, reducing the risk of model degradations. And finally, the compliance, which ensures traceability and accountability for ethical AI and regulatory standards. And by adopting MLOps, organizations can confidently scale AI initiatives, making ML models operationally viable and impactful in solving real-world problems. Now, having learned how MLOps is scalable AI solutions, let's explore why MLOps have become essential. Well, MLOps is crucial for overcoming several challenges inherent in traditional machine learning workflows. It addresses issues like data drift, where data used in production differs from the training data, leading to degraded model performance. Additionally, MLOps resolves the lack of reproducibility and version control, which often hinders the ability to trace back model experiments and configurations. Furthermore, MLOps tackles the deployment bottlenecks such as long delays and manual errors during model deployment. By automating tasks like model training, testing, and deployment, MLOps ensures scalability, reliability, and efficiency, allowing models to continuously evolve and remain effective over time, thus improving the robustness of machine learning systems across different environments and use cases. Now that we know why MLOps is needed, so let's examine the challenges in traditional ML workflows. Over time, production data might diverge significantly from the training data, leading to data drift, or the relationships between variables may evolve, causing concept drift. And these changes can degrade model performance, and without MLOps, detecting and addressing such drifts becomes challenging, resulting in inaccurate predictions. Additionally, machine learning experiments often involve frequent updates to datasets, code, and hyperparameters. And without version control, reproducing results or tracking specific configurations becomes difficult, creating inefficiency and risk, especially in collaborative environments. Lastly, transitioning a model from development to production requires multiple steps, such as scaling, system integration, and latency optimization. Well, the traditional workflow lack automation, leading to deployment delays, errors, and a high risk of production failures. MLOps addresses these issues by streamlining processes and improving reliability. Having identified the challenges, let's see how MLOps addresses them by looking at its benefits. MLOps brings several key benefits to machine learning systems, ensuring they are robust, efficient, and scalable. It facilitates scalability by enabling model deployment across diverse environments like cloud, edge, or on-premises systems, with automated pipelines that efficiently manage large datasets and user demands. Reliability is enhanced through continuous monitoring, which detects issues such as data drift and concept drift early, ensuring consistent model performance. Automated workflows minimize human error and the dependability of ML systems in production. Moreover, MLOps streamlines repetitive tasks like data preprocessing, model training, and deployment through CI/CD pipelines and orchestration tools. And this automation frees data scientists and engineers to focus on innovation, accelerating the ML lifecycle, and maximizing the value of AI investments. Now, with a clear understanding of the benefits of MLOps, let's explore its key components. MLOps consists of several key components that ensures the smooth lifecycle management of machine learning systems. Model development involves data preprocessing, feature engineering, model training, and evaluation using tools like Jupyter, TensorFlow, and PyTorch. Model deployment focuses on pushing models into production environments such as batch processing, all-in inference, or edge computing, leveraging tools like Docker, Kubernetes, Flask, and Fast API. Next, model monitoring ensures continuous performance assessment by tracking metrics like accuracy, latency, and data drift, supported by tools like Prometheus and Grafana. Continuous integration and continuous deployment automates testing, integration, and delivery pipelines for models. Next, data versioning and management track dataset changes to maintain reproducibility with tools like DVC and Delta Lake. Lastly, experiment tracking logs experiments to compare model performance utilizing tools such as MLflow and weights and biases. Together, these components streamline the development, deployment, and maintenance of ML systems. Since MLOps involves various aspects, let's learn about MLOps lifecycle. MLOps lifecycle consists of several critical steps that ensures the effective management of machine learning models in production. Here we have data preparation, which involves collecting, cleaning, and versioning data to ensure consistency and reproducibility. Next, model training and validation includes conducting experiments, fine-tuning hyperparameters, and selecting the best performing model. And once the model is finalized, model packaging takes place, where the model is wrapped into a deployable format using tools and frameworks suited for the target environment. Then, the deployment follows, where the packaged model is integrated into production systems, whether on-premises, cloud, or edge platform. And finally, monitoring and feedback ensures continuous observation of the model's performance in production by tracking metrics like accuracy and latency, while feedback loops allow for iterative improvements to maintain performance and relevance. And this lifecycle ensures a streamlined and efficient ML workflow. Now that we know the core aspects of MLOps, so let's discuss what you need to learn to build a career in MLOps. A wide array of tools and frameworks supports the implementation of MLOps workflows. For pipeline orchestrations, tools like Kubeflow and Apache Airflow help automate and streamline the end-to-end processes of ML workflows. For CI/CD, platforms such as Jenkins and GitHub Actions enable automated testing, integration, and deployment pipelines to ensure smooth transitions from development to production. And for model serving, frameworks like TensorFlow Serving and TouchServe provides robust solutions for deploying and serving machine learning models at scale. Finally, for monitoring, tools like Evidently AI and Prometheus are commonly used to track performance metrics, detect data drift, and ensures that deployed models maintain their accuracy and reliability in production environments. These tools collectively enhance efficiency, scalability, and reliability in the MLOps ecosystem. Now that we have covered the tools and frameworks of MLOps, let's explore its real-world applications. MLOps is widely applied across industries to enable efficient deployment and management of machine learning models. In finance, it supports fraud detection system by continuously monitoring and updating models to detect abnormal transactions. And in e-commerce, MLOps drives recommendation systems, ensuring they adapt to changing user behavior and preferences by managing data pipelines and model updates. In manufacturing, MLOps enable predictive maintenance by processing sensor data in real time and retraining models to predict equipment failures, thereby reducing downtime and improving efficiency. These applications demonstrate how MLOps ensures reliability, scalability, and adaptability in critical machine learning systems. Now, with a solid understanding of MLOps, let's dive into the challenges it faces. MLOps faces several challenges in effectively managing machine learning workflows, such as data drift and concept drift can degrade model performance over time as data patterns evolve, requiring constant monitoring and updates. Next, managing large-scale data and models poses technical challenges such as ensuring efficient storage, processing, and deployment. Integrating MLOps practices with existing DevOps workflows can be complex, as it requires aligning ML-specific needs with traditional software engineering practices. Additionally, staying compliant with regulatory and ethical standards is critical, especially when working with sensitive data, necessitating robust governance and documentation processes to maintain trust and accountability. Now, addressing the challenges in MLOps sets the stage for exploring how emerging trends and innovation are shaping its future, driving more efficient, transparent, and scalable machine learning solutions. Now, let us discuss the future of MLOps. The future of MLOps is poised for transformative advancements driven by emerging trends. AutoML and no-code MLOps are making it easier for organizations to adapt and scale machine learning by enabling non-technical users to build and manage models efficiently. The integration of explainable AI into MLOps workflow ensures the transparency and accountability, addressing critical concerns around bias and trust in AI systems. Furthermore, the incorporation of generative AI is automating various MLOps processes such as feature engineering, pipeline automation, and anomaly detection, accelerating workflows and enhancing model performance. These trends are reshaping MLOps, making it more accessible, reliable, and aligned with future AI demands.
As you know, we are living in a world of humans and machines. The humans have been evolving and learning from the past experience since millions of years. On the other hand, the era of machines and robots have just begun. In today's world, these machines or the robots are like they need to be programmed before they actually follow your instructions. But what if the machines started to learn on their own? And this is where machine learning comes into picture. Machine learning is the core of many futuristic technological advancement in our world. Today you can see various examples or implementation of machine learning around us, such as Tesla's self-driving car, Apple Siri, Sophia AI robot, and many more are there. So what exactly is machine learning? Well, machine learning is a subfield of artificial intelligence that focuses on the design of systems that can learn from and make decisions and predictions based on the experience, which is data in the case of machines. Machine learning enables computer to act and make data-driven decisions rather than being explicitly programmed to carry out a certain task. These programs are designed to learn and improve over time when exposed to new data. Let's move on and discuss one of the biggest confusion of the people in the world. They think that all the three of them, the AI, the machine learning, and the deep learning, all are same. You know what? They are wrong. Let me clarify things for you. Artificial intelligence is a broader concept of machines being able to carry out tasks in a smarter way. It covers anything which enables the computer to behave like humans. Think of a famous Turing test to determine whether a computer is capable of thinking like a human being or not. If you're talking to Siri on your phone and you get an answer, you're already very close to it. So this was about the artificial intelligence. Now coming to the machine learning part. So as I already said, machine learning is a subset or a current application of AI. It is based on the idea that we should be able to give machine the access to data and let them learn from themselves. It's a subset of artificial intelligence that deals with the extraction of pattern from dataset. This means that the machine can not only find the rules for optimal behavior, but also can adapt to the changes in the world. Many of the algorithms involved have been known for decades, centuries even. Thanks to the advances in the computer science and parallel computing, they can now scale up to massive data volumes. So this was about the machine learning part. Now coming over to deep learning. Deep learning is a subset of machine learning where similar machine learning algorithms are used to train deep neural networks so as to achieve better accuracy in those cases where former was not performing up to the mark. Right. I hope now you understood that machine learning, AI, and deep learning, all three are different. Okay, moving on ahead. Let's see in general how a machine learning works. One of the approaches is where the machine learning algorithm is trained using a labeled or unlabeled training dataset to produce a model. New input data is introduced to the machine learning algorithm and it makes prediction based on the model. The prediction is evaluated for accuracy, and if the accuracy is acceptable, the machine learning algorithm is deployed. Now, if the accuracy is not acceptable, the machine learning algorithm is trained again and again with an augmented training dataset. This was just a high-level example, as there are many more factors and other steps involved in it. Now let's move on and subcategorize the machine learning into three different types: the supervised learning, unsupervised learning, and reinforcement learning. And let's see what each of them are, how they work, and how each of them is used in the field of banking, healthcare, retail, and other domains. Don't worry, I'll make sure that I use enough examples and implementation of all three of them to give you a proper understanding of it. So starting with supervised learning. What is it? So let's see a mathematical definition of supervised learning. Supervised learning is where you have input variables x and an output variable y. And you use an algorithm to learn the mapping function from the input to the output. That is y equal fx. The goal is to approximate the mapping function so well that whenever you have attributes of a training dataset can be of any kind of data. It can be a pixel of image, it can be a value of a database row, or it can even be an audio frequency histogram, right? For each input instance, an expected output value is associated. The value can be discrete, representing a category, or can be a real or continuous value. In either case, the algorithm learns the input pattern that generates the expected output. Now, once the algorithm is trained, it can be used to predict the correct output of a never seen input. You can see an image on your screen, right? In this image, you can see that we are feeding raw inputs as image of apple to the algorithm. As a part of the algorithm, we have a supervisor who keeps on correcting the machine or who keeps on training the machine. It keeps on telling him that yes, it is an apple and no, it is not an apple. Things like that. So this process keeps on repeating until we get a final trained model. Once the model is ready, it can easily predict the correct output of a never seen input. In this slide, you can see that we are giving an image of a green apple to the machine, and the machine can easily identify it as yes, it is an apple and it is giving the correct result, right? Let me make things more clearer to you. Let's discuss another example of it. So in this slide, the image shows an example of a supervised learning process used to produce a model which is capable of recognizing the ducks in the image. The training dataset is composed of labeled picture of ducks and non-ducks. The result of supervised learning process is a predictive model which is capable of associating a label duck or not duck to the new image presented to the model. Now once trained, the resulting predictive model can be deployed to the production environment. You can say a mobile app for example. Once deployed, it is ready to recognize the new pictures. Right. Now you might be wondering why this category of machine learning is named as supervised learning. Well, it is called as supervised learning because the process of an algorithm learning from the training dataset can be thought of as a teacher supervising the learning process. We know the correct answers. The algorithm iteratively makes while predicting on the training data and is corrected by the teacher. The learning stops when the algorithm achieves an acceptable level of performance. Now let's move on and see some of the popular supervised learning algorithm. So we have linear regression, random forest, and support vector machines. These are just for your information. We'll discuss about these algorithms in our next video. Now let's see some of the popular use cases of supervised learning. So we have Cortana. Cortana or any other speech automation in your mobile phone trains using your voice. And once trained, it starts working based on that training. This is an application of supervised learning. Suppose you are telling, okay, Google, call Sam, or you say, hey Siri, call Sam. You get an answer to it, and the action is performed, and automatically a call goes to Sam. So these are just an example of supervised learning. Next comes the weather app. Based on some of the prior knowledge, like when it is sunny, the temperature is higher. When it is cloudy, humidity is higher. Any kind of that, they predict the parameters for a given time. So this is also an example of supervised learning, as we are feeding the data to the machine and telling that whenever it is sunny, the temperature should be higher. Whenever it is cloudy, the humidity should be higher. So it's an example of supervised learning. Another example is biometric attendance, where you train the machine and after a couple of inputs of your biometric identity, be it your thumb, your iris, or your earlobe, or anything, once trained, the machine can validate your future input and can identify you. Next comes in the field of banking sector. In banking sector, supervised learning is used to predict the credit worthiness of a credit card holder by building a machine learning model to look for faulty attributes by providing it with a data on delinquent and non-delinquent customers. Next comes the healthcare sector. In the healthcare sector, it is used to predict the patient's readmission rates by building a regression model by providing data on the patient's treatment administration and readmissions to show variables that best correlate with readmission. Next comes the retail sector. In retail sector, it is used to analyze the product that a customer buy together. It does this by building a supervised model to identify frequent item sets and association rule from the transactional data. Now let's learn about the next category of machine learning, the unsupervised part. Mathematically, unsupervised learning is where you only have input data X and no corresponding output variable. The goal for unsupervised learning is to model the underlying structure or distribution in the data in order to learn more about the data. So let me rephrase you this in simple terms. In unsupervised learning approach, the data instances of a training dataset do not have an expected output associated to them. Instead, unsupervised learning algorithm detects pattern based on innate characteristics of the input data. An example of machine learning task that applies unsupervised learning is clustering. In this task, similar data instances are grouped together in order to identify clusters of data. In this slide, you can see that initially we have different varieties of fruits as input. Now these set of fruits as input X are given to the model. Now once the model is trained using unsupervised learning algorithm, the model will create clusters on the basis of its training. It will group the similar fruits and make their cluster. Let me make things more clearer to you. Let's take another example of it. So in this slide, the image below shows an example of unsupervised learning process. This algorithm processes an unlabeled training dataset, and based on the characteristics, it groups the picture into 3 different clusters of data. Despite the ability of grouping similar data into clusters, the algorithm is not capable to add labels to the group. The algorithm only knows which data instances are similar, but it cannot identify the meaning of this group. So now you might be wondering why this category of machine learning is named as unsupervised learning. So these are called as unsupervised learning because unlike supervised learning, above there are no correct answers and there is no teacher. Algorithms are left on their own to discover and present the interesting structure in the data. Let's move on and see some of the popular unsupervised learning algorithm. So we have here k-means, a priori algorithm, and hierarchical clustering. Again, these are just for your information's sake. We'll discuss about these algorithms in our next video. Now let's move on and see some of the examples of unsupervised learning. Suppose a friend invites you to his party and where you meet totally strangers. Now you'll classify them using unsupervised learning as you don't have any prior knowledge about them. And this classification can be done on the basis of gender, age group, dressing, educational qualification, or whatever way you might like. Now, why this learning is different from supervised learning? Since you didn't use any past or prior knowledge about the people, you kept on classifying them on the go. As they kept on coming, you kept on classifying them. Yeah, this category of people belong to this group, this category of people belong to that group, and so on. Okay, let's see one more example. Let's suppose you have never seen a football match before, and by chance you watch a video on the internet. Now you can easily classify the players on the basis of different criterion, like player wearing the same kind of jersey are in one class, player wearing a different kind of jersey are in different class. Or you can classify them on the basis of their playing style, like the guy is an attacker, so he's in one class, he's a defender, he's in another class. Or you can classify them whatever way you observe the things. So this was also an example of unsupervised learning. Let's move on and see how unsupervised learning is used in the sectors of banking, healthcare, and retail. So starting with banking sector. So in banking sector, it is used to segment customers by behavioral characteristic by surveying prospects and customers to develop multiple segments using clustering. In healthcare sector, it is used to categorize the MRI data by normal or abnormal images. It uses deep learning techniques to build a model that learns from different features of images to recognize a different pattern. Next is the retail sector. In retail sector, it is used to recommend the products to customer based on their past purchases. It does this by building a collaborative filtering model based on the past purchases by them. I assume you guys now have a proper idea of what unsupervised learning means. If you have any slightest doubt, don't hesitate and add your doubt to the comment section. So let's discuss the third and the last type of machine learning, that is reinforcement learning. So what is reinforcement learning? Well, reinforcement learning is a type of machine learning algorithm which allows software agents and machine to automatically determine the ideal behavior within a specific context to maximize its performance. The reinforcement learning is about interaction between two elements, the environment and the learning agent. The learning agent leverages two mechanisms, namely exploration and exploitation. When learning agent acts on trial and error basis, it is termed as exploration. And when it acts based on the knowledge gained from the environment, it is referred to as exploitation. Now, this environment rewards the agent for correct actions, which is reinforcement signal. Leveraging the rewards obtained, the agent improves its environment knowledge to select the next action. In this image, you can see that the machine is confused whether it is an apple or it's not an apple. Then the machine is trained using reinforcement learning. If it makes correct decision, it gets rewards point for it. And in case of wrong, it gets a penalty for that. Once the training is done, now the machine can easily identify which one of them is an apple. Let's see an example. Here we can see that we have an agent who has to judge from the environment to find out which of the two is a duck. The first task he did is to observe the environment. Next, he selects some action using some policy. It seems that the machine has made a wrong decision by choosing a bunny as a duck. So the machine will get penalty for it. For example, minus 50 point for a wrong answer. Right. Now the machine will update its policy and this will continue till the machine gets an optimal policy. From the next time, machine will know that bunny is not a duck. Let's see some of the use cases of reinforcement learning. But before that, let's see how Pavlov trained his dog using reinforcement learning, or how he applied the reinforcement method to train his dog. Pavlov integrated learning in 4 stages. Initially, Pavlov gave meat to his dog, and in response to the meat, the dog started salivating. Next, what he did, he created a sound with the bell. For this, the dog did not respond anything. In the third part, he tried to condition the dog by using the bell and then giving him the food. Seeing the food, the dog started salivating. Eventually, a situation came when the dog started salivating just after hearing the bell, even if the food was not given to him, as the dog was reinforced that whenever the master will ring the bell, he will get the food. Now let's move on and see how reinforcement learning is applied in the field of banking, healthcare, and retail sector. So starting with the banking sector. In banking sector, reinforcement learning is used to create a next best offer model for a call center. By building a predictive model that learns over time as user accept or reject offer made by the sales staff. Fine. Now in healthcare sector, it is used to allocate the scarce medical resources to handle different type of ER cases by building a Markov decision process that learns treatment strategies for each type of ER case. Next and the last comes the retail sector. So let's see how reinforcement learning is applied to retail sector. In retail sector, it can be used to reduce excess stock with dynamic pricing. by building a dynamic pricing model that adjusts the price based on customer response to the offers.
Machine learning is a branch of artificial intelligence that enables computers to learn patterns from data and make predictions or decisions without being explicitly programmed. So instead of following the rigid rules, ML models adapt and improve over time by analyzing vast amounts of data. From personalized recommendations on Netflix to fraud detection in banking, ML powers countless real-world applications. So now that we have a basic understanding of machine learning, right? Now let's explore different types of ML models. So not all data is structured the same way, and different problems require different approaches. So for example, predicting stock prices requires the models that learn from historical trends. And then identifying objects in images needs models that recognize patterns in visual data. Next, the chatbots and voice assistants rely on the models trained to understand and generate human language. So to tackle these challenges, as I discussed previously, that ML is divided into different learning models, such as supervised, unsupervised, and reinforcement learning. And each has its own strengths, and it is used depending on the problem at hand. Since we know why different ML models are needed, let's see how they play a crucial role in generative AI. Well, generative AI is one of the most exciting applications of machine learning. And unlike traditional ML models that make predictions or classifications, generative models create entirely new content. And here's how ML enables AI to generate. So first here we have text. A language models like GPT generate human-like text for chatbots, content writing, and coding. Next is the image. So AI-powered tools like DALL-E can create realistic images from textual descriptions. Next is videos. So advanced ML models synthesize lifelike video content, transforming media, marketing, and even filmmaking. So these advancements in generative AI are reshaping creativity and automation, proving that machine learning is not just about making decisions, it's about creating new possibilities. So now that we have seen how ML models enable AI to create new content, so now let us briefly understand the different types of machine learning models. So here, the first type of machine learning model is supervised learning. Supervised learning trains a model using labeled data, where each input has a corresponding correct output. And this makes it ideal for tasks where historical data can be used to predict future outcomes. For example, let's say spam detection. Email services like Gmail uses supervised learning to classify emails as spam or not spam by learning from past labeled examples. The next example is the price predictions. So real estate platforms use regression models to predict house prices based on the features like location, size, and amenities. Now let us see some of the popular algorithms. So first let's discuss on decision trees. These models break down the data into a tree-like structure, where each node represents a decision based on a feature. So they are easy to interpret and work well for both classification. For example, deciding if an email is a spam or not, and regression example predicting house price. However, they can become overly complex. Next is the support vector machines. So SVMs are powerful for classification tasks as they find the optimal boundary, also called a hyperplane, and that best separates different clauses in the data. They work well for high dimensional spaces and cases where the distinction between categories is clear, such as handwriting, facial recognition, or medical diagnosis. So now that we have seen how labeled data is used, so now let's explore how unsupervised learning finds pattern without labels. Well, unsupervised learning works with unlabeled data, identifying hidden patterns and relationships without predefined categories. So here we have some of the popular algorithms. So first is the k-means clustering. This algorithm partitions data into a predefined number of clusters by grouping similar data points based on their attributes. It works well for tasks like customer segmentation, where businesses can group customers based on purchasing behavior. However, it assumes clusters are spherical and may struggle with irregular shaped data. Next, we have autoencoders. So these are specialized neural networks designed to learn efficient data representations by encoding and reconstructing input data. Let us see some of the examples. So first example here we have is customer segmentation, where e-commerce platforms group customers based on their shopping behavior to offer personalized recommendations. The next example is market analysis. Businesses analyze purchasing trends to find association, such as which products are frequently brought together. Now we have covered both labeled and unlabeled learning. So let's see how semi-supervised learning combines the best of both worlds. So, semi-supervised learning bridges the gap between the supervised and unsupervised learning by using a small amount of labeled data along with large amount of unlabeled data. So for example, let's say AI assistant medical diagnosis. Labeled medical images such as X-rays with diagnosis are scarce, but large amounts of unlabeled images exist. Semi-supervised learning helps AI learn patterns from both labeled and unlabeled data, improving accuracy in disease detection. Alright, now let's explore the reinforcement learning, where AI learns through trial and error. Well, reinforcement learning is inspired by the concept of learning through trial and error. So models interact with an environment, receive rewards or penalties for actions, and refine their strengths over time. For example, let's say gaming. Mario AI, developed using reinforcement learning, learns to navigate levels by optimizing actions through trial and error. The next example is robotics, where robots learn to walk, balance, or perform tasks through reinforcement learning by maximizing positive outcomes. Also, reinforcement learning uses agents, actions, and rewards to improve decision making, making it ideal for tasks requiring continuous learning and adaptation. So now that we have covered all the types of machine learning models, so let's go over some of the key tips to help you choose the right one for your needs. So here are the tips. When it comes to supervised learning, classifying emails as spam or not, and diagnosing diseases from patient data. Next is the unsupervised learning. So unsupervised learning is best when you're grouping shoppers by behavior and detecting fraud in banking. Next we have semi-supervised learning. And this is best when you're improving speech recognition with limited labeled data and identifying fake news. And finally, the reinforcement learning. This will be best when you're training self-driving cars to navigate, optimizing AI in video games like Mario.
The first tool which I'm going to talk about is scikit-learn. It's not exactly a tool, it's a library, but it's the initial steps which one should follow. So scikit-learn is a free software machine learning library for the Python programming language. It is a simple and efficient tool for data mining and data analysis. It is built on NumPy, SciPy, and Matplotlib. It provides a range of supervised, unsupervised machine learning algorithms in Python like classification, regression, clustering, dimensionality reduction, and much more. So this is one of the basic steps or the basic building block of any machine learning project or application out there. So you need to know scikit-learn. This is one of the most important tools. Next I'm going to talk about is KNIME, which is Constants Information Miner. It is a free and open source data analytics, reporting, and integration platform which is built for powerful analytics on a GUI-based workflow. This means you do not have to know how to code to be able to work using the KNIME and derive the insights. What you can do is you can work all the way from gathering the data and creating models to deployment as well as production. It consolidates all the functions of the entire process into a single workflow. You can gather and wrangle the data, you can model and visualize, you can deploy and manage, and you can consume and optimize as well. So it's an all-in-one package, and the most important aspect is you do not need to know how to code. So the next library which I'm going to talk about is one of the best library out there for machine learning, which is TensorFlow. It is created by Google Brain team, and TensorFlow, it's an open source library for numerical computation and large-scale machine learning. When it comes to artificial intelligence framework showdown, you will find TensorFlow emerging as a clear winner most of the time. Now what makes it so special? So TensorFlow provides an accessible and readable syntax which is essential for making these programming resources easier to use, and being a low-level library provides more flexibility, and with the new version of 2.0 it is just going to be on the top of any machine learning or deep learning purposes. It is one of the best machine learning tools available, and it also uses Keras and other high-level APIs to make things a little smoother. And the most important thing is it can run on both CPU as well as GPU, and it really helps in graphical purposes, like if you're dealing with images, videos, TensorFlow is the way to go. Now, Weka, which is the Waikato environment for knowledge analysis, it is an open source Java software that has a collection of machine learning algorithms for data mining and data exploration tasks. It is one of the most powerful machine learning tools for understanding and visualizing machine learning algorithms on your local machine. It has both a graphical interface and a command line interface. Now, the only downside to this is that there is not much documentation or online support available. But all in all, it's a very good software and it's based on Java. It also provides predictive modeling and visualization, and it's an environment for comparing learning algorithms. And the graphical user interface includes data visualization as well. Now next, we have a library which is one of the biggest rival of TensorFlow, which is PyTorch or Torch. So PyTorch is a Python-based library built to provide flexibility as a deep learning deployment platform. The workflow of PyTorch is as close as you can get to the Python scientific computing library, NumPy. It is actively used by Facebook for all of its machine learning or deep learning work, and the dynamic computational graphs are a major highlight of PyTorch. The support for CUDA ensures that the code can run on the GPU, thereby decreasing the time needed to run the code and increasing the overall performance of the system. Now, this framework is embedded with ports to iOS and Android backends. Now, RapidMiner, the next tool which I'm going to talk about, is a data science platform for teams that unite data preparation, machine learning, and predictive model deployment. It has a powerful and robust graphical user interface that enables users to create, deliver, and maintain predictive analytics. With RapidMiner, uncluttered, disorganized, and seemingly useless data becomes very valuable, as it simplifies data access and lets you structure them in a way that is easy for you and your team to comprehend. Now, few of the features are that it results in visualization a lot. Through GUI, it helps in designing and implementing analytical workflows. One of the downsides is that the tool is very costly. Now, Google is not very far behind. Apart from TensorFlow, we have the Google Cloud AutoML. Now, Google Cloud AutoML makes the power of machine learning available to you even if you have limited knowledge of machine learning. The Google's human labeling service can put a team of people to work annotating or cleaning your labels to make sure your models are being trained on high quality data. Now, how cool is that? They have various products for different purposes, which makes it a very good machine learning tools. For example, we have AutoML Vision, which is used for images. We have the AutoML Video Intelligence, which is specifically designed for video. We have the AutoML Natural Language, which is used to structure and get the meaning of text. We have the AutoML Translation, which dynamically detects and translates between different languages. And we have the AutoML Tables, which builds the models on your structured data. Now, we have the Azure Machine Learning Studio as well. Now, Microsoft Azure Machine Learning Studio is a collaborative drag and drop machine learning tool you can use to build, test, and deploy predictive analytics solution on your data. You drag and drop datasets and analysis modules into an interactive canvas and connecting them together to form an experiment, which you run in the Machine Learning Studio, and there is no programming required, just visually connecting datasets and modules to construct your predictive analytic model. And finally, you just have to publish it as a web service. Now, Accord.NET is a .NET machine learning framework combined with audio and image processing libraries, which is completely written in C#. Now, the tagline being machine learning made in a minute. That's an amazing tagline, guys. And it is a complete framework for building production-grade computer vision, computer audition, signal processing, and statistics application. Libraries are made available from the source code and through executable installer and the NuGet package manager. The only drawback is that it supports .NET, that it only supports the .NET supported languages. It provides algorithm for numeric linear algebra, numeric optimization, statistics, artificial neural network. It also provides supports for graph plotting and visual libraries as well. And it has more than 38 kernel functions. It contains more than 35 hypotheses tests, including one-way and the two-way ANOVA test, non-parametric tests like Kolmogorov's Smirnov test, and many more. Now, this is rather an interesting product by Google, which is the Core Laboratory. It is a free Jupyter Notebook environment that requires no setup and runs entirely on the cloud. It is a Google research project created to help decimate machine learning education and research. That's a good step forward by Google. It is by far one of the top machine learning tools, especially for data scientists, because you don't have to manually install any of the package and libraries. Just import them directly by calling them. You can directly save your project on the Google Drive, GitHub, or any location in various formats as well. And it also supports libraries of PyTorch, Keras, TensorFlow, as well as OpenCV. These are pre-installed. Now, this is a major step forward in the machine learning education department by Google, so hats off to them. Now, NLTK is another tool which I'm going to talk about, which is the Natural Language Toolkit, and it's an extensive library for natural language tasks. It is a go-to package for all your text processing needs, from word tokenization to lemmatization, stemming, dependency parsing, chunking, chinking, removing the stop words, and many more. Text processing is an extremely important part for any NLP task like language modeling, neural machine translation, or name entity recognition. And it also provides a synonym bank called the WordNet. Now, these are a few of the tools, basically the libraries and the frameworks, which are really necessary if you are going for machine learning or if you're going for deep learning, as a matter of fact. And these list of tools are enough for anyone to get started in the machine learning world.
What is TensorFlow? TensorFlow is a popular open source framework developed by Google for building and training machine learning models. It's like a toolkit for creating artificial intelligence systems. TensorFlow can be used for various tasks, including neural networks, computer vision, where computers learn to see and understand images, and natural language processing, where computers can understand and use human language. So now we got an understanding of TensorFlow, so let's get deeper into it. TensorFlow is a versatile machine learning framework that utilizes tensors, multi-dimensional arrays, and computational graphs to perform operations. This architecture makes it adaptable and scalable for various machine learning tasks. TensorFlow caters to users with different levels of expertise by offering both high-level APIs like Keras for simplified model building and low-level APIs for greater customization. Furthermore, its capabilities with CPUs, GPUs, and TPUs ensures its suitability for both small-scale research and large-scale production environments. Now that you are familiar with TensorFlow, so let us see its significance in AI and machine learning. TensorFlow is a powerful platform that empowers developers to transform AI and ML ideas into scalable solutions, seamlessly transitioning from research prototypes to real-world applications. It is adaptable to diverse needs, with features like visualizations and debugging tools that enhance model understanding and troubleshooting. TensorFlow streamlines the entire machine learning pipelines, enabling efficient handling of large datasets and complex tasks while ensuring scalability and performance. Its versatility allows it to be customized for various applications, from simple experiments to advanced AI systems. Ultimately, TensorFlow has a real-world impact by enabling developers to create innovative solutions that address global challenges and drive technological progress. Now that you know the significance of TensorFlow, so let's discover why to use TensorFlow. TensorFlow is one of the leading deep learning frameworks widely used for machine learning and AI research and production. Its scalability allows TensorFlow to handle massive datasets and complex models efficiently, making it ideal for large-scale AI systems in applications like image recognition and natural language processing. Next, flexibility. Flexibility is another key strength, as TensorFlow offers APIs ranging from high-level Keras for simplicity to low-level APIs for advanced customization, catering to diverse developers' needs. Next, Its rich ecosystem includes an active community, extensive documentation, pre-trained models, and numerous resources that simplify its adoption and usage. TensorFlow's cross-platform support enables seamless deployment across different operating systems and hardware platforms. Finally, its optimized performance, as TensorFlow runs efficiently on CPUs, GPUs, and TPUs, ensuring faster training and inferences times. These strengths such as scalability, flexibility, ecosystem, cross-platform compatibility, and optimized performance make TensorFlow a preferred choice for AI and ML projects. Now that we know what is TensorFlow, so let's compare TensorFlow with other frameworks. So here is the comparison between TensorFlow and another deep learning framework, likely PyTorch, highlighting their respective strengths. TensorFlow is known for its flexibility and versatility, enabling developers to build a wide range of models with customizable implementations, while PyTorch is recognized as initiative and Pythonic, offering a user-friendly approach that appeals to many developers. Next, when it comes to production readiness, TensorFlow excels with robust tools for deploying models in real-world environments, whereas PyTorch is more research-focused, favored for its dynamic computational graphs and ease of experimentations. Next, TensorFlow boasts a large and established ecosystems with an active community, extensive documentation, and a proven track record, while PyTorch is growing rapidly in academic circles, gaining traction as a popular choice for research projects. In terms of performance, TensorFlow is optimized and scalable, capable of handling large-scale models and datasets efficiently, while PyTorch is seen as a competitive alternative, offering its own strengths and appealing to a different subset of developers. Ultimately, the choice between TensorFlow and PyTorch depends on the specific use case and developer preferences, as both frameworks offer compelling features suited to different needs. Next, let's explore the real-world applications of TensorFlow. Real-world applications of TensorFlow in computer vision, showcasing its versatility and impact across various fields. TensorFlow is widely used for identifying objects in images, with algorithms like YOLO, You Only Look Once, and SSD, Single Shot Detector, enabling tasks such as detecting pedestrians and obstacles in self-driving cars or identifying suspicious objects in security systems. It plays a crucial role in medical imaging and satellite imagery, where it aids in analyzing X-rays or MRIs to detect anomalies and assist in monitoring deforestation, identifying land use patterns, and predicting natural disasters. Additionally, TensorFlow powers security systems and user authentications, enabling facial recognitions for tasks like facial detection and identifications. This application highlights TensorFlow's ability to transform industries like healthcare and security, making it an indispensable tool in computer vision. Next, TensorFlow in natural language processing. TensorFlow is instrumental in tasks like spam detections and sentiment analysis, where it helps identify spam emails and determine the emotional tone or polarity, which is positive, negative, or neutral of text, such as customer reviews or social media posts. It provides services like Google Translate, enabling accurate translations between numerous languages and facilitating global communications. TensorFlow also enhances security systems and user authentication by analyzing text data to detect suspicious patterns, fraudulent activities, or by improving authentication process through text-based inputs like passwords and security questions. These applications demonstrate TensorFlow's versatility in advancing communication, enhancing security, and driving innovations in NLP. TensorFlow in the field of generative AI, showcasing its role in driving innovation. TensorFlow powers GANs as similar models, enabling the creation of realistic images, art, and even the manipulation of existing visuals. It is instrumental in training large language models like GPT, which stands for Generative Pre-trained Transformers, translate languages, write creative content, and perform summarization tasks. Additionally, TensorFlow facilitates the creation of deep-fake audio and speech generation, producing synthetic media where a person's likeness or voice can be convincingly replicated. These applications demonstrate TensorFlow's pivotal role in advancing image creation, text generation, and audio synthesis within the field of generative AI. Now, let us explore the industrial use of TensorFlow. There are diverse applications of TensorFlow across various industries, showcasing its transformative impact. In healthcare, TensorFlow is used for predicting analytics to forecast disease outbreaks, identify high-risk patients, and optimize treatment plans, as well as for medical image analysis to detect anomalies in X-rays, MRIs, and CT scans. In autonomous vehicles, TensorFlow powers object detection systems, enabling safe navigation and supports decision-making models in industries like supply chain management and risk assessment. In finance, TensorFlow is utilized for algorithmic trading, analyzing market trends and detecting fraudulent transactions. Retail applications include inventory management to predict demand and reduce stock outs, along with personalized recommendations to enhance customer experience and boost sales. In entertainment, TensorFlow facilitates content creation, such as generating music or art, and it is used in video and audio processing tasks like noise reduction and voice stabilization. Overall, TensorFlow's versatility and advanced capabilities are driving innovation across these industries. Now, let us move ahead and install TensorFlow. To get started with TensorFlow, you first need to install the necessary prerequisites including Python 3.5 or a higher version. You can use a package manager like pip or conda for installation. Here's how you can proceed based on your operating system. First, open your terminal or command prompt and run the following command to create a virtual environment. And the command is python-m virtual environment my environment. Next, activate the environment. For Linux or Mac OS, activate the environment with the following command. And the command is source my environment /bin/activate. For Windows, activate the environment by running my environment /scripts/activate. Once the environment is activated, you can install TensorFlow by running pip install TensorFlow. Now, to ensure that TensorFlow has been installed successfully, you can verify the installation by running the following command, and that is python-c. Inside the double quotes, type import TensorFlow as tf, print, inside the bracket, type tf dot _version . And this will display the installed version of TensorFlow, confirming that the installation was successful. Once the environment is activated, you can install TensorFlow by running this command, pip install TensorFlow. Now, let us open our VS Code terminal and install the TensorFlow. So let us type the command pip install TensorFlow. As you can see, TensorFlow is installed. Now, to ensure that TensorFlow has been installed successfully, you can verify the installation by running the following command. So now, let us run this command in our terminal. Now, as you can see on the screen, the version is displayed. So, this will display the installed version of TensorFlow, confirming that the installation was successful. Now, let us discuss TensorFlow ecosystem. The TensorFlow ecosystem provides a comprehensive set of tools for building, training, and deploying machine learning models. At its core is TensorFlow, the foundation of the ecosystem. TensorFlow Lite enables running models on mobile and embedded devices, while TensorFlow Extended supports building production-grade ML pipelines, including data validation and model serving. Next, the TensorFlow Model Garden offers pre-trained models and examples for tasks like image classification and NLP. TensorFlow.js allows running ML models in web browsers, and TensorFlow Hub provides a library of pre-trained models for easy integration into projects. Now, let us take a look at the key capabilities of TensorFlow, where we will be showcasing its strengths as an open-source, community-driven framework that evolves through contributions. At its core, TensorFlow utilizes tensors, multi-dimensional arrays for efficient data representation and manipulations. Its flexible architecture allows developers to choose between static graphs for optimized performance and eager execution for an interactive development experience. TensorFlow supports a wide range of applications, including natural language processing, generative AI, computer vision, and more, making it highly versatile for various machine learning tasks. Furthermore, it offers cross-platform compatibility, running efficiently on CPUs, GPUs, and TPUs, enabling developers to leverage the best hardware for their needs. So overall, TensorFlow stands out as a robust, adaptable, and versatile framework for machine learning. Now, let us head towards hands-on. There are three main steps in building a churn prediction model using TensorFlow. In step 1, A model is created by defining its architecture, including layers and parameters tailored to the specific problem of prediction customer churn. In step 2, the model is trained using historical data where it learns patterns and relationships that help predict customer behavior. Finally, in step 3, the trained model is used to make predictions identifying customers likely to churn based on input data. This process demonstrates how TensorFlow can be effectively utilized for churn prediction in machine learning projects. Now, without any further delay, let's code it. So first, let us import the libraries. So let us import TensorFlow as TF. Next, import matplotlib.pyplot as PLT. Next, from TensorFlow.keras, import sequential. Next, from TensorFlow.keras.layers, import flatten, dense. So over here, we are importing the TensorFlow library, a popular framework for machine learning and deep learning. Next, import matplot's plotting model for data visualization. Then we are importing the sequential class from TensorFlow's Keras API, which is used to build models layer by layer. Next, we are importing the following Keras layers, which is flatten and dense. Flattens multi-dimensional data into a 1D array for input into dense layers, and then dense creates fully connected dense layers for the neural network. And this imports set up the tools needed to build and train a neural network, and then visualize data and results. Now, to get the data and split it for training and testing, let us write the command. So inside the bracket, let us type train_images, train_labels, and give comma, and again inside the bracket let us type test_images, test_labels, and equal to tf.keras.datasets.mnist.load_data. So this code loads the MNIST dataset of handwriting digits using TensorFlow. Here, the train images and train labels were images and labels for training 60,000 samples. And the test images and test labels are where the images and labels for testing 10,000 samples. Here, each image is a 28 by 28 grayscale image and the labels represent the digits 0 to 9. Now, let us scale down the values of the pixels from 0 to 255 to 0 to 1. So for that, let us type train_images equal to train_images by 255.0. Next, test images equal to test images by 255.0. Now next, let us visualize the data. For that, print, and inside the bracket, let us type train_images.shape. Next, print test_images.shape. And finally, print train_labels. So in this code, the print train_images.shape displays the shape of the training images dataset. So let us run the code to check the output. So as you can see the output, here it says 60,000, 28, 28. This means there are 60,000 images, each of size 28 by 28 pixels. Next, we have the code print test_images.shape, which displays the shape of the testing images dataset. So the output here is 10,000, 28, 28, which means there are 10,000 images, each of size 28 by 28 pixels. The next piece of code is train labels, which prints the labels digits 0 to 9 for the training set. Now, let us display the first image. So for that, let us type plt.imageShow, and inside the bracket, let us type train_images at index 0, CMAP equal to gray inside the single quote. To see the graph, let us type plt.show. So over here, the plt.mshow train images. This displays the first image in the data set, which says train images of index 0, Then CMap equal to gray ensures that the image is shown in grayscale. So let us run this code. So as you can see the screen, here is the output. Now let us move ahead. The next step is to define the neural network model. So let us type my model equal to tf.keras.models.sequential function. Next, type my model. Okay, next is my model.add flatten, and inside the bracket let us keep input underscore shape equal to 28, 28. Okay, next let us type my model.add, and inside the bracket let us type dense and open bracket and write 128, activation equal to, inside the single quote let us type ReLU. Next type my model.add, and inside the bracket let us type dense. Again open the bracket and let us give 10, activation equal to softmax. So over here the tf.keras.model.sequential, which creates a sequential model where layers are added one after another. And next we have this code my model.add flatten input shape equal to 28, 28, which flattens the 28 by 28 input images into 1D array of 784 values and making them suitable for the dense layers. And the next code my model.add dense 128, activation equal to ReLU, which adds a dense fully connected layers with 128 neurons, and then the activation equal to ReLU, which applies the ReLU activation function to introduce non-linearity. And the next code, which is my model.add dense 10, activation equal to softmax, which adds the output layer with 10 neurons corresponding to the 10-digit classes, which is 0 to 9. And activation equal to softmax outputs probabilities for each class. Now let us compile the model. The network will be actually created. So let us type my model.compile. And inside the bracket let us give optimizer equal to, inside the single quotes let us give Adam, loss equal to, inside the single quote let us keep it as parse underscore categorical underscore cross entropy, metrics equal to accuracy. Over here the optimizer equal to Adam uses the Adam optimizer, an efficient and widely used algorithm for optimizing neural networks. This specifies the loss function for multi-class classification where labels are integers. Next, the matrix equal to accuracy tracks the model's accuracy during training and evaluation. Next, let us train the model. So for that, let us type my model.fit, inside the bracket type train underscore images, train underscore labels, epochs equal to 3. So here the my model.fit, this is a function where it trains the model with the provided data. And then we have the train images, train labels, where the input data train images and corresponding labels, which is train underscore labels for training. Next is the epochs equal to 3. The model will go through the entire training dataset 3 times to learn patterns. Next, let us check the model accuracy on the test data. For that, let us type value underscore loss, value underscore ACC equal to my model.evaluate, and inside the bracket let us type test underscore images, test underscore labels. Next, let us give a print statement. So type print test accuracy of my model, value underscore ACC. So here in this code, my model.evaluate evaluates the model using the test images and their corresponding labels, which returns two values, which is value loss, the loss on the test set, and the value ACC, the accuracy on the test set. And next statement we have print So this will display the test accuracy, showing how well the model performs on unseen data. Now let us check the output. So let's run the code. So as you can see the screen, the model is finding patterns in 3 iterations because we had set the epochs to be 3. And here you can see the accuracy is 0.97%. So let us change the epochs value to be 50. So initially we had set 3. So now let us give 50 and run the code. Now as you can see, it's making 50 iterations. However, achieving perfect accuracy on the training set could also indicate potential overfitting, where the model might not generalize well to new unseen data. So to confirm the model's effectiveness, it is essential to evaluate its performance on a separate validation or test dataset. And if the accuracy remains high and the loss is minimal on the test set, the model can be considered robust and effective. Have you seen how tools like ChatGPT with Vision can look at an image you upload and describe it? Or how DALL-E and Midjourney can generate stunning images from just a text prompt? And now, some AI models can even do both at the same time. They can see, read, listen, and even create all in one go. So how is that possible? Well, that's because of something called multi-modal AI. AI that doesn't just work with one type of data like only text or only images, but can understand and combine multiple types of information together, just like we humans do. So in this video, we are going to break down what multimodal AI really means and how multimodal AI works, and explore some amazing real-world examples that you are probably already using without even realizing it. So first, let's break down the word multimodal. So multi means many and modal refers to the modes of information like text, images, sound or video. So multimodal AI is an AI that can understand and work with multiple types of data at the same time. For example, a single AI model that can read text, look at images, listen to audio, watch videos and combine all of this to give a better answer. It sounds a bit like how humans process information, right? So why do we need multimodal AI? So think about how we interact with the world. If you're watching a movie, you're seeing visuals, listening to dialogue, and understanding the story together. Or when you're explaining a recipe to someone, you might show pictures, describe steps, and maybe even play a video. So humans naturally combine different scenes to understand things. So old AI models were single model. They could only process one type of data. Like a text model could only read and write, and a vision model could only look at images. But real-world problems are not just text or just images, they are mixed. So multimodal AI bridges this gap, and it lets AI connect the dots between text, visuals, audio, and more. So how does multimodal AI work? In simple terms, it works like this. It takes different types of input. For example, it could take a photo and a text question about that photo. Then, it converts them into a common language inside the AI model. So think of it like translating text, images, and audio into one shared understanding. Next, it reasons over all the data together. Then it gives you a smart answer that considers all the inputs. So for example, you show AI a picture of a dog and ask, what breed is this? So it looks at the image, understands the features and responds, that looks like a golden retriever. So it's combining vision plus language to answer. Now let us go through a working diagram of a full multimodal pipeline. So as you can see the screen, first it takes different inputs. It could be a text, image or even a video. Then it encoders for each modality. Later, these inputs will be translated into common AI language. Then, a multimodal transformer uses cross-attention to connect relationship across text, images, and audio. And finally, the model generates a response. So let me take another example to explain this diagram. So as you can see, we have different inputs. So the model can take text, images, audio, or even video as input. Next is the encoders for each modality. That means a text encoder converts words into vectors and an image encoder converts pixels into vectors, and then an audio encoder converts sound waves into vectors. Next is the shared embedding space, where all these different inputs are translated into a common AI language, which is a vector space where similar meanings are close together. For example, the word car and the picture of a car are mapped close together. Next is the fusion plus reasoning layer, where a multi-modal transformer uses cross-attention to connect relationship across text, images, and audio. For example, it links the word red to the red region of the car image. Next is the output generation. So finally, the model generates a response, which could be text, a caption, an image like DALL-E, or even sound. Alright, I hope this is clear now. So now let's look at some real-world examples that make it easier to understand. So first we have ChatGPT with vision. So if you upload an image to ChatGPT and ask what's in this picture, then it can describe the objects, text, or even analyze data like a chart. So that's multimodal AI. It's using both image understanding and text generation together. The next example is Google Lens. So when you point your camera at something, Google Lens can recognize the object, read the text in the image, and translate into another language. Again, it's a vision plus language plus translation all in one model. The next example could be a self-driving cars. So autonomous cars like Tesla's uses multimodal AI because they have to see the road through cameras, read traffic signals, hear alerts, and also process maps and text instructions. So they combine all these modes to make driving decisions. Next is the healthcare AI. So doctors now use AI that can look at medical images like X-rays and also read patient reports, combining the information to help diagnose diseases more accurately. But why is multimodal AI a game changer? Multimodal AI is powerful because it's closer to human intelligence. We don't rely on one sense, we combine many. And it makes AI more flexible because one model can handle text, images, audio, and more. It can solve more complex problems like explaining what's happening in a video or understanding a full conversation with context. Alright, now for those of you who want a bit more technical depth, here's a quick peek behind the scene. So as I discussed earlier, a multi-modal AI uses transformer-based models, the same type of models behind GPT. So the text, images, and audio are all converted into a common representations, like a shared language of numbers called embeddings. For example, a picture of a dog and the word dog are both mapped into a similar space, so the AI knows they mean the same thing. Then, the model can reason across all modalities together and generate an output. A great example is Clip from OpenAI, which connects images and text. Another is Google Gemini, designed from the ground up as a truly multimodal model. So what is the biggest challenge? So, the different types of data have different formats and complexity. Combining them efficiently without losing meaning is still an ongoing research area. So it's not just a magic, so it's smart design that lets the AI translate everything into one common understanding. Let's now look at some of the most important multimodal models, how they work and where they are used. So here are the key multimodal models. So first on the list we have CLIP, which is CLIP, which stands for Contrastive Language Image Pre-Training from OpenAI. So let's see how it works. So it has two encoders, a text encoder and an image encoder. So both encoders map inputs into the same embedding space. So during training, it learns this caption matches this image and this caption does not match that image. So it uses contrastive learning. It pushes correct pairs closer and incorrect pairs further apart. So here is the working diagram. So it takes the input, be it image or text, and then it encodes. So an image is a vision encoder and for text is a text encoder. Then it is shared to an embedding space. And finally, it generates the output. So let's have a look at the use cases. So it is used in DALL-E and Stable Diffusion to align text prompts with images. Next, it is used in zero-shot classification, where you give it a photo of a dog versus a photo of a cat, and it recognizes which one matches the image without retraining. And then it is used in search, where it finds images similar to this caption. Next, moving on to second model, which is BLIP2. It stands for Bootstrapping Language Image Pre-training. So let us see how it works. So first, it connects a frozen vision encoder, for example, a clip or VIT, with a frozen large language model, which is LLM. A query transformer acts as a bridge, where it converts visual features into a language-friendly representation. So here is the working diagram. The AI first looks at the image and turns it into features, like objects, color, and shapes. Then, a small bridge model called QFormer takes those visual features and converts them into a format the language model can understand. Next, the large language model then reasons about the image features just like it reasons about text. And finally, it generates a text answer or a caption describing the image. So, vision encoder sees and QFormer translates and the LLM explains. So let's have a look at the use cases. So first, it is used in visual question answering. For example, what's in this picture? Next, in the image captioning, where it can give it like a man riding a horse on a beach. Next, in a chatbots with vision, for example, where you upload an image and ask questions. Okay, the next model on our list is Flamingo from DeepMind. So let's have a look at its working. So here's how it works. So first, it's a few shot multi-modal model. It doesn't need huge fine-tuning for a new task. And then, it uses gated cross-attention layers to integrate image plus text inside a frozen LLM. And it can reason across multiple images and a long text sequence. So, it looks at the image, reads your question, connects both through cross-attention and then explains it. So, let's have a look at the use cases. So, it is used in multimodal chatbots like look at these 5 images and now answer this question. Next, it is used in educational AI, where it reads diagrams plus answer questions. Next, in document understanding, where it reads text plus images in a PDF. And the next multimodal on a list is PaLM-E from Google. So here's how it works. So as you can see, this is the working diagram. So first, the AI gets both visual input, like a photo or a live camera feed, and the text instructions like pick up the red apple on the table. Next, the vision transformer understands what's in the image, like objects, colors, and position, and the PaLM language model understands the instruction and reasons about what needs to be done. So it's combining both. The AI creates a step-by-step action plan for the robot, like move forward, grab the red apple, and place it in the basket. So here are the use cases. It is used in robotics, like pick up the red apple on the table. Next, it is used in real-world reasoning for embodied AI. Then, it is also used in visual navigation tasks. And the next multimodal is Google Gemini. So here's how it works. It's a natively multimodal trained from scratch on text, images, audio, and video. So unlike Clip, which aligns 2 encoders, Gemini has a single model handling all modalities. And it uses joint training with cross-attention. So this is the working diagram. So let me explain this. The AI takes in all types of inputs at once, such as written text, pictures, sound, and even video. Then, instead of using separate models for each type, it uses one powerful transformer model that can understand and combine all these inputs together. And from that combined understanding, it can give any kind of output, a text answer, a generated image, or even an audio response. So basically, it understands everything together and responds in any form you need. So let us have a look at its use cases. It is used in complex queries, such as summarize this video and create a chart. It is used in advanced digital assistants and also in future AR/VR multimodal applications. The next model is GPT-4o from OpenAI. It's an optimized multimodal model. It accepts text, images, audio in real time. And it uses fused embeddings and parallel processing for speed. And it works as a true interactive assistant. So here are its use cases. It is used in conversational AI with vision plus audio and in real-time assistance where you upload an image and get explanation instantly, and also in accessibility tools. For example, describe surroundings for visually impaired users. So these models represent different approaches to multimodality. Some align separate encoders like CLIP, some bridge vision plus LLMs like BLIP2, and some are natively multimodal like Gemini and GPT-4o. So now let us see how are multimodal models trained. So training multimodal models is much more complex than training single model models. So first is the dataset alignment. So you need paired datasets such as images plus captions, videos plus transcripts, and audio plus text. So this challenge is the text and images don't always align perfectly. Next is the contrastive learning. So train the model to pull matching pairs closer and push non-matching pairs apart. For example, image of a cat plus caption, a cat, is a matching pair, whereas image of a cat plus caption as a dog is not a matching pair. Next is the masked modeling. Mask parts of the input such as image patches, text tokens, as model predicts missing information. Then it forces the model to reason across modalities. For example, mask the object in a caption, a dash is sitting on the table plus providing image. Next is the fusion and cross-attention training, where models like Flamingo or Gemini train cross-attention layers to integrate modalities. It requires huge compute clusters. Next is scaling laws. Like LLMs, multimodal models get better with size and data diversity. Gemini plus GPT-4o trained on massive multimodal corpora. So here are the training requirements. You need to have high quality paired dataset, billions of parameters, and TPUs, GPUs for weeks or months, and advanced optimizations such as mixed precision or shade training. So, why is true multimodal AI still hard? It's because of data mismatch. Text is sequential, images are spatial, and audio is temporal. So aligning them perfectly is difficult. Next is limited high quality data. So billions of image text pairs exist but have noises and bias. Next, bias and fairness. Models learn cultural and social biases from multimodal data. For example, stereotypes in images and captions. The next challenge is compute cost. So training needs huge GPU clusters. For example, hundreds of A100 GPUs. And fine-tuning multimodal models is even more expensive than text only. And the final challenge is the evaluation difficulty. So how do you measure reasoning across modalities? So there is no single easy benchmark. So while multimodal AI is powerful, it's also data hungry, compute heavy, and still evolving. So in simple words, the multimodal AI can process and combine multiple types of data such as text, images, audio, and video. It's already in use such as GPT Vision, Google Lens, self-driving cars, and healthcare AI. It's a big step towards AI that can understand the world like humans do. So what do you think? Will multimodal AI make AI more human-like? So drop your thoughts in the comments.
What is Flask? Well, Flask is a web application framework which is written in Python, guys. So it is as simple and as straightforward as that. So basically, a person called Armin Ronacher, who actually led an international group of enthusiasts called as POCO, developed it. Well, Flask has a large community of learners and collaborators on the overall, and it is open source as well. So it obviously attracts a lot of attention. And it is really easy to grasp and work with, and I'll be walking you through that in the entire session. So we said that Flask is a web framework, correct? So what is a web framework? Well, a web framework is simply called as an application framework as well, and it basically represents a collection of, say, libraries and modules that actually enable a particular web developer to write applications without having to bother about any low-level details such as protocol, thread management, and all these, right? One major highlight about using Flask is it's really intuitive and easy to use, especially for beginners, guys. So basically, as I mentioned, Mr. Armin, who's the founder of Flask, he leads an international group of Python enthusiasts called as POCO. And Flask is based on the Workzug WSGI toolkit and the Jinga2 template. Well, both of these are actually the POCO projects, guys. Well, WSGI actually stands for Web Server Gateway Interface, and it has been adopted as the standard for Python web development, guys.
So WSGI is a specification for a universal interface, let's say between a web server and the web application. And Workzeuge, well, it is actually a WSGI toolkit which implements concepts such as requests, response objects, and any other utility functions as well. Well, what this does is it enables building a web framework on top of that. The Flask framework uses Workzeuge as one of its bases actually. Well, what's up with Zinger 2? Well guys, Zinger 2 is a popular templating engine for Python. A web templating engine actually combines a template with a certain data source to render some dynamic web pages. It is as simple as that. Well, Flask is often referred to as a micro framework actually, guys. So it aims at keeping the core of an application simple yet very extensible. Flask does not have any inbuilt abstraction layer for database handling, or nor does it have any validation support, correct? But Flask supports the extensions to add such functionality to our actual application. Well, I'll be covering some of the major Flask extensions as well, so stay tuned until the end. So guys, before we go ahead, I'd like to mention that you will require a little bit knowledge about Python, and if you do not have any first-hand experience coding with Python, well, not to worry guys. I'll leave a link in the description box below for our latest Python tutorial, so make sure you check that out and come back to this tutorial. However, you will require a little bit of HTML as well, but it is really simple and you'll figure it out as soon as I start explaining. So now that that's done, let's begin by installing Flask. Well guys, the prerequisites are pretty much simple. The only prerequisite is we'll actually require Python 2.6 or higher, right? So that is what basically is required for the installation of Flask. Well, Flask and its dependencies work really well with Python 3, actually Python 3.3 onwards, and many Flask extensions do not support it properly. So it is actually recommended that you install Flask on Python 2.7. And we need to install virtual env as well. So virtual env is basically the virtual Python environment builder. It actually helps the user to create multiple Python environments side by side. Thereby, it can actually avoid compatibility issues between the different versions of all of the libraries that are actually present. Well, so how do we install virtual env? Well, it's pretty much simple, guys. For Windows, we use the following command, right? So we actually pip install virtual env, and it's as simple as that. Well, this might require administrator privileges as well. So in case you guys are installing this on Ubuntu or any Linux or something, so make sure you just add sudo there, right? On Windows, you'll need to log in as an administrator. On Ubuntu, virtual env may be installed using its package manager using the sudo apt-get install, guys. It's fairly straightforward. Well, once that's installed, a new environment is created in an actual folder. Well, we'll actually need to create our project. So we're going to create a directory and we're going to call it new proj. So we'll be using the command mkdir, which is actually make directory, to create a folder for us called as new project. And then we're going to go into that folder and we're going to set up our virtual environment there. However, to activate the actual environment, we need to use one of the following commands, guys. For Windows, basically this command can be used, guys. So at this point, we're actually ready to install Flask and we haven't installed it yet. So how do we install Flask? Any guesses? Well, as the name suggests, it's really simple, guys. Pip install Flask is all you need to do. And this command can be run directly, right? So you wouldn't need any virtual environment because we are installing this system wide. Well, if you have done everything at this point, you'll have Flask ready in your system, guys. Well, in order to test the Flask installation, we need to actually check out a simple program for that. So no worries if you actually do not understand anything at this point of time. However, I'll start explaining the code in the following slides so you'll have a better picture there. However, let me quickly walk you through what's going on here, right? So firstly, we're importing the Flask module in the project. And this is definitely mandatory because we're using Flask and we need to run the project based on that. So basically, in our case, an object of the Flask class is actually our WSGI application, guys. However, the Flask constructor takes the name of the current module as the argument, right? So basically, the Flask constructor takes the name of the current module to be the argument, guys. As soon as you start typing this code, make sure you save it as hello.py for now, guys. So next we have something called as the root function. Well, the root function of the Flask class is basically a decorator, guys. That's about it. Well, what does a decorator do? Well, it actually tells the application which URL should be associated with that particular function. As simple as that. Well, check out the syntax which is on the screen right now. We have app.root followed by two parameters, which is rule and options. Well, the rule parameter actually represents the URL binding to that particular function. And the options is basically a list of parameters to be forwarded to the underlying rule object, guys. So it is as simple as that. So if we quickly go back to the previous example, well, the slash is the URL which is bound with our hello world function, as you can see, right? Well, when the home page of the web server is actually opened in the browser, the output of this particular function will be rendered. So as you can guess, we will get an output of hello world as soon as we open the browser. Well, we have something called as app.run at the end, right? So what does the run method do? Well, the run method of the Flask class actually runs the application on that local particular development server, and that's about it. So let us check out a little bit of app.run. So as you can see, app.run has three particular parameters, guys: the host, a port, and the options. Well, the host is basically the name of the host to which we need to listen to on, right? So the default is 127.0.0.1, and you guys might already know it, right? So it's basically the local host. However, we can set it to 0.0.0.0 if you have an external server available as well. And next up is port. Well, the default port is actually 5000, but you guys can change this based on your requirement. And for options, well, basically these are the options that are needed to be forwarded to the underlying worksuke server, as I've actually mentioned before. So at this point of time, let's actually run the program. So basically you need to do python hello.py in case you're running it on the console. I'll be doing it using PyCharm, so all I need to do is directly run and then open the browser. So let me just show you guys the output. So guys, I've opened up my PyCharm and this is the program that we were actually discussing. So let me go ahead and run this and we can check out the output together. So as you can see, it actually provides us with a link, right? So all we need to do is click on the link and it is going to take us to our browser and we can see the output. So as you can see, we got our hello world output. So let me go back to our presentation. So next up on this Flask tutorial, let us actually discuss something called as the debug mode. Well, a Flask application is basically started by calling the run method, right? So however, while the application is under development, it should be restarted manually for every individual change in the code. Well, to avoid this, there is something called as the debug mode. Well, it is also called as a debug support because the server will reload itself if any of the code changes. So you'll not have to stop it and start it again. Well, as the name suggests, it will also provide a basic useful debugger to track all the errors if we do get any in the application. So how do we enable the debug mode? Well guys, it is enabled by setting the debug property of the application object to be true. Well, this is done before running or passing the debug parameter to the run method. Well, as you can see, we actually set the parameter to be true and then we actually call the app.run and then we pass the debug parameter to the actual run method. Well, it is as simple as that. Well, moving on, we need to look at something called as routing. Well, what is routing? Well guys, modern web application frameworks use routing techniques to basically help a user remember the application URLs better. It is really useful to access a desired page without directly having to navigate from its actual home page, right? So consider this example here. The root decorator in the Flask is basically being used to bind the URL to a function. As you can see, hello world is the name of our function and the root decorator is actually used to bind the URL to that. Well, let me just give you a little bit of better clarity, right? So here basically you can see the URL is /hello, right? Well, this rule is actually bound to the hello world function. So as a result, so basically if the actual user visits localhost 5000 /hello, the output of the hello world function will actually be rendered on the screen of the browser. And the add URL rule function of an application object is also available to actually bind the URL with a function as shown in the example, right? So the root function is used. Well, another purpose is being solved and you can actually check it out in this particular example here. Well, it is really simple and straightforward to figure out, right? Well, at this point, all we need to know is that we can actually root using an URL. So we can root to a particular function using an actual URL as I've explained. So moving on, next up I have for you guys is variable rules. Well, it is possible to build a URL dynamically, guys. This is actually done by adding variable parts to the actual rule parameter. And this is done by using a variable marked as the variable name. Well, in simpler terms, it is actually passed as a keyword argument to the function to which the rule is associated. Well, let me repeat. Well, this function is actually passed as a keyword argument to the function with which the rule is particularly associated with, right? So check out the following example. Here, the rule parameter of the root decorator actually contains a name. It contains a name variable part associated with it, right, in triangular braces. And this is attached to the URL /hello. Hence, if your URL was something like localhost 5000 /hello /edureka, and you enter this URL into the browser, well, Edureka will be supplied to the hello function as an argument as I've previously explained. So let's go ahead and check this out, right? So guys, I'm back into my PyCharm and this is basically the code we were discussing, right? So this is the name parameter that we have passed. So let's go ahead and check out the output together. So as you can particularly guess from the syntax, hello and we're passing a string, right? So string in our case is the name which we pick from the dynamic URL. Well, it is as simple as that, so let me go ahead and run it. Well, as you can see, I've passed my name as the argument here. So it says hello Anirudh. Well, hello was actually present in the string, and the value we're actually getting here is my name, guys. So it can be anything, for example. So instead of my name, we can try Edureka. As soon as we type Edureka, it changes to hello Edureka. So it's pretty simple, right? So let me quickly head back to my presentation and we can move on. Well, however, guys, more rules can actually be constructed using these converters, right? So we basically have int, which definitely accepts an integer. We have float, which accepts a floating point value. And later we have path, which actually accepts the slashes, which can be used as an actual directory separator character. Well, we can actually check this out better and you can get a better clarity when I show you an example with this, right? So check out this code. So here basically most of it is the same, but you can check this out, right? So we have int and we have post ID here. Well, post ID is actually the variable and the type of it is actually integer in this particular case. Well, however, we're actually routing another variable which is actually float, as you can see from the code, right? So let me quickly head back to PyCharm and we can actually check out the implementation of this. So basically this is the program that we discussed, right? So we have an integer variable and we have a floating point variable as well. And we have something called as the revision number here, which is basically our example for our floating case. So let me actually open up my browser and enter this particular URL and we can check out the output. So as you can see, the output is blog number 11, right? So can we try playing around with an existing variable to see if it's dynamic? Can we try putting video here? Definitely not, right? So why did this happen? Well, guys, basically we are routing an integer variable which is after blog, right? So anything until the blog needs to be present there, and after the blog we can give any number we want. So let us quickly check out another case, right? So let me change this back to blog right now, and instead of 10, let me give 100. So as you can check out, it says blog number 100 and it works perfectly fine, right? So this has been the integer case. So can we quickly check out the floating case as well? The program has already been run, so all we need to do is change the URL, right? We talked about revision numbers, right? So let me just go ahead and try if we can actually give it a revision number. Well, as you can see, our revision number is 1.1 followed by the number of zeros, and the floating point is definitely present there, and it takes the floating point as I've explained, right? So the revision function actually takes up the floating point number as the particular argument and you get the output to be 1.1. So guys, however, you need to know that the URL rules of Flasks are actually based on the Workzeugs routing module, right? As I've previously mentioned. And this ensures that the URLs formed are unique and based on the precedents laid down by Apache. Well, there are many actual rules to it and let us actually check it out. Well, in this particular code, both the rules appear to be similar, right? But check out the second rule. So it is a trailing slash which is actually being used. Well, as a result, it actually becomes a canonical URL. So what this actually means is that /python and /python/ actually returns the exact same output. However, you need to know that in the first rule, right? So we have /flask. However, if you actually convert it to /flask/, we will not get the output and this will definitely result in a 404 not found error. Well, now that that's done, we need to check out something called as URL binding. Well guys, the URL_for function is very useful for dynamically building a URL for any specific function for your requirement. Well, the function actually accepts a name of the function as our first argument and one or more keywords for the other arguments, and each of these are corresponding to the variable part of a given URL. Well, as you can check out from this particular code, so we actually have a function which is user and the parameter is actually name, right? Well, the user function actually checks if an argument received matches that of an admin or not. Well, if it is matching, the application is redirected to our hello admin function for getting the URL method, right? So this is being done using URL_for. However, otherwise, if you're not an admin, we'll be actually moving to our hello_guest function by passing the received argument as the guest parameter to it. So again, for better clarity, we need to run this to understand, right? Let me quickly open up my PyCharm and I'm going to run this code for you. So as you guys can see, this is the particular code that we were actually discussing. So let me go ahead and run it. So now that the code has been run, we are back into the browser and this was the old output, right? So let me quickly change that. So we need to check if you're an admin or not, right? Well, as you can check out the output, as soon as I give admin, it says hello admin because this was actually passed into our admin function, correct? So let us actually change that and we can actually give another user's name. So again, I'm going to give my name, Anirudh. And yes, so as you can check out, it is really straightforward. So it is not the admin function and it comes into our guest function, right? So hello, it's printing my name as a guest. So it says hello Anirudh as a guest. And the application response is really simple here, right? So it is actually very easy for beginners to understand, and this is all complex as it gets, guys. Well guys, stay tuned till the end and I'm gonna actually prove it to you on how simple that this actually is. So now that that's done, so let us actually consider moving on to something else. Well, I have for you guys HTTP methods, right? So an HTTP protocol is basically the foundation of data communication in any particular World Wide Web. Guys, there are different methods of data retrieval from any given URL which are actually defined in a protocol, correct? Well, let us actually check out a table in which I've actually summarized the different HTTP methods for you guys. Well, as you can see, I have GET, which actually sends the data in an unencrypted form to the server, and GET is actually very commonly used as well. And next, we have HEAD. Well, basically, this is the same as GET, but a head does not have a response body, guys. So this is important and you should actually remember this. And next, we have POST. Well, POST is basically used to send the HTML form data to a particular server, and the data which is received from the POST method is actually not cached by that particular server. And moving on, we have PUT. Well guys, PUT actually replaces all of the current representations of the target resource with the uploaded content. And lastly, we have delete. Well, delete removes all of the current representations of the target resource given by a particular URL, guys. So I've put it out all on the screen so you guys can actually pause the video and take a note of it at this point, guys. Well guys, by default, the Flask route actually responds to the GET requests. However, this preference can be altered by providing methods argument to the route decorator. Well, in order to demonstrate the use of POST method in the URL routing, well, let us create an HTML form together and later we can use this to actually use the POST method, which will eventually send the form data to our URL, right? So let's quickly look at an example for better understanding. So this is the basic URL, guys. As you can check out, we'll be having a form and our action URL is basically our localhost and a login. We'll be entering our name. The input type is text and the variable for our particular case is nm. And eventually we have a submit button there as well. Well, it is as simple as it gets, right? So we need to save this as login.html in this case. Well, let us check out the Python script next. Well, this particular case is pretty much simple, right? So you can see that we're using the methods of post and get here as well. Then we have actually defined a login function, and if the method is actually post method, and then we request from our form, which is nm as I've previously shown. And if it is success, we're going to actually print the name of the user. Well, if it is not a success, we'll actually be getting the argument. As you can check out, there's a small change in the code. Well, user equal to request.form from our particular form if it's correct. Well, if it's not, we actually have the argument through which we need to get it, right? And lastly, again, we're using it in debug mode because we don't have to run the code every time, right? So now that we actually have two files, we need to make sure that we actually run our development server first, which is actually basically the Python code, and then open the login.html in our browser, and then we can enter the name of the text, right? So let me quickly go ahead and run this Python script, and then we can run the login.html function. So this was the particular code that we discussed, right? So let me quickly go ahead and run it, and I'm going to open up my login.html file, which I actually shown you previously, right? So let me open up our HTML in a browser, and we're presented by this, right? So we have a text box and it says enter name. So let me quickly go ahead and enter my name, Anirudh. Well, as you can see, as soon as we hit the submit, our form data is actually posted to our URL in the action clause of our form tag, correct? So basically in this case, our localhost /login is mapped to our login function as I explained to you. Well, as you can see, it is as simple as that, guys. So let me quickly go back to my presentation to see what's next. So guys, next up, let me walk you through templates in Flask, right? So it is actually possible to run the output of a particular function which is bound to a certain URL in the form of HTML. Well, for instance, consider this particular example, right? Well, here we have the hello function which we have seen before, right? So this particular hello function will actually render hello world with an h1 tag attached to it, right? Well, however, generating HTML content from Python can be cumbersome, right? So especially when we have variable data and Python language elements such as conditional elements or looping elements or anything like that. So it basically complicates everything and this becomes cumbersome on an overall, right? And this would actually require frequent escaping from our HTML code as well. Well guys, with Flask, this is where we can take advantage of our Zynga 2 template engine, right? So Flask is based on this as I've already explained. So what we can actually do here is, instead of returning hardcore HTML from our particular function, a HTML file can be rendered by our actual render_template function, guys. Well, Flask will actually try to find our particular HTML file in the templates folder which is present in our actual application folder, guys. So we have our application folder where we have our hello.py, and we have another folder called as templates there, and inside the templates we'll have hello.html. So you might have heard of the term which is web templating system, right? Let me tell you what it is basically. Well, it actually refers to designing an HTML script in which the variable data can be inserted dynamically. Well, a web template system consists of an actual template engine and some kind of data source, right? And obviously something called as a template processor. Since Flask uses Jinga2 template engine, here a web template actually contains our HTML syntax, which consists of the placeholders for our variables and expressions, right? So in this case, since we're using Python, it is Python expressions, obviously. Well, these values get replaced as soon as the code is actually rendered. So let's quickly check out an example. Well, the following code is pretty simple, right? So we're printing hello and we're printing the name. This is inside an h1 tag. So next we can check out the actual Python script. Well, here again, hello/user, pretty much straightforward, right? So again, the order of executing is that you need to actually run our development server first and later open up the browser, right? So let me quickly go ahead and run the script and we can check it out. Well guys, as I explained, this is the particular code we'll be looking at, and I've already run it, so our server is running. So let me quickly run our HTML file and we can check out the output. So as you can see, we have actually run our HTML file, but in this particular case, our actual variable is the name here, right? So instead of hello Anirudh, I can actually get it to print hello Edureka as well. And that is what I want you to notice in this particular example. So the variable part of it got inserted, and there are many things about the Jenga2 template engine, right? So there are many delimiters as well. So we can come back and check out the delimiters right now. So we have the percentage symbol for our actual statements, and then we have two flower brackets for our expressions which we need to print in our template output. And then we have hash. Well, hash is actually used for comments and it is definitely not included in our template output, right? And then we have line statements at the last. So next up, again, this is the particular syntax we need to follow in case we are actually making use of the conditional statements such as if, else or anything. On the left, you can actually see the Python code, and on the right, we have the HTML, right? So if your marks are greater than 50, print that the result is pass, else print that the result is fail. Good enough. So what else, right? And we have another example in which we have actually considered for, right? So remember, for is a looping statement, so we have used % in this particular case. So for that particular key value and the value being present in return.iter items, we actually print the key and that particular value as well. Well, the output we'll get is physics to be 50, chemistry to be 60, and the math to be 70. Well, how did I know that? Make sure you take a look on the left as well, right? So in the Python script, we actually have a dictionary where we have actually considered physics and 50 to be our key value pairs, chemistry and 60, and math and 70 again. So we'll be returning our rendered template to our result.html, and the result is being printed as a dictionary, right? Well, it's as simple as that, guys. So next up I have for you guys is static files. Well, guys, a web application will often require a static file, right? So what is a static file? Well, a static file can be anything such as a JavaScript file or a CSS file or something which supports the displaying of a particular web page, right? But usually the web server is basically configured to serve them for you. But during the particular development, these files are actually served from a certain static folder in your package, right? Or even next to your module, and it will be available at the particular header, which is actually /static. And also, a special endpoint called a static is used to generate the URL for static files as well. Well, in this particular example, consider a JavaScript function which is defined as hello.js, right? So it is called on a particular onClick event, which is actually an event of our HTML button in the index.html, which is rendered on the particular /URL in the Flask application, right? So as you can check out, the HTML script for index.html is to your right, and our Python code is actually to our left. So what does a JavaScript function looks like? Well, it is pretty simple, and it actually is a particular function, and then it prints hello world to you. So it is as simple and straightforward as this, guys. Since my particular goal for this tutorial is for beginners, I will not be diving into the depth of this, guys. However, do stay tuned for more videos on Flask, and I'll be bringing you more content on this as well. Well, now that that's done, let us check out a tiny concept called as our request object. Well, guys, the data from a particular client's page is actually sent to the server as a global request object, correct? Well, in order to process that particular request data, it should actually be imported from our Flask module. And at this point, there are certain important attributes of our request objects that I want you guys to note. Well, firstly, we have form. Well, form is nothing but a dictionary object which consists of the key value pairs of form parameters and their particular associated values. We have arguments. Well, arguments are basically parsed contents of our query string, which is actually the part of the URL after a particular question mark. So if you've noticed multiple URLs, there is actually a question mark, right? So any of the arguments are actually passed after that. So the next time you actually look at a URL, make sure you understand all of these as well. And we have cookies. Well, basically cookies are nothing but dictionary objects holding cookie names and values, right? So I'll be talking about cookies in the further slides. And next we have files. Well, files are actually straightforward, guys. So it is basically the data pertaining to that particular uploaded file as well. And next we have method. Well, method, as the name suggests, is nothing but the current request method, guys. So it is as simple as that. So guys, as I mentioned, next up is cookies. Well, what's a cookie? Guys, a cookie is basically stored on a client's computer in the form of a text file, right? So its purpose is to actually remember and track the data pertaining to a particular client's usage for better visitor experience and even site analysis as well. Well, a request object contains a cookies attribute that I've previously mentioned. So it is nothing but a dictionary objects of all of the cookie variables and their corresponding values that the client has been transmitting. Well, in addition to that, a cookie also actually stores its expiry time, path, and domain name of the site as well. So it consists of certain details too. Well, in Flask, cookies are set on the response object. We'll be using make_response function to actually get the response object from the return value of a view function. And after that, what we do is we actually use the set_cookie function of the response object to store a cookie. And reading back cookies are really simple, guys. So all we need to do is use the get method and we request cookies attribute is actually used to read the cookie. Well, consider this particular Flask application, right? So a simple form opens up as soon as you visit the /URL. And this HTML page actually consists of just one simple text input for us. So the form is actually posted to our set cookie URL. Well, the associated view function sets a cookie name to be as user ID, which actually renders into another page. Well, readCookie.html contains a hyperlink to another view function which is getCookie, which again reads back and displays the cookie value in the browser. So guys, I'm back into my PyCharm to actually run that particular code so that you can understand it better. So we run the particular application server and then we actually go to our URL, right? So the server is running, so let me quickly go to my URL. So as you guys can see, it says enter a particular user ID. So let me quickly enter a particular user ID. Let me enter my name. So I'll hit login. So as you can check out, as soon as I hit the submit button, it says the cookie user ID is set. However, this was a set cookie, right? So at this point of time, we're actually setting the cookie. So what is the output of our read back cookie, right? So we can go to our get cookie file and we can check out the output. If you remember, I'd given the name as Anirudh, right? So let us quickly check out the output there. So as you guys can check out, it says welcome Anirudh because this was actually stored in the text file of our particular cookie, right? So as I've been mentioning, guys, it is really simple and straightforward to get started with this and well, in my opinion, it is very code friendly for the beginners out here so that you can get started really quickly, right? So let me quickly head back to our presentation and we'll see what's next. So next up is a pretty much simple theoretical concept, guys. So we'll be talking about the redirect function and all the possible errors that we might come across. Well, the Flask class actually has a particular redirect function which is used to return a response object, right? So check out the prototype I have here for you guys. So basically in this function, we have three parameters, which is location, status code, and the response. Well, the location parameter is basically the URL where the response should actually be redirected into. And the status code is actually sent to our browser's header. And there is a default value for the status code as well. So it is actually 302. And then we have the response parameter, which is actually used to instantiate that particular response. So guys, it is at this particular point of time, I'd like to suggest that you actually pause the video and then make a note of all of these concepts that I've been mentioning. So next up, let's actually check out our status code, right? So we have some standard codes and they're as displayed here, right? So we have HTTP 300 for multiple choices, 301, which is moved permanently, 302 is an object found, 303, see others, and so on, right? Until temporary redirect. However, the default status code is 302, which is for found, right? And then there is another function called as flask.abort and it takes the code as a parameter, right? So we are very much familiar with this because we might see this on a daily basis, right? So we have 400, which is bad request, 401, which means unauthenticated, 403, forbidden, 404, which is definitely the most famous error out there, error 404 not found, right? And 406, which is for not acceptable, 415, unsupported media type, and 429, which actually means too many requests. So there is no particular need that you need to actually by heart any of these standard status codes, guys, because again, as the name suggests, it is all standardized and this is not changing, right? So 404 will definitely be not found until someone decides to change it. And 400 is definitely bad request. So while you're starting to code, it might be a little cumbersome to actually remember all of these, but as you go ahead, it is really simple. So guys, next up I have for you the concept called as extension, guys. So this will be our last concept for this particular session. So what is extension, right? So guys, Flask is often referred to as a particular micro framework because the core functionality includes WSGI and the routing is based on Workzug and the template engine is based on Zynga too, right? Well, in addition, Flask framework has the support for cookies and session and all the web helpers like JSON, static files and all of that, right? Well, obviously, this is definitely not enough for the development of a complete full-fledged web application. Well, this is where our Flask extensions come into our picture, guys. Well, extensions will give us that extra extensibility to our particular Flask framework. Well, again, as I mentioned, there are a large number of Flask extensions available, guys. So basically, a Flask extension is nothing but a Python module which adds a particular type of support to the Flask application, right? So the extension registry is actually a directory of all of the extensions applicable. But this is not provided by Flask itself, right? So the required extension can be downloaded by pipping it, right? So by pipping it, I actually mean using the pip utility. So as you can see, I have 4 main extensions for you guys, right? So first one is Flask Mail. Well, Flask Mail actually provides our SMTP interface to Flask application, and SMTP is nothing but simple mail transfer protocol. So next up we have Flask WTF. So this basically adds rendering and validation to our WT forms. And then next we have SQL Alchemy. Well, this basically adds our SQL Alchemy support to our particular Flask application. And lastly, we have Flask Ajax. So this is particularly an interface for Ajax for Python and jQuery library that makes Ajax easy to use in web applications. Well guys, each type of extension usually provides extensive documentation about its particular usage, right? So an extension is actually a Python module. It needs to be imported for it to be used.
Let's start out with what's version control. So to understand what is version control system, we need to understand first why we need a version control system. So we'll see why do we exactly need a version control system. So for that, let's take a scenario where there are 3 developers working remotely on a web application or a mobile application. Now for simplicity's sake, let's just assume that it is a streaming application and one of them is working on a streaming page. Let's call them developer 1. Developer 2 is working on a user information page and developer 3 is creating the payment portal. Now all 3 of them are done with their respective pages at 10 o'clock, 11 o'clock and 12 o'clock respectively. Now the thing is, all 3 developers are working in isolation. There may be their own changes, there may be changes in somebody else's page. They're all kind of adding some new files or modifying older files, changing the source code or something like that throughout the course of this project. But how exactly are they going to collaborate considering that they are working remotely? The solution to this is a version control system. With this system, I'll tell you what happens. At 10 o'clock, developer 1 uploads all the files regarding the streaming page. With a version control system, this modification is recorded and updated to one central directory or folder. So every time you're modifying an older file or adding a new file, it creates a snapshot of the latest version or the latest update of the changes that you've made or all the files that you've uploaded. So the snapshot of your update at 10 o'clock is saved, and then when developer 2 adds their user info page, this modification is also saved as a snapshot. Now there are 2 snapshots saved, and finally the payment portal page is added, and this is the last modification done at 12 o'clock, and this is the most recent snapshot saved, along with other snapshots of other updates and modifications done throughout the course of this project. Every change in your project, a snapshot is created and your entire project is saved that way. And these snapshots are actually known as different versions, which are basically the state of your project at a particular time or at the current time. It means that it will contain the kind of files your project is storing at one particular time and what kind of changes you have made so far between the previous version and this particular version. And this is exactly how a version control system works. So version control system basically is a system that records changes to a file or a set of files over time so that you can record specific versions later. These versions are recorded in a repository and they can be recalled anytime from these repositories during the course of your project. So version control systems essentially are of three types. Now, the local version control system is one of the simplest forms of VCS and has a database that keeps all the changes of the files under revision control. So all the files are saved by this one user and they manage all of the files. But it's actually really hard to maintain the changes of the file, and you can accidentally replace one or the other file that you need. It also needs something known as RCS or revision control system, which keeps patch sets or the differences between updates in a special format on your disk. All of this, your local version control systems maintains all the track of all the files within your local system. As a user, you can track specific versions later, and it basically works as an independent standalone system for an application. So your applications like spreadsheets and word processors have this control mechanism. So that's one type. Apart from this, you also have your centralized version control system, which basically uses a central server to store all the files and enables team collaboration. So it's not one local system, but multiple systems which work on a single repository to which users can directly access as a central server. So the repository is a central server that could be local or remote, which is directly connected to each of the programmer's workstation. And the third kind of VCS is a distributed version control system. Now, these systems do not necessarily rely on a central server to store all the versions of a project file. In a distributed version control system, every contributor has a local copy or a clone of the main repository. So everyone maintains their own local repository, which contains all the files and the metadata present in the main repository, and they can push or commit or update the main repository if and when required. Now we are going to cover more on the latter two version control systems further in the session. So now let's try and understand in depth what's the difference between a centralized version control system and a distributed version control system. As I had mentioned before, in a centralized version control system, each programmer working on a branch on a project has absolute access to the central server. So the centralized version control system uses a central server to store all the files, and everybody on the team can directly access the central server as it is one single repository. So if you have 3 workstations, workstation 1, workstation 2, workstation 3, all of them can directly commit to the repository and get updates from the repository, which is your central server. The repository here indicates a server that could be local or remote, directly connected to each programmer's workstation. Every programmer can extract or update their workstations with the data present in the repository, or can make changes or updates or commit in the repository. And every operation is performed directly on this repository. Even though this seems pretty convenient when we are just talking about 3 people, to maintain a single repository like this has some major drawbacks. One of them is that it's not locally available, meaning every change that you have to make, you will have to be connected to a network to perform any action. Also, in any case, the central server getting crashed or corrupted will result in losing the entire data of the project. Also, another small thing which is revertible, but is if one person accidentally makes some unwanted updates. Instead of his or her local system, they will be making that changes directly in the central server. So recovering that part back will be again a time-consuming process. This is where distributed version control systems come to the rescue. Now, these systems do not necessarily rely on a central server to store all the versions of a project file. In the distributed version control system, each and every contributor has a local copy or a local workstation clone of the main repository. That is, everybody maintains a local repository of their own which contains all the files and metadata present in the main repository. You will understand it better if you take a look at the diagram. As you can see, every programmer maintains a local repository or a local copy on its own, which is actually the copy or clone of the central repository on their local hard drive. They can commit and update their local repository without any interference from one another. And then they can update their local repositories with new data from the central server by an operation called pull. Once they are done with their bit of the code, they can affect the changes of the main repository by an operation called push from their local repository. Now, this system or this act of cloning an entire repository to your workstation and making all the changes on a local repository gives you a couple of advantages over a centralized version control system. First of all the operations except push and pull are very fast because the tool only needs access to the hard drive and not a remote server. Hence, you do not always need to be connected via a network connection, or you always do not need an internet connection. Committing new change sets can be done locally without manipulating the data on the main repository. Once you have a group of change sets ready, you can push them all at once. So you complete your set of code on your local system and then you push all the files once and for all into the main repository. Third, since every contributor has a full copy of the project repository, they can share changes with one another on wanting to get some feedback before affecting the changes in the main repository. So this enhances the essence of collaboration amongst a development team. And finally, if the server gets crashed at any point in time, the lost data can be easily recovered from one of the contributors' local repository. And that is why distributed version control system has been picking up popularity over the past decade. So why version control is important? First of all, it helps collaboration. It allows remote development, shared workspace, and real-time updates. All versions of your code are preserved, hence it helps you manage versions of the same code. Easy rollback from current version. Suppose a part of your project has been headed to a wrong direction, you can easily roll back from the current version to the last version which was stable. Now, because you can reverse faulty updates, you can save time and hence it reduces downtime of your project development. And finally, it improves visibility. You can analyze and compare different versions, and that gives you like a 50-foot top view of your entire project, which just accelerates your product delivery. So now that you have a bare sense of what is version control and why do you need version control, let's understand one of the most popular version control systems that exists today, and that is Git. So Git is a distributed version control tool that supports distributed nonlinear workflows by providing data assurance from developing quality software. So basically what it does is that it lets you and your team of developers work together on the same project remotely from anywhere across the world. Your team members can work efficiently on files and easily merge their changes into one source without the fear of losing or deleting anything of importance due to the easy rollback feature. Git is primarily used to manage your project comprising of a set of code or text files that you may want to change from time to time. Now, Git is an integral part of DevOps. DevOps, as most of you might have the idea of, is the practice of bringing agility to the process of development and operations. A couple years ago, it was this entirely revolutionary ideology which swept IT organizations worldwide, boosting project life cycles and in turn increasing profits. DevOps promoted communication between development engineers and operations participating together in the entire life cycle, from design through development process to production support. Now, in the entire life cycle of DevOps, starting from planning of the projects to its deployment and monitoring, Git plays a vital role. When it comes to managing the code that collaborators contribute to the shared repository, this code is extracted for performing continuous integration to create a build and test it on the test server and eventually deploy it to production. Tools like Git enable communication between the development and operations team. When you are developing a large project with a huge number of collaborators, it is extremely important to have communication between the collaborators, between the developers while making changes in the project. Commit messages in Git play a very important role in this particular collaboration or communication amongst the team. The bits and pieces that we deploy or update lies in this version control system, such as Git. To succeed in DevOps, you need to have all the communication in version control. Hence, Git plays an extremely vital role in succeeding at DevOps. And due to this very reason, Git has earned way more popularity compared to other version control tools available in the market, such as Apache Subversion, concurrent version systems, and Mercurial. If you compare the interest of Git by time with other version control systems, you shall realize that larger companies' products are generally developed by developers using Git all around the globe. And some famous names out of them are Facebook, Yahoo, Zynga, Quora, Twitter, eBay, Salesforce, Microsoft, and many, many more. Now, lately, all of Microsoft's new development work has been in Git features. Microsoft migrating .NET and many of its open source projects on GitHub, which are managed by Git. One of such projects is the LightGBM. It's a fast, distributed, high-performance gradient boosting framework based on the decision tree algorithms, which is used for ranking, classification, and many other machine learning tasks. Here, Git plays an important role in managing this distributed version of LightGBM by providing speed and accuracy. So basically, to enable version control, Git is your go-to solution. It's fast and suitable for handling massive code bases scattered across multiple developers, which makes it the most popular tool used today. Now that you know about Git, a terminology we'll be using a lot while talking about Git and GitHub is a repository. Now, repository, or a repo as it's most commonly known as, is a directory or a storage space where your projects can basically live. It can be local to a folder or your computer, or it can be a storage space in another online host such as your GitHub. And in this particular space, in this particular directory, you can keep your code files, text files, images, you name it, all of it inside a repository. Through the course of this, we shall also be talking about something known as GitHub, which is nothing but a central repository, the kind that we spoke about when we discussed centralized versus distributed version control systems. There's a central repository, and that is where all of your code will live. You have your local repository where you'll make the changes, and there you have the central repository to which you will push all of the changes. Yeah? And the central repository is something that all of the developers involved in this particular project, in a certain project, have access to. All right, moving on, let's discuss a few Git features which make it so popular amongst organizations as well as individuals. First of all, it's economical. It's free and open source. Git is released under GPL's General Public Licenses, open source license. So you don't need to purchase Git. It is absolutely free. And since it's open source, you can modify the source code as per your requirement. Second is its speed. Now, since you do not have to connect to any network for performing all of the operations, it completes all the tasks really fast. Performance tests done by Mozilla showed it was an order of magnitude faster than other version control systems. Fetching version history from locally stored repository can be 100 times faster than fetching it from the remote server. So the core part of Git is written in C, which avoids runtime overheads associated with other high-level languages, which makes it extremely fast compared to other version control systems. Next is that Git supports non-linear development. Git supports rapid branching and merging and includes specific tools for visualization and navigation of a non-linear development history. A core assumption in Git is that a change will be merged more often than it's written, as it is passed around various reviewers. Hence, branches in Git are very, very lightweight and is only a reference to a single commit. With its parental commits, the full branch structure can be constructed. Next, let's talk about the robustness. Nearly every single task in Git is undoable. Git gives each developer a local copy of the entire development history and the changes copied from one repository to another. These changes are imported as additional development branches and can be merged and deleted and recovered the same way as a locally developed branch. Next is the snapshots, which are recorded changes made to a file rather than the file itself. Followed by which you have integrity, which means no changes can be made without Git recording it. Since every contributor has their own local repository, on the events of a system crash, the lost data can be recovered from any of the local repositories. You will always have a backup of all of your files, and none of the changes made to the central repository will go unlogged by Git. Git uses the SHA-1 or the secure hash function to name and identify objects within its repository, and every file, every commit is checksummed and retrieved by its checksum at the time of the checkout. The Git history is stored in such a way that the ID of a particular version, a commit in Git's terms, depends upon the complete development history leading up to that commit. Once it's published, it's not possible to change the old versions without it being recorded. Then it's a distributed system, which means every user has their own copy of the repository and the data is stored locally. Git gives each developer a local copy of the entire development history, and the changes are copied from one such repository to another. These changes are imported as additional development branches and can be merged in the same way as a locally developed branch. And finally, it's easy branching. Now, branch management with Git is very simple. It only takes a few seconds to create, delete, and merge branches. Feature branches provide an isolated environment for each change to your code base. So when a developer wants to start working on something, no matter how big or small, they can create a fresh new branch which is not interfering with the main branch, which ensures that the master branch or the main branch always contains production quality code. So any little experimentation that you want to do or little things that you want to try out can always be on a separate feature branch instead of the changes made to your master branch. Because ultimately, your master branch should contain your publishable product. So now that you know the basic features of Git, let's try and understand what the basic workflow of Git is, or how does Git work. So the basic overview of how Git works goes like this. You basically create a repository or a project with a Git hosting tool like Git or Bitbucket. You copy or clone the repository to your own local machine or your working directory. You add a file to your local repository and commit the changes, which basically means you save the changes. Then you push the changes to your master branch. Then you make changes to your file and commit. Then you pull the changes to your local machine. You create a branch or a version, make a change, commit the change, same process, open a pull request, and merge your branch to the master branch. Now, this is a little complicated listening to it like this, but once we get on to our demonstration, I think things will be way more clear. You can still take a good look at this diagram, but if you don't get it, don't worry. I will be explaining these operations one by one when we get to the demonstration part of this Git tutorial. Moving on, let's get to the good part, the hands-on section, starting with the installation and setup of Git. Now, there are two ways in which this goes. First of all, for Windows users, you need to install Git Bash for Windows. And for Linux users, you'll have to start by updating the package index and then install Git using the terminal. So first of all, for our learners using Windows, you'll have to log on to gitscm.com/downloads and then click on Downloads for Windows button and then run the executable file and follow through till you finally install Git Bash. I'm not going to install it completely as I already have Git Bash downloaded, but I'm still going to open the page to show you guys. All right. So the latest source release is Git 2.30 0.1 on the 8th of Feb, and you can just click on this button. The moment you click on this button, it's going to start downloading Git for you. And once you have the executable file, all you have to do is open it or run it in your own system, right? Next, for people using Linux, this is an example considering you are using Ubuntu. If you're using CentOS, a lot of the commands don't change, but instead of apt install, you will be using yum install for CentOS. So for that, now I'm going to open my terminal on a virtual machine. So here I have running an Ubuntu machine using the Oracle VirtualBox. So I'm going to start by running an update. All right, this is going to take a while. Kindly be patient. So here I have my Ubuntu running on a virtual machine. So to install Git on your Ubuntu machine, you have to start by updating. So this will take some time. We're going to use sudo apt update. If you're using CentOS, you will be using yum instead of apt. Let's clear that out, and then we're going to install Git. And then you can look for the Git version. Yeah? All right. Now that we have our Git installed, let's go ahead and look at the operations and commands that we are going to take a look at today. You have your repository setup, which include the commands init, clone, config, and alias. Then you have your save changes operations, which have your add, commit, diff, and stash. All of these commands we are going to go on and off and look at collectively mostly. Then we are going to look at the inspect operations, your inspect repository operations, of which the git status command is something we are also going to look at throughout this demonstration right from the beginning. So apart from that, you have your git log, git tag, and git blame commands. So you have your merge rebase command. So let's move on to our first set of git operations. First of all, you have your git init command, which basically creates a new empty git repository. Now this can be used to convert an existing unversioned project to a git repository or initiate an absolute fresh git repository. Now most other git commands are not available outside of the initialized repository. So this is usually the first command that you will run in a new project. That is, if you're using git bash. So when I run git init, it reinitializes an existing git repository, which I already have here. Now what this does is it reinitialized my existing git repository in this particular directory, in this .git directory. Yeah. What git init does is that it creates an empty git repository or reinitializes an existing one, like it did for me right now. It basically creates a .git directory with subdirectories and template files. And when you run the git init command in an existing repository, it will not overwrite the things that are already there. It'll rather pick up the newly added templates. So that's the repository initialized. You can go ahead and create some files in the directory or repository, whatever you call it. Now that is about initialization. Now, what about if there was an existing repository on Git that you had to act upon, that you had to make updates to, that you had to add files to, things like that? That's where you use the git clone utility. Yeah. Now you have the git clone utility, which you use to target an existing repository and create a clone or copy of this particular repository on your local machine. Now this is one of the features provided to you by a distributed version control system, as we had discussed before. So this is a blank file called Edureka rep with just the readme text file. Let me just go ahead and copy this. And then I can just git clone and paste its HTTPS URL. And as you can see, it's cloning this into Edureka rep. And now if I change directory to Edureka rep, you can see the README file is right there. Yeah. So we're basically going to work off of this particular repository today, Edureka rep. Yeah. So now that we created a clone, moving on, we have the git config command, which basically is a convenience function that is used to set up your git configuration values on your global or local project level. This command is basically used to modify your configuration text file. So if I typed git config global user.email, and here I type, so there I gave in my email ID as the global user email ID. So if I ask for what the global user email ID is, it will return my ID back to me. Yeah. Basically, these configuration levels, like your username and your user ID, correspond to your .git config text files. Now, executing this basically will help you modify the configuration text file. Git uses this series of configuration files to determine non-default behavior that you may want. Yeah. So the first place Git looks for these values is in the system-wide configuration file, which contains settings that are applied to every user on this system. So basically, if you pass the option to your git config, it will read and write from this file specifically. And the next place the Git looks is the config/git config file, which is specific to each user. Now you can make Git read or write to this file by passing your global option, which is what I did. And the final command in the setup operations that we are going to look at is an alias. Now, alias, as the name suggests, is basically used to create shorter commands that map to longer commands. They enable more efficient workflows when you obviously have to use lesser keystrokes to execute a command. There are these lengthy commands which obviously kill a lot of your time. So these aliases you can use to shorten those commands. And these are also something that you will create via the git config command. There isn't really a direct way or a direct command of creating aliases. Yeah, this is just something I wanted to add in here along with the git config command. Like a very common alias created is CO for checkout or anything else, CK for checkout. So yeah, this is something that you can do using the git config command, just creating aliases. Moving on, let's look at operations that you use to add changes and save changes to your Git repository. Now, the first two commands here that we're going to look at are git add and git commit. Now, this combination is basically used to create these snapshots that I was talking about initially in the session, right? So basically what you do is first, you use the git add command to add a change in your current directory or your working directory. And you add that to the staging area. It tells Git that you want to include a particular set of updates or changes in a particular file in the next commit. Then what you do is you move on to git commit after making the changes to your working tree. Then you use the git commit command, which captures a snapshot of your project's current state. So basically, you use add to update the index using the current content found in your working tree. And then you basically prepare the content in the staging area for the next commit. Then you run the commit command to take that snapshot of your project's current status. Now remember, this is very important and you have to do it each time. You must use the add command to add any new modified files to the index. You can't directly commit anything without adding it to the stage area first. Now what I did was I quickly went ahead and added 3 files to my repository Edureka rep. So if I go into this repository, you can see there are 3 files, Edureka file 1, file 2, file 3. Now let's see if these files are in my index or not using the command git status. Now git status basically displays the state of the working directory and the staging area. It will list all the modified files which are ready to be added to the local repository. It lets you see which changes have been staged and which haven't, which files are being tracked by Git and not. So if I typed git status, you can see on your main branch, you have 3 untracked files, which are the 3 files that I just added, Edureka file 1, 2, and 3. These are not added to the index yet. This means I cannot commit these changes unless I added them explicitly to the index. So now we are going to add these 3 files. This command will update the index using the current content, which is found in your working tree, as you can see in front of you, and then it'll prepare the content in the staging area for the next commit. So either I can just git add and put in the directory name, or I can just use git add with an extension of a, which means all, and this will add all of these files to the index which are in the directory but not updated in the index yet. Yeah, now I've done that. Let me go ahead and use git status again, and you can see all of these file names are written in green, and you can see changes to be committed written here, which means all of these changes are ready to be committed. They are added to the index. Now these files are added to the index. You are ready to commit them. Now, as I had mentioned before, we're going to commit them, and committing refers to recording the snapshots of the repository at any given time. So your committed snapshots will never change unless it's done explicitly. So I'm going to clear this, and we're going to commit this by typing git commit and then adding a tag or a message called committing 3 files. Let's try this out. As you can see, 3 files changed, 3 insertions. You can see our Edureka files 1, 2, 3 have been committed. The git commit command has committed the changes in the 3 files in your local repository. Now, if you want to commit a snapshot of all of the changes in your working directory at once, you can always go with commit-a. Now let me add a couple more files to my directory just to show you the difference between your files added to the index versus the ones that are not. If I type ls again, you can see there are 2 more files over here. As you can see, I have 2 other files. I'm just going to add the Edureka file 4 and not the file 5. And then I'm just going to git commit committing files. And as you can see, only 1 file changed, only 1 insertion happened. And that only happened because Edureka file 5 is not added to the index. And even if I use the extension A, I cannot add Edureka file 5 because that has not been added to your index. Now if I just go ahead and add Edureka file 5, voila, the change has occurred in our Git repository. Now if I typed git status, there are no more files to add or commit. Our branch is ahead of the origin or main branch by 3 commits. And you can use git push to publish your local commits. Now what is git push? This is something we will cover later in this session. Now understand that before you affect the changes made to the central repository, you should always pull changes from the central repository to your local repository just to get the most updated version of your branch. You'll get all the work of your collaborators that have been contributing in the central repository. For that, you use the pull command. Now, as you can see, there's nothing to commit and your working tree is clean. There are other commands like the git status command, which you could use for similar purposes. For example, you have the git log command, which only operates on committed history. It basically will display to you the committed snapshots and will let you list the project history, filter it, and search for specific changes. So if you typed git log, it's going to show you all the commits that have happened since we started with this git file. Okay, here you can see at the bottom, your original main, there's your initial commit, right? Then our first commit where we committed 3 files, then we committed the 4th file, and finally when we committed file number 5, right? These are all the commits including the initial commit, the first one. Yeah, along with the author and the date and time. Remember when I told you about everything is recorded when you're using Git? This is what I meant. You can always access who made commits at what time and what commits were made when you use a version control system such as Git. Now at a point like this, I think it's crucial to mention one more command, which is the git tag, and it's used to basically capture a tag in history or a point in history that is used for a marked version release, right? So it's basically like a branch that doesn't change, and after being created, they have no further history of commits. Yeah, so that is one. And another one is git blame. Now the git blame function displays of the author's metadata attached to a specific committed line in a file. It's used to examine specific points in a file's history and get context as to who the last author was that modified that line. So if I went back and typed git blame Edureka file 5.txt, it's going to show who the person is that is to blame, who committed this particular file or made this particular change, right? It'll also, if you paid attention, give you the commit number. As you can see, this E9D63EFO commit number. This also has this E9D63EFO, which is the first few characters of this particular commit number. Yeah. So now that you know how to check the status of the changes and see who made the changes, it's time that you understand how you fetch changes from your remote repository to a local repository, and how you push commits from your local repository to your remote repository. So here we are going to look at two commands called pull and push. Now, first of all, you have the git pull command, which fetches changes from your remote repository to a local repository. Basically, it merges upstream changes in your local repository, which is a common task in Git-based collaborations. But at first, you need to set your central repository as the origin using the command git remote add origin, and I'm going to add the link to my central repository, which is this. And as it says, the remote origin already exists. Now that your origin is set, and now we're going to pull our main branch. So I'm just going to type git pull origin main, and it says we are already up to date. Now, certain number of tutorials or documents that you might be following might even give you the command git pull origin master, in which case you're working on the master branch. Now, to know which branch you're at, you can just use the command git branch vv. Yeah, I'll tell you which branch are you working on. Yeah. So yeah, we are working on the main branch, and we are already up to date with the branch since my local repository was already updated with files from the main branch. This is the message of an up-to-date branch. Now you can also use git pull origin and your whatever branch name. Here I'm using main. That's a mistake on my part. Maybe I was trying to clear the screen. All right. So here, even if I pull from the branch using git pull origin and the branch name to my local git repository, You can see it's already up to date. So now my local Git repository is now all updated with the recent changes. So now it's time to make the changes to your central repository by using the push command. So if you're going to use the push command, this command transfers commits from your local repository to your remote repository. And it is basically the opposite of your pull operations. Pulling will import commits to your local repositories, whereas pushing will export commits to your remote repositories. It's going to ask you for your username, and password before it lets you push into your main branch there. So I've put in the username and password for my GitHub account. And with that, this has pushed the changes from my local repository to the remote repository along with all the necessary commits and internal objects. Now this has created a local branch in your destination repository. The use of git push is to publish your local changes to a central repository. After you've accumulated several local commits and are ready to share them with the rest of the team, you can then push them to your central repository by using the git push command. Now the files which have already been committed previously in the commit section and they were all push ready, you will use git push origin master to reflect these files in the master branch of your repository. All right. So let's go ahead to our repository and see if changes have been made. And yes, you can see all of our files on our GitHub repository. You have Edureka file 1, 2, 3, 4, and 5. All the 5 files that we had created on our local repository. Yeah, you have all these 5 files and the README file here. Here also you have the README file and all the 5 files that we had created. Now at this point in this Git tutorial, I hope you have understood the basic commands of Git. You have pulling, pushing, adding, committing, things like that. Now let's take a step further and understand the 3 basic commands of parallel development. Here I'm going to be talking about branching, merging, and rebasing. So first of all, let's talk about merging. Now, merging is a way to combine the work of different branches together. This will basically allow you to branch off, develop a new feature, and then combine it back in. As you can see in the diagram, it shows you 2 basically different branches, new branch and master. Now, when we merge the work of the new branch into the master, it creates a new commit, which contains all the work of the master and new branch. Now, if we merge the 2 branches with the merge command, as I had mentioned before, Git allows you for easy branching, which means you have parallel branches with your master branch that help you carry on your individual work while not interrupting your main product, which is your master branch or your main branch. So branches in Git are nothing but pointers to specific commits. Yeah. So Git generally prefers to keep its branches as lightweight as possible. Now there are basically 2 kinds of branches via local and remote tracking branches. A local branch is just not the path of your working tree. On the other hand, the remote tracking branches have special purposes. Some of them are linking your work from your local repository to your central repository and automatically detecting which remote branches to get changes from when you do a git pull. So you can check what your local branch is by using git branch. So you know you are at your main branch. And the one thing you should understand, one thing is like a main mantra of people who use git are branch early and branch often. Yes. So to create a new branch, you're going to use a command git branch and your branch name. And in this case, I'm just going to use a branch name Edureka images. All right. And here you can see this diagram shows the workflow of a new branch that is created. When we create a new branch, it originates from the master branch itself. So since there's no storage or memory overhead with making many branches, it's usually easier to logically divide your work up than having big chunky branches. Hence, the branch often part. Now let's see how to commit using branches. Now branching includes the work of a particular commit along with all parent commits, right? So as you see, the new branch has detached itself from the master or the main branch, and hence it'll create a different path. So we are going to git check out the branch name, which in our case is Edureka images. And then we are going to git commit. So you have untracked files, Edureka images, and nothing added. So you made that branch. Now, merging is a way to combine the work of different branches together. So basically what this does is, now that we've branched off to something known as Edureka images, you can go ahead, add files to it, develop a new feature, and then combine it back into your main branch. Here you can see two different branches. You have your new branch and your main branch. And when we merge the work of a new branch into the main branch, it creates a new commit, which contains all the work of the main branch and the new branch. So now if we merge this branch, as you can see, it's already up to date. It's important to know that the branch name here should be the branch that you want to merge into the branch that you're currently checking out. So make sure that you are checked out of this destination branch. So let's just merge all the work of the branch Edureka images into your main branch. For that, I will first check out my main branch and then merge Edureka images with git merge Edureka images. And as you can see, all the data from the branch Edureka images has merged into the main branch. Now notice that merging in Git creates a special commit that has two unique parents. Now this is one way of merging into the main branch. There's also another way of combining the work between two branches, which is called rebasing. Now rebasing takes a set of commits, copies them, and stores them outside your repository. The advantage of rebasing is that it can also be used to make linear sequence commits. The commit log or the history of the repository stays clean if rebasing is done. Now our work from the new branch is placed right after master, and we have this nice linear sequence of commits. This command doesn't copy but moves all our work from the current branch to the master or the main branch. They look like they've been developed sequentially instead of having developed parallelly. So if I just did another branch called git branch Edureka images 2, and then maybe git checkout, okay, then we git commit this, and then I could just git rebase main, and your current branch will be up to date. This command basically moves all of your work from your current branch to your master branch, and it'll basically look like it has been developed sequentially instead of having developed parallelly. Now, apart from these, there are certain operations that you ought to know. Firstly, archiving your repository. You can use this command. It stores all of your files and data in a zip file rather than a .git directory. This creates only a single snapshot, omitting version control completely though. This comes in handy when you want to send these files to a client for review who doesn't have Git installed in their computers. Apart from this, you can also bundle your repository, which basically turns your entire repository into a single file. This pushes the master branch or the main branch to a remote branch, only contained in a file instead of a repository. You could alternately change the repository, clone the repo bundle, create a copy, and use git log, but that is like 5 commands instead of 1. Why not just use 1 command? And finally, stashing uncommitted changes. When you want to undo adding a feature or any kind of added data temporarily, we can always stash them temporarily. You can use git status, stash status, and then you want to reapply the changes you stashed using git stash apply. Having said that, let's move on to another very important topic in this Git tutorial. Let's go through a brief introduction to SSH. Now, what is SSH? What is an SSH key? Now, an SSH key is an access credential for Secure Shell Network Protocol. It's basically an authenticated and encrypted secure network protocol and is used for remote communications between machines on an unsecured open network, for remote file transfer, network management, and remote operating system access. So basically, it's typically used to log into a remote machine and execute commands in it. But this also supports tunneling, forwarding TCP ports, and X11 conditions. It can transfer files using associated SSH file transfer or secure copy protocols. It provides you several alternative options for strong authentication and protects the communication security and integrity with very strong encryption. It's a secure alternative to the non-protected login protocols and insecure file transfer methods such as FTP. So basically, how do you create SSH keys? You start by using the command ssh-keygen, and then you'll be prompted to enter a file in which to save the key. So home, Edureka. Then we're going to enter a passphrase. I'm just going to leave it empty again. And you can see our identification has been saved in the file that we specified. And we have something known as a key fingerprint. And finally, what we have to do is add the new SSH key to the SSH agent. And then you will see identity added. And that's it. You have created an SSH key.
The need for GitHub. It is extremely important for software developers to work on a web-based platform to share their projects and collaborate with other developers. This platform must be a version control system, that is, it must enable multiple people to simultaneously work on a single project. Each person edits his or her own copy of the files and chooses when to share those changes with the rest of the team. This application must also be capable of hosting millions of programmers and hobbyists that download and evaluate each other's work. GitHub is one such platform of choice for developers that can host multiple programmers and review their code. GitHub has several competitors. For instance, GitLab. GitLab is an open source web interface and source control platform based on Git, whereas Microsoft Team Foundation Server is an enterprise-grade server for teams to share code, track work, and ship software for any language, all in a single package. Bitbucket, on the other hand, stores all of your Git and Mercurial source code in one place, with unlimited private repositories. So what really makes GitHub so powerful and popular among developers? GitHub is an open source platform, and the community is really what fuels it. Moreover, GitHub is the platform of choice for developers from various large corporations too. Microsoft is the #1 contributor to the system, but there are also Google, SAP, Airbnb, IBM, PayPal, and many others. Exposure and insight that you can get on GitHub are simply unmatched by any other platform. Here you can discover code written by others, learn from it, and even use it for your own projects. Versions control on GitHub works very much like Microsoft Office or Google Drive. It simply tracks all the changes made to your code and who makes them. You can always review the detailed change log that neatly hosts all of the relevant information. Using GitHub eliminates the need for complex corporate security solution because everything is on cloud. The platform protects code branches, verifies commit signing, and controls access. Now that we know why we need GitHub, let us understand what is GitHub. GitHub is a Git repository hosting service that provides a web-based graphical interface with many features. A repository is usually used to organize a single project. Repositories can contain folders, files, images, videos, spreadsheets, anything your project needs. Let's say, for example, a team wants to work on a particular project. Here they can simultaneously write and update their code to a central repository which is present on GitHub. So GitHub is a highly used software that is typically used for version control. It is helpful when more than just say one person is working on a project. For example, a software development team wants to build a website and everyone has to update their codes simultaneously while working on this project. In this case, GitHub helps them to build a centralized repository where everyone can upload, edit, and manage the code files. Most software projects have a bug tracker of some kind. GitHub's tracker is called Issues and has its very own section in every repository. Issues basically are a great way to keep track of tasks, enhancements, and bugs for your project. Moving on, people often get confused between the terms Git and GitHub. Now let me clearly explain the difference between them. Git is simply a version control system that lets you manage and track changes within your project, whereas GitHub is a cloud-based service that lets you manage Git repositories. So basically, Git is the tool and GitHub is the service. Now that we know the difference between Git and GitHub, let us move on and understand how these two work hand in hand. We already know that Git is a version control tool that will allow you to perform all kinds of operations to fetch data from the central server or push data to it, whereas GitHub is a code hosting platform for version control collaboration. GitHub is basically a company that allows you to host a central repository in a remote server. Now, without any further ado, let's get started with the demonstration on how to use GitHub. So for this demonstration, we're working on the website version of GitHub. There's another version of GitHub that is the desktop version, which you can download it to your personal computer. So we're simply going to search for GitHub in our search engine. The first link will lead you to the official website of GitHub. So I'm going to click on that. So this will redirect me to the main homepage of GitHub. As you can see, there is a search GitHub option. There are also two buttons that says sign in and sign up. If you're new to GitHub, you can simply enter in your credentials, that is a username, email, password, and sign up for GitHub. But if you already have an account like I do, I'm simply going to click on the sign in button and it'll redirect me to a page where I have to enter the credentials, that is my email address and password. I'm going to do that now and I'm going to click on the sign in button. Now, this is the main page of my account. As you can see, I have no repositories. It's all new, it's all fresh. But if you're not new to GitHub, you can view all of your repositories on the left-hand corner. Now, before we move on, I'm going to explain you all the features that are present within GitHub. So you can see a search bar here. So the search bar will allow you to look for profiles, certain keywords, look for different kinds of projects that are available on GitHub. All of those can be done using this bar here. And you can see 4 options next to the bar that says pull requests, issues, marketplace, explore. Pull requests we'll learn later on in this session, but the issues and marketplace we won't be discussing in this video for now. The explore button, on the other hand, is an extremely important and interesting button. So once I click on that, it'll redirect me to a page with some activities that are going on around in GitHub. You can see here they're trending repositories, they're trending developers. Basically, this is a feed that will allow you to interact with developers and other people, collaborators from all around the world, basically. In Instagram too, you have an explore button, which will allow you to interact with different people from all around the world. So the same concept is implied in the GitHub explore button too. So you can explore topics, you can explore trending repositories, developers. Basically, it's an interaction with other people from different parts of the world. So I hope that's clear. Now, the most important part of the session are the 3 buttons that are available in the right-hand corner of the navigation bar. So you can see there's a bell icon, there's a plus icon, there's a pixelated icon on the right-hand corner. So the bell icon allows you to read notifications of your activities that occur in GitHub. So that's what it really is. You can see the inbox will allow you to view all of the notifications. You can also view the unread notifications by clicking on this unread button. As of now, I don't have any notifications, so there's nothing available. You can also group these notifications by the date or repository by clicking on this group by button here. You can also view your saved notifications by clicking on here. And the done button, on the other hand, will let you mark all of your notifications that you're done with, your previous notifications. So these are the 3 important buttons you'll have to know in this bell icon. And the filters are not necessary as of now, so I'm not going to discuss that. This button, on the other hand, will allow you to manage your notification settings and your subscriptions too. So that's all for this bell icon. The next important button is this plus icon. As you can see, there are 5 drop-down options that appear here. The first one being new repository, followed by import repository, new gist, new organization, new project. So new repository we've already discussed previously in this session. A repository is a place where you create your files for your project. It's basically a storage space, right? So your repository can directly interact with your Git, right? So the new repository option will allow you to make files, a repository to your GitHub account, right? The Git, on the other hand, the tool that which we use to make local repositories in our personal computer can be directly pushed on. The local repositories can directly be pushed onto your GitHub account. So that's what the new repository button allows you to do so. But the new project, on the other hand, is a place to track issues, features, and other tasks that are related to the code within the repository. You can also connect with the DevOps build and deploy process, assign people to tasks, and so on by using this button. That is the new project button. So the difference between the new repository button and the new project button is that projects in GitHub are only a part of GitHub, but not Git. But the new repository option is a part of GitHub and Git. So that's the main difference between new repository and new project. I hope that's clear. So the next button will drop me down some interactions that I can make with my profile. So if I click on this your profile option, it will redirect me to a page where I can edit my profile. I can really create my identity using this page. So here, if I click the edit profile, I can add a bio about myself. I can add the company in which I'm working in, the location at where I am, the website, Twitter username, etc. All of that I can add here, all of the information about myself. I can also view the repositories I'm working on currently, or the repositories I've worked in the past, projects that I'm working on, the packages, and the entire contributions I've been making on GitHub from the last year. So basically, it allows me to build an identity, or it'll help me build my profile on GitHub. So I hope that's clear. Now, if I click on this button and if I want to sign out from a profile, I can simply scroll down and click on the sign out button here, and this will sign me out of my account. So that's all for getting started with GitHub. These are the basics on what GitHub is and what each of the button and options really do. Now, if I want to move back to the main page of my GitHub profile, I can simply click on this Octocat. That's GitHub's logo. So I'm just going to click on this Octocat logo, and here I'm back to my main page. Now, before we move on and work on the different operations and options within GitHub and learn different things about GitHub, I'm going to give you a brief overview on how to download the desktop version of GitHub. So I'm simply going to search for GitHub Desktop on my search engine, and I'm going to click on the first link that's available on this page. Now I can simply click on this button that says download for Windows 64-bit. That's compatible to my current version of my personal computer. If you have a Mac, you can simply click on the Mac version and download it to your desktop. But as I've already mentioned previously that we're going to work on the website version, so I'm going to simply switch back to this. Now let's quickly move on to the next part of the session. Create a repository. So firstly, let us understand what a repository is. It is simply a storage space for the correct project that you're working on. GitHub is a very popular central repository that allows you to share your files, whereas Git allows you to create local repositories that are present on the system you are working on. So you can basically push your local repository into GitHub and share it with other collaborators via the central one. Now that we know what a repository is and how it works, let's go on to the demonstration part and create our first repository. So you can do this in 2 ways. Either you can click on your create repository button that is present on the left side, or you can, as I've already mentioned in the previous part of the session, you can click on to this plus icon and you can click on the new repository option. So this will redirect you to a page that says create a new repository. You can add your repository name. I'm going to name my repository as Edureka, and it's available. All of your repository names must be unique from one another to identify them easily. You can also add a description, which is optional. I'm just going to add the description. This is my first repository. And a description allows people or other collaborators to understand what your repository is all about. But as a good developer or a good programmer, you would definitely want to add a description and give an overview of what your repository is all about. There are two options now available that says private or public. Now you can choose your repository to either be public or private. So the private one lets you decide who can access your profile, whereas the public one lets anyone view and access your repository, but you can choose who can commit to it. That's the difference between public and private repository. I'm going to let my repository be public as of now. Now, if you scroll down, you can see that you can initialize your repository with three options. The first one being add a README file. The second one being add a git ignore file. You can always choose add a README text file to your project, which often contains information about the project and other necessary details the user must be aware of when he or she is accessing that particular project. Now, I want a README file for my repository, so I'm going to click on this button here. That's going to check it. The next option is add a .git ignore file. So this file will let you ignore a list of files when the user is pushing files to GitHub. That's what this option really does, but I'm going to let this be unchecked for now. For your repository to truly be open source, you will need to license it, so others are free to use, change, and distribute the software. You can simply click on choose a license option and pick the required license for your project. There are several licenses like MIT, GPL, Apache License 2.0, BSD, etc. But for this repository, we don't really need a license, so I'm going to untick this too. And now you can see there's a piece of information that says this will set master as the default branch, but I'm going to ignore this for now. I'm going to explain about branches later on in this session. So this is all you have to do to create your first new repository. You add a name, you choose a description, you add an optional description, you let your repository be either public or private, and you initialize your repository with either of these three options. And I'm simply going to click on my create repository option. Now this will redirect me to a page with all the information and the files that are currently present in my repository. You can see here my repository name is present here with the optional description that I gave, and the number of files. Currently we have only just one file, that's the readme text file, and that's present here. So this is all we have. Congratulations, you just created your first repository. Now you can see there are some options that says issues, pull requests, actions, projects, wiki, security, etc. We don't have to really talk about all of these right now. We will just learn about one option that says code here. So this is really important. If you click on this button, you can see that there's a link that is available here, an HTTPS link. So if you copy this link and paste it on your Git terminal that's present on your computer, you can download this entire project directly to your local system. So that's what the link is for. I hope that's clear. And the next option that says open with GitHub Desktop will allow you to open this entire repository in your GitHub Desktop version. And you can also, the last option that says download zip will allow you to download this entire repository in the form of zip files. So all of your project files will be within that zip file. So that's all you have to really know about your repository. And I'm going to click on the README text file that's available. It will take me to another page with some extra information about that file. You can see currently we have 2 lines and the memory space that is allocated to this file. So we currently have 2 lines, that is Edureka, and this is my first repository. And you can also see the number of contributors to this project. That is just one, that's just me for now. And you can view the history of the commits or the changes that have been performed in your file. So we'll come back to that part later on this session, but you can move back to your main page of this repository by clicking on the name button here. So Edureka is the name of my repository, so I'm going to click on that. So now I'm back to the main page of my repository. Before we learn how to create our first branch, let us understand what branches are. Branches allow you to work on other features that can be included and merged with the master branch if required. So what is the master branch? The master branch is the main branch where your project resides on. So all of the changes, all of the activities that you do with your main project lies or is on your default branch that is named as the master branch. So what really GitHub allows you to do is it allows you to create additional branches. So on these additional branches, you can work on the other features, or you can experiment with your project And if you're happy with this, you can simply merge these features to your main branch, that is your master branch. This is what branches are really for. So they simply allow you to work on other features. That's what branches are. So let's move on to the demonstration part and look at how we can create our own branches. So now if you look on the left corner, you can see a button that says master. So currently we're on the master branch, and there's only one branch, and the master branch, as I've already mentioned, is the default branch. So when you create a repository, you're automatically creating a master branch. So this is where your project will be residing on. And now if you want to create another branch, say let's name this branch 1 branch. So this is what I want to name my additional branch. I'm simply going to name it, and I'm going to click on the enter button. So it will redirect me to a page. So this is the exact replica of your master branch, and you can work on this branch. You can work on any other feature, or you can add something, you can remove something, you can really experiment on this branch. And if you're happy with this, you can merge back this feature or the experimentation that you've been working on to your master branch, right? So you can see there's a readme text file. It's exactly the same. There's the name of your repository, the description of the repository. You can click on the readme text file, and everything's the absolute same. You can quickly switch back to the main page. But the only difference is that you're currently on a branch named branch 1 branch. You're not on your master branch. Now, if you want to switch back to your master branch and work on it, you can click on this button and you'll find the master here. You can click on that and it will take you back to your master branch. Here you can work on your project. So there are currently 2 branches. You can see that, and everything's normal. Everything looks simple. That's all for branches. It's really easy. I hope it's clear. So you can look for branches here on this bar here that's present here. You can also create new ones in the same option. So that's all for branches. Let's move on to the next part of the session. Make a commit. Now, what are commits? Commits simply record changes to one or more files in your branches. So basically, they save the changes that you're making in your project. Git always assigns each commit a unique identification, which is called SHA, or hash, that identifies the specific changes. So for any changes are made to your project files, you can simply go back and look at the version history or the history of each commit you've performed on your project files. So that's what really commits are all about. It's extremely easy. Let's go ahead and make our first commit. Now I'm going to switch to my branch 1 branch and I'm going to make my first commit. I'm going to click on my readme text file. That's the only file currently in our repository. So we'll make the change in the readme text file. There are 3 really important icons that are present in the right corner, as you can see. The first one is a PC icon that says open this file in GitHub desktop. So if you click on this file, this entire file will open in your GitHub desktop version. The next one, that is the pencil icon, will allow me to edit this particular file. That is my readme text file. And the third icon is a bin icon, which will allow me to delete this file. Now, what we'll be working on is the pencil icon. That's the edit this file option. I'm going to click on this and I can simply view a space or a file that will allow me to make changes to my readme text file. I'm going to add another line here that says this is my first commit. This is what I want to add to my readme text file. And if I want to preview the changes, I'm going to click on this preview changes button. You can see that this is my first repository. This is my first commit. This is my first commit is the additional piece of information that we'll be adding to my readme text file. And it's highlighted in blue, so we know that that's the additional information. I'm happy with this change. I'm going to switch back to my edit file. I'm going to scroll down. And if I want to add a description about the change that I'm performing to my file, I can do that. A good programmer would always add a description to the change that he's making to the project file. So other collaborators, when they view the commit or they view the change, they can read the extended description and understand what the change is about. So that's a good habit that you must follow. But as of now, we're not going to do that. So I'm going to leave this blank. As you can see, there are 2 radio buttons that are currently available. The first one says commit directly to the branch 1 branch. This will allow me to make the change or save or make the commit directly to my branch 1 branch only. So the change that I'm making currently is only implemented to my branch 1 branch. The second option allows me to create a new branch for this particular commit and start a pull request. We're not going to talk much about this option right now, but the first option is extremely important. So we'll let this be stuck on to the option that says commit directly to the branch one branch. And I'm going to click on the commit changes options. And this will simply implement the entire change to the file. You can see that the change is implemented. The additional piece of line that says this is my first commit is added to my README text file. Now, the interesting part is if I switch to my master branch, the change is not implemented in my master branch. So the change is only currently present in my branch one branch. And now if I want to view the history of the changes that I've made, I've already mentioned in the previous part of the session that the history button will allow me to do so. So I'm going to click on this history button, and you can see that I made my first commit 23 minutes ago, and I made my new commit 41 seconds ago. And there is also a hash number, unique hash identification number, that allows me to distinguish between both of these changes. So all of my commits that I'll be making on this branch will be available here. So that's the main point of a version control system, isn't it? Understanding and keeping a record of all the changes that we're performing in our files and our projects. So this gives full justice to the word version control. So that is what GitHub is all about. Now that we learned how to make our first commit, let's move on to the next part of the session. Open and merge pull requests. So what are pull requests? Pull requests let you tell other developers about changes you've pushed to branch in a repository on GitHub. So once a pull request is open, you can acknowledge and review the changes with collaborators and add follow-up commits, after which your changes are merged into the base branch. So there are two ways to create a pull request. The first one being pull request from a forked repository, and the second one being pull request from a branch within a repository. Currently in this demo, we will work on the second one, that is pull request from a branch within a repository. Now I'm simply going to switch to my demo part. Okay, now currently I'm on my master branch. I'm going to click on this pull request option that's here. Now it says branch one has had recent pushes 3 minutes ago, compare and pull request. I'm not going to click on that. I'm going to simply click on the new pull request option here. So this will allow me to compare the changes. There's a base branch and a compare branch. The base branch is the master branch, and the compare branch, I will compare my master branch to my branch one branch. So this notification says that the merge between the branch one branch and master branch is definitely possible. So it's a green signal. So if I scroll down, I can view the difference between both the branches. So the left hand side indicates the information that is present on the master branch, and the right hand indicates the information that is present in my branch one branch. Plus sign indicates the additional information that is present in my branch one branch. I'm happy with this. So I'm simply going to scroll up and create the pull request. I'm going to click on that. I can also leave a comment and I can preview the change. That's not necessary for now. So I'm going to go ahead and create the pull request. Now this will redirect me to a page. So this page says that the pull request has been opened. And now I can choose to merge this pull request. That is, I can merge the branch one branch to my master branch. So it says this branch has no conflicts with the base branch. Merging can be performed automatically. And that's good news, right? So I'm going to click on merge pull request, and I'm going to confirm my merge, update my README text file. I'm happy with that, so I'm just going to confirm it. Now it says pull request successfully merged and closed. You're all set. The branch one branch can be safely deleted. I'm not going to delete the branch. I'm going to compare both of the branches and see if my master branch is exactly the same as my branch one branch. So I'm going to click on this Edureka. I'm going to go to my main page of my repository. So my master branch has the additional piece of information that says this is my first commit. Now if I switch to my branch one branch, it has the exact piece of information. So the information that was present in my branch one branch has been successfully implemented to my master branch. So that's all for the pull request part 2. We've reached the end of the demonstration part. Now let's quickly look at the case study of how Microsoft implemented GitHub. I'm pretty sure most of you have heard of Microsoft. Microsoft Corporation is an American multinational technology company. It develops, manufactures, licenses, supports, and sells different computer software, consumer electronics, personal computers, and other related services. So initially, Microsoft was against the use of the open source because they held very tightly to the Internet Protocol. They were completely hesitant to adapt to this new concept of sharing code to the entire world. But in 2010, they rethought this entire scenario, and now Microsoft is one of the biggest contributors to open source. Today, about 2,000 to 25,000 Microsoft engineers maintain TypeScript, .NET, Windows Terminal, DARP, Helm, and more than 1,000 other open source projects. So first what they did was they released new processes in measured containment. But later on, they released only licensed software. So here, developers can learn from the company's source code, but they couldn't really build on it. Eventually, the stigma died, and now even closed code like .NET is open source under an MIT license. Teams realize that they need to accept contributions to get feedback and learn from other developers. To organize and understand this approach, Microsoft created their Open Source Programs Office, which enables distribution and centralization of knowledge. So the OSPO provides the resources and maintainers to manage thousands of repositories and contributors effectively on GitHub. Even though Microsoft invests in its tools, they expect other individuals and organizations to lead the way. Microsoft believes that GitHub's value isn't in any one feature, but its entire community. GitHub is the place to collaborate, it's where everyone is, and where most of the entire world's open source is already happening. It's not just a feature, but the whole thing.
So guys, let's first talk about why we need continuous integration. Let's talk about a scenario where we are not using continuous integration. Now, when we work in a development team, there are multiple developers. Now, all the developers work on different components for a project or for a code. A developer A may be writing code thinking scenario, let's say Python 1.0, and developer B will be writing code thinking of a scenario 1.2, 1.3, and so on. One of the biggest challenges that we face in an industry is how to make sure that all the developers' codes get collaborated and that we are having properly released getting deployed. That is the biggest challenge in the industry. Now, another challenge that most developers fail is debugging. Now, whenever you write a code, there are a lot of bugs and issues. Now, the code is often written thousands and thousands of lines. Now, if you don't have any proper continuous integration mechanism or a packaging mechanism, you'll see it takes days, even weeks and months to debug your code to make it 100% bug-free. Now, that is a challenge that really makes the development process very slow. So, how to test the code? Now, testing used to be a monotonous task. Now, there are teams used to spend months of a life cycle to make the code, complete the test code, and make sure it's bug-free. Now, what used to happen is, guys, two things. One is you are not able to deliver on time, and secondly, business never see value coming out of the IT. If businesses see IT not adding value, IT is not delivering product on time, they will start rethinking and giving a second thought. Why do we need to invest so much money in the IT industry or in the IT software? These things were hampering big time in the development and release of modern day deployment software cycles. In the modern day world, we want to make sure our deployment cycles are robust, we're able to get the main need of the market and deploy the product as soon as possible. But with this approach, we're not using the CI tools. It used to take 6 months to develop a product, deploy a product, and make it bug-free. Now things change drastically when we start using continuous integration. Now, using continuous integration, we can deploy codes at the quickest. Amazon, for instance, deploys code every 11.6 seconds. Now, how is that possible if you ask? It's because they are using the continuous integration mechanism. Using CI tools like Jenkins, where we can automate the process like building, packaging, deployment, testing, and so on, so that we can do all these things with the click of a button in a matter of seconds. CI process helps us to deploy multiple releases parallelly. Now, in one day, we can do thousands and thousands of releases without impacting our environment and making sure these releases are in line with our requirement. The CI tool has an awesome notification mechanism where it notifies instantly of any success or failures happening, so that if I have to debug the code or troubleshoot it, I will know exactly at the pinpoint location where it is failing. You can do multiple notification management mechanism like an email and SMS, any ITSM tools. Now, all those modern ways of notification are possible using the CI tools like Jenkins. Now, we integrate these CI tools like Jenkins with modern day build and packaging tools like Maven and Gradle, so that we can automate the common problem which developers spend most of their time on. Now, developers spend half of their life cycle like packaging their code, code review, code deployment, unit testing, Now, all those things can be automated and can be done with the click of a button using these CI tools. Now, what is continuous integration? Now, we have talked about how it helps to save time, how it helps to save the energy, and how it helps to make release more frequent, and it helps us to streamline the process. Now, what actually is continuous integration? Now, if I go traditionally, continuous integration is basically, you can say, a process that helps us to combine or make smoothen the automation of tasks like compiling the code, doing the testing, and deploying the code into our life cycles. So how does this continuous integration work? So developers who works on projects generally commit their code in any version tools like GitHub, GitLab, Gitbucket, SVN, etc. So using continuous integration, we pull the code from the version control system like Git, for example. Now we automate the process like code compiling, code testing, code review, and then finally deploy the code in the lowest lifecycle environment. You can say continuous integration is sort of a development practice where developers pull the code from the version control system and make the code deploy in the lower lifecycle environment. Now, the beauty of using these CI tool is we can automate the process in such a way that whenever developers make a new commit or a new change in the version control system tools, we can create a sort of a pipeline, and the pipeline automatically picks the code from the VCS tools and compile it and then deploy the software. Another good thing about it is it does not require any human intervention. So once I have set up a pipeline, then I don't need to worry about running the code again and again or making any changes. It automatically happens in a fully automated process, as I mentioned a while back. Now we can use the process whenever a new commit happens, or you can run it on a scheduled basis or something. Now CI, or continuous integration, was first time proposed in 1991 as part of the extreme program concept. At that time, it was not adopted so well, but in the modern day industry, it has become the bread and butter of smoothing up release or for our development process. In a modern day world, continuous integration can be said as a practice of merging all developers, working copy to a mainstream where you can develop and deploy the code multiple times in the same day with as many changes as possible. Now, there is no limit of how many lines of code. It can be tens and thousands of lines of code, which can be compiled multiple times throughout the duration. Let's see a case study where we try to see how things change for an organization after it adopted to the CI, or continuous integration mode. Here we have picked up an example of Adobe to see how it helped in the development process. Adobe realized at some point at the time that they have not released very frequently. When this happened, their market percentage share was down as they were not following the continuous integration approach. Now they were using the native method of compiling the code, debugging the code, testing the code, because of which they were noticing that it used to take up to 6 months release updates. Now 6 months was a long duration, whereas their competitors were releasing very frequently, which was helping them to capture the market share. Adobe decided some point at a time that they need to change their software development and deployment strategies, and they tried to adopt the continuous integration mechanism. Once they adopted the continuous integration mechanism, they found that the response time was a lot better and a lot faster. Now they were able to deploy the updates more frequently with every time a change was made by a developer or new release was being released. And it helped them reduce the response times, and they were 60% more faster. The development teams were getting more effective, and they were able to really deploy losses far more in a better and structured way than what they were doing without using CI. You can see how CI helps industry. Amazon is the best case scenario. Amazon in modern day scenario deploy codes every 11.6 seconds, almost 5 times every minute. Now this is all possible using the continuous integration. Now what is Jenkins? Now we've talked about what is CI, we've talked about why we need CI. Now let's talk about what is Jenkins and how does Jenkins fit in this particular picture. Now Jenkins is an open source automation server which helps us to automate the process of development relating to testing, deployment packaging, and others. It is a server-based system that run on software, Apache Tomcat. Now it supports VCS store like Git, Bitbucket, etc. It also supports build automation tools like Apache, Maven, and it helps to make and facilitate our continuous integration and continuous delivery process. Now Jenkins was first released in the year 2011, and it's completely open source software as a part of the MIT license. Jenkins is a plugin based profile. In Jenkins, you have got plugin, which basically used to interact with different tools and components. In Jenkins, plugins are primarily released in language other than Java. Plugins are available to integrate Jenkins with most version control system tools and most databases. Using these plugins, we set up purposes, for example, unit testing. Now you can do compiling, you can do packaging. Now you can create some reports. Now you can do some logging. Now all these things are possible using plugins and Jenkins. Another important component that we've talked about in Jenkins, apart from plugins, is Jenkins notification, which we call it as Mailer. Using Mailer, guys, we can configure email notification. For instance, you can configure scenario. For example, you want mail notification when build is successful. Now, all these things can be done using Mailer as the Jenkins component. Another important component in Jenkins is the SSH agent. Jenkins also follow a typical master-slave topology. Now, why do we need a master-slave topology and a CI tools like Jenkins? Now, when you work in the organization, we have got multiple teams which you want to build and deploy their own pipeline or deploy their own software project codes. Now, teams don't want the piece of code to be run on a server which is owned by some other teams. So what we can do is we can set up a master-slave topology where Jenkins may run on a server X. But you can connect multiple other servers which will act as a slave. So when you are deploying a code executing a pipeline, you can run those codes on those XYZ servers. Now this is the beauty of using Jenkins master-slave topology. Now another good thing about Jenkins is Jenkins can be deployed on any operating system. In Jenkins, you can use in a Windows mode, a Linux mode, a Mac mode, or now all these Jenkins jobs can be deployed on any operating system. It is not at all dependent. Now both master and slave needs to be of the same operating system. Another important core component of Jenkins call is JavaDoc. This is our plugin in Jenkins, which basically is a part of Jenkins core that helps us to publish results like build action, build directory, what is the expected build output. All those things that we see in Jenkins, they all are happening using JavaDoc. Now let's talk about security injection. Apart from that, Jenkins have other sorts of authorization like project-based strategy, metric-based authorization, which help us to make Jenkins more secure. We'll talk more about this when we talk about the Jenkins overall. So as you can see on the diagram, Jenkins is pulling code from the source code control system like Git, Bitbucket, etc. To start deploying it in Jenkins, we have got a notification management system using Mailer, where if the build is successful, we get a WAR file or a zip file. We can define how we want the build to be created, and if it is a failure, it will send the notification management to a developer that something happened wrongly with the specific code lines and you need to rectify your codes. Now that is the beauty of using Jenkins. So Jenkins is still the bread and butter in the industry. There are some Jenkins competitors also in the market like GitLab Jenkins and some others. But by default, Jenkins is the to-go tool for the CI industry. So far we've talked about Jenkins. Now let's talk about what is pipelining in Jenkins. Now let's say I want to deploy a code. The code may have certain steps like first step, I'm building the code. Second step, I'm compiling, then code reviewing, then packaging, then deploying. So how do I automate a combine of all these steps which can be executed in one go? Now to deploy all this scenario, we have created a delivery pipeline. Now pipeline is nothing but it's a combination of different steps or different tasks that we need to perform in order to deploy our code. Now using a pipeline, instead of doing this task or code deployment manually, we combine them and deploy them as a sort of one common approach of a delivery pipeline. Now there are multiple ways on how you can create a pipeline. The two most common ways or common approaches of using a pipeline, as you can see from scenario, a declarative approach. And the second one that is used in the industry is a scripted approach. This particular is an example of a Jenkins pipeline script. Here you are saying we are first doing a stage called build stage, where we will be combining multiple tasks. Like first we are using Java, then we are printing something called echo hello pipeline. Then we are using Maven as the build automation tool and try to deploy a package. And then we are doing a shell script output of what all things are present in that particular directory structure. This is a typical example of syntax of how to create a pipeline in Jenkins. Now let's talk about the two predominant pipelines that are used in the IT industry, scripted and declarative. Now let's talk about what is scripted and declarative and how they are different from each other. A scripted pipeline is a traditional Jenkins pipeline approach, and a declarative pipeline is a modern day pipeline approach that is used in the industry. In a scripted pipeline, the syntax was first strict, while in declarative pipeline we use something called as groovy syntax. When you use a declarative pipeline, you can get a code from any version system tool like Git, you can create something called as Jenkins file. And you can download Jenkins file from a virtual constant tool, and that can be used to run your Jenkins code. When you use a scripted pipeline, you define a code something called as a node block. But one declarative pipeline will define a code in a pipeline block, as we can see in the previous example. Now let's talk about what is Jenkins file and how it can be used. Now Jenkins file are like a text file where you define your entire structure and syntax of your Jenkins. You know only how to download the file, and in particular, you can just give the part of your Git repo. If it is true, then get the credential, the private repo, and it can pull all the contents from there and just execute your code. It is a modern deployment mechanism that we use when we work with a Jenkins pipeline. Using Jenkins pipeline, we use certain things which help us. Let's talk about this. First is code review. Now you do a Jenkins pipeline, you can easily review your code. Your code can be reviewed by multiple developers before being executed. Now how that works is, in Jenkins file, they are stored generally in a version control tool like Git. You can put something called as a pull request for a code review. Now different members of your team can review the code before you actually pull the Jenkins file and deploy it. Now you can do an audit trail, or refer to as a long audit. You can log each and every step's output that is being executed as part of the Jenkins file, and can see what is happening when the Jenkins file is getting executed. It's sort of like a verbose log. Then you can find a single place to store all your data or all your outputs. You don't need to have developers scattered here and there and writing their own codes for executing a Jenkins pipeline. Whole organization can approach a Jenkins file methodology where code can be stored in a VCS tools, and from there the code can be downloaded and can work as a single source for your entire pipeline. Now let's talk about the Jenkins workflow in particular. How does Jenkins workflow work? Jenkins workflow always start with a version control system, or you can say a source code repository. Multiple developers collaborate and they put their code in a source code system like Git, from where Jenkins try to pull the data from that source control system. For your system, there is no mandatory or the source code needs to be Git. It can be Bitbucket, SVN, whatever your organization uses with Jenkins server. Now we execute tasks like build, deploy, compiling, packaging, code reviewing. Now all these things happen using Jenkins server, where your Jenkins actually installed was running. Now Jenkins server can be any operating system. It can be a Windows machine, Ubuntu machine, Linux machine, or a Mac as well. It can be any operating system of today's modern world availability. Using this Jenkins server will execute our different tasks and scenarios. In Jenkins server, we use the mail functionality for the feedback mechanism. We notify developers the commit or the code deployment successfully or it is a failure. It also has some challenges. Now what can be done using the feedback mechanism? Possibly using the Jenkins server. So using Jenkins server, we always first deploy the code on a lower lifecycle environment. That is recommended standard practice. So what we do is we first deploy a QA server on a testing server, and once the code deployment is successful on the lower lifecycle, then we go ahead and deploy the code on a production server. That is how the entire Jenkins workflow, mainly particular, interact first. Now guys, let's talk about the Jenkins installation and how to install Jenkins in a machine. As you all know, Jenkins by default run on 8080. So please make sure that if you're using any VMs in your organization, the port 8080 firewall settings are open and configured so that it can be accessible. I will get into some of the prerequisites required for installing Jenkins post, which will go ahead and install Jenkins on a Windows box. Now there are a few first configuration that needs to be done, and I'll be covering those as well. So once I have Jenkins installed and configured properly, I will get into the user administrative part, then create few users, and I will get into some of the plugins for setting up various kinds of access permissions for these users, and I also put in some of the freestyle jobs. Freestyle job is basically nothing but a very simple job, and I will also show you the powerfulness of Jenkins by scheduling this particular job to run based upon time schedule. Then I will also connect Jenkins with GitHub. Now GitHub is a source code repository where I've got some repositories put up there. So using Jenkins, I will connect to GitHub, pull up a repository that is existing on GitHub onto the Jenkins box, and then run a few commands to build this particular repository that is pulled from the Jenkins sending out emails. Now it's a very important configuration of Jenkins or any other continuous integration server for that particular matter. Now, whenever there is any notification that has been sent as a part of AWS, going bad, or by being good or building propagate to some environment, and all these scenarios, now you will need the country's integration servers to be sending out notification. So I will get into the bit of details of how to configure the Jenkins for sending out emails. Now, I will also get into the scenario where I will have a web application such as a Maven-based Java web application, which will be pulled from the GitHub repository, and I will deploy it into the Tomcat server. Now, the Tomcat server will be locally running on my system. Eventually, I will get into the other very important topic, which is the master-slave configuration. It's a very important and pretty interesting topics where distributed builds is achieved using a master-slave configuration. Now, all this can be very easily based up using a plugin. So this is what I'm going to be covering as a part of this tutorial. Now, Jenkins is a web application that is written in Java, and there are various ways in which you can use and install Jenkins. Now, I've listed the popular three mechanisms in which Jenkins is usually installed in any system. Now, the topmost one is a window or a Linux-based services. So if at all you have a window like the way I have, and I'm going to use this mechanism for this demo, so I will download the MSI installer. So whenever you start as a service, it goes out and nicely install all that is required for my Jenkins, and I have a service that can be started or stopped based upon my needs. Any flavors of Linux is one of many other ways of running Jenkins in downloading this generic WAR file, and as long as you have a JDK installed. You can launch this WAR file by the command opening up a command box prompt, or shell prompt defer to later on Linux box specifying jar and the name of this WAR file, typically bringing up your web application, and you can continue with your installation. Now, the only thing being, if at all you want to stop using Jenkins, you just go ahead and close this prompt, even into a control C, and then bringing down Jenkins. And then you also have the other older versions of Jenkins where run popularly using this way, in which you already have a Java based web server running up and running. So you kind of drop in this WAR file into the root folders or the HTTP root folder of your web server. So Jenkins will explore and kind of bring up your application. All user credentials or user administration is all taken care by the Apache or the Tomcat server, or the web server on which the Jenkins is running. This was a very old way of running, but still some people use it because if they don't want to maintain two servers, now if they already have a Java web service which is being nicely maintained and backup, now Jenkins can't run a test to it, alright? So either ways, it doesn't matter however you're going to bring up your Jenkins instance, the way we're going to operate Jenkins is all going to be very same or similar, but the subtle change in terms of user administration. Now, if at all you're launching it through any other web server, which will take care of the user administration, otherwise all the command or all the configuration or the way in which I'm going to run this demo is going to be same across any of these installation. All right. As I mentioned earlier, Jenkins is nothing but a simple web application that is run in Java. So all that is needed is Java, preferably JDK 11 or 17, with a 2 GB RAM, which is a meant RAM for running the Jenkins. And also, like any other open source tool sets, when you install JDK, ensure that you set in the environment variables. Now, Java home to point in the right directory. Now, this is something very specific to JDK. Now, but for any other open source tools that I've installed, there is always a preferred environment variable that we got to set, in which is specific to that particular tools that if you're going to use. This is a generic thing that there is for you to know. Now, for any other open source project, because the open source project discover themselves by using the environment variables. So as a general practice or a good practice, always set these environment variables according. So I already have a JDK 17 installed on my system, but in case you do not, what I will recommend is just navigate to the browser, to the Oracle homepage, just type in your search for install JDK page, then you'll have the accept the license agreement. Now what I will recommend is just navigate on your browser to the Oracle homepage and just type in your search install JDK. Now you're gonna navigate install the 64 installer, that is the .exe. Now let me show you what I've done with regards to the path. So if you get into these environment variable, so I have just set in the Java home variable. Now you can go back to your this PC, go to C programs, go to Java, and then copy this part, then click in the variables. I'll select the first one, that is the edit the system environment variable. and we click on the environment variables, and we'll set a path here. As you can see here, Java home, and we'll go down here on the path. So this is the path for your Java home screen. So simply click on edit and click on new, and we will just paste the path which we have just copied from the install.exe Java. So I've already installed it. As you can see there, C program files. I simply click on OK. So the only difference between the system variables and the user variables for daemon is this is control the whole system of the JDK, the system variable. So we want to edit in the system variables. So the path I've been changing here is in the system variables. All right. Now the home variable is where I have the SQLs and program friend of the JDK 17. Now you see this is my Java home. All right. Now one thing to do is ensure that in case you run Java or Java C, for a command, you ensure that you also add the path into this path variable, right? So if you see somewhere, I will say there you got the colon program files. Now you click on that, and I'll show you the bin as well, which I've copied and pasted here as well. Okay, so simply just go back. So that's how you get the bin. Copy this path and paste it here, which I've already done it. So I'll just simply click on OK, OK, and OK. Now let me minimize the screen as well. So the next thing we need to do now is go to CMD to check if your Java has been installed on your system. So you simply type on Java /version, and you can see I already have Java version 17.0.5 installed in my system and is up and running. So as you can see the runtime environments, and this is a 64-bit server. This is a VM, virtual machine. Okay, so as you can see, Java is installed in my system and is up and ready. So the next thing we need to do now is install Jenkins. I'm just canceling that and open a new browser again, new tab, and type in jenkins.io. Now, as you can see, this is the homepage of Jenkins, right? So you can even read the documentation, or you can simply click on download. Will take you to this page. Now here you can see the hardware and software requirements, then what packaging is required for downloading the installing Jenkins. So this is the part for, on the left hand side we have the LTS, and on the other side we have the, which is a more stable, and on the right hand side we have the regular weekly releases. So we'll definitely go for the stable LTS download, which is a long-term support, which is released every 12 weeks, whereas the regular releases changes weekly. So I'll be going ahead and scroll down and click on window. So as you can see, there are different parameters where you can have on Dockers, then you have Ubuntu, then you have the CentOS, Fedora, or the Windows, like I'm going to install in this case in this demo. Then but we have different aspects as well, like the FreeBSD, the CentOS, macOS, etc. So as you can see on the first stop, we have the .var. We can even install that and unzip that. But in this case, in this demo part, we'll simply click on Windows. So go on ahead and click Window, guys. Now you can see the download has started. So we just wait a few seconds until it's done installing the MSI. And as you can see, it's done. So this is my downloaded Jenkins instance. So what I'll be doing now is simply click on Next. Now, as you can see, guys, on top here, it's written the Jenkins run on localhost 8080. So keeping that in mind, click on Next. As you can see, this is where our Jenkins is installed. That is in C and program files and by the name Jenkins. So you can always change this location where the Jenkins has been installed. But in this case, I'll rather keep it on the C drive itself. So the next thing you need to do now is we'll run server as a local system so that we don't have to put any administrator or the password. And so the next step now is we test the port. So as you can see, you got a green tick mark. So we'll click on next. Now you can see here that it has failed because there is no compatible Java version 11 or 17. But as you can remember, guys, we have already installed Java 17 and we have already verified that we're using the command prompt where it has shown us the version Java 17. So what you need to do is simply click on change and select the Java 17 from Java 8. So simply click on Java 17, JDK 17, as you can see, click on next and click on the install part. Done and dusted. So I've already told you that Jenkins run on the localhost 8080, right? So we're gonna go localhost :8080 and hit on enter. Now, as you can see, please wait while Jenkins is getting ready for work, right? So this will take a few minutes, and then you'll be having to provide the credential of the administrator. All right. So just give it a few minutes while it's starting up. All right. Now you have to provide the administrator password, right? So you can go ahead and go down out here. You can see the password is in the C and goes to the program data, then Jenkins. Then we have a .Jenkins, then a secret, then you'll find the initial admin password. So we need to head out there. So what we need to do is we'll go down there. So I'm just going to minimize the screen now, minimize it once again. And as you remember, we go to the C. So you can see right where it is. I'll just show you, minimize the screen here so you can see and do it along with me. So you can see this in PC, then scroll down to C disk. Okay, this thing popped out, sorry. It's in this, so you have a program data, right? As you can see here down, there is no program data, right? So what you need to do is it's in the hidden file. So what you need is click on the three buttons and view, click on show and click on the hidden items. Now let's see if it's there. Scroll down, program data, you can see at the last. Yeah, simply click on that, double click on it. As you can see, then we have to go to the folder name as Jenkins. Yeah, you can see on the top, Jenkins and .Jenkins. Then we need to search for secrets. There it is, folder. And as you can see, there's an initial admin password. Now you simply click on that. We'll try with the notepad so we can copy. So simply copy that and paste it in the administrator password and click on continue. So in this case, I will not save it in my computer or system. So there are two installation plugins available, which is custom by Jenkins. One is they have suggested plugins, and the other one is you can select the plugins which you want to be installed. So in this scenario, I'll simply click on the install suggested by the Jenkins. So what happened is the plugins are all related to each other. So it's like the typical RPM kind of a problem where you try to install some plugins and got a dependency which is not installed, and you get all those issues. In order to get rid of that, what Jenkins recommends is that there are a bunch of plugins that is already recommended and they are good to go, right? So just go ahead and blindly click on that recommended by the plugins, which is a suggested or custom by the Jenkins. And as you can see, the getting started process is going ahead. So it'll take a few minutes depending on your internet speed or on the system. Now you can see all these plugins are installing it for you. So it will take a few minutes time. So let's just wait till we get all the plugins installed in a system properly. So this is a good combination to kind of begin with, and keeping that in mind, Jenkins need a lot of bandwidth, right? Now in terms of network, so in case you know your network is not so good, it'll make for a few of these plugins will kind of fail, and these plugins are all are available on openly or mirrored site, and sometimes some of them may be down. So do not worry, in case some of these plugin kind of fail to install, you get an options to kind of retry installing them, but just ensure that you at least at the most 90 to 95% of all of these plugins are installed without any problem. As you can see, we are almost there. It's around 60% to 70%. Now once all these plugins are installed, now my plugin in the installation is all good. There's no failure in any of the plugin. So after that, we've got to create this first username, that is the first admin user. So you need to give in the username, then the password, then you have to confirm your password, give it your full name and your email address, right? So we'll start it by giving the username. I'll keep it plain and simple. Now you got to remember these password and the confirm password, because if you kind of lose or you don't remember the password of the Jenkins, it'll be really hard to get back your account. So try to keep it as simple as possible, and keeping in mind that you have to remember the password, because getting back this account will be really difficult. All right, so I'll be putting the password as well. Give it my full name. Okay, my A is small, and go to the email address damandla.namare@edureka.co. All right, so once it's all done, so just simply click on save and continue. So click on never, don't want to save the password. And as you remember, I've told you by default Jenkins run on localhost 8080, right? So you can simply click this, or you can copy this, or just write save and finish. You can even copy this link, save and finish. Now start using Jenkins. All right, now that's kind of complete my Jenkins installation. As you can see, it was not that tough at all. Now the Jenkins is installed correctly. Now let me quickly walk you through some of the very minimal configuration that is required. Now these are kind of the first time configuration that is required. So, and also let me warn you, the UI is a little hard for many people to wrap their head around, especially the window guys. But if you're all a Java guys, you know how painful it is to write UI in Java. You kind of appreciate how the effort that has gone into the UI bottom line. It was a little hard to know wrap your head around. It becomes like start using it, possibly you start liking it all right. So I will get into some of these important ones, something called as configuration system, or the configuration a system. This is something kind of put in your configuration to complete your Jenkins instance. Now few things to kind of look out for. This is the home. Now configure system is where you kind of put in the configuration for your complete Jenkins instance. Now a few things to keep a lookout is the home directory. All right, now this is a Java home where all the configuration, all the workspace, anything and everything regarding Jenkins is stored out here in the system message. Now in the system message, you can put in some of the message on the system. You can just type anything you want, probably show up somewhere here on the menu. Now the number of executors is a very important configuration. This just lets Jenkins know at any point in time how many jobs or how many threads can be run. So you can kind of visualize like a thread that can be run on this particular instance. As a thumb rule, if at all you're on a single core system, the number of executor you should be good enough in case at any point if there is any multiple jobs that kind of get triggered at the same time. Now in case the number of executor are less compared to the number of jobs that are out there to open up the new, so you don't need to panic because they will get queued up and eventually Jenkins will be get up and running. So just keep that in mind that whenever a new job kind of gets triggered in the CPU usage and the memory usage, in terms of the disk, it's like a very high of the Jenkins instance. So that's something you got to keep in mind. All right. The number of executors for my system is kind of a good label. For my Jenkins, I don't want any of these usage. So how do you want to use your Jenkins? This is good for me because I only have a primary server that is running. So I want to use this as low as possible. All right. As you can see, it's 2. Now this is usage. So I can leave everything to default. So what I want is I want this SMTP server configuration. Now Jenkins will be sending out some emails. What I've done here is I've configured the SMTP details of my personal email details. In case you are, in your organization, you want some sort of an email that is like an email ID that is set up for a Jenkins server. So you can specify the SMTP server details of your company so that you can authorize Jenkins to kind of like send out emails. But in case you want to try it out, like I have configured my personal email ID, which is of the Gmail for sending out notification for the same TP server, will be the SMTP Gmail. So it's right as username as so we have used SMTP authentication and then we given the password. Now you can just send out an email to see if at all this configuration works again. Now Gmail will not allow you to allow anybody to send out notification on your behalf. So you just have to lower the security level of your Gmail ID so that you can allow programmatically somebody to send out email notification on your behalf. So I've already done that. So let's see if this works. Let's test this again since I've entered the wrong password. Let's see if this works or not. And it has given me a password has not accepted. So now as you can see, since my Gmail has not been set up, so what you have to do is you have to lower your security level of your Gmail ID so that you can be allowed to test your email configuration. All right. So simply click on save. So now we're heading back to the dashboard. Now we should go to the global tool configuration. Now look at the scenario where Jenkins is a continuous integration server. Now it does not know what kind of a code base it's going to pull and what kind of tool says is required or what is the code that is going to pull in and how it is going to build. So you'll have to put in all the tools that is required for building the appropriate kind of code that you're going to pull in. from, like a source code repository. So for example, in case your source code is a Java code, and assuming that you have, because this demo, this is my laptop and I put all the configuration, JDK, everything on my laptop because I am a developer and I'm working on the laptop, but my country's integration servers will be known as a separate server without anything being installed on it. So in case I want Jenkins to, like run on a Java code, and I need to specify the JDK location of this out there. So, okay. Since I've already have the JDK installed and have already put in the Java home directly, or rather and the environment correctly, so I don't need to do it. So now if at all you want the Jenkins server to use Git, now as you know that Git is a command bash or the command prompt for running Git and connecting to any other Git server. So you will need Git to be installed on that particular system. Now Gradle and Maven, if at all you have some Maven as you want to do this and any other tools that you're going to install on your system, which is your continuous integration server. So you'll have to come in here and try to configure it. And in case you have not configured, then Jenkins will not be able to find these tools for building your task. So since I don't want to install anything, we'll go back to manage system. Now you can see the configure global security. Now you can see this an SSH server. Now what does this mean if you ask me? Jenkins own user database. So this is nothing but the security access control which is set to Jenkins own user database. So what this mean is, Jenkins by default, it uses files system where it stores all the usernames, which hashes up like these username that kind of stores them as of it. So as of now, Jenkins is configured to use in your own database, assuming that you're running in an organization. So you will probably want to, have some sort of LDAP server, which will in turn have a control of your access to your Jenkins repository. So you will specify your LDAP server details, the root TN password or the managed TN. So the LDAP, as you can see, or the LDAP, which the Jenkins itself will tune in for your specific servers. Now you have the manager DN, the manager password. Now all these should be filled, all these details should be filled in case you want to connect your Jenkins instance with your LDAP server or any of the authentication server that you have in your organization. But for now, since I don't have any of these things, I'm going to use its own database. That's good enough, right? So I'll simply the Jenkins own user database. So I will set up some authorization methods. So for now, let me not get into any of these details of this. Just be aware that Jenkins can be connected for authorization to an LDAP server, or you can have Jenkins managing its own server, which is happening as of now. Let me put in a very, very simple job. All right, so let's create a new job in this video. So simply click on new item. Now simply you can add any item name here. So the most important here are the freestyle and pipeline. Now for the first demo, we'll click on the freestyle job and click on OK. So in the description, you can write anything in your description. This is an optional thing. So you can say this is my first job demo for. So in this demo, I don't want it to connect it to any source code for now. So I'm just going to leave it to none. Now we don't need to write any build environment as well. Now in this build step, we simply click on execute Windows on. So since I'm on the window box, I will say execute window bash command. All right. So what do you want to do? So let me just echo something. Echo hello world. This is hello. Welcome to my first demo job in Edureka. Then we'll specify the date and time as well. So put in date, colon as time as well. So you can see it's a very, very simple command. You just have to put an echo and we have something along with the date and time. So we'll keep everything as simple as possible. So we'll save this job. So once it is shipped, so you can see there's a build history. So once you have saved this job, the job name comes up here. As you can see, project first job. By mistakenly, I've written double T in my first job. Now, as you'll see here, there's some builds history. So there is nothing as of now because I've put in a job. I have not yet run it. All right. So let me try and build it now. Now you can see there's a number, my first job. So you will see a date and you will see the time since I've clicked twice. So if I've come 1 and 2. Now if you click on this, now you can see the console output. Now if you click on this, now you can see it. And this is the output that is run. Hello, welcome to my first demo job in Edureka, along with the date and along with the time. Now if you see this, now if we navigate this, we go back to here. Now, as you can see, there's a folder created as jobs, right? So this is the directory what I was mentioning earlier regarding Jenkins home. If you can just open it up wider, you can see this folder jobs. So this as mentioned earlier regarding Jenkins home. So all the job related stuff, it's specific to this particular Jenkins installation is all here. Now all the plugins that I install, the details in each of those plugins can be found here, right? So the workspace is where the jobs that I've created, whichever I'm running would, there'll be an individual folder specific to the jobs that has been put up there. All right. So one job, one quick run. That is how it looks like. So the workspace is where all the jobs that I've created, whichever I'm running, would, there'll be an individual folder specific to that jobs that has been made up. All right. So as you can see, there's the first job that we have just created just now. So one job, one quick run that we have done. That is how it's look like. It's pretty simple. Now let's go back. So let us put on a second job. So we can go back to dashboard, click on new items and say second job. Let's get the spelling correct this time. Second, I wrote second first again. Second job, and I can put a semicolon here, underscore. Second job. We click on freestyle again. Click on OK, and you can say this is my second. So I just want to demonstrate the powerfulness of the automation server and how simple it is to automate a job that is put on the Jenkins, which will be triggered automatically. Now remember what I've said earlier about Jenkins, because at the core of Jenkins is a very, very powerful automation server. All right, this is my second job. This is my second job, which will be triggered automatically. Okay, so in the build step, we'll put bash tabs, then we'll write here echo again. So we'll say here something as second job is going on here. The tools, with the tools of an automation tool. And then I'll give some date as well. Date, put on the time. But this time I'm going to demonstrate the powerfulness of the automation server that is there. So if you see here, there is a build trigger. So build can be triggered using various triggers that is there. So you'll get into the GitHub trigger or a hook or a webhook, which is kind of triggering. So we'll see that later on. But for now, what I want to do is I want to ensure that this job that I'm going to put in will be automatically triggered. Let's say every minute I'm on this job to be run on its own. So we'll put as build periodically and we will set the time. Now, if you can see here, there's a bunch of help. If you want to go through it, and you can go through it. Let's just put out very, very simple regular expression for scheduling this job every minute. All right. So 5 star is all I'm going to put in. 1, 2, 3, 4, 5. Now let me save this. Let's go back. So when you build periodically, is now you can see here. Now we just copy that. And now how do we check if it gets triggered every 15 minutes? So I just don't do anything but wait for 15 minutes. And if everything goes well, Jenkins will automatically trigger my second job in 15 minutes. Now you can see here, it's still processing. So we have to wait for 15 minutes. Now we can go through all this command of the scheduling time. So you can see how many stars required for each minute or for each hour. Now as you can see, it's done. You can just go and go here and go to console output. Now you can see the finish is success and you have this. Now we can go back and copy this and see if they're on your it's already there. You can go to workspace. You can see your second job has also been created automatically by Jenkins. Now that I have my Jenkins up and running, a few jobs that have been put up here on my Jenkins instance, I will need a way of controlling access to my Jenkins server. This is where I will use a plugin called a role-based access plugin and create a few rules. The rules are something like a global rule and a project rules for a specific role. I can have different rules and I can have users who have signed up, or the users from my create kind of assign to these roles so that each of these users fall into some category. This is my way of kind of controlling access to my Jenkins instance and ensuring that people don't do something unwanted. All right. So first thing first, let me go ahead and install a plugin for doing that. So we get into manage Jenkins, then we go to manage plugins. We will plugins, install plugins. We have advanced settings. So these are the available plugins, and then if you go to install, these are the installed plugins. Now let's go and search for a role-based. Now you can see here, base authorization strategy. So this will happen is it enables user authorization using a role-based strategy. Now roles can be defined globally or for particular jobs or nodes selected by a regular expression. This is the plugins, everyone. So you will install it without restart. So it's success. It looks good. Looks good. Now waiting for this. Yeah, success. Done now. So go back to the top page. Now one thing to remember, guys, is Jenkins is running on a Java using a Java instance. So typically many things will work the same way unless inherently you want it to restart. So, but a good practice is whenever you do some sort of a big installation or a big patches on your Jenkins instance, just ensure that you can restart it. Otherwise, there will be a difference in terms of what is installed in the system and what is there on the file system. So you'll need to flush out few of those settings later on. But for now, these are very small plugins. So this will run without any problem. But otherwise, if at all there are some plugins which they will need to restart, you can kindly go ahead and restart your Jenkins instance. But for now, I don't need that. So it looks good. I have installed the plugins. So where do I see my plugins and install the plugins? Which is specific to the user control to the access control. Now let's go to the configure global security. Now we can go ahead and check the authorization. You can see here authorization, role-based strategy popping out here, right? As you can see, the role-based strategy has been installed and has been shown here. This is because of my installation of my role-based plugin. So this is what I would want to enable because I already have my own database set up, and for the authorization part in that sense that you can do what I'm going to install. I mean, I've already installed a role-based strategy, right? Now I'm going to enable that strategy. So we'll simply click on role-based strategy, okay, and click on save. So now I'm going to enable that strategy. All right, now I will say, okay, now I've installed the role-based access plugin. Now I will need to just set it up and check, I will go ahead and create some roles, and it shows that I've assigned users as per these roles. So let me go to manage the configuration, manage Jenkins, and let's see how we can create our roles. Not here as well. So we can do manage and assign roles for creating a roles. Okay. Now you'll only be able to see this once and only when you have installed those plugins. Now I've enabled the plugins. Now I've enabled the role-based access control as well. Now we'll go ahead and create some rules for this particular Jenkins instance. So first I will manage roles. So this is at a very high level, which is a global role. Now there are some role to add which you can add by yourself, some item roles for some projects or something. So let me create a role that's kind of visualized like a group. So we'll create our own called the developer. Typically the Jenkins instance or the CA instance are kind of owned up or controlled by a QA, guys. So that's why I'm creating a role called developer, and I'm adding this role at a global role. So I will add this here, and then I can click read as well. So we've given this administrator, right? So we add this. So as you can see here, you will see this develop a rule that there is each one of these options that you can hover here and sort of see what kind of permission you have given it to this developer role that you have just created. So you can read and write, then you can create some changes. We have given a permission as credential, which you can create. Then you can delete, then manage the domains. So this kind of help or the permission that they're giving it. So these are some kind of sort of a help for a permission specific. So you want to see it's like how it sounds a little different, but I will want to give you a very, very little permission for the developer. So from an administrative perspective, I just want him to have a read and write kind of a role credentials. Okay, let's read and write, and I can allow him to view as well. I don't want him to create agents or give him some delete. No, I don't want him to configure, build, provision, or connect or disconnect anything. So I'll just give him a read and a view. I don't even want him to have access to my workspace as well. So I'll just give him now for run. So I won't even give him the access to that. Now we can give view as well. I don't want him to delete. And what am I doing here is just creating a global rules for the developers. And I've given him a very, very limited roles in the sense that I don't want this developer to be able to run any agents, nor create jobs or build jobs or cancel jobs or configure jobs at the maximum. Right? So I just want him to read that is already put up there. Okay, so I will save now and create a rule. That is done. Now that I've created a rule. Now I still don't have any users that is in there. the system. So let me go ahead and create some users on the system. So we'll go back to Manage Jenkins and go to Manage Users. Now let me create another user, okay, by clicking on plus users, and we'll say this one as a developer. Give him some password and name him as develop23. And email, you can just simply give my email here and click on create users. Okay, 1-2. So we have created. Now this developer 1-2 is a user that I've configured, but still yet I have not set any rules for this particular user. So I will go to the manage and gain and will give him the manage and assign roles. So now we'll go manage and assign roles and we'll assign role. So what you're gonna see, what I'm gonna do now is I'm gonna assign a role that is specific to that particular developer. So I'll find that particular user and assign him, or means the developer role that I've already configured the rules. Okay, so this is the role that we have created. So we will search the user that we have just created, developer 1-2. Now I've assigned this. So go ahead and save the changes. Now let's go ahead and check the permission of this particular user by logging on to my main account and logging back as the developer one. Now let's log out from here. Log out and say developer 1. Now if you remember, this role was created with very less privilege. So there you go, I have Jenkins, but I don't see a new item. I can't trigger a new jobs. I can't do anything. I see these jobs, however. I don't think I'll be able to start this job. Now I don't have the permission to set forth at the maximum. So what I can do is look at this job, see. So this is a limited role that was created and I've added this Damanang Lamare to that particular role, which was a developer role, so that the developers don't get to configure any of the jobs because the Jenkins instance is owned by a QA person. He doesn't want to give developer any ethnicity or right. So the rights that you set out by creating a developer roles, or any user who's tagged as a part of this developer role will get the same kind of permission. And these permission can be, fine grained. It can be a project specific permission as well. But for now, I just demonstrate the high level permission that I've set. So let me quickly log out of this user and get back to my admin account. So because I need to continue my demo with the developer roles that was created. Now, one of the reasons for Jenkins being so popular, as I mentioned earlier, is the bunch of plugins, but it's got plugin for connecting anything and everything. Now you can find the Jenkins plugins, then you will see the index over here. There are so many plugins that are there. All of these are wonderful plugins. Whatever connectors that you will need if you want to connect Jenkins to the AWS instance, or you want to connect Jenkins to a Docker instance, or any of those containers, you will have a plugin. You can go and search up if you want. If you want to connect Jenkins to Bitbucket, simply click on Big. So as you can see, these are available. So bottom line, Jenkins without plugin is nothing. So plugins is the heart of Jenkins for you to connect, or in order to connect Jenkins with any of the containers or any of the other sets of tools, you will need the plugins. Now, if you want to connect or you want to build a repository which has got Java and Melvin, you will need to install Maven and GTK on an instance. Now, if at all you're looking for a Microsoft build, you will need to have MS Build installed on your Jenkins instance, and the plugins that will be triggered MS Build. If at all you want to listen to some server-side webhooks from GitHub, you will need a GitHub specific plugins. You want to connect to Jenkins, to AWS, you need those plugins. Now, if you want to connect Docker instance that is running anywhere in the world, as long as you have the URL, which is publicly reachable, you just have a Docker plugin that is installed on your Jenkins instance. So if you want to connect to a Docker instance that is running anywhere in the world, as long as you have the URL which is publicly reachable, you just have a plugin that is installed on your Jenkins instance. Now, SonarQube is one of the popular statistic code analysis, so you can connect a Jenkins build. You can build a jobs on Jenkins and push it to a SonarQube and get SonarQube to run analysis on that and get back the result in Jenkins. Now, all of these works very well because of the plugins. Now with that, let me connect our Jenkins instance to a GitHub. So now let us connect our Jenkins instance to a GitHub. Now I already have a very simple Java repository up on my GitHub instance. So let me connect Jenkins to this particular GitHub instance and pull out a job that is put up there. Right. So this is a very, very simple and repository is called Hello Java. And this is what is there in the repository. This is a simple class file. It's just got some one line of system .out. So this is already present on github.com at this place. and this will be the URL for this repository. So I will pick it up. So what I'll do is I will connect my Jenkins instance to go to my GitHub and provide my credential and pull out this repository, which is on the cloud hosted in the github.com, and get it to my Jenkins instance and then build this particular Java file. Now I'm keeping the source code very simple. It is just a Java file. Now how do I build my Java file? How do I compile my Java file? I just say java.c and name. Now the name of my class file is hello Java, and how do I run my Java file? I will say Java and hello. Okay, so remember I don't need to install any plugins now because what it all needs is a Git plugin. So Git plugin which is already installed on this system. So let us go back, create a new items. We'll create a first job here. Let's say this is a Git first project. Now let it be a freestyle. Okay. Now we'll go to the source code management. Remember, right? We always have been keeping it on none. So in this part, we'll put it as Git. Now, as you remember earlier in examples, we do not use any source code because we were just putting up some echo kind of jobs that did not need any integration with any of the source code system. So now let us connect this. So I'm going to put up my source code and it will show up because the plugin is already there. Now I've already copied the HTTP address from the GitHub and simply paste it here. Now what is the credential? So I'll simply add that. If you add credential this time, so I'll just click and cancel. So if it just add Jenkins, so we'll add a username here. Now if there are any errors in terms of not able to Jenkins to be able to find the Git or the git.exe, or if the credentials are wrong somewhere down here, so you'll see a red message, okay, like something is not right. So for now it's okay. Now I'm gonna build Edureka. Now what will be there as a part of my build step? Because this repository just have the Java file correct, hello Java. So in order for me to build this, I will say execute window bash command, and I'll say Java, hello Java, Java. Now let's save this. Okay, so let me try to run this. Okay, build now. Click on this. Console output. Great. Now as you can see here, there's a lot of executed Git on the behalf. It goes on there to provide my credentials, and so it pull all my repository and my default. Now we'll pull up the master branch. This is there on the post string, and it kind of builds this whole thing on Java C hello world. Finish, and it's given me a success. So it's kind of build this whole thing Java C hello to Java, and it runs this Java hello world. And there, as you can see, this is the output. It's there, and here you can see if you want to look at the content that was created on the repository. Now if you can go there into my workspace like I've showed earlier, you can just simply click here and you can already see here it's been created Git first project and it's saying hello. Now as you can see, it's already there. Now if you can go back, as you can see, and simply close that. Now what it did was Jenkins on your behalf went over all the way to GitHub, pulled this repository from there, and then it brought it down to your local system on my Jenkins instance. Now it's compiled it and it ran this particular application. Now that I've integrated Jenkins successfully with Git, simply within the Java application,
now let's start with the Docker use case. Imagine that you're working in a fast-paced IT department where issues keep popping up, asserts go untracked, and changes need approval. That is where IBM Control Desk comes in. It streamlines IT service management by centralizing incident, problem, and asset management into one easy-to-use platform. And it helps in solving problems faster with automation and intelligent workflows to improve service quality and keep things running. Let me tell you all what is IBM Control Desk. IBM Control Desk is an IT service management tool that helps manage and also support users and IT infrastructure. It builds on IBM Maximo Asset Management, a platform originally designed for managing physical and IT assets. Did you all know that even IBM faced challenges? IBM Control Desk, while a robust IT service management solution, faced several challenges in traditional environments. The deployment process was often complex, requiring extensive configuration and manual efforts that prolonged setup times. Its architecture was resource-intensive, leading to inefficiencies and also higher operational costs. Scalability was another significant hurdle, as adapting to increasing workloads required to major architectural adjustments. limiting its responsiveness to business needs. Additionally, maintenance and upgrade process were frequently causing downtime and increasing operational overhead. And also, the traditional on-premises setup was lagged and flexibility of modern cloud-based solutions, making integration with other tools more difficult and highlighting the need for a more modernized approach, such as containerization to improve performance, scalability, and ease of management. Imagine managing thousands of IT assets and services without scalable infrastructure. This is where the IBM Control Desk was before Docker. So, let's ever think why Docker was introduced into IBM Control Desk. In the IBM Control Desk case study, Docker was introduced to address the challenges associated with managing traditional IT service management applications. IBM Control Desk, a complex and resource-intensive platform, often faced issues with scalability, high resource consumption, and complex deployment process in traditional environments. Docker helped overcome these challenges by containerizing the application components, allowing for more efficient resource use, easier scaling, and simplified deployments. By using Docker, IBM Control Desk could quickly adapt to changes, reduce operational overhead, and also improve performance, aligning with modern DevOps and cloud-native practices. Here is a simplified explanation of the setup described, where a single VM on Red Hat Linux with 2 CPUs and 4 GB RAM hosts both the IBM Control Desk and the DB2 database. Application files are shared via NFS, that is making them accessible to Docker for container deployments. Here comes another step, that is building Docker images. They decided to strictly follow what is stated in the Maximo Asset Management. That is, Maximo Asset Management is a comprehensive software solution developed by IBM that helps organizations manage their assets effectively throughout their lifecycle. That is, it is a part of an IBM Watson IoT, that is Internet of Things, platform, and it's widely used in industries such as manufacturing, utilities, and also transportation and facilities management. A team built a Docker image for IBM Control Desk, like generating the WAR files and also for the UI. Using Docker files, server.xml, and also jvm.options, they built images for various applications including UI, cron, MEA, BROS, and also API. Since JMS wasn't provided, they created it from scratch. Based on the WebSphere Liberty docs, the service portal image built from the Node.js included certificates for secure communication. Next is that they deployed containers. Containers were deployed on an Ubuntu machine with 4 CPUs and 32 GB RAM. Each application had a container connected to a Docker network for inter-container communication. Docker Compose managed all resources using dockercompose.yml for configuration, including environment variables and host settings. The streamlined approach enhanced scalability, simplified management, and improved integration for IBM Control Desks. Let me tell you what Docker brought in change. Docker transformed IBM Control Desk by enabling containerization, improving resource efficiency and scalability. It simplified deployment, reduced downtime, and made updates easier through the component isolation. This enhanced system flexibility, reliability, and overall performance, making IBM Control Desk more agile and responsive. So, here is a condensed version of 4 points. First is the efficient containerization. Docker improved IBM Control Desk's resource efficiency and scalability by containerizing its components. They also streamlined deployment, enabled faster setup with fewer errors and reduced downtime. Easier maintenance too. Docker isolated components, which made updates and maintenance more manageable and flexible. Enhanced agility work. Docker was also an enhanced agility that made approach for IBM Control Desk more agile and responsive to business needs, optimizing operations. Now let's see the overall solution bought. Involving Docker in IBM Control Desk bought a comprehensive solution by containerizing its application components, which improved resource utilization and scalability. This approach allowed faster and more consistent deployments, reducing setup errors and minimizing downtime. Docker also enabled seamless updates and maintenance by isolating different components, enhancing the system's flexibility and reliability. Furthermore, the streamlined modular architecture simplified operations, reduced operational cost, and increased responsiveness, ultimately transforming IBM Control Desk into a more efficient and agile IT service management platform. Let's see the key benefits bought. First is enhanced scalability. Containerization optimized resource and also simplified scaling as demand grew. Efficient deployment. Docker streamlined deployment, reducing errors and downtime for a more reliable setup. Simplified maintenance. Isolated components enabled easy updates, boosting flexibility and reliability. Last is the cost-effective operations. The modular setup cut costs and also improved responsiveness, making IBM Control Desk more agile. The result brought by this use case was, this article showed a case study using container technology to leverage the native support of WebSphere Liberty Profile with the IBM Control Desk product. So, they found that they have more traditional product to container to evolve it toward a cloud-native-like architecture without any need of touch the code. That is, there were also no impact at the application level. This case study showed how container technology was used to transform IBM Control Desk into cloud-native-like architecture without changing the application code. Despite being a traditional product not originally designed by the microservices, containers allowed the IBM to modularize its components, mimicking microservices and improving scalability and flexibility. The process involved identifying dependent modules, that is, by updating build scripts, deploying each module in its own container, setting up communication between them, and testing the setup. This approach shows that even traditional application can be modernized with containers, making deployment easier and more efficient. Now let's see why Docker is so necessary. First, Docker is portable, that is, they run app consistently across any environment. Second, they are lightweight. Containers use fewer resources than VMs, that is, the virtual machines. Then their efficiency, faster setup times and better resource utilization. Next comes the scalability. Easily scale apps using container orchestration. Then is the consistency. Same behavior from development to production. DevOps integration has streamlined CI/CD pipelines. Next is the isolation. Securely run multiple applications on the same host. Last is the simplified dependency management. That is, package all dependencies in one container. Now, let's see the prerequisite to learn Docker. Docker simplifies creating consistent environments across workflows. But to fully harness its power, you'll first need a solid grasp on Linux, command line tools, and also the containerization basics. The three main programming languages needed are Python, JavaScript, and Golang. And the additional prerequisites needed are version control, that is, understanding Git or another version control system can be beneficial for managing code changes in Docker projects. Then is the networking concepts. A basic understanding of networking concepts like IP address, ports, and networking protocols can be helpful for configuring Docker networks. Last is the operating system. Familiarity with command line interfaces like CLI and basic system administration concepts. Next, let's see what is a container. A container technology was launched in 2013 as an open source Docker engine. It leveraged existing computing concepts around containers and specifically in the Linux world. Primitives known as C groups and also namespaces, Docker's technology is unique because it focuses on the requirements of developers and systems operators to separate application dependencies from infrastructure. A container is a lightweight, isolated unit that packages an application and its dependencies. It also ensures it runs consistently across different environments. Now let's see why Docker uses containers. Docker uses containers for its portability as it runs the same anywhere. Then for its efficiency that uses fewer resources than virtual machines. Then comes the scalability, where it can easily scale applications. Last is its consistency, that ensures the app behaves the same in all environments. Now, let's see what is Docker. A Docker is a platform that enables developers to design, develop, and deploy testing to manage applications in isolated, portable environments known as containers. Containers allow you to package an application and all its dependencies like libraries, configurations, etc. into a single unit, ensuring that app runs consistently across different environments. Next, coming to the benefits of Docker. The benefits of Docker are consistency, which runs applications the same way across development, testing, and production. Efficiency, Docker containers use fewer resources than VMs. They also run faster to start and also use less memory and storage. Scalability, Docker is commonly used in cloud environments and microservices architecture, making it easy to scale applications horizontally. Simplified CI/CD, Docker helps automate and streamline continuous integration and continuous deployment pipelines. We will look at the virtual machines versus containers and their differences. The architecture of the virtual machines is that VMs run on a full operating system on a hypervisor, and containers share the host OS kernel but isolate applications. The resource usage of the VMs are heavy, requiring more CPU, memory, and storage as they run separate OS instances. But containers are lightweight and efficient since they share the host OS. The the start time of the VMs take minutes to boot, but the containers start in seconds. The portability of VMs are less portable, tied to OS and hypervisor. Containers are highly portable and run consistently across different environments. The performance of VMs have more overhead due to virtualizations, but containers offer near-native performance with minimal overhead. The use cases of the VMs are full isolation, legacy apps, and heavy resource needs. But in containers, we have fast scaling, microservices, cloud-native apps. Containers are ideal for lightweight, scalable deployments, while VMs are better for complete isolation and resource-heavy applications. Moving on to Docker components. The core components of Docker are: first is the Docker engine. This is the heart of a Docker, responsible for building, running, and managing Docker containers. It's available for Windows, Mac OS, and Linux. Docker images. These are the blueprints of containers containing the application code, libraries, and dependencies required to run the application. Last comes the Docker containers. Instances created from Docker images. They are lightweight, isolated environments where applications run. Now let's learn the architecture of Docker. Docker follows a client-server architecture that allows applications to be packed into containers. It consists of several key components working together to manage, build, and run containers efficiently. Here is an overview of Docker's architecture. First, let's learn about the Docker client. A Docker client is a primary interface for users to interact with Docker. Users issue commands like Docker build, Docker run, and Docker pull, while the client translates into API calls that are sent to the Docker daemon. The client can communicate with either the local Docker daemon or the remote one. The key role of a Docker client is they send commands to the Docker daemon using the REST API. Next, let's see about the Docker daemon, or it's also known as the Docker engine. The Docker daemon is the core service running in the background on the host system that manages Docker objects like containers, images, networks, and volumes. The daemon listens to API requests from the client and also handles all the container management tasks such as creating, starting, and stopping containers. It is responsible for executing the container lifecycle, including pulling images, building containers, and ensuring their isolation. The key role for the Docker daemon are it executes commands, managing containers, images, and networks. Next is a Docker image. A Docker image is a read-only template that contains instructions for creating a Docker container. Images include everything needed to run an application, like code, libraries, environment variables, and configuration. The key role of a Docker image is that they are blueprint for creating containers. Docker container. A container is a runnable instance of a Docker image. Containers are lightweight and isolated, but they share the host OS kernels, making them efficient compared to virtual machines. The key role of a Docker container is that they are lightweight, portable, and isolated instance of an application. Next comes the Docker registries, that is the Docker Hub. Docker registries are repositories that store Docker image. The most common registry is the Docker Hub, a public registry maintained by Docker. Developers can push their custom images to a registry or pull pre-built images for use of their projects. Registries can be public or private, allowing organizations to manage and store their proprietary container images securely. The key role of a Docker registry is that they store and distribute Docker images. Moving on to the Docker Engine REST API. Docker's Engine API allows programmatic interaction with the server Docker daemon. The API can be accessed over HTTP, enabling developers and servers to manage Docker programmatically. All the communication between the Docker client and the daemon happens via the API. The key role of a Docker Engine REST API is that they enable automation and remote management of Docker through the REST interface. Docker Volume. Volumes allow data to persist beyond the lifecycle of a container, providing a way to store and share data between containers or with the host system. They are commonly used to store the database files or other data that are needed to persist even if the container is destroyed or recreated. The key role of a Docker volume is they have the persistent storage for containers. Last comes a Docker network. A network is a group of two or more devices that can communicate with each other either physically or virtually. A Docker network is a virtual network created by Docker to enable communication between Docker containers. If two containers are running on the same host, they can communicate with each other without the need of ports to be exposed to the host machine. They may use the Docker to manage Docker host in any platform manner, regardless to whether they run Windows, Linux, or the combination of two. The key role of a Docker network is to manage communication between containers and external networks. Now let's see the development workflows of Docker. Docker enhances development workflows through: first is a containerization, having packages, application, and dependencies into lightweight, portable containers ensuring consistency environments across development, testing, and production. Next is the local development. Enables developers to replicate production environment locally, speeding up testing and debugging. Next comes the continuous integration or the continuous deployment, which integrates with CI/CD pipelines for automated build, test, and deployment process. Last is the version control. Supports versioning of images, allowing easy rollback and management of application versions. Now we'll see how to install Docker on our Ubuntu machine. Now let's start with installing Docker on our Ubuntu machine first. Now in order to install Docker on Ubuntu, there are some prerequisites. I would advise you to go to Docker's Install Docker engine on Ubuntu. Click on the first link that you can see, Install Docker engine on Ubuntu. Here you can see the documentation and check for all the prerequisites that are specified there. Once you're done with the verification, you can move ahead with the installation process. We'll be using the following: install using the apt repository process to install Docker on our Ubuntu machine. First, open the terminal on your Ubuntu machine. Now let's set up the Docker's apt repository. To do that, first we need to add the Docker's official GPG key. We begin by running a simple apt get update to refresh the package lists. So let's type sudo apt get update. This will refresh all the package list that is needed. Be patient until the packages are getting refreshed. So next we'll install CA certificates and curl on our machine. For that, let's copy and paste the command on our terminal. So as you can see that it's getting installed, type S to continue the installation. CA certificates in our command is a digital certificate that ensures your machine can communicate securely over the internet by verifying the authenticity of websites. The curl is a tool used for transferring data with URLs, allowing us to download files from the internet, such as Docker's GPG key. So now let's move to the next command, that is, we'll be creating the directory for storing the key rings. So for that, let's copy and paste the next command to the terminal. Now let's also add Docker's GPG key to it. We'll download Docker's official GPG key using the following command. Now let's also type the command to ensure that the GPG key can be read by the system. So we'll copy and paste from our documentary and paste it on our terminal. Next, let's add the Docker's repository to apt sources. So for that, we'll add the Docker's repository as the apt sources, and this step will allow Ubuntu to know where to find Docker's packages. So the command we just ran adds the Docker's repository to our apt sources list. This command will specify the architecture of our machine to ensure compatibility. This part will extract the code name of our Ubuntu release, making sure we download the correct version of the Docker. Now, let's also update the package list again. Now that we have added the Docker's repository, we'll run another apt get update command to refresh the list of available packages from this new source. So as you can see, the reading package list is done. Now we'll install Docker by running the command below. This installs Docker Engine, Docker CLI, and the essential Docker tools on your system. Enter S to continue the installation. So be patient until the Docker's installation is getting installed. In our Docker installation command, we have Docker CE, that means Docker Community Edition, the main Docker engine. And the Docker CLI means the command line interface for Docker. Container.io is the core container runtime for Docker. And the Docker BuildX plugin is a plugin for building Docker images. Docker Compose plugin is a plugin to manage multi-container application. So let's be patient until all the packages in the Docker is getting installed. We have successfully installed Docker on our Ubuntu machine and verified it with the Hello World image. Let's clear the screen. Now that we have successfully installed Docker, let's clear our terminal and explore what happens when we simply type Docker. When you run this command, you will see a list of all available Docker commands. This list is incredibly useful when you're unsure about which command to use. There's also a brief description next to each command that will help you understand its purpose. Now let's go over some of the common commands. First is run. It creates and runs a new container from an image. This is one of the most frequently used commands in Docker. It allows you to run a container based on an image, which can be pulled from a registry or built locally. Next is the execute command. It allows you to execute a command in a running container. This is useful when you need to interact with a running container, such as opening a shell inside it. The ps command, that is the list containers. This command shows you all the containers that are currently running or that have been stopped. Next is the build. This command allows you to create a Docker image from a Docker file, defining the environment and dependencies of your containerized application. Next is pull. It allows you to download an image from a registry. Use this command to pull images from a Docker registry like Docker Hub. Push. It uploads an image to the registry. If you want to share your image with others, you can push it to a public or private registry too. Images. Images are the list of images. This command shows all the Docker images that are available on your local machine. Login. Authenticate to a registry. Use this when you need to log into a Docker registry, for example Docker Hub, to pull or push images. Logout. This allows you to log out from a registry. This logs you out from the Docker registry too. Search. Search Docker Hub for images. This allows you to search Docker Hub for pre-built images based on your requirements. Next is a version. Show the Docker version information. It provides details about the version of the Docker you're running. Last is the info. It will display system-wide information. This command gives you detailed information about your Docker installation, including how many containers and images are present, your storage driver, and other system-wide stats. Let's start by checking the Docker version. If you're not familiar with the version you're running, you can simply use this command, that is the Docker version. When you're running this command, it displays the current version of the Docker on your system. In case it shows a version 27.3.1, which is the latest version. Similarly, we can check more detailed system-wide information using the info command. So let's type sudo docker info. This info command provides extensive details about your Docker setup, including the number of containers, images, and other resources being used by Docker on your system. So as we progress through this tutorial, we'll dive deeper into many of these commands and understand how to use them in real-world scenarios. Now, moving forward, we'll build a Docker image using Dockerfile and run that image on your local host as a container on your system. And we'll also open a web browser to see our web page hosted after running the container. So, the first step is to create a directory for our project. We'll use the following command, that is mkdirectory myapp. This creates a directory named myapp. So here you can see that myapp is seen. Next, we'll move into this directory using the cd myapp. Now we'll create a file named index.html. So for that, we'll type the command, that is touchindex.html. Once the file is created, we'll open it using the nano editor and write the content into the file. So I will be typing here, subscribe to Edureka. Then press Ctrl+X followed by Y to save and press enter to confirm the file name as index.html. To verify the content inside index.html, we will use the command, that is cat index.html. So here you can see that subscribe to Edureka is also visible. Our next step is to create a file named Dockerfile. For that, we need to type the command as touch Dockerfile. Then type ls to see. So here you can see that our Dockerfile and index.html is visible. After creating the Docker file, we'll open it in the nano editor and write some instructions into it. So let's type from Nginx. So Nginx is an open source web server that is widely used for serving static content, load balancing, and also acting as a reverse proxy. In this case, we are using it to serve our index.html file. Next, let's type copy index.html /user share nginx/html. So the copy instruction will allow you to copy our index.html file from the current directory into the HTML directory. which is the default directory where Nginx serves its web pages. If your index.html file is in a different folder, you'll need to specify the correct file path in the Docker file. The Docker file is essentially a text file with set of instructions that Docker uses to build an image. So by typing cat docker file, you can see the content that we have written in the nano editor. So next, we'll need to make sure that the Docker is running. If Docker is not running, you can start it with the following command. That is sudo service docker start. If needed, you can also stop the Docker by typing sudo service docker stop. So press Q to exit the status display. As we have stopped the Docker, let's start the Docker again. So let's type the command as sudo service docker start. We can also see the status by writing the command sudo service docker status. So here you can see that a Docker is active and it is running. Now let's proceed to build our Docker image. We'll use the docker build command, that is docker build -t my app. Let's write the command for the build, that is docker build -t my app and a dot. Docker build is a command that builds a Docker image based on the instruction provided in the Docker file. And the T flag is used to tag the image with a name. In this case, it is my app. This makes it easier for reference later. And the dot after my app refers to the current directory, in which the Docker file is located. So by running the build command, we can see that the error is occurred. So the error shows that the permission denied while trying to connect to the Docker daemon. It means that we need to connect as a super user. So let's type the command as sudo su and then write the command for build. So now you can see that my Docker is getting built. Be patient because it might take time. Now that we've successfully built our image, now it's time to run the Docker. Now let's type the command, that is docker run -d -p 6969 :80 my app. -d flag runs a container in detached mode, meaning it runs in the background. And the p flag is used to map ports. In this case, we are mapping port 6969 on a local machine to port 80 inside the container, which is the default HTTP port for Nginx. This command essentially starts a container from my app image, allowing us to access our web page on the local host via port 6969. Now to check the container is running, we use the docker ps command. This will list all the running containers and you should see the my app container running. Finally, to see what we have hosted on the container, open a web browser. Here we'll use Firefox. So on the search bar, let's type localhost 6969. So when you visit to this URL, you should see subscribe to Edureka displayed on the web page, confirming that our Docker container is serving the content successfully. Now, going back to our terminal. Now that we have successfully built and run our Docker image locally, let's move ahead and push this image to Docker Hub, where it will be publicly accessible and stored privately in your Docker Hub account. If you don't have a Docker Hub account yet, go to hub.docker.com to create one. It's a simple sign-up process. Once you have created your account, we can proceed with logging into Docker Hub from the Docker CLI. Now, to push our image to Docker Hub, we first need to log in to Docker from the terminal. We can do that using the docker login command. So let's type docker login -u and give our username -p with our password. The U flag is specified for username and the P flag is specified for the password. So once you're logged in successfully, the Docker will display a message confirming the login. Before pushing the image to Docker Hub, we need to tag our local image with a name that includes our Docker Hub username. This ensures that a Docker Hub knows which repository the image belongs to. For that, let's type the command, that is docker tag my app, the username, my app : and then the version tag. Here my app : latest is the name and the version tag for the image. We are tagging this image as latest to indicate it's the most recent version. Now we can push our Docker image to Docker Hub using the docker push command. So let's type docker push with the username and the version tag again. This will upload the My App image to your Docker Hub repository. Docker will display the progress as it pushes the image layers. And once it's complete, you will see the confirmation message. So let's be patient unless the image is pushed. So here you can see a confirmation message telling that it is pushed. So after you have pushed the image to the Docker Hub, you can log out of your Docker Hub account from the CLI using the docker logout command. For that, let's type docker logout. This is useful when working on the shared machines or environments where you don't want your credentials to remain stored. To verify that our image is now available on Docker Hub, we can use the docker search command. This command allows you to search the Docker Hub for images. So for that, let's type the command as docker search, username, and my app. So here you can see all the images that we have published. So once the image is on the Docker Hub, we can pull it to any other machine or even to a current machine to ensure that it works as expected. The docker pull command allows us to download the image from the Docker Hub. So let's type the command as docker pull with our username and the image name with the version tag. This command will download the image layers from the Docker Hub to your local machine. So here you can see that our image is pulled successfully. After pulling the image, you can run it on your local machine, just like we did earlier using the docker run command. So now we can open our web browser and visit, typing the localhost 6969. You should see the same, that is subscribe to Edureka page, confirming that we have successfully pulled and run the Docker image from the Docker Hub. And that's it. You have successfully learned how to push an image to Docker Hub. Search for it, pull it, and run it on your local machine. Now that we have learned how to work with individual containers in Docker, let's introduce Docker Compose. Docker Compose is an essential tool when you're working with multi-container applications. Instead of managing each container individually, Docker Compose lets you define and manage all the services your application needs in a single YAML file called the dockercompose.yml. So here we have the command to install Docker Compose. The option -L makes the curl follow, redirects, ensures that it reaches the final download URL. And the uname-s part dynamically inserts the operating system name, such as Linux or Windows. And the uname-m inserts the system architecture, that is whether it is 64-bit or 32-bit. This ensures the correct version is downloaded for your system. The Docker Compose option specifies the output location where the Docker Compose binary will be saved. In this case, it is user local bin Docker Compose. Once the binary is downloaded, apply executable permissions, that is sudo chmod +x command. To verify that Docker Compose has been installed correctly, let's check the version. So let's type the command as docker compose version. So here you can see that the Docker Compose version is v2.29.7. That is the latest version. Now that we have installed Docker Compose, let's create a simple Docker Compose file. This file will define two services, a web server having an image of Nginx and a database that is Redis. So first, we'll create a new directory named Docker Compose file. So let's write the command for it, mkdir Docker Compose file. Then we'll go inside the directory. So type cd Docker Compose file. Inside this directory, we'll create a new file named dockercompose.yml using the touch command. So let's type touch dockercompose.yml. Next, we'll open this file with a nano editor and add the following content. So let's type services, web that uses the Nginx image, and the other file is the database which uses the Redis image. We'll save the file by pressing Ctrl+X, then Y to confirm and save, finally enter to confirm the file name. Before we run the file, let's check if it's valid using docker compose config command. This command checks the syntax error or misconfigurations in the YAML file. So let's type the command docker compose config. If the file is valid, you will see the content printed out. Now we are ready to run our services. To start both Nginx and Redis containers, we'll use the docker compose up command. We'll run it in the detached mode so the containers run in the background. So let's type docker compose up -d. So once the containers are up, we can verify by listing the running containers using the docker ps command. You will see two containers running, Nginx and Redis, which were defined in our docker compose.yml file. Now to stop and remove the containers, we can use the docker compose down command. This command will bring down all the services defined in our docker compose file. So let's type docker compose down. Now let's modify our docker compose YAML file to expose a port for Nginx service so we can access it from our browser. So open the file again with nano. We'll add the following lines under the web service to map ports 8080 on our local machine to port 80 in the container. After making this change, let's validate the file again by typing docker compose config. If the file is valid, we can now run it again using the docker compose up command. If the file is valid, we can now run it again using the docker compose up command. Since the Nginx and Redis images are already downloaded, it will skip downloading and simply start the containers. Now let's go to the browser and type localhost 8080. So you'll see a default Nginx welcome page confirming that our container is running and accessible on the port 8080. Once you're done, you can bring down the containers again using docker compose down command. Docker compose comes with several useful commands. To see a list of available commands, we can use the help command. So let's type docker compose --help. You will see a list of commands like up, down, config, ps, and many more. These commands allow you to manage your Docker Compose services easily. So, that's a quick introduction to Docker Compose. We have seen how to install Docker Compose, create and validate a Docker Compose.yml file, run multiple containers with a single command, map ports for service access, bring containers down when they are no longer needed.
What is Kubernetes? Kubernetes, also known as K8, is an open source system meant for automating deployment, scaling, and management of containerized apps, and it is used alongside Docker in most cases, which is the leading container solution in the market. The containerized applications are essentially packaged applications that run in isolated environments called containers. These containers encapsulate apps with all dependencies like libraries, binaries, and system files. Also, one quick fact about Kubernetes is that it was developed by Google and written in the Go language. Since Google made it, it was heavily tested even before it was launched in the market. So, it has a reliability factor to it. Now, let's look at the need of Kubernetes. First, containers are a good way to run your applications reliably. So, you don't need them to fail when operating in production. In a production environment, you need to manage the containers that run applications and ensure that there is no downtime. This is what Kubernetes does, as it enables everything to operate smoothly. Kubernetes provides you with self-healing, secret management and configuration management, and load balancing, in addition to service discovery. First, let's take a look at self-healing part. This is one of the favorite things about Kubernetes according to me, as Kubernetes can restart containers that fail and replace container, and kill those containers that don't respond to user-defined health check parameters. The secret and configuration management lets you store and manage sensitive information like password and tokens or SSH keys. It deploys and updates secrets and app configuration without the need for rebuilding the container image entirely. And load balancing. If the traffic is high, Kubernetes is able to load balance. This distributes the network traffic so that deployment is stable. Now, let's look at how Kubernetes is useful. To understand that, we have to take a short history lesson. At first, we had traditional deployment era in which organization ran applications on physical servers. During this time, there was no way to define boundaries for applications, and this resulted in resource allocation issues and multiple others. As a solution to this, virtual era came, which allowed for multiple VMs to run on a single physical server's CPU. Virtualization allowed applications to be isolated between VMs and provide a level of security and better utilization of resources in a physical server. This also allows for better scalability because applications can be added or updated easily. Now, the VMs were amazing as they were, but containers took it to another level. The containers have relaxed isolation properties to share the operating system among applications. This makes them lightweight. Decoupled from underlying infrastructure, the containers are portable across clouds and OS distributions. This brings us to the usefulness of Kubernetes. First, it should be understood that Kubernetes manages containers. Though other containerization apps exist like Runc and Containered, Docker is the most popular and Kubernetes is compliant with it. Second, Kubernetes is compatible with almost every platform you can think of. One of the easiest way to use Kubernetes is with the Google Cloud Platform in my opinion. But you can use it with AWS or other clouds as well. Third, Kubernetes is highly secure as it implements role-based access control, also known as RBAC. Think of this as assigning privileges for different users according to their needs. You can define a role and the rights for that user to ensure that non-privileged users cannot make unwanted changes to the network. Fourth, Kubernetes is highly available. Using multiple replicas of pods, if one fails, it can replace it immediately, ensuring the smooth operations of everything on the network. And finally, Kubernetes has a big community, and it was built by Google. So, it has a huge community that is engaged and working to fix any bugs and solve any potential issues with Kubernetes. Features of Kubernetes. Here, we look at major Kubernetes features. These are automatic bin packing. You can provide Kubernetes with a cluster of nodes that it can use to run containerized tasks. You can tell Kubernetes how much CPU and memory each container requires. Kubernetes can fit containers onto the nodes to make the best use of the resources available. Storage orchestration. Kubernetes allows you to automatically mount a storage system of your choice, which can either be local or cloud storage. Open source. Since the project is open source, you can look at the code and identify and even make changes and help out the project and community by improving it further. Automatic rollbacks and rollouts. You can describe the desired state for your deployed containers using Kubernetes, and it can change the actual state to the desired state at a controlled rate. Service discovery and load balancing. Kubernetes can expose a container using the DNS name or using their own IP address. If traffic to a container is high, Kubernetes is able to load balance and distribute the network traffic so that deployment is stable. Secret and configuration management. As talked before, you can store and manage passwords, tokens, or keys using Kubernetes effectively without exposing secrets in your stack configuration. And lastly, self-healing. We talked about this before. It is the feature of Kubernetes that make it fail-safe, where it can replace failed containers and kill those containers that don't respond, or it can restart containers. Now, let's talk about what Kubernetes is and what it is not. Some common misconceptions that we know about Kubernetes are that it is for containerizing applications, and that it is replacement for Docker, and that it is best for every app that ever exists. So let's clarify. Kubernetes is best suited for applications with microservices architecture. Using Kubernetes with a simple architecture applications is not ideal and can even lead to performance issues. It is not a replacement for Docker. It just adds to the capabilities of a container tool by managing things better. Lastly, Kubernetes is a container orchestration platform. Period. Orchestration is management. And you can think of Kubernetes as a conductor controlling the music played by a group of musicians. Now, this is where we will get our hands dirty. So let's dive into the demo. Here on my GCP, I have my master node and my worker node deployed. I have already set this up, so let me go ahead and show you. Now, our objective here is to deploy an Nginx web server. Here I have my master node and my worker node has already been set up using my GCP. So if I type in here kubectl get nodes, I can see my worker node on which I am currently working and my worker node which is connected. Now, as our objective is to deploy an Nginx web server, I'll be writing some commands here. So let's create the deployment. I do this by typing this command. Now that I have deployed this, I can see it as well. Now, as you can see, I have one deployment ready to go. You can find out more information about this by typing in kubectl describe deployment followed by the name of your deployment. So here you can click at the information available. So as it says here, we have Nginx container and we provided the image of Nginx. And you can see other variables here such as replica sets as well. Now what I'm going to do is I'm going to create the service. Now by typing this command, what we have essentially done is that we have launched our Nginx deployment. So you can get more information about that using this command. So if you look at here, it says that Nginx was of the type node port, which we already specified, and it has been launched on this port number. So if I type in here this command followed by the port number, we should get the welcome page of Nginx. We can also do this by running this command, which essentially says that it is accessible for every worker node as well. And as you can see, it is accessible. We can again verify this by going to the external IP and adding in the port number. So here, I go to my external IP in my GCP. I copy this, followed by my port. So this is my port, and I'll copy this onto my browser with my external IP address. And as you can see, we get a confirmation, and we were successfully able to deploy our Nginx web server. And with that, the demo is concluded.
What is Prometheus? Prometheus is a free software application used for event monitoring and alerting. Now, what it really does is it records real-time metrics. We'll talk about metrics later on in the session. Now, this metrics that it records is stored in a time series database built using a HTTP pull model. And with this, you also have flexible queries and real-time alerting. Prometheus basically pulls these metrics, which are in a key value format, and stores the data as time series, allowing users to query data and alert in a real-time fashion. At given intervals, Prometheus will hit targets to collect metrics, aggregate data, show data, or even alert if some thresholds are met, in spite of not having the most beautiful graphical user interface. Now that we know that Prometheus is basically an alert monitoring system, now let's move on and understand why we need Prometheus. As I've already mentioned in the introduction, it basically contributes to the DevOps system by monitoring cloud-native applications and infrastructure, and also by watching over hundreds of microservices. Now, it really works well for recording any purely numeric time series data. Now, another really important benefit of Prometheus is that it fits both machine-centric monitoring as well as monitoring of highly dynamic service-oriented architectures. This is a real advantage. Now, in a world full of microservices, its support for multi-dimensional data collection and querying is a particular strength. Now, another advantage of Prometheus is that it is designed for reliability. To be the system you go to during an outage to allow you to quickly diagnose problems. Now, each Prometheus server is standalone, not depending on network storage or other remote services. You can easily rely on it when other parts of your infrastructure are broken, and you do not really need to set up an extensive infrastructure to use it. Now, you must be wondering why Prometheus really, because there are other time series databases that can be used too, right? So one of the noticeable differences between Prometheus monitoring and other time series databases is that it is a pull-based tool, unlike Nagios, Sensui, etc. Now, because it is a pull-based tool, what it really does is it actively scrapes targets in order to retrieve metrics for them. For example, the node exporters or application exporters. So Prometheus expects to retrieve metrics via HTTP calls done to certain endpoints that are defined in Prometheus configuration. Node exporter and application exporters will listen on particular ports, and Prometheus server initiates a HTTP call to this particular exporter and fetch system or application metrics from the end. Now that we know why Prometheus is so important, let's move on and understand continuous monitoring in Prometheus. Monitoring applications and application servers is an important part of today's DevOps culture and process. Now, via continuous monitoring, you obviously want to continuously monitor your applications and servers for application exceptions, server CPU, memory usage, or storage spikes. And you also want to get some type of notification if the CPU or memory usage goes up for a certain period of time, or a service of your application randomly stops responding, so that you can perform appropriate actions against those failures or exceptions. This is why Prometheus is used in continuous monitoring. Now, with monitoring, the number of tools out there such as Amazon CloudWatch, Nagios, New Relic, and many others. But Prometheus is a very popular free and open source project for monitoring dozens of servers, as I've already mentioned, even microservices. Now that we know what is Prometheus used for in continuous monitoring, let's move on and check out the Prometheus architecture. So in Prometheus terms, we call the main monitoring service the Prometheus server. You can see that on the screen. And the things that Prometheus monitors are called targets. So the server is the monitoring service, and the targets is what the Prometheus monitors. So I hope that is clear. So in short, the Prometheus server monitors targets. I said earlier, targets can also refer to an array of things. It could be a single server or a target for probing of endpoints over HTTP, HTTPS, DNS, TCP, or it could simply be a HTTP endpoint that an application exposes, through which the Prometheus server gets the application's health status from. So now let me explain a little bit about metric. Each unit of target, such as current CPU status, memory usage, or any other specific unit that you would like to monitor, is called a metric. So Prometheus server collects metrics from targets over HTTP, stores them locally or remotely, and then displays them back in the Prometheus server. Now, the Prometheus server scrapes targets at an interval that you define to collect metrics from specific targets. For example, for a minute or 30 seconds or whatever you want, you can give the target as, and then it will finally store it in a time series database. You can see the storage box that is in between. That is your time series database. Now, you define the targets to be scraped and the time interval for scraping metrics in the prometheus.yml configuration file. You get the metrics details by querying from the Prometheus time series database, where the Prometheus stores metrics, and you use a query language called PromQL in the Prometheus server to query metrics about the targets. So in other words, you ask the Prometheus server via PromQL to show us the status of a particular target at one particular time. As you can see in the third white box, it accepts queries, that is, it accepts PromQL queries. Now, Prometheus provides client libraries in a number of languages that you can use to provide health status of your application. But Prometheus is not really only about application monitoring. You can use something called exporters to monitor third-party systems. Now, exporter is a piece of software that gets existing metrics from a third-party system and eventually export them to metric format that the Prometheus server can eventually understand. Now, a sample metric from a Prometheus server could be the current usage of free memory or file system free via a node exporter in the Prometheus server. We learn all of this in the demo part of this session. Now, I hope Prometheus server is clear to you. So the main component here is the Prometheus server, which is divided into three parts: the retrieval part, the storage part, and the HTTP server. So the HTTP server really accepts queries and displays it in the graphical user interface. Also, we'll be learning about Alert Manager later on in this session. So I hope all of these are clear. Let's move on to the next part of this session and learn about Prometheus metrics and its types. So here, each unit of a target, such as the current CPU status, memory usage, or any other specific unit that you would like to monitor, is simply called the metric. So the server collects the metrics and stores them either locally or remotely, and then eventually displays it on the Prometheus graphical user interface. Now, moving on, let us check out the 4 different types of metrics that are available. The first one that we'll be talking about is the counters. A counter is simply a cumulative metric that represents a single monotonically increasing counter whose value can only increase or be reset to 0 on restart. Now, for example, you can use a counter to represent the number of requests served, tasks completed, or errors. You always have to remember this, to not use a counter to expose a value that can decrease. Now, for example, do not use a counter for the number of currently running processes. Instead, use a gauge. We'll be talking about gauges in a bit. Now, client library usage documentation for counters are Go, Java, Python, and Ruby. Let's move on and understand the next metric type, that is gauges. I'm sure you must be aware of gauge. Now, a gauge is a metric that represents a single numerical value that can arbitrarily go up and down. Gauges are typically used for measured values like temperatures or current memory usage. If you check out a speedometer in a car, it looks like a gauge, right? That is a gauge. That's exactly what we're talking about here. So the client library usage documentation for gauges are Go, Java, Python, and Ruby. The next metric type is the histogram. Now, a histogram samples observations and counts them in configurable buckets. It also provides a sum of all observed values. A histogram with a base metric name of base name exposes multiple time series during a scrape. Now, when you're operating on buckets, remember that histogram is cumulative. Now, moving on to the next metric, we have summary, which is very similar to histogram. A summary samples observations, while it also provides a total count of observations and a sum of all observed values. It really calculates configurable quantiles over a sliding time window. Now, a summary with a base metric name of base name exposes multiple time series during a scrape. Now, the difference between summary and histogram is that here you do not know what the range of values will be upfront, so you cannot use histograms. Whereas in histogram, you know what the range of values will be upfront, so you can just define it on your own. Now, with this, let's move on to the demo part of this session and install Prometheus on our Linux virtual machine. So I'm just going to check out my Ubuntu machine number. So the first thing what we're going to do is we're going to install Prometheus from the official website. So I'm going to go to my web browser. So I'm just going to type in Prometheus in my web browser and I'm going to click the first link. And as you can see, this is the official website of Prometheus. I'm going to click on the download button. So once I click on the download button, it will redirect me to a page. So as you can see here, there are a lot of products: Prometheus, Alert Manager, Black Box Exporter, and a lot more if you keep scrolling down. Right now, we're going to be downloading Prometheus. So we're just going to stay here and I'm just going to click on the operating system as Linux. And this will just show the tar file for the Linux operating system. I'm just going to right click on that and I'm going to click on copy link location. And I'm going to switch back to my terminal and click on wget. And this will download Prometheus for me in my Linux operating system. Now that it's downloaded, I just want to see the list of files in my tar file. So as you can see, there's the Prometheus Linux tar file, which is present currently in my Prometheus folder. Now what I'm going to do is I'm going to copy this file and then untar it using the command tar -xvf, and then I'm just going to paste this file. This will immediately untar the file for me. Once that is done, now I'm just going to list down the number of files that are currently present in my Prometheus file. Now you can see that there's an file which has been untarred here. Clear my screen. Okay, now I'm again going to just list it so you can see it clearly. Now I'm just going to copy this file and enter this directory. So I'm just going to list down all the files that are present. You can see there's console libraries, there's consoles, license notice. There's a file that's named Prometheus. So this is the application, the Prometheus application. So I've already mentioned before that the prometheus.yml configuration file really just defines the targets that has to be scraped, right? And also the time interval for scraping metrics. Now let's just check if all of those parameters that I just mentioned are there in the configuration file. So I'm just going to use scat command for it. You can see that there's a scrape interval parameter of 15 seconds. You can set the scrape interval to every 15 seconds. Default is every 1 minute. So I also have an alert manager configuration. Right now, we haven't set that up, but it's just there. You can also load your own rules and evaluate them according to the global evaluation interval. And you can see by default, it is currently active on the 9090 port. Okay. And by default, a scrap configuration containing exactly one endpoint to scrape is given. That is the Prometheus itself, right? As I've already mentioned before, Prometheus is a tool or an application that will scrape out metrics from different applications. But by default, right now, we have the Prometheus itself to be scraped, and that is currently present on the port number 9090. So I hope that is clear. We will learn about the rules in the next part of the session. We'll also learn about the alert manager configuration in the later part of the session. So both of these will be clear later. But I hope the scrap interval and the scrap configs are clear to you. Now let's move on to the next part. Now I'm just going to clear the screen. Now I'm just going to execute Prometheus by using /Prometheus, and this will immediately activate and get my Prometheus application running. If we move back to my web browser and just type in localhost 9090, this will redirect me to my Prometheus application, as you can see. Now, if I come out of my terminal, right? Okay, and I reload my page, you can see that it is unable to connect to my Prometheus. So what I'll have to do is I will have to create a Prometheus service and get that running. So let's learn how to do that. I'm just going to clear my screen. So now to be able to run Prometheus as a service, I'm going to use the copy command. I'm just going to use the cp-r command. I'm just going to copy all of these files that are consisting in this folder to the destination folder. And I'm going to use this command -user local -bin Prometheus. Now, for any application to be run as service, you will have to compulsorily have a .service file. So let's go ahead and create one. So to create the service file, I'm just going to use the command sudo vi, and I'm going to enter that particular folder. So as you can see, I just typed out a tiny piece of code. And as you can see here, this is my executable command and this is my configuration file. Let's go ahead and save this. Okay, great. So now that our service file has been created, I'm just going to clear my screen, and now we're just going to start our service file. Now, once that is done, I'm just going to check the status of Prometheus. It is active and running. Great. Now, if I want to stop Prometheus, I'm just going to type in the command sudo service Prometheus stop. Okay. Now that I refresh my page, you can see that Prometheus is up and running. So that's great. I hope it's clear how to create your own service file so you can get Prometheus up and running. I hope it was very clear, and I hope you understood how to install Prometheus into your virtual machine. Now, in the next part of the demo, I'm just going to brief you all about the graphical user interface of Prometheus, so stay tuned. Okay, so now we're going to check out the user interface of Prometheus. So in the previous session, we installed Prometheus and we got the instance running. Now, if I click on Prometheus, this is where it will take me. Now you can see that there are three options that says enable queue history, use local time, enable autocomplete. You can use the local time if you'd like to enter some time to evaluate the queries. So there's a search bar here for you to type in the expression that you'd like to execute. Now the expression or query that you'd like to execute is usually executed in two different forms, that is the table form and the graph form. As of now, since you don't have any expression and query, it says no data queried yet. Now on the top, you can see three options that says enable query history, use local time, enable autocomplete. So this option will allow you to use your local time. Since I'm in India and it's 10:08 right now, so that's my local time. Now, if I want to also enable my query history, that is all the queries that I have executed in the past. So this option will simply enable me to check out the queries that I've executed in the past. So I'm just going to untick that because I don't have any queries that I've executed in the past anyway. Another interesting thing in this page is that you can add several panels, right? So you can execute different queries all at once. This is great. And this option add panel has been added in the recent times. So this is the new user interface. You also have a classic user interface. I'll shift to that. And you can see that here you can enable query history. That's the only option that's common from the new user interface. Also, you have a bar that will allow you to type in your expression or query. You can also insert metric at cursor. Now, since Prometheus is written in Golang, so you have a lot of metrics that are related to that. You also have metrics related to Prometheus. Now, if I want to execute any of these metrics, I can just click that and I can execute it. You can see that the instance localhost of port 9090 is currently up and running, and the job is Prometheus. I can view the graph too if I'd like to. Now let's just execute another query. I'm just going to click Go Info, and this will just give me the version of the Golang and the job, etc. So you can just really execute all the queries directly from this option in your classic UI. But as you can see in the new user interface, that option is unavailable. Now let's move on and check out the other options that are available in this panel. Let's click on alerts. Currently, we have no alerts. As I've already mentioned before, that alerts are simply conditions that you will have to specify. And if these conditions are satisfied, so the alert will be triggered to that particular maintainer or manager. So currently, as we have none, it just shows nothing here. So these options will allow me to check my inactive alerts, my pending alerts, my firing alerts. So usually it's in inactive state if the condition is not satisfied. If the condition has been satisfied, then it'll go to the pending stage. And finally, if it exceeds the critical limit or the critical amount, it will enter the firing stage. So you can view the alerts based on these three states, that is the inactive state, pending state, and firing state. Moving on, we have graph. So this is the same as the homepage of Prometheus, right? So we've talked about that. So once I click the status option, you can see that there are 7 different options that drop down. The first one is runtime and build information. This just really gives me, the information about Prometheus. That is the start time of Prometheus, the working directory, the configuration reload. Extra information about my runtime and build is given in this option. Now the alert managers, there are none, so it just says endpoint. Now you can also see the Go version here. You can see the build user, build date, all of that. The version of the build information also is given here. So this is what the runtime and build information is all about. The next option in the status is TSDB status. What is TSDB? TSDB is simply the time series database. So this option allows me to check out my database's status, right? The number of series, the number of chunks. So I can just view the statistics of the head cardinality. So I can just view the top 10 label names with value count. I can view the series count by metric names. And I can also check out the label names with high memory usage. In fact, I can also, take the queries from this top 10 series count by metric names. I can just execute it as a query. And you can see that this gives me the data of and this just executes the information and gives me the data, the list of data that allows me to check out my HTTP request duration in seconds. So also I can view this in graph. So I'm just going to click on that. And this just gives me information of all of the data that is available in the table in terms of graph. So I hope this is clear. Now moving on, we'll check out command line flags. This is just the command line flags that I can use to really make changes in my service file. We created a service file, right, to run this particular service of Prometheus. So this just really gives all the information about my service file. So you can see that there's config file currently in this location. There is also query timeout, and you can view all of that, all of the extra information here. You can check out the web listen address. It's in port number 9090. You can also check out the web page title. Currently, the web page title is Prometheus Time Series Collection and Processing Server. You can change this if you'd like to. You could also check out the web read timeout. So all the information basically about this service that we've created is given in the command line flags. So moving on, we will check out a configuration file. This configuration file we've already seen before, right? This is our prometheus.yml file, right? So this is simply the same file that is given here. You can see global, alerting, scrap configs. You can check out the targets and then finally the port number. Okay, so if you'd like to copy this, you could just copy to clipboard. Moving on to the next option, we have rules. There's none right now, so it shows nothing. Later on in the session, we'll be creating our rules, so stay tuned for that. Now, the next option is targets. There's only one Prometheus service that is up and running, and that is of port number 9090. So the state is up. You can see the instance, you can see the job, and the last scrape, the scrape duration, and if there are any errors that will appear here. Before we move on to the next option, so I'm just going to show you the metrics of this instance, the Prometheus instance that we're running. I'm just going to click on metrics. Now you can see that Prometheus defines a very nice text-based format for its metrics. I'll just zoom this a bit so you can view it better. So now you can see that the data is relatively, human readable. And we even have the help and type decorators to really increase the readability, right? As I've already discussed before, Prometheus has only 4 types of metrics, right? To keep everything really simple. That is counter, gauge, histogram, summary. Now the type and help attributes here help us provide user-friendly hints for each metric in the output. So that's what this help and type decorators really do. They just increase readability. You can't really view all of these metrics and understand what they are. So they're just helping you with the readability. You can see that the help here says go GC duration seconds, a summary of the pause duration of garbage collection cycles, and the metric type is summary. Here you can see the type is gauge, and you can see all of that information. Here the type is counter. Also here the type is counter, gauge again. So that's what really the type will do. So the type will just give you an insight of what type of metric it is. So help will just really describe the metric, and type will just give you the type of metric. So I hope this is clear. So I hope metrics was easy to understand. Now that we finished targets, let's move on to service discovery. And this just shows you, so currently there's just one endpoint that has been scraped, and that is our current running active instance, that is Prometheus. Now it just shows the address, the metrics path, and the scheme, the job, and just shows some labels of the target. So that's all service discovery is all about. And if you'd like to check out and know more about Prometheus, just click the help option in the panel, and this will redirect you to the Prometheus official website. Now the classic UI we already discussed, and this is all for the graphical user interface of Prometheus. I hope it was easy to understand. I hope it was easy to learn. Now let's move on to the next part of the session. Okay, so now in this part of this session, I'll be downloading the Prometheus node exporter. So for all of y'all who don't know what the node exporter is, it really is a way to measure various machine resources. Now the machine resource can be your memory, disk, or even your CPU utilization. So it's a very famous application of Prometheus. So without much ado, let's go ahead and download our node exporter. I will go to my web browser and I'm going to the official website of Prometheus. So the first link will redirect me to the official website of Prometheus. I'm going to click on the download button and I'm going to scroll down and look for node exporter. So I'm just going to copy the link location. I'm quickly going to move back to my terminal and I'm going to download node exporter. So now that the node exporter has been downloaded, now let's just check if the file is available, and it is. So I'm just going to untar this starred file with the command tar xzf, and I'm just going to copy this. And this command will just untar my file. Okay, so I'm just going to clear the screen. Now let's just move ahead and check out what are the files that are there in our node exporter file. So we have license, node exporter, and notice. Now what I'm going to do is I'm going to use the sudo cp command. So I'm going to copy the node exporter file to my user local bin location. So with the help of the copy command, that is the cp command, I'm just going to create a copy of the node exporter file into my user local bin location. Okay. Once that is done, I'm just going to check out the files that are present in my user local bin location. You can see that there is a node exporter file that has been copied, right? So I've just copied this file into this location. That's all I've done. Moving on, we'll now create a service file. So we created a service file for a Prometheus application, right? So even for the node exporter, I'm going to create a service file using the command sudo vi. So I'm just going to name this as node exporter.service. So I have written down a piece of script the same way we did to a Prometheus service file. Here you can see the description, which says Prometheus node exporter service. You also have the type, you have execution start, which is currently present in the user local bin location. Now, once that is done, I'm just going to save this and I'm going to reload my system. Now I'm just going to start the service. You'll have to make sure of one thing, and that is the node exporter. So what you're naming the service file, you'll have to initiate the same name. So as you can see here, the service file is named as node exporter. So I'm just going to type the same thing here and I will start the service. Once I start the service, I'm just going to check its status and you can see that it's active and running. So that's great. So the node exporter is currently running on address 9100 ports. So we're just going to check it out. And it opens. So you can check out the metrics that are currently running in our node exporters. So this is the endpoint as to where our Prometheus will scrape all of its data. So now that we have node exporter up and running, let us configure the node exporter into our prometheus.yml file. So every time you'll have to configure a particular target, you will have to go to the prometheus.yml file and add the target there. Okay. So what I'm going to do is I'm going to move to my directory. Okay, once that is done, I'm just going to list out all the files. So you have the Prometheus file here. Here you can see the prometheus.yml file, right? I'm just going to clear my screen. So now I'm just going to view all the files that are present in Prometheus. As you can see that there's the YML file here. So we're going to use the command sudo vi prometheus.yml to edit our configuration file. So now you can see there is only currently one job, and that is Prometheus. We have to add another job to our file. So here I'm adding node exporter as my job name, and the target is with IP address 9100, right? So make sure the indentation is correct. So once the indentation is correct, we have applied a target. We have added a target to our configuration file, and we can just save this. Once that is done, I'm just going to clear my screen. So now I'm going to restart my Prometheus and check the status. It's active and it's running, so we can just go back to our page. So you can see here the node exporter has been added to our service discovery with address as localhost 9100. It's localhost because we are currently working on our machine. If you want to add another machine's port address, you can do that too in Prometheus by mentioning their address. And now you can just go back and you can check out the configuration file has its changes. So it has another target that's named node exporter, and also its port number is 9100. So if I move back to my classic UI2, I can check out the metrics that are here. If you notice, there are a lot more metrics than before, right? You also have the node metrics. If I want to check out the node CPU seconds in total, I can execute it, right? So now that I've executed it, you can check out the CPU's total number of seconds it is hosting the node exporter for. You can also check out the username info of the node. You can see that the instance name is given here, the machine that we're currently working on, the node name is Edureka, the system name is Linux, the version is given here, and also, so the entire node's username info is given if we execute this query. So this is great, right? Like, now your node exporter has been successfully configured into Prometheus. Let's move on to the next part of the session. Before moving on to the next part of the session and configuring Alert Manager, let's understand querying a little bit more in detail. So Prometheus, as we all know, fundamentally stores all of its data as time series, right? Now, each time series is identified by a metric name. We've also discussed this before, and as well as a set of key value pairs that Prometheus calls labels. Okay. Now, the metric name indicates the overall aspect of a system that has been measured. Let me just execute this query, Prometheus HTTP request, duration seconds total. Okay. Now you can see that labels serve to differentiate subdimensions of a metric, such as, the handler, the code, the instance, the job that it's currently running on. Finally, a sequence of samples forms the actual data for a series. Okay. Each sample consists of a timestamp and a value, where timestamps have millisecond precision, and here values are always 64-bit floating point values. The best part of Prometheus queries is that you can add regular expressions, you can specify a time limit, a certain time limit. You can also use different functions. We'll see all of this. So now I could add a certain filter to my query. Now, if I want to just execute the queries with label code 400, I'm just going to add that filter here and execute the query. And this will automatically display the HTTP requests in total with code 400. And you can really, add whatever you'd like to in your filters. So that is one way to work with queries. And also, as I've already mentioned, you can also add regular expressions, right? So you can use not equal to, is equal to, and many other things. So for example, if you want to list all the series, no matter which metric name or job, with the handler name starts with API, okay? So you can just simply run this query. What we've done in this regular expression is, so this is obviously a regular expression, right? So in this regular expression, it needs to end with a full stop and a star. Okay, since regular expressions always match a full string in Prometheus. Now, the resulting time series is usually a mix of series with different metric names. Now you know that how to select your time series by the metric names as well as a combination of their label names. So in the next part, we will learn how to calculate rates or deltas of a metric over time. Now, one of the most prominent frequent functions you will use in Prometheus is the rate function. Now, instead of calculating event rates directly in the instrumented service in Prometheus, it is a very common thing or a common way to track events using raw counters. Okay. And to let Prometheus server calculate rates ad hoc during query time. This has a number of advantages, such as not losing rate spikes between scrapes, as well as being able to choose dynamic averaging windows at query time. Counters start at 0 when a monitored service starts and get continuously incremented over the service process's lifetime. Occasionally, when a monitored process restarts, its counters reset to 0 and begin climbing again from there. Graphicking raw counters is usually not very useful, as you will only see an over increasing line with occasional resets. Now we will just use another query for this example. Now I'll just explain you how the rate function really works. And for this, I'm just going to use the query Prometheus HTTP request duration seconds count. Okay. And I'm just going to specify the job as Prometheus. And you can also view the graphs. It looks something like this. Okay, now to make counters useful, we can use the rate function to calculate their per second rate of increase. This is really why we use rate function. We need to tell rate function over which time window to average the rate by providing a range selector after the series matcher. Okay. Now, for example, to compute the per second increase of the above counter metric as averaged over the last 5 minutes, we can just add the rate function and just specify the time limit as 5 minutes. I'm just going to close the braces and execute the function. Okay. You can check out the graph now. You can see now the result is much more useful, right? Rate function is very smart and automatically adjusts for counter resets by assuming that any decrease in a counter value is a reset. The variant of rate function is irate function. While rate function averages the rate over all samples in the given time window, that is 5 minutes in this case, irate function only ever looks back 2 samples into the past. Okay, it still requires you to specify a time window like 5 minutes to know how far to maximally look back in time for those 2 samples. Now, irate function will really react faster to rate changes and is thus usually recommended for use in graphs. In contrast, the rate function will provide smoother rates and is recommended for use in alerting expressions. Okay, now let's execute the irate function for this. You can see that the graph would look like this, okay, uncovering short intermittent dips in the request rates. Rate and irate functions always calculate a per second rate. So here sometimes you'll want to know the total amount by which a counter increased over a window of time, but still correct for counter resets. You can achieve this with the increase function, okay? For example, to calculate the total number of requests handled in the last hour, you can use the increase function. And I will change this to 1 hour. Now that we know how queries work, how you can use regular expressions, and how you can really use functions in your queries, let's move on to the next part of this session, that is custom roles. Okay, so time series queries can quickly become quite complicated to remember and type using the expression browser all the time, right? So what you can do is, sometimes in some situations you'd want to use some queries very frequently, right? But you don't want to really type the same query over and over again. So in this case, rather than remembering and typing this particular query every time, we can create a recording rule that will run at a chosen interval and make the data available as a time series. So how are we going to do it? I'm just going to, so this is a pretty popular query that I'm going to execute. That is node memory 3 bytes. Okay. I'm just going to execute this query. This will just give me how much of free bytes is available in the node exporter. You can see the free number of bytes here. But what if I want to execute this in terms of, percentage? So here you can see the number of memory that the job node exporter is using, and it's just 4. So I'm just multiplying by 100 to check in percentage form. So you can see that it is only using 4 bytes of memory. Now, if I want to see how much of memory is remaining, I'm just going to minus the entire query with 100. So you can see that 95% of bytes is left over. Now, what if I want to execute this query very often, right? So it'd be very time consuming for me to type the whole thing out and then execute it, right? So, but there's an easier way to make this a query, right? So it'll just drop down in your drop down list, and then you can just search for it and execute it, right? So how do we do that? So what we're going to do is we're quickly going to shift back to our terminal. I'm just going to clear my screen. Okay. And I'm just going to move into the user local bin Prometheus directory. And now here we have to create a new file called Prometheus rule. So that's what I'm going to do. And since it's a YML file, I'm just going to add the YML extension. Here, I'm just going to add the name as custom rules. And I'm just going to specify my rule here. So I just type the whole thing out. I have named this custom rules, and I've recorded this query as node memory free in %, and the expression we've already executed is the same one. I'm just going to go ahead and save this. I'm just going to clear the screen. So Prometheus usually comes with a tool called Prom tool, and this Prom tool can be used to really check your rules files, and you can do really a lot of things with Prom tool. For now, we're just going to use this command which I typed out, and we're going to execute this command to check if our file is running okay. And you can see that it checks the Prometheus rules file and it says it's success. Now let's go ahead and add the Prometheus rules.yml reference to the Prometheus YML rule file section. I'm just going to clear the screen. Now I'm just going to enter the Prometheus.yml file. So here I'm just going to enter the Prometheus_rules.yml file. So now I'm just going to save this file. Now once that is done, I'm just going to restart the system. And I'm just going to check the status too. Okay, great, it's up and running. So we're just going to switch back to Prometheus. And I remember naming it free bytes. I'm just going to switch to the classic UI so I can look for it. And it was named node memory free in %, right? This is exactly what we named our query. And I'm just going to execute this. And you can see that it's 95%. So this is how easy it is to make your own queries and execute them. Okay, so now that we've created our, custom rule, so let's just go check out our custom rule. And you can see that it's here. And the state says, okay, so that's great. Now let's go ahead and create our first alert rule. Okay, the same way that we created our custom rule, we're going to be creating our alert rules. This is exactly why I explained you custom rules in the beginning. So I'm just going to switch back to my terminal. I'm going to clear the file. I'm just going to go to the Prometheus_rules.yml file. And once that is done, so I'm just going to type in my alert in this Prometheus_rules.yml file. And once I'm done typing, so I'll just explain you the alert after that. So I've created a rule named alert rules, and this alert will allow you to recognize when your instance is down. So we have currently the Prometheus instance that is running, and we also have the node exporter that's running. So if any of these instances go down for up to 1 minute, and then the alert will be up. Okay. So the severity is pretty critical, and we have given annotations too where we have mentioned the instance. So this just gives a summary of what instance is going down and a description too of the job type. And also we have mentioned the job type and that it has been down for more than 1 minute. Okay. So once this is done, we're just going to save this. I'm going to clear my screen. So the same way that we executed the prom tool command, we're just going to execute that. So we're just going to execute this command, and it says 2 rules found. That's great. Now I'm just going to restart my Prometheus, and I'm going to check the status. Okay, it's up and running. Let's switch back to our Prometheus and reload it. Now you can see that there is now an alert rule, okay, which has the alert instance down, and the expression is up is equal to 0. So this expression that says up is equal to 0 is pretty interesting, because now if I go to my Prometheus and just execute up, it'll just tell me what are the jobs that are currently up and running. Now the value is currently 0. So if the expression turns 0, so then the alert will be activated. So here, this is what the expression really means. So here, if the up is equal to 0 for more than a minute, then the alert will be immediately activated. As I've already mentioned before, the 3 stages, that is the inactive stage, pending stage, and then the firing stage. If none of the alerts are up, then it's just going to be an inactive state. And if, for instance, one of the jobs go down, okay, then it will immediately move to the pending state. So once it immediately moves to the pending stage, then it will wait for a minute, because we have specified the condition that it should be in the pending state for a minute. And if it goes beyond a minute, then it should go to the firing stage. Okay. So once it reaches the firing stage, all of the managers that are involved in getting the notification about this alert, then they will be informed about it immediately. So I really hope you understood how to create your own rules, how to configure them into your Prometheus rules.yml file, and then just really, understand how they really work. Now let's move on and install and configure our alert manager. We'll have to just simply go to the Prometheus official website, click on download, and then you'll get an option called alert manager. I'm just going to click on that, and then I'm just going to copy the link location of Linux, because I've been clearly using Linux machines. So I'm just going to copy that link location, clear my screen, and so I'm just going to download Alert Manager. So once I copy the link location, what I'm going to do first is I'm just going to move back directories. So now I'm just back to my root. I'm just going to move into my Prometheus directory. So I'm just going to download my Alert Manager here. Okay, as you can see that the download is complete. I'm just going to list out the files. And you can see that there's an Alert Manager, the tar Alert Manager file. I'm just going to untar this using the command and you can see that using the command sudo tar -xvf, and then I'm just going to paste the link. And you can see that the files have been untarred. I'm going to clear my screen and I'm just going to list out the files. Yeah, so the Alert Manager file has been untarred. I'm just going to enter into this directory and check out the files that are currently in this. You can see that there's an Alert Manager executable file. You have alert manager.yml, the configuration file. You have an AMP tool. So now what we're going to do is we're going to be running Alert Manager as a service. The same way we ran Prometheus and Node Exporter as a service, we're going to also run Alert Manager as a service. So what I'm going to do first is I'm just going to copy my files into the user local bin. So now I'm just going to create the Alert Manager service file. If you remember, we also created a Prometheus service file and also Node Exporter service file. So we're just going to do the same. We're going to create an Alert Manager service file. So once you create your Alert Manager service file, this is what you'll have to type out. I've typed out the script. So you have a description, you also have the type of the service, and you're just going to mention the location of the configuration file. and where the execution will begin from. Okay, once this is done, I'm just going to save this file. I'm going to clear the screen. So I'm just going to shift locations to the user local bin alert manager directory. So I'm just going to list out the files, and you can see there's the alert manager.yml file. So here is where we'll have to make a few changes. That is the alert manager configuration file. So I'm just going to make some changes there. So this is the default file. I'm just going to make some changes here, and I'm just going to explain what the changes are about. You can see that you have receivers where you have to configure your email ID, that is your email ID from where you're sending the message, and the receiver who's going to receive the message, right? So you're just going to add a to email ID, you're going to add a from email ID, and you're also going to add a username, you're going to add identity, that is the email ID, and then you're also going to add the Gmail password. Now that all of my email IDs are in Gmail, so I'm just going to mention the public Gmail host server. So I'm just going to add in all my credentials and cut to the next part of the session. And as we have already seen before, there's a tool that is called AMP tool in the alert manager. So the AMP tool is just an executable that allows you to view or to modify the current state of the alert manager. So I'm going to execute this command user local bin alert manager AMP tool and check the configuration file, and then just give the location of my service file. Okay, and once that is done, it's going to check. So I'll just check if it's successfully configured. Once that is done, you can just see that there's one receiver on this end. Okay, I'm just going to clear my screen, and I'm going to start my alert manager. So once I've made changes to my service file, so now I'm just going to execute my command user local bin alert manager AMP tool. Now for all of you all who don't know what AMP tool is an executable that allows you to view or to modify the current state of the alert manager. Okay, so once this is done, this is successful. So you can just check the config file with the help of AMP tool, and once that is successful, you can just see that there's one receiver. So what I'm going to do is I'm just going to clear my screen, and I'm going to start my alert manager service. Now that the alert manager is up and running, you can see that it's currently running on port number 9093. So I'm just going to check out the port where the alert manager is up and running. As you can see that there is 4 different options that are given: alerts, silences, status, help. And you can just filter your alerts, group your alerts, and you can also see the status of your alerts. And you can also see the active, pending, and expired alerts. You can get help from this page too. So you can just see your alert manager in general. And now now with the alert manager active, let's move on to the demo part. Okay, so now that we have set up our alert manager, so we'll quickly shift back to our terminal, and I'll clear my screen. So now we have to configure alert manager into Prometheus. I'm just going to move out from this directory, and I'm just going to enter the Prometheus directory. I'm just going to list out the files that are present here. So I'm just going to edit my prometheus.yml file. And here, as you can see, I'm going to specify my alert manager. So I'm just going to specify my alert manager to port number 9093. And once I'm done with that, I'm just going to save this file. And now I'm going to restart Prometheus. Okay, it's up and running. So I'm just going to check if my endpoint has been successfully scraped in my runtime and build information. And if I scroll down, you can see that, so the alert manager has an endpoint, right? And this is it. So that's great. We have Prometheus, we have alert manager up and running. Now let's just go check the status of all our targets. We have node exporter, which is up. We have Prometheus, which is up. Okay, now let's go to our alert stage. We have one alert rule that we've currently written, and it's inactive. Now let's get into the demo part, and let's So let's just stop one of the instances. I think I'm going to stop my node exporter instance, and once that starts, so let's just see how the alerts go by when one of the instance is shut down. Okay. So I'm just opening a new terminal, and what I'm going to do here is I'm just going to Okay, now what I did is I just entered my Prometheus directory. I just listed down the files, and we have the node exporter file. I just changed the directory to the node exporter and listed down the files. And currently the node exporter is up and running, obviously. But now what I'm going to do here is I'm just going to stop this service. Okay, before that, I'll just clear my screen, and I'm just going to stop the service. And I'm just going to check the status. So it's inactive. And once that is done, I'm just going to quickly shift to my status of the target. So you can see that one of the target is down, and I'll just execute the up query, and you can see that the node exporter has the value 0. That is, it's down. Okay. I'm just going to check the alerts. You can see that the alerts is in the pending state, right? There's 0 in inactive and there's just 1 in pending. So it's just going to be in the pending state for a minute. If you remember, we had specified that for a minute, it's going to wait if the instance is going to be down. So once it crosses the 1 minute threshold, it's going to go to the firing stage. Here, it's going to alert the manager. That is me currently. I will receive the mail saying that one of the instance is down, and it's a critical alert that you will have to address immediately. Okay. So that's how it really works. Now let's reload the page. And you can see that after a minute, it's entered the firing state. Okay. And there are none in pending state. So it was in pending state for a minute, and then it moved to the firing state. So in the previous session, we learned about how to create our own alerts in Prometheus and how to be notified about these alerts so that we can take discrete actions whenever necessary. So in the next part of the session, I'm just going to integrate Prometheus with one of the most famous visualization tools in DevOps, that is Grafana. So before I explain you about Grafana, I'm just going to briefly explain you about Node Exporter and how we're going to be displaying its metrics in Grafana. So Node Exporter is simply an exporter that collects technical information from Linux nodes, right? Such as CPU, disk, memory statistics. I'm sure you must be aware of this by now. So the metrics that the node exporter exposes of the Linux machine that we're currently working on, that is Ubuntu, all of these metrics are going to be visually represented in Grafana. We know that Prometheus doesn't have like a great UI, right? All of the information is very textual and it's not very like visually appealing. So with the help of Grafana, I just really want to, expose all of these metrics in a graphical representation like gorgeous or, bar graphs, anything. It could be anything. So before we download Grafana onto our Linux machine, I am quickly going to be making some changes in the YML file. Before that, I'm just going to check if my Prometheus is up and running. It is. And I'm also going to check if my node exporter is up and running. It is. So that's great. I'm just going to clear my screen. Okay, so now that is done. So I'm just going to list down the files that are currently in the Prometheus directory, and I'm just going to shift to my Prometheus file. So I'm just going to move into this directory. I'm going to list the files. Okay, great. So we're just going to make some changes in the prometheus.yml file. I'm just going to. Okay. Now you can see that you have our alert manager configuration, our rule files, scrape configs, a job name. But here in the static config, so I'm just going to add the node exporter as a target too. I'm just going to add the IP address of, currently it's running on localhost 9100. Okay, great. Just going to save this. And I'm going to restart Prometheus. Okay, it's up and running. I'm just going to clear the screen. Okay, great. Just going to go down. So now I'm just going to go back to my Prometheus directory, and now let's go ahead and download Grafana. I will click on my web browser and I'll just go to the official website of Grafana. So this is the official website of Grafana. I'm just going to click on the download button. So on this page, you can just click download. And then if you scroll down, you can see Linux. So these are some of the commands that you can use to download Grafana on your Linux machine. So I've already made a list of all of these. So I'm just going to use them to download Grafana. And okay, now that Grafana has been installed, I'm just going to clear my screen and I'm just going to check if it's up and running. So I'm just going to use this command to start the Grafana server, and then I will check the status of it. And it's up and running. Currently, it's running on port 3000. I'm just going to quickly shift to my web browser and check. As you can see that Grafana is up and running. That's great. If you've newly installed Grafana, the email address and the password by default is admin. Okay, and you can obviously create your own password. So once you're prompted with your credentials admin, then you can just create your own password and submit it. But I'm just going to skip this for now. And this is how the Grafana user interface really looks like. Okay, you can see that there's a search button, there's some icons on the left hand side, and there are also panels that you can play around with. So you can create your dashboard that will allow you to create beautiful visualizations for your data source, right? So once that is done, I'm just going to add my first data source. Just going to click this option in the basic panel. And here, as we are going to be working with Prometheus, we want our data source to be Prometheus. I'm just going to select this and it says data source added. So you can name your data source anything you'd like, but I'm just going to let it be Prometheus for now. And our URL of Prometheus is localhost 90, right? Once that is done, I'm just going to check if everything looks fine. Yes, it does. So for adding a data source, all you have to do is name it and then add a URL. That's how easy it is. I'm just going to save and test this. And this is great. It's working, right? So once I've saved and tested it, so I'm just going to click the Grafana icon that's present on the left corner, left top corner, and this will redirect me to my homepage of Grafana. Okay, now that we are done with this, I'm just going to click the plus icon and click on the option import. So what we're going to do is we are going to import the dashboard from grafana.com. So if I search for Grafana Node Exporter dashboard and click on the first link that's available, it will redirect me to a page which has the name Node Exporter full, right? So what it really does is it has an ID. The Node Exporter has an ID. So I'm just going to copy this ID to the clipboard and I'm quickly going to import this ID here, okay? And I'm going to load it. Because we're using the Node Exporter dashboard in Grafana, I'm just going to copy that ID and I'm going to go down. If you want to change the name, you can do that. And I'm going to select Prometheus as my data source. And I'm going to import this. Once that is done, you can see a beautiful representation of your CPU, your system load, your RAM used, and the root FS, the swap used. all of the information is beautifully being represented in gauges, right? These are gauges, okay? And these are the graphs currently. You can see that it's just been used here. You can see busy system, busy user, and all of how long it's been idle for, all of the information about the CPU. This is basic CPU information. You have storage disk. You have 8 panels here. You can see that here. So there's several different panels that have already been created by Grafana, and all you have to do is import it and add your data source. That is your Prometheus, right? And this is way better than viewing it on Prometheus, because Prometheus has everything in text and in terms of metrics. So it is very boring to view it like that. I'd obviously prefer Grafana to just view all of this.
So what exactly is AWS? Now, I've talked about this term for a very long time because I've been taking or conducting sessions on Amazon Web Services for a very long time. And in all my previous sessions and videos, you might have seen me talking about this term. But again, for people who are completely new to this terminology, let's get a quick introduction to what Amazon Web Services is. So this is what the definition has to say. It is a secure cloud service platform offering compute, power, database, storage, content delivery, and other functionalities like machine learning, big data, IoT, and a number of other services. Now, if you talk about Amazon Web Services, it provides you more than 100 services that concern different domains. So again, for people who do not know what AWS is and they're fairly new with cloud computing, they still might wonder, what does this definition mean? So let me just simplify this definition a little more. Let's consider this analogy. So I believe I've used this analogy as well. So what happens here is, basically when you talk about electricity, I mean, we all use electricity at home or at our offices, right? I mean, we have bulbs, lights, we have ACs, computers that constantly run and consume electricity. But all we are concerned about is using this electricity and paying the bill at the end of the month or at the beginning of the month, depending upon your cycle, right? So are we ever concerned about where does this electricity come from? Who manages it? How does it reach our homes? What if it goes down? Who takes care of all these things? How do they take care of all these things? No, I mean, even if we know about it, it does not impact our life in a particular way, because all our concern is using electricity, right? Making sure that our systems are charged, our bulbs are glowing, lights are glowing, AC is working. That is all our concern is. We are not concerned where does this power come from and all those things. Now, cloud computing is similar to this concept. I mean, what we do here is we pay only for the units of electricity we consume, right? So if you compare this situation with computing or building softwares and applications, you'd realize that building softwares and applications is a costly process because you have to have too much manpower, make sure every software is built, it is tested. You have servers to host your applications and stuff like that. Now, even servers are very costly and maintaining them is a difficult task. What if we could use these computing services and these infrastructures just like we used electricity? I mean, what if somebody else could take care of the servers, monitoring, maintenance part, helping you with the development part, and you paid only for these services and only for the time durations or units you use these services for? Wouldn't that be nice? It would be just like using electricity, right? So this is what cloud computing does. It gives you these computational database storage and various services, which we saw in the previous slide. It gives you these services and you pay only for the services and resources you actually use. And you pay only for the time duration you use these services. So I hope this analogy answers your question about how cloud computing works. Now, what is AWS? Now, when I say cloud computing, there are certain service providers that provide you these services, which I just mentioned. One of those service providers is AWS, and AWS is like one of the best service providers in the market, which has the highest market share. It is one of the oldest cloud service providers, and that is why its services are very smooth and they work with great finesse. So yes, AWS is a great cloud service provider. And if you talk about cloud computing, it is here to stay. Now let's discuss another terminology, that is DevOps, and then we would understand how AWS and DevOps go well together. So what exactly is DevOps? Now I just talked about software development, right? So when you talk about software development, you have to mention DevOps. Now let's try to understand why. To do that, let me give you this basic definition first. So it is nothing but a set of practices intended to reduce the time between committing a change to a system and the change being placed into normal production while ensuring high quality. Yes, very textbookish. And again, for people who do not know what DevOps is, this might seem a little vague. So let me just simplify this definition for you people. Again, you see an image here. What you see is you see a developer, you see an operator, and there is a deployment wall, which none of these two is ready to take responsibility of. They're pushing their responsibility on someone else. So yes, this is what the scenario is when you talk about software development. Again, let me give you a little more idea about this particular term. So let's try to understand how developers work and how operators work. And when you talk about developers, their responsibility is to create code, to update this code whenever required, wait for the next releases, and if there are any changes, commit those changes, submit those changes, and again, move it to the production environment where the operators take care of it. Then wait for the feedback from the operators if there is any, and then again, go through the changes if there are any. Likewise, wait for newer softwares, newer products to work on. So yes, this is what their responsibility is. Create code, create applications, right? So what happens here is when you do create a software, so there are constant releases that you need to focus on. We all know that every now and then you'd be getting a Windows update or your mobile phone update saying that, okay, you have a new operating system, new release, new version, update it. So this is how the technology is working. Everything gets updated every now and then. So the reason this is happening is people want to stay competitive in the market, the software companies at least, and they want to ensure that their product has the latest features. So this puts burden on the developers because they have to constantly update their softwares. Now, once they update a particular software, it has to go and work in the production environment. But at times it does not work in the production environment because the developer environment and the production environment might be a little different. So something that works in the developer environment might not work in the production environment. So again, some changes are thrown back by the operators and developers again get stuck. So they have to wait till they get the response from the operators. And if it takes a longer while, their work is stuck. Now, if you take a look at it from the operator's perspective, their job is to ensure that whatever is working in the developer environment, it has to work in the production environment as well. They deal with the customers, get their feedbacks, and if there are any changes which need to be implemented, at times they implement it themselves. If there are any core or important changes that are required, those have to be forwarded to the developers. So yes, what happens at times is what works, as I've already mentioned, works in the developer environment does not work in the production environment. And operators might feel that this was the responsibility of the developer, which they did not do, and probably they are facing problem because of it. Again, the customer inputs, if those are forwarded back to the developers team, the operator team has to depend on the developers to make those changes, right? So as you can see, these two teams are interdependent on each other. And at times they feel that somebody else's work, the developers' work is pushed upon the administrators, or the developers feel that the administrators' team's work is pushed upon their side. So there is this constant tussle which the company owners have to take care of. They have to think as in, okay, if this goes on, how can I generate or produce new releases, new softwares every now and then? This could be a problem, right? So this is what DevOps does. As the name suggests, it is Dev plus Ops. That means it combines the operations team and the DevOps team. When I say combine, they bring in this approach where integration and deployment and delivery, it happens continuously. And the fact that these things happen continuously, we do not see the tussle between these two teams. So yes, as you move further, DevOps helps you unite these two teams and they can work happily together. So this is what happens in DevOps. You code, you plan, you release, there's deployment, there's operations, there's monitoring, there's testing, everything happens in a pipeline. And these are some of the popular DevOps tools that let you take care of all these things. But now, again, this is DevOps in general. You have Git, you have Puppet, you have Chef, you have Ansible, SaltStack that help you automate this process of integration and deployment of your software. But the fact that everything is moving to cloud these days, we are thinking about how can we do all these things on cloud? Do I need to move in these many tools? If you want, definitely you can move all these tools. But a platform like AWS, which is a popular cloud service provider, what they have done is they've ensured that all the requirements of DevOps can be taken care on the platform itself, and you have various services that are made available to you that help you in this process. Now, say for example, you have EC2, right? Instances. Now, you can launch servers at your will. You can launch instances at your will. So if your concern is scaling up and down, AWS takes care of it. You have various services which help you monitor your process. So monitoring is something that is taken care of. There's auto scaling. There are various other services which this cloud front, which actually lets you create content delivery networks. I mean, you can have temporary caches where you can store your data and stuff like that. So there are various AWS services that actually help you carry out the DevOps or the CI/CD process with a lot more ease. And that is why DevOps and AWS, they form a very good combination or a combo. Hence, we are talking about this term today, that is AWS DevOps. Now that we have some idea about what AWS is, what DevOps is, let's try to understand how continuous integration, delivery, and deployment work with AWS and how they incorporate the DevOps approach. To do that, let's try to understand continuous integration and delivery first. So let's take a look at this diagram to understand this process. So these are the 4 steps that are there. You have split the entire chunk of codes into segments. So guys, think of it as more of your map reduce kind of an action. I mean, what happens is in your continuous integration and delivery, we are trying to bridge in the gap between the developer team and the operations team, right? So we try and automate this process of integration and delivery. So the fact that continuously you have various software updates, which I just mentioned, right? So what if I have like 50 or maybe 100 developers who are working parallelly? Now there are certain resources that need to be used by everyone, right? So what problem it creates is, suppose if I'm working on a particular code, I work on that piece of code. And if somebody else is working on that piece of code, and we have this central system where the data needs to be stored. So I'm working on this piece of code, I make a particular change and I store it there. Now someone else is working on this piece of code, and that someone makes a change and he or she stores it there, right? So tomorrow if I come back, probably I need a fresh copy of this piece of code. What if I just start working on the piece of code that I'm working and then I submit that code there? So there would be an ambiguity, right? Whose code to be accepted, whose code's copy should be made. So we need this central system to be so smart that each time I submit a code, it updates, it runs tests on it and sees whether it's the most relevant piece. And if someone else submits their piece of code, then tests are run on that piece of code. This system should be able to ensure that each of us next time when we go and pick the piece of code, we get the latest piece of code and we get the most updated one or the best piece of code. So this process of committing the code, putting in that piece of code and automating this whole process so that as it moves further, it also gets delivered and deployed to the production in the similar manner with the tests that need to be conducted is called as continuous integration and delivery. Now, integration, as I've mentioned here, the continuous updates in the source code or the code that I'm building, the code is built, compiled. And when I talk about delivery and deployment, the pieces of code, once they're ready to move to the production environment, those are continuously deployed to the end customer. Now, deployment seems a very easy process, right? I mean, picking up the code and giving to the end customer. No, it's not that easy. Deployment actually involves taking care of all the servers and stuff like that. And spawning up these servers is a difficult task. So automating this process becomes very important. And if you do it manually, you're going to suffer a lot. So yes, this is where continuous integration and delivery comes into picture. Code, it is continuously generated, it is compiled, it is built, then compiled again, then tested, again, then delivered, and made sure that it gets deployed to the end customer the way it was supposed to be. So you can see that there are certain steps here. It says split the entire chunk into codes or into segments, keep small segments of codes into manageable form, basically integrate these segments multiple times a day, which I mentioned that there should be a central system, and then adopt a continuous integration methodology to coordinate with your team. So this is what happens. I mean, you have a source code repository where the developers work, they continuously submit their pieces of code. Now repository, think of it as a central place where the changes are constantly committed. Then you have a build server where everything gets compiled, reviewed, tested, integrated, and then packaged as well. Finally, certain tests, final tests are run to go through the final integrities. And then it goes to the production environment where this process, the building, the staging, and the committing process, it gets kind of automated to reduce your efforts. So guys, when you talk about AWS in particular, you have something called as AWS code pipeline, which lets you simplify this process. It lets you create a channel or a pipeline in which all these processes can be automated. So let's take a look at those processes as well. First, let's get through the definition part. Let's see what it has to say. I would be blankly reading this thing and then probably we'd be having the explanation part that follows. So as the definition says, it is a code pipeline, which is nothing but a continuous delivery service. We talked about continuous delivery already. And you can use this service to model, visualize, and automate certain steps required to release your software. something that we've already discussed in continuous integration and delivery. So this is basically a continuous delivery service which lets you automate all these processes. So as I mentioned, automating these processes becomes very important. So once you do use this service, these are some of the features it provides you. It lets you monitor your processes in real time, which becomes very important because we are talking about deploying softwares at a greater pace. So if this can happen at real time, I mean, if there is any change and if it is committed right away, probably you're saving a lot of time, right? You ensure consistent release process. Yes, as I've told you, deploying servers is a difficult task and time consuming task. If this can be automated, a lot of effort is saved. Speed up delivery while improving quality. Yes, we've talked about this as well. And view pipeline history details. Monitoring becomes very important, guys. So what code pipeline does is actually it lets you take a look at all the processes that are happening. I mean, if your application is built, it goes to the source, then it moves to the deployment. All these processes can be tracked in the pipeline. You get constant updates as in, okay, this happened at this stage. If anything failed, you can detect as in, okay, this is the stage where it is failing, maybe stage number 3, stage number 4. And accordingly, you can edit the stuff that has happened at that stage only. So viewing the pipeline history details actually helps a lot. And this is where code pipeline comes into picture. So this is what the architecture of code pipeline looks like. It's fairly simple. Guys, so some of this might seem a little repetitive to you people because the concepts are similar. The concepts which were discussed, those can be implemented by using code pipeline. So yes, I've talked about these things, but let's try to understand how the architecture works. And we would be using some other terms and discuss some terms in the future slides as well, which we've already talked about. But each of these services, they do this task a little differently or help you automate these processes. Hence the discussion. So let's see to how much level can we keep it unique, and let's go ahead with this discussion as well. So let's see how the code pipeline works. Basically, there are developers, as I've already mentioned, these developers would be working on various pieces of codes. So you have continuous changes and fixes that need to be uploaded. So you have various services. One of them is code commit, which lets you have an initial source management system kind of a thing, which lets you basically take care of repositories and stuff like that. So it lets you directly connect with Git. I would be talking about Git, what Git is, but for people who know what Git is, if you have to manage your Git repositories, you have a service called as code commit. So this is what happens if there are any changes, those go to the source, your developers can commit those changes there, and then it goes into the build stage. This is where all the development happens. Your source code is compiled and it is tested. Then it goes to the staging phase where it is deployed and tested. Now, when I say tested, these are some final tests that have to be implemented before the code gets deployed. Then it has to be approved manually. It has to be checked manually whether everything is in place. And finally, the code is deployed to the public servers where customers can use it. Again, if they have any changes, as I've mentioned, those can be readily taken from them and it goes back again to the developers and the cycle continues so that there is continuous deployment of code. This is another look at it. It is very simple, but this is more from AWS perspective. So if there are any changes that developers commit, those go to the source. Now your data is stored in a container called as S3, that is simple storage service in the form of objects. So if there is any change that has to happen, the data is either fetched from the storage container, which is S3, and the changes are built. And then again, a copy of it is maintained in the form of zip. As you can see here, there are continuous changes that are happening and those get stored in the S3 bucket. Now S3 should preferably be on the region or in the place where your pipeline is. That helps you carry out the process of continuous integration and delivery with ease. In case if you are concerned with multiple regions, you need to have a bucket at each region to simplify these processes. So again, here to the code gets to the source. It is probably submitted to the build stage where the changes happen. A copy is maintained at S3 and then it goes to the staging. Again, a copy is maintained and then it gets deployed. So this is how the code pipeline works. And to actually go ahead and implement all the actions of code pipeline, you have a service or these services, that is your code deploy, build, and code commit in AWS. So these services actually help you carry out some or most of these processes that are there. Let's take a look at those services and understand what do they do. So first and foremost, you have your code deploy, code build, and code commit. So this is not the order in which you deal with these things. Now, these things actually help you in automating your continuous delivery and deployment process. They have their individual commitments. Let's talk about them one by one. First, let's talk about code commit, which is last in the slide. So basically, I talked about moving your piece of code to a central place where you can continuously commit your code and get the freshest or the best copy that is there, right? So code commit, what it does is it helps you manage your repositories in a much better way. I mean, think of it as a central repository. So it also lets you connect with Git, which itself is a central storage or a place where you can commit your code. You can push and pull that piece of code from there, work on it, make own copy of it, submit it back to the main server or your main or central operating place where your code gets distributed to everyone. So that is Git. And what code commit does is it lets you integrate with Git in a much better way. So you do not have to worry about working on two different things. It helps you in automatic authorization, pulling in the repositories that are there in your Git account, and a number of other things. So yeah, that is what code commit does. Then you have something called as code build. As the name suggests, it helps you automate the process of building your code where your code gets compiled, tested, certain tests are performed, and again, making sure that artifacts or the copies of your code are maintained in your S3 and stuff like that. So that is what code build does. And then you have code deploy. As I've already mentioned, deployment is not an easy task. I mean, if we are stuck in a situation where we are supposed to manage the repositories, we are supposed to work on quite a few things. In that case, if we are forced to kind of take a look at the servers as well, spawn new instances, spawn new piece of servers, that could be a tedious task. So code deploy helps you automate these processes as well. So this was some basic introduction to these things. Let's just move further and take a look at the demo so that we can talk about some of these terms and the terms that we've discussed previously in a little more detail. Now, in one of my previous sessions, I did give you a demo on continuous integration and delivery. I believe there were certain terms that people felt were taken care of in a speedy way. Hope that I've explained most of the terms with more finesse this time and in more detail. As we go through the demo too, I would try and be as slow as possible so that you understand what is happening here. So let's just jump into the demo part, guys. So guys, what I've done is I've gone ahead and I've switched into my AWS console for people who are new to AWS. Again, you can have a free tier account with AWS. It's very easy. You have to go and sign in, put in your credit card or debit card details. A free verification would happen and probably you'd be given access to these services. Now, most of these services are made available to you for free for one complete year. Now, there is certain limitation on these services. So you have to follow those limitations. If you cross those limitations, maybe you would be charged, but that happens rarely. I mean, if you want to get started, definitely this 1 year free subscription is more than enough to get hands-on on most of the services. So I would suggest that you create this free tier account. If you've taken a look at my previous videos, you would know that how to create a free tier account. If not, it's fairly simple. Just go to your browser and type AWS free tier, and probably you'd be guided as in what details have to be entered. It's not a complex process. It is fairly simple and it happens very easily. So you just have to go ahead and do that. Once you do that, again, you'd be having access to this console, guys. So once you have an access to this console, you have all the services that you can use. So in today's session, we would be working on a similar demo that we worked in our one of the previous sessions. Here we would be creating an application, a PaaS application, platform as a service application, and we would be deploying that application using our code pipeline. So there would be talking about other terms as well, like code commit, code deploy, and code build. So do not worry, we would be discussing those as well. So this is what the demo is for today's session. So guys, let's start by creating our PaaS application. To do that, we would be using Elastic Beanstalk, which lets you have a ready-to-use template and using which you can create a simple application. Now, this being a demo, guys, we would be creating a very simple and a basic application. So just come here and type Elastic Beanstalk. So when I come to this page, guys, if you've created an application, it would show you those applications. But the fact that if you're using it for the first time, this is the console that you'd be getting. That is why I have created this demo account so that probably we get to see how you can start from the scratch. So if you click on get started, guys, creating an application here is very easy, like extremely easy. You have to enter in certain details only. It takes a while to create an application, understandable. I would tell you why it takes the time, but once it happens very quickly. So all you have to do is give your application name. Let's call it, say, deployment app. I'm very bad at naming conventions. Let's assume that this is good. You can choose a platform, guys. You can choose whatever platform you want. Say PHP is what I'm choosing right now. As I've told you, it's a PaaS service. PaaS, that is platform as a service, means that you have a ready-to-use platform, guys. And that is why you can just choose your platform. And your Elastic Beanstalk would ensure that it takes care of all the background activities. You do not have to set up your infrastructure. It takes care of it. So once I select the platform, I can use the sample application or use the code if I have. In this case, I would be using a sample code that AWS has to offer, and I say create. There you go, guys. This thing is creating my application. So whatever is happening here, it shows that these are the processes. Now it is creating a bucket to store all the data and stuff like that. So it would take care of all these things, guys. It might take a couple of minutes. So meanwhile, let's just go ahead and do something else. Let me just open AWS console again somewhere else. I hope it does not ask me to sign in again. I've already signed in. So meanwhile, that application gets created. Let me just go ahead and create a pipeline, guys. So code pipeline again. It's fairly simple, guys. What happens here is very easy. I just go ahead and put in certain details here as well, and my pipeline would be created. So do you want to use the new environment or want to stick to the old one? You can click on old, right? And you can go back and create it the way it was done, or you can use the previous environment. I'm going to stick with that. I was very comfortable with that. So let's just stick with it. If you want, you can use the new interface. There's not a lot of difference, certain little or minor differences. So you can just come here and add in the name of the pipeline that you want to create, say demo pipeline. I say next. Source provider. Guys, I would be using GitHub here because I want to basically pick up a repository from GitHub that helps me in deployment. So I need to connect to GitHub for that. It would ask me to authorize. If you have an account, you can always do that so that it can basically bring in all the repositories that you have. So just say authorize. If not, you'll have to sign in once. So my account has been added here, guys. Repository, I need to pick a repository. This is the repository that I would be picking. Do not worry, I would be sharing this piece of code. Or else what you can do is you can just go to GitHub and type AWS-code pipeline-S3-code deploy-Linux. Now it is a repository given to you by AWS. If you take a look at it and if you type it just the way it is named here from AWS, you should get that repository in GitHub. You just have to go ahead and fork it into your GitHub account, and probably you'd be able to import that repository directly. You can see that repository has been forked here into my GitHub account. You just type the name here, this name, search it, and probably there would be an option here, fork. I forked it, so it does not activate this option for me. In your case, it would be activated. You have to just click on it and the repository would be forked into your account. So I'm getting or importing a fork from my GitHub. I've authorized my account, and then I can just go ahead and do the stuff. Branch, master branch, yes. And just do the next step. Build provider, no build here. I don't have anything major to build, so I don't need to go ahead and provide a build provider. You can use code build, right? Guys, if you want to move or basically deploy your code to EC2 instances, you can use code build if you want. In this case, I have an application in which I have an EC2 instance and stuff like that. So I don't need to go ahead and do any building stuff, hence no build for me. So I say next, deployment provider. In this case, my deployment provider would be my EBS. So we have that option. Yes, select EBS, Elastic Beanstalk, not EBS. EBS stands for Elastic Block Storage. That is a different thing, guys. Elastic Beanstalk, make sure you do that. Application name, deployment app was the name, right? Yep. And the environment. This is the environment. It creates the environment on its own. I believe that it has created the environment. It says it is starting. I hope the environment has been created. So guys, let's just see whether our application is up and running so that probably I can pass in the details. Yes, the application has been created, guys. So let's just go back and select this. Say next. Now create an IAM role is what it is saying. So let's say sample. Okay, guys, so what happens normally is an IAM user gets created each time you create a role. So in this case, it is asking me to create one. It's access, create a new IAM role, AWS code pipeline, and I say allow. Successful. So a role has been created. Next step. Now it gives me the details, guys. Basically, it would tell me what are the stuff that I've done. So everything is here. I don't think I need to cross check it. You might just cross check the stuff that has happened and say create a pipeline. So guys, the pipeline has been created here. As you can see, these are the stages that have happened. If you want, you can just go ahead and say release a change. Now these things are happening, guys, and let's hope the deployment also happens successfully. We've just created an IAM user. Let's see whether it falls in place. Everything is in place. As far as the source part is concerned, it has succeeded. And now the deployment is in progress, so it might take a while. Meanwhile, just go back and take a look at this application. So if I open this application, guys, it would give me an overview of what has happened with this application, guys. As you can see, these were the steps that were implemented. Now the application is available for deployment. It successfully launched the deployment environment. It started with everything that it was supposed to do, like create or launch an EC2 instance and stuff like that. So everything is mentioned here, what happened at what time. So this is a PaaS service, guys, and it works in the background. I mean, if you actually go ahead and launch an instance on your own, configure IAM users, configure security groups, it takes a longer while. But what the service does is it automates that process. It understands that you need an EC2 instance. It launches that instance. It assigns security groups, VPCs, and stuff like that. All you have to do is run your application on top of it, as simple as that. So it has taken care of everything and run a PHP application for me. So yes, this is what has happened here. If I just go back here, meanwhile, let's see whether our code has successfully run. You can see what has happened here. I've released the change as well. And you can view the pipeline history if you want. You can click on this icon and all the details will be given to you, what happened in what stage. So these are the things that have happened till time. Now guys, let's just go back and take a look at something that we could. So I'm going to come here and say service EC2 because my app launched an EC2 instance. So there should be an instance created by Elastic Beanstalk. See, one instance is running. It has a key pair attached to it as well. So these are the details, guys. I have a public IP associated with it. If I copy it, there you go, copy this IP, and I say run this IP, you have successfully created a pipeline that retrieved this source application from an Amazon S3 bucket and deployed it to 3 instances. It did not deploy it to 3 instances using code deploy. It deployed it to only 1 instance. You see this message that it deployed it to 3 instances is because the code or the repository that I used, it was supposed to deploy it to different instances if there are multiple instances, and hence this message would have made more sense then. But the fact that we've deployed it to only one EC2 instance, it should actually display that message. So the message that you're supposed to give, you can actually come back here and make change to the piece of code that you worked on. If you go to the readme MD file, I think this is where the piece of code is. There you go. Okay, no, not here. Okay, where is that file that needs to be edited? Let me just take a look at some other files as well. Yeah, this is the file, sorry. So if you go to the index.file, here is the message, guys. So you can probably make a change to this message. Instead of saying 3, you can say 1 here, edit this piece of code, and then you submit the code again. So when you do launch or type in this IP address, probably that change would be reflected. So guys, what we've done is we've actually gone ahead and created a pipeline successfully. And in that process, we've actually gone ahead and moved or deployed our application from here. So guys, in case if I do go ahead and commit changes to the code that I just talked about, those would get reflected right away in my history when I talk about this pipeline. So it does give you continuous integration and deployment. So these are the components of Azure DevOps. I mean, you have Azure Boards, you have Azure Artifacts, Azure Pipelines, Azure Repos, Azure Test Plans. Now, basically, these are different services that kind of let you carry out certain practices that concern DevOps. If you're interested or if you wish to create pipelines in which your products would be built, tested, and deployed, you need Azure Pipelines. Azure Artifacts let you keep track of all the artifacts that you're actually going to go ahead and use in your DevOps approach. Azure Repos is similar to GitHub, where you can actually go ahead and have your in-house repository or in-house orchestration, where you can actually go ahead and put in your repositories, commit them, pull them, basically branch them and do a number of things with them. Test plans, as the name suggests, it gives you plans using which you can actually go ahead and carry out the testing process when you talk about Azure DevOps in particular. Azure Boards, this is something that we are going to discuss in a little more detail today. So Azure Boards, think of it as a one place that basically unifies all these services or brings in all these services together. It is more of a dashboard that basically lets you keep track of all the activities that you do in this process. So whether it's about building your applications, deploying them, testing them, kind of importing your repositories, all these things can be managed on a single platform or on a single page, so that it creates simplicity. I mean, if you have a team of maybe 25 people, if all of them can interact with all these services on one single page, on one single dashboard, that would be really good. And That is what Azure DevOps exactly does. It is not just a medium which brings in all these things together. It does a lot more. So as we move further, we would be discussing that as well. But for now, that is what the definition says, or that is what I would define it as, by saying that it is a place where you bring in all these services together. So let us move further and try to understand something else. So what are the components of Azure Boards in particular? So guys, these are the terms that we would be more concerned about as we move further into the demo part. So let us try to understand these one by one. Calling them components, I'm not sure how right an approach that is, but yeah, these are more of the terminologies that concern Azure Boards. Now, I've already mentioned that it is a page that brings in all the services together. So basically what it does is it lets you keep track of all the activities that are happening. So whether there are certain work items that you're dealing with, whether you're dealing with certain issues, certain tasks, whether you're talking about different views in which you wish to view all the data that is there, whether you're keeping track of all the repositories that are there, whether you're keeping track of all the sprints, if you wish to take a note of what happens in a particular sprint, or if you have certain queries that you wish to throw into so that you can understand your process or you're working much better. In that case, you have your Azure Boards basically, which lets you take care of all these activities. So what are these terms and what do they do exactly? Let's try to understand those. Now, as I've already mentioned, each artifact that would go on your Azure board, I mean, whether it's an issue, whether it's a task, whatever it is, it comes under a particular classification. I mean, I want to make note of that particular artifact in the form of some entity. So that entity is my work item, as in what your work is being done, what your action is being done on this particular item. That can be taken note of by using this particular thing. Work item is nothing but basically creating a simple tab in which you keep track of everything. Okay, if I have a particular issue, say for example, I have some issue with committing a change to a particular repository. In that case, I can create a work item or an issue saying that, okay, this is the stuff that I'm working on, or this is the stuff that I need to keep note of. So this basically is a work item. Boards, now again, if you have a particular project that you're working on, now that project would have its self-defined board. In this case, you can think of it as a Kanban board basically, which is very popular, and it comes self-integrated with every project that you work on Azure Boards specifically. Backlogs, yes, the fact that you are working on sprints, I mean, let me simplify this a little more for you. Basically, Azure Boards also lets you keep track or lets you perform sprint management and agile development and management as well. That means you would be working on software development in different phases. So you would be working in different sprints, right? So there might be a possibility that you are working on a particular software or developing a particular software. In that case, you would be having certain backlogs, certain issues that need resolving. So in order to keep a track of it, in order to keep an order in the flow of your software development, you can always have backlogs which let you backtrack and keep track of what has happened and what has not. So for that, you have backlogs. Queries, we've already discussed that. I mean, you can always throw in queries to understand what is happening on your dashboard or on your board. Sprints, I believe we have a fair bit of idea about that as well. When you talk about dashboards, yes, as I've already mentioned, you have a separate board. Azure ensures that you get that simplicity. I mean, you get everything on one simple page. So as we move into the demo part, probably we would be understanding these topics in a little more detail. So let us quickly just do one thing, that let us quickly switch into the Azure boards and let us get started with the demo part so that probably these terms make a lot more sense to you people. So guys, what I've done is I've gone ahead and I've switched into my Azure portal. Technically, I haven't switched into my Azure portal. Azure portal is a one-time place or a single place where you can actually go ahead and implement or carry out all the Azure practices. So that happens with most of the cloud platforms that are there in the market. So in case if you wish to practice Azure, all you have to do is go and search for Azure portal or free tier for Azure, and you would be directed to a page where you can create a free tier account on Microsoft Azure. You'd be expected to enter your credit card or debit card details. This is because these services have an upper limit or a cap on top of that, so that you cannot exceed those limits. Because if you do exceed those limits, then Microsoft Azure would charge you, and that is why they need your credit card or debit card details. But if you are a beginner and you wish to practice, do not worry, these resources are more than enough for you to practice. So I would suggest that you actually go ahead and create a free tier account. Okay, one more important point. Once you create that free tier account, you have certain credits which are somewhere around $200 if I'm not wrong, 200 US dollars, And if you are from India, the fact that I am conducting this session in India, I have a credit. If I create a free tier account, I have a credit of somewhere around 12 to 13,000 Indian rupees, which is more than enough if I'm not wrong for the practice sake. And you have a validity of 1 month to practice these services for free. Once you exceed the 1 month part, your account would be deactivated or you won't be given access to the services. If you wish to have an access to these services, you would have to probably sign up to some plan that they have. But meanwhile, you can use these resources for free for a month actually. So with AWS, it is for 1 year. With Azure, it is for 1 month if I'm not wrong. So once you do have that free tier limit with you, you can visit this particular link. As you can see on the screen, you can actually go ahead and search for this particular screen. And once you do that, guys, probably you can actually go ahead and come to this page where you can start free with the boards. So let us see how can we get started with this particular service. So click on Start Boards. It would ask you as in, do you wish to continue? Just say yes. It is an Azure DevOps service basically. So it would ask you for the name of the organization. I mean, you have a structured approach here where you would be having an organization under which you'd be having projects. So let us call it, say, Azure Boards. Guys, I'm giving a random name because most of the names are taken. Azure Boards 1, 2, 3, 4, 5. Continue. Okay, I just backtracked accidentally. Let's say Azure Boards sample 1, 2, 3, 4, 5, and I say continue. So it creates an organization and it redirects you there, and then it says that actually go ahead and create a project. So I'm gonna say demo project for this session, and I'm gonna keep it public because I wish to add certain users. So let's just keep it public for now, because if I create a private account, I would have to look into access rights for the users that I'm creating. And there you go, your project is created. So you can go through this welcome guide if you want. I'm gonna skip it for now. So guys, this is how the interface looks like, and as you can see, I've mentioned that you can take a look at the backlogs if you've created, which I haven't in this case. You can create issues if you want. You can do that as well. You have an option of epics issues, which lets you basically keep track of all the stuff that you're doing. You have certain work items that you can add if you want to here. Boards, what boards are you using? Backlogs, you can keep track of all the backlogs that you do. Sprints and queries. So if you just come to boards and then you say add a new item, let's say sample item, there you go. So guys, you can see that it comes with these two options. You have a particular state here. So for now it says to do. What do you wish to do? It is that phase. Okay, so you can actually go ahead and change the state as well, saying once you do change the state, it moves to the next part, as you can see here. So if you are working on a particular action and you've actually moving from one state to the other, you can always make changes to that, and probably you'd know that, okay, what state is the work item into, what state is the issue into. So if I click on this thing, it would probably go back again. As you can see, you can add tasks here saying that, okay, this is a particular subtask or a task that needs to be done. Say for example, clear cache, and there you go. Cache has been added. If I am done with this particular task, say for example, I move into doing phase and I clear this task and I say I am done with it. There you go. As you can see, the color here has changed, indicating that the flow is correct and my task has been completed. So you can keep track of all the resources that you're using here. You can actually go ahead and add users. You can do a lot of stuff that is there with these projects. So come here and take a look at the overview. You can, suppose if you name it, say sample for today maybe. Guys, I'm gonna go very random with this session. I mean, whatever I feel is worth telling, I'm gonna go ahead and share that with you. I hope that flow is fine with you people. So there you go. Let's see if we can add a user from here. If not, we'll create a user from somewhere. Okay, so a user was added here. One user is added and assigned an access level to user one. You can view the status here as well. It says for now it has failed because probably I do not have the license to actually go ahead and assign users, but you can actually go ahead and assign users as well. So that depends upon the access rights that you have. Once you do that, you can actually go ahead and do a lot of stuff. You can just come here. Probably you can visit your dashboards and the demo projects that you are creating. Maybe go to boards. Once you do that, you can come here and add backlogs as well. Suppose I have an item here, which is this. Now say let's add a new item. Take a look at this issue. Say add to top. There you go. I can come and assign it to a particular user. Let's say I assign it to this particular individual, and there you go. The person can actually go ahead and make change to the issue. You can see the update is here, and if it is done, it's going to go to green again. And if I come back to my boards, you can see that it is here. Work items, again, if I actually go ahead and move it to the other state, that won't be a problem. It would again go to the green part. So this is how it works. You can actually go to the project settings as well. You can come here, you can do a lot of stuff here. Say for example, you can manage your teams, take a look at the security principles that are there. You can test. Let's not get into the test part for now, but let's say if you wish to have GitHub connections, you can connect to your GitHub account as well. Just come here and probably, okay, so you can just go ahead. My GitHub account is already added, I believe, here, so it shows that thing to me. Else you'd require to sign up as well, so you can just say save, and the repository gets added here. So you can actually go ahead and move to the repos part as well and take a look at the stuff that has happened here. Say for example, let me switch to some other account that I have. This is the one, or maybe Edureka boards. So if I go to samples, there was something I was wanting to tell you. Yeah, this is the part. So you can enable your repos as well if you want. Okay, you can enable your pipelines, even artifacts. You can see that all these things are available here as well now, because I've actually gone ahead and enabled those things. If you just enable these things, you can have access to these resources here and here. So if you have any files or stuff, you can actually go ahead and check if there is anything that is there in your repos or in your other services, and you can clone those. You can make changes to those services that you've used. You can commit certain changes to the code that is there. Say for example, you have some index files or some basic codes that are there. You can actually go ahead and edit those changes. Once you've actually edited those changes, you can go ahead and commit those. You can create branches as well. So you have your master branch, you have your sub branch, and you can make changes and commit those changes to the master as well. So when you talk about DevOps operations and various activities that concern a particular board, everything can be taken care of when you talk about Azure boards in particular. So this is it, guys. There is not a lot to explore when you talk about these services. These are very important to use though, because they help you keep track of a lot of things. I would suggest that you visit Microsoft Azure's documentation as well, because there are quite a few other activities that you can do with this particular service. Some basic activities which are simple, but something that are important and can be done as well. So as far as you are concerned, you can actually go ahead and explore as many services as you want, and you can understand what all can you do with Azure boards in particular. As far as this session goes, guys, I just wanted you to get introduced to this particular topic, and I believe I've done justice to that, and I hope that you've understood this particular topic to some extent where you can take it further and probably enhance your knowledge in this particular domain. Let us try to understand what is Azure pipelines now. Now basically this particular service helps you carry out following things, or this is what the definition has to say. Well, it is a service that caters the need for creating pipelines on Azure cloud platform, which is pretty much evident. And what it does is it lets you build, test, and deploy applications to Azure cloud and other supported platforms. Let me simplify this definition for you a little more. Now, basically what it does is it lets you create a pipeline. Now, when I say a pipeline, when you develop a software, it needs to be built. So there are steps involved in it. You would be picking up a piece of code, or you'd be creating a new code. Once that code is there, you would build that code. You would probably run some tests on top of it. If any changes are required, you would again build that code, again test it. And once it is ready, you would deploy and deliver it to the end customer, right? So instead of doing these things individually or doing these separately, what if there was a channel in which you could do all these things and keep a track of all these at one single location? Wouldn't that be nice? Well, when you talk about Azure pipeline, that is what it does. It basically lets you bring in all these actions under one umbrella. And these are some of the features that Azure pipeline has to offer to you. Let us take a look at those one by one. Well, Azure pipelines are basically platform and language independent. What do I mean by this? Well, if you have your application and you wish to run it on a particular platform, well, Azure gives you option for that as well. You can run it on maybe your Windows operating system. You can run it on your Linux operating systems. You can run it on your Mac operating systems as well. Plus, it is language independent. That means whether you are building a Node.js application, you are building it in some other programming language like Python or stuff like that, you can definitely run this piece of code or build your applications using different programming languages, and you can run those on different platforms as well. Freedom to work with containers. Definitely true. What do I mean by this? Well, containers are something that let you simplify the process of virtualization, or in simple words, they let you separate your piece of code and binaries from the platform on top of which you wish to run those. So in simple words, your code is locked into a container which can run anywhere. There are containers like Kubernetes, Docker. So basically what it does is it lets you push your applications on top of these containers. You have Azure Container Registry as well, if I'm not wrong. That is an Azure service for containerization basically. So you have the freedom to move your applications on top of these containers or inside these containers as well. Deployment to the other cloud vendors. Definitely yes. Now, the fact being that this is an Azure service and it lets you create pipelines does not mean that it restricts your applications to Microsoft Azure only. If you have been using other cloud vendors or your customers or whatever it is, I mean, your end goal is to move it to some other cloud platform, you can do that. If you're talking about cloud platforms like AWS, which is popular, GCP, which is a very good competitor, if you wish to move your codes or your applications to these vendors, well, definitely deployment to these vendors is also supported. Support for open source. Yes, Microsoft Azure has put in a lot of effort in recent times to ensure that Azure is open to open source projects, applications, and tools as well. This being said, it is very easy to integrate open source services with Azure these days, and that is why if you wish to keep your project open source or you want it to be accessible to others, you can take care of that as well. So these are some of the features that make Azure Pipelines a must-have tool or a must-have service. So let us just quickly move further now and quickly switch into the demo part, because I do not want to stall any of your precious time. So let us just quickly take a look at what Azure Pipelines can do for you. So guys, what I've done is I've actually gone ahead and I've switched into the console. Now, if you talk about Microsoft Azure, they give you some free credits to use Azure services for free for 1 month. The credits are somewhere around 12 to 13,000 Indian rupees and somewhere around 200 US dollars if I'm not wrong. So you can utilize these credits to use these services because these services are chargeable. But the fact that you have free credits, you can utilize these services for free for 1 complete month so that you can test and practice what these services have to offer to you. So if you do not have a free tier account, just go ahead and sign in for Azure portal. And once you do that, guys, you would be having this free tier account which you can use. Once you do that, probably you would want to search for Azure DevOps, something that we are going to use. Just type Azure DevOps in your browser and you would be redirected to this page. And from here on, I would be taking you further. So let us take a look at what you can do with Azure Pipelines, guys. So I'm going to start with Start Free. No sooner I click on this icon, guys, it would probably, if you are starting as a fresher or somebody who hasn't worked on any project, it would ask you to create an organization and a project to start with. The fact that I already have an organization or a project, it has actually redirected me to this particular page. So let me just quickly see if I can just go ahead and delete this particular project or organization and see if we can start fresh. How do you do that? Just come here and say delete. And this was the name. Just gonna copy it. Control C, Control V, and delete. So guys, when you click on start fresh, this is how it should start if you've started fresh. If not, you can continue from the interface where I just left from. So it says, do you want to get started with DevOps? I would say yes. Give it a name, your organization. I'm just gonna say sample for today. Okay, South India. I'm kind of based in Bangalore right now, so that is why it says South India. And it would say create a project. So the name should be demo project for me. You can name it whatever you want to. If the name is available, you can use it. Do I want it private? Do I want it public? I would say public for now because I wish to import certain repositories as well, and keeping it public would make it easier for me to get access to those repositories. No other reason. So I'm just going to go ahead and say create. So guys, we've gone ahead and we have an organization for our usage, and under that we have a project as well. So if I just scroll down, I would see following options. I can switch to these 5 services that we've discussed, and I can also have them on one tab as well, which you can see it here. I've already added those as extensions to my dashboard, so we can use it from here as well. Let's just say create pipelines for now. There are no pipelines here because I've deleted my previous project as well. So I'm just going to go ahead and say create a new pipeline. So where is my code is what it is asking me. Is it in Bitbucket? Is it in Azure repositories? Is it in GitHub? I have some pieces of code in GitHub. So let's just go ahead and use a random piece of code that is there in my repository. Once you click here, guys, if you're not authorized to use your repositories or use your GitHub, you would be required to sign in here. It would throw in a page where you can actually log in with your credentials to GitHub and pick up your repositories if you wish to use those. I have this one here. It is available actually. You can look for pipelines, Python, Django for Azure, and probably you would get these anywhere. You can just fork it by clicking here. If you do not have it, do not worry. I would be sharing the link for this as well. For now, let us just go ahead and continue with the demo part. So I'm going to select this. So guys, this is basically a piece of code for Django framework supported by Python. What it does, it tests a Django project on multiple versions of Python. It adds steps that help you analyze the piece of code, save, build artifacts, deploy, and more. So basically, you can visit this particular link as well to know more about this piece of code. So this is what it does. You can see step by step the information is here. What VM it is going to use. Again, what are the versions that it is going to use. What is the script that is here to export a particular path. Source, plus if you go ahead, these are some of the commands that you would be wanting to take a look at. These are nothing major. It just basically goes ahead and builds a particular project for you and deploys it. So let us just go ahead and do that as well. Let's just say run. So it would configure your piece of code, and once it starts doing that, you would get all the information as in what is happening here step by step. So bear with me. Let it just configure the stuff and give you the information. Probably might take half a minute to get started. And there you go, guys. It has already started. The agent is ready for the job is what it says, and it would start the connection. Once it does that, there would be a log made available to you people. So guys, this is what has happened, and this is what is happening. You can see it is getting logged step by step, whatever is happening, and you can see the commands and piece of code running in the background. And once it has succeeded, it would give you the status succeeded. So it initialized an agent, prepared a job, initialized the job, checked out, then it used a Python version. It did actually go ahead and explore or export a particular project, installed the prerequisite. It ran test on top of it. It published the piece of application or the result basically, and it actually did go ahead and check out and finalize the job. So these are the things it has actually gone ahead and performed. You can take a look at the summary part as well, as in this is what has happened step by step. Tests, these were the tests that were run and those were successful. So you have the stats for those as well. You can click on release, but there is nothing to release for now. So yeah, so you can choose where you wish to actually go ahead and deploy your application. You can carry out these steps as well. So these are the options that you have, and you can just go back. Let me just leave it. Yep. And if I overview, it said pipelines, it is 100% successfully built. Member is the account that I'm using. Pipelines, if I go here, it would give me information about that as well. This is the master branch that I'm using. I can actually go ahead and update my piece of code as well if I wish to. So guys, there are a lot of things that you can do. You can actually go ahead and commit certain pieces of codes here as well. You can go to repos. You can decide what piece of code you want. The existing master branch that you're using in the pipeline, you can actually go ahead and fork that particular piece of code. When I say fork, you make a copy of it for your own sake. You make changes in it and then you push it to the master, and if the master finds the latest version doable with the proper access admin rights, you can actually go ahead and merge that piece of code, something called as commit. You can commit your code to that particular pipeline. So guys, this is how your pipeline works. This is how your piece of code works, or this is how basically you actually go ahead and use your Azure pipelines. There are a lot of other things that you can do. You can actually go ahead and install certain extensions to your Azure pipelines so that you get quick sites, or basically you get analysis as in what was the process that was implemented and what steps it took. If you wish to know more about it, do visit our YouTube channel and visit Azure DevOps video where we've talked about that. The video also talks about how you can actually go ahead and add badge to your particular piece of code or your application, suggesting that whether all the builds were succeeded or were successful or not. As far as this session goes, guys, I believe I've talked enough about what Azure pipelines are. I've shown you a sample as in how you can actually go ahead and create a sample piece of code using Azure pipelines, or not a piece of code, or how you can actually deploy a sample piece of code using Azure pipelines. I believe most of the parts here are covered, but let us quickly take a look at some of the other pointers and then probably we can rest this session. So here you'd be having summary of what is happening. Dashboards, I don't think it would show any dashboard. You can just go ahead and add widgets if you want. So you can click it or click on this particular icon, select a widget. You can add it here and you can say add. So now if you go to your dashboard, you can select a pipeline here. Let's say this is the pipeline and I say save. So it gives me the history as in what has happened 4 minutes ago, and whatever changes happen, those can be studied and understood here.
What is Azure DevOps Test Plans? Azure DevOps Test Plan is a service launched by Azure DevOps that provides a browser-based test management solution for the exploratory, planned, manual, and user acceptance testing. It provides rich and powerful tools so that everyone in the team can use to drive quality and collaboration throughout the development process. It is easy to use and it is browser based test management solution which provides all the capabilities required for a planned manual testing and user acceptance testing or exploratory testing and for gathering feedbacks from the stakeholders as well. So now that we have come to know what is Azure DevOps Test Plans, now let's deep dive into the concept and understand what are these test plans basically. So first let us understand what do you mean by a test plan. So a test plan is nothing but a container for storing test suites that are nothing but a collections of test cases. So these test plan function by allowing you to establish a container in which you can group your all test suites. So as you can see in this diagram, this is a container which comprises of number of test suites which are grouped and then stored into these test plans. So test suites are nothing but the collections of test cases which then form a group and then they are stored inside these test plans. So there are three types of test suites, that is static based, requirement based and query based. So static based test suites are type of test suites that are used either as a container to group other test suites or to group a specific set of test cases. So in Azure DevOps Test Plan, you can have nested test suites. That means a static test suite itself become a form of a container where we can add different test suites and then we can place or as a place to create a test case ad hoc. So as I said, it will be in a nested loop form. So most of the time you will be using a static test suites as you mean by grouping test suites together. Next is requirement based test suites. So requirement based test suites are the simplest and the most traceable test suites. It is basically they pull all the test cases for a given requirement. This means when you go to build a test suite, you will not be choosing test cases. Instead, you will simply choose the requirements. So what happens next is that any test cases that have already been built or connected to that particular requirement will get pulled in and populate your test suites. So you can then run all of the tests for that particular given requirement. So if you use a requirement based test suites, your team can create a traceability matrices so that you not only see how your test cases align with your requirements, but also you can see whether a particular test case has passed or failed for that particular given requirement. And next comes the query based. So query based test suites are the type of test suites which pull in a group of tests from your project irrespective of what requirement the test cases are linked to. So it affords teams that have the ability to create a test suite using any criteria available. What does this mean actually is that when you are creating this type of test suites, it asks you how you want to pull these test cases and allows you to construct an ad hoc query to do so. So here you are not concerned with how test cases are connected to specific requirements, and instead it allows you to pull in the test cases that match a specific criteria. So when do you use these query based test cases is like when the team will run these tests on all the test cases that are currently in a given iteration
or run the test on everything with a given tag. So the idea behind the query-based test suite is that you can easily include test cases from your project that you would like to test irrespective of the affiliation to that particular requirement. So as I said, a test suite is nothing but a collection of these test cases. So what are test cases? Test cases defines to test a system, software, or any application. It can be a singular set of action or the instruction for a tester for a test to perform that validates a specific aspect of a product or the application functionality. So here in this particular test suite, you can have n number of test cases which can be then grouped based on the different types of test suites, that is static based, requirement based, and query based. Now that we have come to know about the test plans, test suites, and the test cases, now let us look on to some of the key scenarios which will help us understand why do we use Azure DevOps test plan. So Azure DevOps test plan provides software development teams some of the key benefits, such as they can test on any platform. So this means that with test plans web portal, you can use any supported browser to access all manual testing capabilities. It enables you to create and run manual tests through an easy to use browser based interface that users can access from all major browsers on any platform. Next is it has a rich diagnostic data collection. So here using the web-based test runner test runner, you can collect rich diagnostic data during your manual test. This includes your screenshots, image action logs, screen code coverage, traces, and test for your apps under the test. And this data is automatic in all the bugs you create during test, making it easy for the developers to reproduce this issue. Next is end-to-end traceability. Your DevOps provide ability of builds bugs. You can create your requirement qualities from cards on the Kanban board, and the bugs created while testing are automatically linked to the requirement and builds being tested to track the quality of the requirements and the builds. Next is integrated analytics. So in this, the analytics service provides data that feeds into built-in reports, configurable dashboard widgets, and customizable reports using Power BI. Data tracks test plan progress and trends for both manual and automated tests. The test analytics then provides real time visibility into test data for builds and releases. So, teams can act on this data to improve the test collateral to help maintain healthy pipelines. Lastly, is the extensible platform. So, you can combine the tools and technologies you already know with the development tools that work best for you to integrate with and extend Azure DevOps. You can use the REST APIs and contribution model available for the test platform to create extensions that provide the experiences you need for your test management lifecycles. So these were some of the major key benefits that makes Azure DevOps useful for the development teams. Now let's quickly understand how does these test plans work. You can work on with the test plans with two ways, that is manual testing and automated testing. In manual testing, the Azure DevOps test plan uses test specific work item types to plan and author these tests. In addition, it provides two test tools to support running the test. Test plans, parameters, and configuration hubs provide the tools to efficiently create, manage the test items, their settings, and as well as their configuration. Now, in this, the test suites can be dynamic requirement based or query based suites to help you understand the quality of associated requirement under these development, or static to help you cover regression tests. Next is automated testing. So, automated testing is facilitated by running the tests within the Azure pipelines. So, here the test analytics provide you real time visibility into your test data for builds and releases. It helps you improve the pipeline efficiency by identifying repetitive, high impact quality issues. So, these are the two types in which the test plans actually work. Now that we have come to know what are test plans, test suites, how do they work, so now let's have a quick demo on these test plans. Now let's quickly work on some of the demos where we'll create test plans, test suites, and see how it works. So for that, first we need to log into our Azure portal. So let's quickly log in. So for that, what do we need to do? First, we need to log in. Stay signed in. All right, now that we have come to our dashboards, here as you can see, this is the whole dashboard of the Azure portal where you find all the different kinds of services and resource group and all other subscriptions and stuff. So we'll be directly moving ahead to our Azure DevOps organization. Now let's go to my DevOps organization. So once we come here, so this is the dashboard of Azure DevOps where we can see projects and we can also create new organization. So it is basically you need to create a new owner where under which you have a different you can create different projects. So I already have one of the test plans, but we'll create a new project. So let's create a new project first and let's name it as Azure Test Plans Demo. Now we can give a descriptions to our project or else you can leave it as it is and it's just a demo for us. So I'll be taking the private option and now we can just create. So now our Azure test plan has been created. So this is our project overview. So in this, we can add boards, repos, pipelines, test plans, and artifacts. So let's quickly go to our test plans. Now once we come here, now we need to first create a test plan. So as we said, a test plan is a container where we have group of test suites. So for that, we need a container. So let's quickly create one new test plan. So let's name it as Azure Test Plan 1. Okay, that would be cool. And here you can choose the area path. So as our project name is Azure DevOps Test Plan, so we'll be keeping it under that. And the iterations, so here the iterations are nothing but our sprint. So we can take, or we can keep it as it is. Later we can just change whenever to sprint 1. So let's quickly create. So now that we have created our test plan, now under this, we will be creating the test suite. So now here we need to see, here we can create a test suite over here. So this is our test plan. Under this, we'll be creating a new suite. So as we discussed before, we have 3 types of test suites, that is static, requirement based, and query based. So we'll be taking here static suite. And now let's name it test suite 1. All right. Now our test plans are created and our test suite is also created. So if you go to our more options, so you can create one more under that particular test suite. You can create another test suite based on your requirements. And you can also assign testers to run the tests which are under these test suites. So now that we have created our test suites, so let's quickly go to our boards. Under that, we'll go to our sprints. So in this, we'll see whether our test plans are available or no. So as you can see here, Azure Test Plan Demo, that is our test plan. And under that, we have the test suite, which is under sprint 1. But currently, we don't have any test cases. For that, we need to create test cases as well. So as you have created these test suites, so in this you can either add new test suites under the test suite 1 or else you can assign the testers to the particular suite. But before that, we need to create new test cases. So now what do we need to do is we'll first edit our test plan and we'll choose our iteration, that is our sprint 1. So we'll be choosing that and we'll just save and close. So once we do that, we'll just go to our boards. So as you can see, this is our test suite and this is our test plan. So, and it is currently active. So once you go to our sprints, so here you can see, as I said, in sprint 1, we have only one sprint, but we don't have any test cases. So now what do we need to do? Now we'll go back to our test plans. And here, as you can see, we can have add test cases. So let's quickly new test case. So here we'll enter the title for our test case. So let's keep it quite simple. So let's create a test case like change the title size from H2 to H3. Okay, so what do we need to do is like we are changing the title size from H2 to H3. So here we'll provide the test case states that will be in the design stage. So here what do we need to do? Here we need to add the steps. How to change the title from H2 to H3. So let's quickly add some steps. Alright, so we'll just give couple of few steps, that is open home.html, then go to class is equals to hello, and then we will change from H2 to H3. So these are a couple of steps we can add, and based on that you can also give your expected results. Here we'll write size changes. That means the size gets changed. We need to check that. So we'll just save and close. Now let's create one more test case. Let's try one more. So we'll just create one more test case, that is new test case. So in this test case, we'll just write something different. Now we'll say change the title size from H2 to H1. And here, as we said, we need to give our steps. So we'll just follow the same steps. Open home.html, then go to class is equals to hello, and then change from H2 to H1. So we have also created the steps, and this will, so our expected result should be same. Now here you can also add the status, means you can give it the priority to our test cases. So there are different types of priority based on which you can create. So let's keep it 2. Let's not change anything, and we'll just quickly save and close. So we have 2 test cases. Now in this define section, we are able to see the different test cases which are assigned. Now we'll go to our execute, and here you can see that your test cases are also visible. So you can select one or multiple test cases. So let's quickly select one and just run for web application. So once we run the web application, so here you can see the steps are specified here. So now what I will do is go to these web applications and I'll check whether the changes have been done or no. When I open the home.html, if it is running well, so I'll just tick mark, or else if it is not, then I will just fail the test step. And then I go to the class hello. So once I go there, so I tick mark that, and I change from H2 to H3, so I'll click that. So once that is done, whereas here you can add some more steps, like here you can see insert new step. You can just create new steps, or you can delete the steps if you are not requiring it. So here you can just add any one new. All right. So here you can also take screenshots, or you can just select the image action and also create a video. Now once you have done this, we'll just save and close. So as you can see here, our test case, that is changed the title size from H2 to H3. So here it shows passed. Now we'll also do with the second one. So let's run it together. Let's see what happens. Okay, so here you can change your test. Like we have our first test and you can switch your test cases. So currently our one test has been done. So we'll do with our second test as well. So we'll just pass all the tests and we'll just save and close. All right, it shows active state. Let's see whether it has been done or no. All right. Okay, so what did we do? We did it for the first one as well. So we'll just quickly do for this as well. And just save and close. So as you can see, our both the test cases have passed. So now that our test cases are run, now let's go to our chart section. So here you can create a new chart. So here you can either create a new test case chart or the test result chart. So now first let's create the test result chart. So here you have different kind of charts. So let's select bar as just to make it simple, and we need it to group by. You can choose as per your requirement. If you have number of suits, you can choose that, or testers. So I'll take it as upper as the priority. So now here you can change the colors of your bars and you can customize it on your own requirement. So once that is done, so now this is the test case. As we said, we have only one test suite. So based on that, our chart looks like this. So now that we have just run both the test cases and we also see the charts as well. So there were two test cases that had run successfully. Now we'll just go to our boards, and in that we'll just select any one of the test cases. Now as it has been run successfully, we'll just change the state. You can change the state by ready, closed, anything. So it will be just, we'll close this and we'll save it. All right. And now let's go back to the work items and let's do the same as well with the second test case, that is the change the title from H2 to H1. So let's do ready and let's save it. So what do we do is now we'll just go back to our test plans and create a new chart and see how our test case looks. So let's check based on our states. So here you can see one is in the ready state and one is in the closed state. So we had changed the state of one test case as closed, means the test has been done, and one as it is ready. As said, you can also change the colors based on your choice. You can give any colors to your charts and you can show to the people. So in this test suits, let's create a new test case chart. So in this, let's take a pie chart itself and let's group it by the states. So as we change the state of each of the test cases, based on that, we'll be seeing. So as you see, one test case was closed and I had changed one of the test case to be ready. So we can see the differentiation based on it. So it will be helpful for the team also to understand that how many test cases are closed under which states. So this is for you can create. So this was under the test suite one. Whereas you can also do it for your test plans as well. So as you can see here, it is like you can create new test cases over here, and based on that, you can create a chart. Now let's create one more suite and let's see how does that chart look. So let's create a test suite, that is test suite 2, and in this also we'll have a test case. Let's create a new test case like hello world, and we'll give couple of steps. Open hello world dot HTML, go to class, and then print is equal to hello world. Alright, now we'll just save and close. So this is our test case. So now we'll not run this test case now. We'll just create a chart and see how does it look like. So we'll just go to our test plan itself. So under this test plan, we will create a new test case. Okay, so here you can see it automatically gets changed. You don't have to like create a new chart over there. It automatically gets changed, and you can see one is in the design stage, one is in the ready stage and close stage. Whereas you can also edit it while if you want to change the constraints based on like state or anything. So you can change it accordingly. So I'll just keep it as it is. So this is how you do the manual testing in DevOps test plan. Whereas I said you can also do the automated testing by building pipelines, and with those pipelines you need to connect it with your test suites, and through that you can just automate all your test plans. What are Azure artifacts? So, according to the definition, Azure Artifacts is a package management system integrated with Azure DevOps that allows you to develop and share packages like Maven, NPM, and Nugget, etc., via public and private feeds to any size business. So basically, Azure Artifacts is kind of an extension that makes it easy to discover, install, and publish packages in Azure DevOps. It's deeply integrated with other hubs like Build so that package management can become a seamless part of your existing workflow. It enables developers to share their code efficiently and manage all their packages from one place. Using Azure DevOps artifacts, developers can publish packages to their feeds and share it within the same team, access organizations, and even publicly. So this was all about what are Azure artifacts. Let's quickly move on to the next, that is why Azure DevOps artifacts. So there are three main features in Azure DevOps artifact which makes it more special and demanding. So let's quickly have a look. What are those three? So first is you can keep your artifacts organized. So what does it mean? That you can share code effortlessly by storing any packages irrespective of whatever programming language you are using, like Maven, NPM, Nugget, and Python, etc. You can just feed them all together in the artifacts and keep it organized. Second is protect your packages. So here it means that you can keep every public source package that you use, including packages from npm.js and nugget.org, safe in your feed where only you can delete it, and it is backed by the enterprise grade Azure SLAs. So that means that all your packages are safe and secure. Third is integrated package handling into your CI/CD pipeline. So what does it mean? That you can access all your artifacts in builds and releases in which artifact integrates natively with the Azure pipeline or CI/CD tool. So these were the three benefits, or we can say features, that makes Azure DevOps artifacts more demanding and mostly helpful to users, basically like developers. So let's quickly move on ahead. So next is Azure Artifacts workflow. So let's see how Azure Artifact work. So it is a three-step process in which makes it easy to work. So we can see the first step is to create a package. So basically what is it? A package feed is a location you use to host packages you want to deploy with a deployment manager. So when you set up a deployment manager, you need to choose a feed you want to use to host your package. So here what do you do? First you create a package feed or a team feed. So once you create a team feed, then we move on to the next step, that is build integration. So basically what do we do here is like we connect to the feed in the Azure DevOps and then we start building integration. The main purpose of build integration is to define the order in which the components and subsystem should be implemented which builds to create when integrating the system and how they are to be assessed. After this, we move on to the third step, that is consume from feed. So here what do we do is that we pack and push packages to your feed, and then we consume feed by running build and restoring packages from team feed and setting up new solution locally to consume the feed. So these were the three easy steps, or we can say the whole workflow of Azure DevOps Artifact. So with no wait, let's quickly move on to our demo where we'll see how do we work with the artifacts. So first we need to open our terminal. Let's open our terminal. And now what we'll do is we'll create a folder where we'll be storing our both the projects. So let's quickly create the folder. So here you can see our DevOps folder has been created. Now let's just confirm whether it has been created or no. Document. All right. So here you can see this is our DevOps folder. So now here we'll be adding our both the projects, whatever we'll be building. So let's quickly build our projects. Let's move to our Visual Studio. Okay, so here we'll be creating our project. So as I said, I'll be using the Java project. So let's quickly make it. Control Shift P. And this is the option, create Java project. So we'll just click on this. And I'll be taking Maven. You can take any other tools like Gradle, Spring Boot, Quarkus, Microprofile, any of your choice. For me, I'll be choosing Maven and then Maven Arctag Quick Start. And our version would be 1.4. And now here we need to give a name to our group ID. So let's keep it Azure Artifacts. All right. And now they ask for the artifact ID. So we'll keep it very simple, project 1. And here we need to select the folder. So we'll be selecting the DevOps folder which we had created. So this would be our destination folder. So here you can see it is executing. All right. So here you can see your group ID, artifact ID, and the version. So our version would be 1.0 snapshot. So just copy this and paste it over here. Hit enter. And they ask for the confirmation of your properties. So our group ID is Azure Artifacts, artifact ID project 1, version 1.0 snapshot. Package. So here we must update the package name. It should be similar to the artifact ID. So let's just update it. Snapshot, our version is 1.0 snapshot. And package, will name it as our artifact ID. So project 1. Yes. And here you can see our project 1 has been created successfully. And here you get the message and we'll just open this. All right. So here, as you can see, this is project 1 and you do have your source files and pom.xml. So this is the where you find all your dependencies. So let's quickly build our project 2. We'll follow the same process. Control Shift P, Java project, Maven, type 1.4, and our group ID would be same. So Azure Artifacts, and this will name it as project 2. Now select the folder, destination folder. All right. So here we see our group ID, artifact ID, project 2. Let's keep the version same. So just copy this and we need to update our package. So let's update it. Project 2. Yes. All right. So our project 2 has also been successfully built. Here you get the message. We'll just open this as well. So here also you can see your source file and your pom.xml file has been created. So now both the projects are created. Now what do we need to do is to create the dependencies. So let's create the dependencies. For this, we'll just maximize this. In project 2, we'll come to this dependencies section and we'll copy this dependency code, copy, and just paste it below. And now what do we do here is, as we need to create the dependencies, so we'll change the group ID, artifact ID, and your versions. So what would be our group ID is Azure Artifacts, which we had created. So let's just copy and paste. And our artifact ID is project 1, as we are making project 1 dependent on project 2. So let's write it project 1. Alright, our version would be 1.0 snapshot. Cool. And our scope would be system. Now below this, we need to give the system path. So let's quickly give the system path. Okay, so our system path would be $base star live project 1-1. So here we get the option 1.0 snapshot.jar. So we'll quickly save this and we'll open our terminal. So let's open our terminal. So now to build this jar file, we need to go to project 1. So let's go to project 1, cd project 1. Alright, so here what do? We'll just hit the command maven compile. Alright, so here it shows it has been built successfully. After this, we'll just hit the command maven package. Alright, so your maven package command has also been run successfully. Let's quickly cross check it once. Let's go to project 1. Now here we see the target folder. So let's quickly check. So here you can see your project 1.0 snapshot.jar file has been created. Now what do we need to do is we need to copy this jar file and paste it in project 2. So for this, let's create a folder in project 2. Let's name it live and we'll copy this jar file and paste it in. Okay, now what do? We'll run the same commands, that is maven compile and maven package, in project 2 as well. So let's quickly go to project 2. Maven compile. Alright, so here you can see it has been built successfully. Let's run another command, that is maven package. Alright, so here you can see maven package has also run successfully. So this is how you create the dependencies between the two projects. Now let's quickly move on to our Azure. So we'll go to our Azure DevOps. Okay, so here first we'll be creating a project. Let's create a new project and let's name it Azure DevOps Artifacts. And we'll make it private. Like you can choose any one of the you can choose the visibility of your own choice. So but I will prefer private and we'll create it. So this is our new project. Here you can see there are different options like boards, repos, pipelines, test plans, artifacts. So first we'll go to repos and here we'll be uploading our project, whatever we have created right now. For this, now what do we need to do? The first step is so let's go to our project. Now we have created the dependencies, like we have created our jar files and both the projects are dependent on each other. So it is basically typically for like one developer environment. But let us assume like if you have two different teams, and then what you need to do, that you need to always come over here and open the jar file and just update the versions of the jar file every time. So what do you need is to have a central location where you have all these files, and then every time whenever you compile these projects, then it is going to go ahead and the latest file, and then it is basically that you don't need any more, like you won't have to just come over here and keep on updating your versions. So it would be automatically done. So for that, what we'll do we'll just delete this jar files from here so that only the code is like transferred to our reports. So let's go to our files and go to project 1, and in target there is a jar file. So we'll just delete this jar file. Same would be done in project 2, project, and we'll just delete this folder. Alright, so now that is done. So let's move on to our terminal. Now we need to move to our destination folder where we have posted, where we have built our both the projects. So I have come here to this DevOps folder. Now what we need to do is we need to send these two projects into our Git repository. For that, we'll git init and then git add all and then git commit and then first commit enter. So here you can see our both the files have been gone into the repository. Now what do we need to do is we will go to our repository and we'll just copy this git remote add origin. So what do we need to do is we'll just copy this link, copy, and git remote add origin, git remote add origin. And now we'll use the git push command. So let's use it, git push -u origin master. Alright, so our files are uploaded now. Just let's refresh this repository. Let's go to repos. Okay, so here you can see both the projects are uploaded over here. So it is quite clean. We just have our formx.xml and our source folder. We don't have our jar files or anything as such. Now after this, let's move on to our artifacts. So here first is we need to create a feed. So let's create a feed. Let's name it project Azure app. And here we can give the visibility. It's upon you, like whatever choice you need to give. So you can give the visibility like only accessible to the members of the organization or to the specific people. So I'll select the second option and upstreaming sources. So here we like from the public sources, we include the packages, like no matter whatever languages you're using. And our scope would be project. It can be either project or organization. So for me, I'll be selecting the project and I'll just create it. So yes, as you can see here, our feed has been created. Now next, what do we need to do is connect to feed. So here you can see all different languages, the packages which you need to like connect and you need to feed on to the artifacts. So here there are different languages like .NET, Nugget, Visual Studio, NPM, Gradle, Python, Pip. So you can choose any one of your choice. For me, I will be choosing Maven as we have worked on Maven. So let's, what do we need to do is here, let's copy this repository and we need to paste it onto our project files. So let's go to project 2 and let's search for our repository section. So do we have any repositories? So no, we don't have repository. We need to create a new repository. So let's create a repository just below our dependencies. So repository is Let's close it. Alright, now what do? We will just paste the code over here and just save it. Now we can also copy this whole code and paste it on project 1 as well. So this is a project 1. Let's go and do the same thing under repository. Under the dependencies, we'll paste this repository code and we'll save it. Alright, so now you can see this URL. So this URL needs some authentication as this is private. So how do we give the authentication? So let's move on to our Azure DevOps. Here we'll go to personal access key tokens, and here we'll be creating a new token. So let's create a new token over here. You can give any name to your token. Let's keep it project Azure app artifact. All right, and let's give the authentication. We'll give the packaging read, write, and manage. Once that is done, let's create. So as you can see, your token is created over here, and this is your password. All right, so just copy this password. Now, where do we put this keyword so that we can authenticate? So there's a folder, Maven folder, that is m2.m2. So we'll go to that m2, and here you can see the repository folder, and there's a settings.xml. So we'll go to the settings.xml file, and here you can see this is the code where you can give the authentication to your Maven project. So here, this is the code server. Under this, you have your project ID, project azure.app, and your username is your organization's name. Now let's paste the password which we had copied. So let's paste it over here and let's save it. So now let's go to our Azure DevOps and we'll go to the artifacts, connect to feed, Maven. And so here you can see the settings.xml file, your username is there, and your personal access token which we created previously have been initiated. Now what do we need to do is copy this repository as it has been updated. Let's copy this and paste it again to our both the projects. So we'll just copy this repository, paste it over here and save it. Let's do the same with our project 1. So this is our project 1. Alright, so we'll save this as well. Now what do we need to do is we need to also have this distribution management code. So let's find out if we have this section. So we don't have it. Let's paste it again to just below the repositories. Just close this. Copy, paste, and close. Now what do we need to do is copy the same repository code and paste it just inside this distribution management and save it. Alright, now we'll just do the same thing with, this is for the project 1, we'll do it for project 2 as well. Let's copy project 2 and paste. Alright, so we'll save it. So now let's move on to the terminal of project 1 and npm deploy. Alright, so here you can see it has been successfully built. Now let's just check whether it has come or no. Let's go back and refresh this. So here you can see your project 1 artifact have been created. Just click on this and here you see all your details, all your files are already existing. Now what do we need to do is just copy this dependency and we'll paste it in our project 2. So we'll just select this and paste it and save, and let's npm Deploy. Even this has been built successfully. Let's check. Refresh. So here you can see both the projects have been uploaded, and this is how you push your packages into your artifacts. I hope you all understood how actually the Azure DevOps artifact works. How do we push packages into our artifacts?
Now I would like to brief you through the process of how machine learning works actually. And this is pretty much common for most of the algorithms that you're going to implement. First and foremost, you would be needing data. Now I've already talked about the point that data is centric to machine learning. If you do not have data, you cannot make any predictions. And more the data, the better it is for you. So the first part is having data. And once you have the data, the next point you need to confirm or make sure is the data is appropriate for machine learning. And this is where pre-processing steps in. What pre-processing does is it helps you process the data that you have and prepare it for machine learning. I mean, your data might not always be clean. There might be some missing values, some repetitive values, which you do not want in your data when it is getting processed, right? So in this case, we filter out this data, we clean it, we fill in certain values, we predict certain values, and we put in those values there. And once this data is up and ready for working, then we pass it on further, and then we provide a particular machine learning algorithm to it. Now, this again is a trial and error kind of method where it seems simple at times because we've discussed all those machine learning algorithms, right? So to naked eye or to naked mind, basically, we might think in this direction where we would think that, okay, this is the kind of problem I'm dealing with, so this is the algorithm I might use. But that is not the case. At times, the data is misleading. We are not sure what kind of algorithm I want to use, what kind of data I want to pass, and how much data I want to pass. In that case, what we do is we first allot a particular algorithm, use it, implement it, then we test the values, then we try out some other algorithms as well, and then we come to a conclusion as in, okay, this is the best algorithm, and using which I've generated a model which is best to meet my needs. And while doing that, there are quite a few processes that happen, processes like training, testing, validating, where you pass in certain amount of data, you build the model, you train the model, and then again you pass or keep some data behind, which you later pass to test these models, as in are they working properly or not. So this is an iterative process, and this might take in more than one iterations to actually go ahead and jot down or settle down onto a particular point. So once your algorithm is selected, once your machine learning model is built, you can actually go ahead and deploy this model into your environment or real-time working where it would be able to predict the real-time data or the data you provide your so-called algorithm, right? So this is how the whole process of machine learning works. Now, the processes which I talked about, pre-processing, then implementing various algorithms, training, testing your data. Now, this again, they look simple, or when you listen to them, they seem pretty easy, as in training the data and all those things. But once you start implementing these things, it is fairly difficult. Ask any data scientist and that person would tell you that pre-processing is something that is very difficult to deal with. And mostly 60 to 70% of the work is done in these phases only. So what if we had something that could actually help us here? Wouldn't that be easy? I mean, if we could just speed up this process of pre-processing, algorithm selection, training and testing data, instead of doing these manually, can we do all these things automatically? The answer is yes. Now, this is where your Azure Machine Learning steps in. What Azure Machine Learning does is it helps you carry out the whole process. But as you can see, we have something called as ML Studio, and it focuses on your pre-processing, application of algorithms, and deployment processes. So bulk of the task which can be repetitive or which can require you to put in more efforts to implement manually, it actually helps you automate or speed up that process. So that is what ML Studio is basically. It is a studio or a service in a very popular cloud service provider, that is Microsoft Azure, which lets you implement various machine learning algorithms, and it carries out the bulk of tasks or the bulk processes which you would otherwise not want to do. Now, this is not something that actually is used to replace data scientists. You cannot do that. So no offense to any data scientist who is listening to this video or going through this video. It is more or less complementary to data scientists. You would be needing statistical knowledge, and hence we talked about machine learning a little, because even if you build models using Azure or any platform, you would be required to have proper statistical acumen or knowledge about data science, something that would help you understand the output of the models that you've built. So yes, some statistical knowledge would always help and you cannot replace that. But definitely if you are working on machine learning and you need to speed up this process or make it more efficient, then Microsoft Azure and ML Studio in particular is a very important resource for you to have. So what I'm going to do now is I'm going to switch into the demo part, and we would be building a model so that we can discuss some of this stuff that I've already talked about. And we also get to see how Microsoft Azure works in real time, right? So let me just switch to the Azure portal or console that we have at our disposal. So guys, what I've done is I've gone ahead and I've switched into my Microsoft Azure portal. For people who are completely new to Microsoft Azure, you can actually avail certain services that Microsoft Azure offers you for free for 1 month. Now, during this period, you can avail certain credit for US citizens or people who have an account in US region. They can actually avail up to $200 of usage where you can use certain services. Now, these services are chargeable. That is why the free credit that is made available to you. So, which I believe is more than enough for 1 month's practice. So if you're somebody who's new to these platforms, I would suggest that you go through or sign up for Microsoft Azure and you can avail those services. Now, since I am from India, we have Indian rupees as our currency. And for our usage, we are given somewhere around 13,300 INR or Indian rupees, which is a very big amount if you talk about using a service for a month's time. So it actually serves my purpose. I have been using it for a long time. That is this particular account. I've had a couple of accounts, but this one is something I created some 15 days back. And as you can see, I still have like 12,400 something, which I can use. And we would be not needing this much today, somewhere maybe 10-20 rupees to the max. So yes, you can go ahead and create this account. Once you do have this account, then you'd be having access to all the services that Microsoft Azure has to offer to you. You can go ahead and create all the resources you can have or utilize its compute services, storage services, database services, and all the services that it has to provide to you. But since we are talking about machine learning, we would be sticking to those applications as well. So in order to use your Azure machine learning, you need to create a workspace where you can actually go ahead and put in all your data. And once you create your workspace, you actually need to go ahead and sign into the Microsoft Azure ML Studio, which is an interface or IDE where you can actually go ahead and create all those models. So in order to go ahead and create a workspace, you just need to come here and type machine learning. And you might be having that thing in the suggestion. It was already typed, I believe, machine learning. And you have this place where it says machine learning studio workspace or service workspace. You can click on these. The studio workspace is something I've clicked on. And you need to put in some details, as in what is the name of your workspace, what subscription are you using, resource group. You can use the one if you already have one. If not, you can create one. Just give in some name. Now, resource group is something that holds in details about your resources that you're using, and then what kind of storage account you are using. You can create a storage account as well. It's not a big deal. It is nothing but think of it as a storage place where you can store in your data. That's it. So you do go ahead and put in these details and then you say create. Before that, you have to put in what pricing tier are you using, and you'd be entering the region where you want your workspace to reside. Now, what cloud does is it stores your data in particular locations on the globe, right? So you can choose the location that is closer to you or closer to your business, depending upon your needs. For now, I'm gonna stick to the basic one that is here because we are just creating a simple demo. In fact, I'm not gonna go ahead and create a workspace because I already have my own workspace. But I would suggest that you put in these details and create one. Once this workspace is created, you can actually just open it, and at the bottom you would be seeing an option called as Machine Learning Studio. Else, what you can do is you can type in this URL and you would be redirected to this page where you have to sign in with your Microsoft Azure portal account. And once you do that, you would be redirected to the ML Studio that I'm talking about. So the workspace would be created. Once the workspace is there, you log into your Azure ML Studio. And once you do that, this is what you'd be having at your disposal. Now, these are some of the experiments that I might have worked out or worked on in last week or so. Some of them are finished, some are still in drafts. So you can actually go ahead and create these workflows or these kind of workflows. Now you have so many options here. What are the projects that you create? Experiments, which we just saw. Different web services that are made available to you. You can actually go ahead and create web services as well. You have your notebooks. Now, you might not always go ahead and start from the scratch, right? You might have your code written in maybe R or some other language like Python. So you want to import that code, you can do that as well. Or you can use the existing notebooks which Microsoft Azure has offered to you, where you have ready to use codes or ready to use models as well. And then we have data sets. Now, again, you can import your data sets that you have. There was one financial sample data set which I imported recently. you can actually go ahead and use sample data sets as well. Now you can see there are quite a few data sets that are made available here, which you can use and implement your own algorithms or implement the algorithms that Microsoft Azure has to offer to you, right? So you can do that as well. So it pretty much depends upon what do you want to do and what kind of processing do you want to do. As you can see, if you come here, you have some, this is somewhere you can see your trained models as well as in the work you've done or some models that you've implemented. So you can have that here. In this case, we are going to go ahead and implement one of the algorithms or algorithms that are implemented by Microsoft Azure. So if I come here to experiments and I go to samples, you can see that we have so many implementations. So we would be taking a look at one of these and then we would be implementing that on our own. Do not worry, we won't be copying it right away. So we have quite a few options here, as you can see. Okay, let's just go ahead and do one thing. Let's build our own model here. So for that, we need to go to experiments, or rather we can come down here and say new, and I say add a blank experiment. Let's just go ahead and try to build a recommender system or something like that. So to do that, let's call it say my recommender. There you go, and save it. Okay, there are no modules, so you cannot save it. So first, let's get started. Now, in order to create a recommender, for people who do not know what a recommender is, it is nothing but you pass in certain data and it might suggest, or the model might suggest you as in what you might like or what you might want to do. Say, for example, when you shop on Amazon or any other website that is there, you normally have some suggestions, right? I mean, you may like this, you may like that. Same as with YouTube, you go through certain videos and it gives you suggestions as in you preferably might like these videos as well. So that is a recommender system. So let's go ahead and create one recommender system. Let's create one for movies. So let's just go ahead and practice or play with the data that we have. For that, we would be needing a data set first, right? Now, if you talk about ML Studio, it is very simple. You just drag and drop stuff, just like creating workflows. It is as simple as that. Now, in order to use a particular data set, we have these saved data sets here. Samples. Let's make a recommender systems for movies maybe. Yep. So movies. Do I have something in movie? Yeah, there you go. Movie ratings. So we would be using this data set. Now, once you put in this data set, it is available. You can just go ahead and take a look at it. So let's just visualize this data. And as you can see, the information is here. It has certain values like user ID, movie ID, ratings, and timestamp. Timestamp is something that people do not use frequently, but yeah, these are things that are important to us. We have factors like your ID, that is your movie ID, user ID, and rating. It's somewhere around up to 10. So I believe it has started from 0 or 1 maybe. So we have ratings from 1 to 10, which we would be using. So this is the data that we've just visualized, but at times this data is not as simple and as managed. It might have some missing values and you might be required to play with it or make some changes to it. You can actually go ahead and put in some factors here as well. Now here you have so many options that are made available to you, right? So you can actually go ahead and process your data a little, manipulate your data a little, like you can take a look at statistical analysis and all those things. But this being a clean data, we do not need to do that. So we're just going to stick to the recommender system part here. So we have the data set now. I need to select the columns that I want to use. So I'm going to project certain columns out of it. So for that, we have a module here called as project columns. Okay, I don't see it here. I believe they've changed the name. Select columns to, okay, so this is the one. They've changed the name. It's called as select columns in dataset. So we drag it and place it here. And we hold on to the circle that is there on the previous module or the tab we had, and we pull it down so we can connect these two. Now they are connected. But since I've connected them, there's an error here. It says value required. Now I need to pass in some values as in what are the columns I need to focus on, right? So I would be clicking on this icon here or tab which says launch column selector, and it gives me options. So I'm going to put in certain rules. Now, what are the columns that I want? First, I would say that get in all columns and just exclude the ones that I don't want. So what are the columns that I do not want? Timestamp was something that won't be very handy. So I'm going to remove that. So I would be excluding that and I would be saying OK. Once you do that, the error is gone. So we have the data set, we've selected the columns. Now, next phase is I need to go ahead and pre-process the data, but data is already pre-processed. So I don't need to do that either. So in this case, I would be going ahead and splitting my data into two parts, my training data and my testing data. Training data is something that we would be passing on to the model and we would be training a model based on the data. And test data is something that we would be holding back. And then we would be using that testing data to test our models or to predict the outcome or to see whether the model is working fine or not. So to do that, we need to split our data. So come here This process is easy. Just go ahead and type in the words that you need to do, and it gives you modules to do that. So split data, I just pass in the data. So I've gone ahead and I've created or I've pulled this split data module or tab into my workflow. So yes, the data would be split, and it would be split in this fraction 0.5. That is, we would be using 0.5% data to test. That is half of the data to test and half of the data to train our models. So there you go. I won't be tinkering with these factors. Those are good enough for me. So let's just move further. Now there's an option here where you can zoom in or zoom out your model to fit in the screen. So the data is split now. Next job is to train your data. So train your recommender system. Do we have option to, yeah, train Matchbox recommender. So we select this and pull it here. Now what we do is we pass in one of these branches here, first one, and the split data is passed on to this training module or tab. Now I'm not too good with the nomenclature, that is why this confusion. Let's call it tab. So yes, so I've pulled in this data into the tab. So this is something that would get trained here, and I need to score it as well. So once I come here, I select this first, and it shows me the details as in, okay, how many traits of the data that I have that I want to use to build this recommender system. Let's just say 10. Okay, 10 is fine. I don't see too many problems with it. Maybe let's do it 20. Number of recommendations I want. Okay, no, this can also stay to 5, no problem. Training batches 4 is fine. So we just move further, and next what we do is we just go ahead and score the data that we have. So I say score, and I pick in this thing. So again, to this I would be passing in my training data here, and I would also be passing in my split data, that is the testing data. There you go. So the data that has been trained, that would come here, and also the testing data would be here. So I have this score where I need to give in the details as in what are the predictions that I'm looking for. Now I basically want prediction where I would be wanting related items, right? If I watch this movie, what kind of movie I need to watch, right? So this is what I would be entering here. So once I enter related items, it says what are the maximum number of related items to find from an item that you have. Let's say I want just one item. There you go. And so it would give me one related item to the movie. So if I pass in a particular movie to this recommender, it should suggest one movie that I might like watching. So that is what I'm talking about here. So one related movie, you can have more than one as well. So that is up to you. So we've done this. Now next is I built a model, or I've actually gone ahead and put in a tab for training and scoring. Next, I need to evaluate this data, right? So I say evaluate or test rather. So it says evaluate your recommender. You get in here, and this time you take in this value, that is your score, and you put it here in this column. We passed in one of these threads here. Next is we take in the split data and we enter it here. There you go. This is fine. I would be saving it here just to be safe. Once you save this data. Okay guys, so the connections that we pass in, these are important. In which port are you passing in what value? So this might hold. And this is more or less an experimental kind of a stuff where you might actually go ahead and put in some wrong connections and you might get in some errors. So you actually need to go ahead and troubleshoot some of those at times, not always. So we've actually gone ahead and we've almost built a model. Now we need one more table here, or one more data set, that is movie IMDb titles. Let's place it here. Okay, it has gone somewhere. Yeah, so I place it here. There you go. And whenever we have a new data set, we always visualize it to understand what it has. Okay, this should not take this long, but for some reason it is. So I have this data set where I have movie ID and movie name. So I would be using this data set for my recommender, where it has some IMDb titles, which is not the actual IMDb, that website which we have. It is a sample data set that is created. So we have this data set here. Now that we've seen the data, I'm gonna go ahead and use a command called as edit metadata, and I'm gonna place it here. And as usual, I'm gonna go ahead and put this thing in here. Now, if I come here, as you can see, there's this column here which says select certain columns which you want to use. So what are the columns that I want to pass to my metadata basically, or what is the metadata that I want to use? So I'm gonna go ahead and click on launch column selector. And in this case, with rules, I would start with no columns and I would say include. So what are the columns I need? First is I need item. So you have to hit the enter button. You won't be given a suggestion here. Okay, for some reason it is not taking in this value. Let me see what is wrong. Okay, we need to pass in first values to this so-called metadata. Before that, we won't be able to deal with items because we just took a look at this data set and it does not have item value. That is why we are not able to pass in that value. So let's pass in other values to it, the values that are more relevant to this data set. So we'd be coming here and we'd be selecting some other values. Now you can see that we have these values that are available. So let's just go ahead and select those. There you go. And I say, okay. So the error is gone now. Now we have a metadata which is made available to us. And I have a model which is up and running here. Now I need to put in joins here. Now, if you all know what joins do is, they basically help you select data from one table to the other. So we have two tables here or two data sets. So I want to combine the data that these two tables have. Now I won't be getting into the details of joins and all those things, but we would be using them here for the general reference sake. So I have these two data sets here and I want to predict or compare the table with the table that is here. So what I'm going to do is I'm going to build a model or create a join that lets me compare the movie names from one data set with the other or give me recommendations from one of the two data sets, right? So for that, I would be needing a join here. So let's just come here and say join. Okay, before we get into this thing, there is one more important point. My edit metadata data type, it has to be string. There you go. Now I need to pass in values to this tab as well. So for that, I would be needing a score from here. So I would be taking this and I would be placing it here. There you go. And one from the metadata to this joint. Now, what are the values that I want to pass in here? Now it should be item, I believe. So as I've said, hit the enter button. There you go. And you say, okay. And columns from R or the other table, what do you want from here? I would be saying maybe movie ID. There you go. I say okay. What kind of join do I want? I want left outer join. Now again, I won't be getting into the details of these joins. Don't keep the right key columns because that is the reason I'm using this join. There you go. I would be needing one more join here and I would be pulling it here because the first join would just give me the movie ID. But I just don't want the ID. I want the movie name as well, right? So I'd come here, I'd pull in this thing and I would pass it to this data set and edit metadata. There you go. Again, if I come here, it would ask me for values. I would say, give me related items if you have any. And here, I want the movie name. We would say save. If you missed out on one thing, we need to come here first and remove this left outer join and now save. We are bound to have some errors, guys, so stay tuned. Now this thing runs, it would run it tab by tab or module by module, and then everything would be executed. So this might take a couple of minutes. Once the module or the tab is executed, it shows a green tick on it. As you can see here, we have ticks here and here. This might take a longer because we've increased the number of iterations to 20 in the slide or in the tab when we were working on it. So the whole processing might take a little longer than normal. Okay, it says related item not found. Let's see why is that happening. Launch recommender selector. Yeah, this is the one that is there, related item 1. Probably there is no related item variable in the dataset that we generated. Now, as I've told you in the first model, I'll show you where. First, let me select this for now. And let me say, okay. Here in the score match box, I had passed in number of related items, right? It was 1. So by default, it was given a name called as related items 1. So that is something which we are passing in here or something that we would be displaying. So there you go. So what we've done is we've actually gone ahead and put in all the stuff that we wanted to. Let's just see whether it runs. And once it runs, I would be explaining this again to you people. So do not worry. First, let's run it. Now this time around, it should happen quicker because most of the stuff is done. We just have the error in the last tab or the last module. So the other parts should be done quicker, as you can see. And now the last one would be implemented and it is done already. So guys, our model is up and running. Let's just go ahead and check. So when I click on this icon and I say visualize, it should give me some values. See how relevant values these are. Let's just verify it. Now this being a model, it might not be that accurate, but let's hope it gives some values. It is not giving me the movie name and movie ID for the other section or the related item. Let's see why is that the case. But it says if you have seen this movie, you might like this movie, but we do not have that movie. So let us see where we have gone wrong first. So there is some error here or here. We have a movie ID here. So let's just come here and see. Okay, so we can just match ID to ID or map ID to ID. So let's remove this for now and say movie ID and then see whether we get the output. So I say save, not save as. I would say save and I would run this. So again, it should run quicker than the last time. There you go. Now let's just see what is the output that we get. So I say visualize. And there you go, guys. It's as simple as this. I mean, we put in or pulled in some values and we've edited certain values and we have the result here. Now, this is an Indian movie called as Talash, and it says that if you like this, you might like this. Oblivion, probably Jack Reacher. I haven't seen either of this. Iron Man, you might like Stand By Me. So I don't think this recommender is that accurate, but probably I'm sure that there would be some movies in it which are more relatable. So, and for people who are big movie fans, they probably would be able to relate a lot more to the movies that are here. So again, you can actually go ahead and select the number of related items that you want to select, and you might actually go ahead and tinker and tailor your algorithm a little more. For that, you have to play with the values that are there you have in this algorithm. You can just come here and switch in these details, and probably the answer might vary depending upon the inputs that you pass to this algorithm. So this was my basic aim. I wanted you to get some hands-on on Azure Machine Learning Studio and nothing more than that. But as far as this model goes, or this particular session goes, we've actually gone ahead and taken in 2 data sets. We've actually gone ahead and built a model, trained it, tested it, and then we've used a join to actually go ahead and see what would be the possible movie that you might want to watch if you liked one of those movies. So again, as I've already mentioned, it might not be that accurate. You are free to go ahead and play a little more with it. You can pass in your own data sets as well.
Now, what exactly a chatbot is? A chatbot, as you know, is a complete conversational, we can say, toolkit, right? Which is basically written in natural language. Like we have the concept of NLP, natural language processing. Now, the main purpose of this one is, again, where it simply understand the intent of the user. That means the context, right? Because again, if we talk about NLP, natural language processing, it simply revolves around the idea of different context, because the same thing can be said in different manner. The same thing can be said in different manner when we are talking about the context here, right? So different users, they can simply say things in different contexts, and that is exactly what we have to focus on here, correct? Because then because again, just like we have Alexa, we have Google Assistant, we have Siri. Now, for performing the same task, we can order these assistants in different manner, right? And again, it doesn't matter in which context we say them. We give them the order, they will perform the activities, right? Because again, they are able to judge on the context, right? They are able to evaluate in which context that particular thing has been said and how they have to process it. And that is what a complete concept for natural language processing is, right? And basically, it is simply used for understanding the intent of the user and sending a response back based on the business rules of the organization. That's the main concept of chatbots running on NLP, natural language processing here. All right. And for now, the first chatbot called as Eliza was built in 1966 to mimic the human conversation altogether. That was when the first chatbot Eliza was built, right? And in terms of chatbot applications, here they are extensively used in online shopping, in booking tickets, in news reports, in ordering foods, right? So there are multiple use cases available for chatbot application that we can think of, right? And again, basically in terms of types of chatbots, we have command bots and then we have learning bots. So command bots works on the concept of predefined text that has been defined inside these chatbots, again, and based on those predefined responders, they can respond accordingly. Or here we have learning bots. So based on the users, how they are interacting, they can learn their pattern, they can learn their language, and then only they can get started, right? Depending upon the context in which they have been said here, you can simply start understanding the users' languages in which context they are saying things, and then only they can get started. All right. And Amazon Lex here is basically a service for building conversational interfaces into applications using voice and text-based support, right? So basically now here it simply uses NLP, natural language processing, along with the ASR called as automatic speech recognition. So these are all two different components that we have. We have these Amazon Lex based on NLP as in natural language processing, and then we have ASR called as automatic speech recognition as a part of ASR itself, right? So basically this is used for building the conversation interfaces into any application using voice and text-based results altogether. That exactly we have Lex for, right? We have Amazon Lex altogether as a part of the entire discussion here. Now the main purpose of Lex, as we have discussed, is it is basically used for building the chatbots for handling the customer support, or we can say customer contacts the bank. Now, for example, if we are implementing this on top of any banks, right? So in here, customers can contact the banks for the account balance, right? They can simply send the message, or they can simply use the chat-based system that the bank has been, or that bank has opted in for, bank customers they have opted in for, right? And then now we can use Lex, we can use AWS Lex as a part of Amazon Web Services, right? And then we can allow Lex to understand the context of the user based on the request, what they have generated, right? And after this request here, we have Amazon Poly, right? So again, here we can, what they can do is they can simply respond to user in speech, right? Poly is again a service offered by Amazon where we can deliver the results as a part of speech itself. We can deliver the results as a part of speech as well, right? So again, they can simply revert back, okay, savings account or checking account balance. Again, they can simply revert using the Amazon Poly service as well, right? And for sending the notification, we can simply use Lambda service. Now, Lambda is a serverless computing services offered by AWS. So basically, we do have the costs for launching the full-fledged server. We have EC2, right? The concept for which we have discussed so far. And AWS Lambda is basically a serverless computing platform offered by AWS, right? That we can use to get started, right? So using Lambda here, we can simply connect our application with DynamoDB. Now DynamoDB is also something that we will be discussing in detail as we move further. So it's basically DynamoDB is a NoSQL database. DynamoDB is a NoSQL database. Then we have Amazon SNS. SNS is simple notification service used for delivering the notifications that has been generated by any service. And then we have Amazon SES. SES is simple email service. That means if we want the emails to be sent, right? We want the emails to be sent here, then we can simply use SES for that, right? And at last we have all the other services that we can use. Suppose if we have data also stored as a part of RDS, we have data also stored as a part of RDS with any engine, right? Then we can connect it Lambda using these two, or you can say these multiple engines as well as a part of AWS Lambda services integration. And once they have got the data, then again they can send the data back to Lex, right? And again, these now whatever is happening here, the logs for these will be stored and events are also kept a track of. Now this is also done using a service called as CloudTrail. Now CloudTrail is also a service offered by AWS through which it simply maintains the logs for different kind of activities happening in the entire system altogether, right? So that any kind of activity happening here, this can be reported. This can be reported back, and we can say well here as a part of AWS, right? And once the entire processing has been done here, now the customer is provided with the accurate, or we can say account balance, either through voice or either through text-based system. And as a part of our hands-on here, we'll be focusing on how we can create one chatbot as well using AWS Lex. And in here we can use it to build powerful interfaces to be used with both mobile applications, right? Like we have the customer, like we have OYO Health, right? So basically it is also used for building high interactive and conversational user experiences for IoT itself, because again it is highly useful for IoT platform as well. IoT as in Internet of Things, where different devices are connected to a single network altogether. as a part of IoT platforms. And this is being used by NASA, right? Again, these are basically used for building the enterprise the chatbots to check sales data, marketing performances, and much more, right? So again, there are multiple use cases that we can have, that we can observe on top of these automated chatbots, right? And this will be really useful when we are deploying the applications for our own company as well, right? When we are building applications for our own company, and then we can simply deploy these as a part of our entire integration as well. Now, again, if we are not the actual developer, still we can have the entire team. Delivered for us, right? As a part of use case for Lex, here. And basically, the main benefits of using Amazon Lex is it offers an easy to use console, and we have predefined bots. So here, even though when we don't have that much of technical expertise here, we can simply define the logic, and then we can get the entire chatbot up and running by using the predefined services offered by AWS here, right? And again, it simply employs advanced deep learning functionalities that we can offer here, correct? And again, it provides us complete seamless deployment and scaling. And again, there are multiple integration built in with AWS platform and offering a cost-effective platforms here. So basically, in order to understand the Lex here, first of all, chatbot receives the user input, and then it can simply reply with the answers and perform the actions, or we can also ask for other inputs as well, right? If the entire input has been received here, right? If the entire input has been received by chatbots, then you can simply process it first, right? And using the Lambda services here, it can simply connect. Now, chatbot will simply trigger AWS Lambda service, and Lambda function, whatever we have defined here, it will simply be integrated by some other services that we have DynamoDB, SNS, SES, and for any of the services as per the requirement or as per the structure that we have defined for chatbots, right? And then here we can, and then in order to get it started, first of all, here we can create a chatbot. Then we can test the bot on a Windows side. Then we can simply publish a version and create an alias, and then we can deploy it on top of a suitable platform here, right? And before we get started on seeing the hands-on on top of Amazon Lex here, first of all, we have certain terminologies that we have to be acquainted with. First of all, we have Amazon bot. So it's simply an artificial program that is useful for simulating an interactive conversation, right? Then we have intent. Now, intent simply represents an action that users want to perform. For example, we want the user to send an image. We want the chatbot to send an image, right? Or we want the chatbot to send the users to a link altogether. So these are what? These are the intent, right? That means the action that the user wants to perform, correct? And then we have the attributes as name, other cases, and then we have intent fulfill, right? We'll be discussing these parts step by step as we continue further. And then we have slots. So slots are simple parameters that an intent might require, right? Suppose again we have intent, right? We want the user to suppose open up a specific web page, right? Again, and there are multiple parameters. That means which page it has to at which page, which time slot here. What are different other parameters that needs to be specified here as a part of intent, right? Then we have slot types. So again, each and every slot has a type, and again here we can use built-in, or we can also define our own custom slot types altogether, right? Once the intent has been completed, again it will simply build a function to fulfill the intent, and it will simply be deployed on top of client application as well. So yeah, there are two ways through which we can fulfill our intent. We can use our inbuilt Lambda function, or in case it has been some other functions defined by the companies itself or the client for which we are building it, they can use those. And then we can define the Lambda function as a part of a code hook, here, right? Where the users can customize the entire user interaction, or we can simply initiate and validate the user input. Suppose if they have entered a wrong input, then that cannot trigger the entire AI system as well, correct? And that's why we have to make sure we are validating the entire input of the users as well. And then at last, we have to simply execute the entire input altogether, right? All right, so now let's get right back to our console. so that we can log into our console and then we can have the quick access on top of Lex services. Okay, here we have to enter the MFA code. Let's fetch our MFA code as well. Just a moment. So here we can enter the MFA code 879104. Okay, it hasn't changed. 169996. So once we log in into our console here, we would be able to see here, we would be able to see the same portal for which we have signed up. Now, once we are not, as always, guys, again, here we simply have to look for the service that we are focusing on, right? Like we have been looking for S3, for EC2, for IAM services. So same way here, first of all, here we have to search for a service called as Lex, right? So here we can simply use a search bar. We can simply go and use the search bar here. And here we can simply search for a service called as Lex. Now here we'll be finding Lex here. Here we have Lake Business. So here we have to open up Lex. Let's open this up. Currently by default we are into Mumbai. So now remember guys, Lex is not available for every region here. So currently we are in Mumbai. So now let's do one thing. Let's simply switch to North Virginia. As we had discussed, not every service is available in every region here, right? So here we can switch to our service for North Virginia. Now, once we are into Amazon Lex here, we can simply click on Get Started. First of all, we have to look for the service called as Lex, and then here we can simply click on Get Started here, right? Now in here we can choose. We can create our own custom bot, or we can choose any of these predefined samples here. So just like we have now, we will be looking at samples for almost every service that we will be discussing here. For example, we have other services like we have Beanstalk, we have CloudFormation, right? Where we get multiple predefined samples. Suppose we are just simply a beginner, right? And we want to see how exactly the chatbots work, and we want to see a simple, or we can say simple base here, right? Then we can simply choose these samples as well. For example, here we want to try a hands-on for booking trip, right? For order flowers, for schedule appointment, right? For example, here we're looking for book trip, so we can choose book trip. We want to look for order flowers, right? We can see a sample for order flowers. We can look for schedule appointment as well, right? So based on our now, as you can see, as soon as we are making changes here, the responses and the questions are also being changed here, as we can observe. So if we go to order flowers, again, if we go for booking trip here, if we go for booking trip, we can see, first of all, here we have, I would like to book a hotel, sure, which city, New York City, then what date do you want to check in? And then we are simply checking for it, right? So basically, first of all, it simply starts with the intent. That means that the user main intent is to book a trip, to book a hotel altogether, right? That's the main intent of the users, correct? Then they have started with the other cases. Now then we have started with the other cases. That means spoken or typed phrases, right? That invokes our event. Now currently our main intent is to book hotel, right? And for booking the hotel, as a user, we have received, okay, I would like to book a hotel, right? And then we have slots. Now that means again based on the parameters here, then we have asked which city, and then they are giving us slots as in the required data pointers to fulfill the intent, correct? That is a part of city altogether, right? And then we have prompts, here. So prompts will simply ask question how the user, okay, say any additional data that needs to be defined. And then once we have defined this, then we are simply fulfilling it as well, right? And then it will simply process it. Okay, are you sure you want to book a seat or book the hotel in your city? Once the user confirms, then the entire confirmation will be done here, right? Same way for ordering flowers as well. Same way for schedule appointment, right? So in here we can simply create our own chatbots using these systems, right? And in here, we can simply click on custom bot to get started. We can simply click on custom bot. And in here, we can define the bot name. In here, we can define the bot name here. What exactly we are trying to create here. We can define the entire bot name. Now, under bot name, we can simply, let's say here we are trying to create any bot, right? In here, we are trying to create any bot here. Okay, so for what purpose shall we create this bot here? So you can go for movie booking as well, because movie booking sounds good. So let's book a movie, because again, we don't want to make anyone hungry by ordering food, right? So let's go for movie booking here. Now in here, we can define the bot name. Suppose say we want to call this as book movie. Here we can call this bot as book movie altogether. So let's say we make it as book movie, and then we can define the language. Then here we have to choose the output voice itself, right? Now these are the output voice, as in, now in case you have been using the, we can say the different voice based system, like we have Alexa, we have Siri, right? So in here we can define the voice as well, right?
Hello, my name is Sally.
As you can see, suppose if we go for Sally here, right? So basically, it will simply showcase you a sample of the voice in which we want the chatbots to respond here. For example, let's say we want to hear some other voice here. For example, suppose for Matthew.
Hello, my name is Matthew.
Right? So depending upon our context here, we have different use cases.
Hello, my name is Kendra.
Sounds interesting. So just like we have our own voices here, we can simply go for the current voices here. Now, for example, let's hear for Ivy as well.
Hello, my name is Ivy.
Okay, this sounds like a schoolgirl. So now here, let's say we stick with salad.
Hello, my name is Sally.
And here we can simply define the text that we want to hear, right? For example, suppose we have, or suppose which movie do you want to book? Or suppose which movie, as simple as which movie, right? Let's suppose we simply type which movie itself. So this will simply talk this aloud.
Which movie? Which movie?
As you can see, now we have the entire sentence being repeated in our own voice, in that particular voice altogether. Yes, Ajay, we can have our own. Now we can't have our own voice, but again we can choose a voice that we want to use as an output voice here. We can choose the output voice here, right? Now once we define that part here, then we have session timeout, right? So here we can define the session timeout. For example, that means after a given time period, it should be how much time it should be opted out for. Because again, now as you can see, now Siri has an Indian version, right? Siri do have an Indian version. So currently it is being developed as a part of the entire development for every possible system, because they have already known that this is going to be a big market, and that's why they are customizing this. All right. Now, once we define this part here, now next is we can simply define the IAM role. We can keep it to by default. We can choose the default IAM role for this entire service. Now here, depending upon a rule here, we can simply make it yes, or we can simply define the no as well, right? Suppose here we don't want to. Now here we are not following the entire COPAP rule, mostly applicable for Europe. Or if we are, again, we can simply keep it to yes, and then we can simply have to define the role altogether, right? So in here we define the timeout as opposed 2 minutes. We define the session timeout to be 2 minutes as a part of standing timeout, and then we have create. Once we define it here, we can click on create. And this may take a second. Okay, let's refresh. Now, once we define the intent here, now once we have the bot created, then we have to start by defining the user, we can say user intent altogether, right? So here we have to click on this option which says create intent. Now, once you click on create intent here we have to simply define, okay, if you already have the intent created from the past, then we can simply work on importing the intent, or we can simply click on create intent here. We can click on create intent, and then we can define the intent. For example, let's say here our main intent is to book movie ticket. Here our main intent is to book movie ticket. We can define book movie ticket, right? That is our main intent, book movie ticket. And once we add this here, now here we have to define the utterances. That means, now for example, suppose the first attempt here, that means the first component that the user will be typing here as a part of utterance here, right? The first thing that user will be typing in. So here we can simply define, suppose say here we get ask the user, suppose as I would like to book a movie ticket. We can define I would like to book a movie ticket, right? Now in here we have to define multiple slots as well. In here we can define multiple slots as well, right? Now slots are basically, we can say the variables. Now these are the variables for the legs itself, right? Suppose let's say when we are now in case, suppose let's say when we are ordering pizza, right? The slot will be like, for example, size, or again, or for example, in here we have to define, that means the options, right? So slots are simply like option itself. Slots are simply like options, right? So here what we can do is we can simply add the slot itself, right? So here we can define the name as well. For example, here we can define the name. Suppose what can be the slots, or we can say for movies itself, what can be the option for movies. So for example, suppose if we are talking about hotel booking, right? Then slots can be location. That means in which location we are trying to book a hotel, right? Same way for movies, what kind of slots can be there? So first of all, it can be location, right? Then we have to choose a slot type as well, right? That means this is what now. This is just like we have data type, just like we have data type itself, right? For example, here we have multiple things defined here, right? For example, here we have region, book, we have book series, we have civil, colors, country, codes, right? So there are multiple slot type that we can define here. There are multiple slot type that we can define here, right? So for example, here as we define location, suppose we are asking the users as location itself, right? Then we can choose some different slot type here, right? For example, here we are defined simply now here we want to go for location itself, right? Or suppose let's say here we simply want the user to type in their city name. Now since this is basically focused only on for US itself, so here we can search for city. Suppose let's say here we are going for US city itself, right? And then we have to define the message. Suppose here we choose the US city here, then we have to define the message as well. That means in which city, or suppose what city or which city we are looking for, right? So here we can define what city as a location, right? And then suppose if we want to keep on adding more prompts here as a part of more slots here, we can simply click on add, and then we can ask for more options here. For example, next is we can also ask for timing as well, right? Timing, or we can say we can ask for show time, right? And then we can define again we can choose between the slot itself. We can choose from this slot itself, right? Suppose here we want the user to enter time itself, right? So what we have done, we have chosen show time, and now we are asking the users to the slot type is basically focused on time altogether, right? We can choose time, and then here we can ask the user as show time as a part of preference here, right? So here we can simply define as show time, and then we can simply define these step by step. Now, in here, once we have defined the slots here, then we have the confirmation prompt as well, right? So here and here, we can simply configure the confirmation prompt as well. Suppose once the user have entered anything, they'll be prompted with the confirmation as well. Next is, again, we can define, now in terms of fulfillment here, we can simply return the parameters to the client itself. Now, next is, in terms of any kind of responses here, right? Again, if we want to add a specific and customized message here as a part of response, we can simply define these, right? Now let's keep this by default. We don't want to change this, right? So here we can keep this by default here. No, Sitarama, we haven't defined anything under confirmation prompt, right? But again, if we want, we can define a confirmation prompt as well. For example, suppose if we want to define a confirmation prompt, right? So okay, suppose, are you sure you want to order a drink? For example, let's say if the user has selected, suppose, are you sure you want to book a ticket, right? Here we can define the name itself, right? Suppose here we have, are you sure you want to book? Now in here we have to define the parameters. Now in here we have to define the parameters itself. For example, if we type in as, are you sure you want to book? Now currently we have to define, now this should be replaced with the movie name, right? Suppose let's say here we have here they are asking for show time, for location. Now okay, we haven't asked for movie, right? Or suppose any kind of movie name itself. So again, if we want, we can add another slot as well. If we want to ask the users for movies as well, right? For which movie they're trying to book here. Suppose if this is what movie itself. So here we can name this as movie, and in here now whether we want this to be treated like a name itself, or suppose we already have a option available for movie in this slot type. Like we have movie, we can search for movie. Right here we can choose a movie here as a part of slot. Just a moment. Right, and again here we can choose, okay, which movie, or suppose which movie or what city, show time. Okay, we can go for what movie itself, right? Or we can say for which movie. Here we can define the prompt as well, right? Here we can choose, okay, how exactly we want it to be added here. For example, we want to keep on adding multiple prompts here. We can simply go on and on one by one. We can define that, and in here we can define the order as well, right? We define the movie, then we have chosen the movie name. Here we can go for which movie, like we have defined as a question, right? And in here we can define the orders as well. Suppose we want, first of all, we want the bot to ask for location, and then we want the bot to ask for movie, and then we want the bot to ask for show time, because that should be the order, correct? Because we want to ask for the location, the movie, and the show time. Suppose we no longer want this show time to be mandatory here, right? We can simply market these two for being the most important components here, location and movie altogether, right? We can define those, and then we have the confirmation prompt. Here we can choose, okay, are you sure you want to book? Now suppose we had defined the name as movie, right? Then in here in parameters, now remember this has to be made as a part of double quote, as a part of parenthesis itself, right? So here we had to define movie, right? And suppose if the user does not define as confirm, suppose if the user does not define as confirm, then again, if the user simply says no, then again here we can simply make sure, okay, your movie tickets are not your movie tickets are not booked. We can simply showcase them complete message like this one, right? Okay, your movie tickets are not booked, right? So in here we can have a complete control of how exactly we want to create the bots here, right? This is how we can customize the entire bot as well. Here we can customize the entire bots exactly as per our requirement, right? Now next is we can define the response as well. Now by default we can simply return the parameters to a client itself, or we can simply send it to a Lambda function, right? Now currently, as we have not discussed on Lambda function yet here, we can simply keep it to return to parameters to client for now. Then we'll be coming back to the Lambda function in a while. All right. Now, in terms of response, we can keep it to blank as of now, because again, here we can keep this option blank altogether. We don't want this one, right? Now, in here, we can simply click on Save Intent. Once we are done, we can simply click on Save Intent. Now, once we are done here, now what we can do is, now to see this in live action here, we can simply click on Build. Okay, I think we missed on the hook URL here. I think this will generate a simple error as we have missed the hook URL. Now, depending upon the parameters here, guys. So again, here we can simply, it may take some time for this one to be executed here. All right, so now once we have the bot created here, now once the bot has been successfully created here, now here in the right section of the screen here, we can see a sample test bot, right? Absolutely. So now here we can simply go ahead and test it as well, right? So for example, here we simply test, okay, I want to, suppose here we can simply define as I would like to book movie ticket. As you can see now, even though we suppose, let's say, we simply type book movie ticket. Now we have defined I would like to book movie ticket. As you can see, can you all see this? We have the what city here, right? So now in here we can simply define, suppose we want to define this as, suppose we want to book this up in New York. We want to book a ticket in New York altogether, right? Then it will automatically ask which movie. Suppose we name the movie as any name here, for example, like Shawshank Redemption. Again, then it is asking us for show time, for example, let's say for 8 p.m. Right? And again, since we have defined for the confirmation as well, this will ask, okay, are you sure you want to book for Shawshank? As you can see, can you all see this? All 3 slots has been filled here, correct? So we had defined location, we had defined show time, and then we had defined movie name itself, right? So all these slot details has been completely booked. And as you can see, all of these 3 details has been booked here, right? So suppose if we simply revert this with yes, as you can see now, intent movie ticket is ready for fulfillment. That means now we can simply define the fulfillment, right? So currently we have defined, okay, we want this to be returned to the user itself, right? And suppose we want to run a Lambda function, that means we want the actual booking to be done, right? Then we do have to integrate this as a part of Lambda function as well. So I hope you all are enjoying this. You all did enjoy this entire discussion on machine learning, using like how we can create this using the chatbot, guys. And now as a continuation here, suppose let's say we want to create a Lambda function. We want to create a simple Lambda function here, right? So Lambda, as you know, is simply a serverless computing platform. Lambda is what? A serverless computing platform, right? And now if we want to indicate Lambda here, what we can do is, first of all, we do have to go ahead and create a Lambda service, right? We do have to go ahead and create a Lambda service. Now for doing that, we can simply search for a service called as Lambda. Now we haven't discussed this part yet, and we will be discussing this part going forward step by step. For example, in here, if we want to process it by Lambda function, we can process it. In case we want to store the data into Amazon Aurora database, or suppose DynamoDB, right? Depending upon where we want the data, suppose if we already have a list of show times with us, right? How we can refer to those show timings, how we can store data. That means suppose whatever is being entered by the user, how we can store it as well. Like we can all do this exactly as per our requirement, right? We can do this all exactly as per a requirement here. So now in here, what we can do is, first of all, in order to add a Lambda function, we have to create a Lambda function as well. We have to create one Lambda function as well, right? And for doing that, what we have to do is we simply can search for service called as Lambda in services. We can simply open up Lambda service. Here we can open up Lambda. Now, When we open up Lambda here, we simply have to create one service. We have to create one function here, right? Now in here, what we can do is now in here, if you don't want now, if for the first time for the first time user here, now Lambda, as you know, is a serverless computing platform, right? So basically, the main purpose of Lambda. Now we will discuss Lambda going forward as well, but again, to have a quick understanding of what exactly Lambda is, first of all, let's go back to a Picasso board to have a quick understanding here, right? Now, to understand Lambda in a much better way here, so basically when we are launching any application, like we discussed on the concept of EC2 as well, right? When we are launching any particular application altogether, we have to create one server. We have to create one server on top of EC2, right? As a Elastic Cloud Compute server itself, right? Now, we can use this server we can use this EC2 server, right? As we have been discussing so far, if we want to deploy any application on our or for our website, suppose we are deploying a website, right? Then we can deploy the website on top of EC2, right? And again, suppose we want to test the application altogether. For example, if we only want to test the application, we don't want to deploy a full-scale application. We don't want to deploy a full-scale server. Then what we can do, we can simply use a service called as Lambda, right? So that suppose if we want to simply execute and test our code here, right? That means we are only looking for testing the code. Then we can use this Lambda function to simply now using this Lambda service, we can upload a code to Lambda, and suppose the code took 3.2 seconds, suppose 3.6 seconds in order to be executed complete, right? That means here we have to pay only for these 3.6 seconds, nothing less, nothing more, because as we have discussed in EC2, there's a pricing for an hourly basis. That means we have to pay for every hour, correct? But here in Lambda service, the pricing is for every 100 milliseconds. The pricing here is for every 100 milliseconds here, right? That means here we have to pay only for the exact duration of time for which the code has been executed, right? And let's say suppose if we have any kind of event trigger system, for example, we have any kind of notification systems where we need to use the processing power only when there is a change or only when there is a trigger in the event, correct? Then we can use the services for Lambda.
First, let's understand what Google Cloud Platform is. So, offered by Google, it is a suite of cloud computing services that runs on the same infrastructure that Google uses internally for its end user products, such as Google Search, Gmail, file storage, and YouTube. Along with a set of management tools, it provides a series of modular cloud services, including computing, data storage, data analytics, and machine learning. For organizations with large amount of data to store or analyze, Google Cloud Storage prices are up to 20% cheaper than AWS. If you know AWS, it's Amazon Web Services, which has the largest market share in cloud computing. It's like really an old cloud computing service, but still GCP is actually cheap, 20%, at least 20% cheaper than AWS. So while there is no difference in the price of container services, Google Cloud is an industry leader in the field and is also investing heavily in AI and machine learning technologies. Many small and large enterprises are increasingly adopting Google Cloud Platform, which bodes well since it disengages things and makes them more secure at reasonable costs. Now let's move on to understand why one should prefer Google Cloud Platform. We all know how big is the database of Gmail, YouTube, and Google Search is. And I don't think in recent years Google server has gone down. It's actually one of the biggest in the world. So it seems an obvious choice to trust them, right? So now let's look at some of the features of GCP which really gives it an upper hand over other vendors. So firstly, it is cost effective, which is like really has a better pricing than its competitors. Second, it is highly scalable as it uses auto scaling to automatically adjust the number of virtual machine instances that are hosting your application. So what it does is it allows your application to adapt to different varying amounts of traffic. With custom machine types, you can like create compute engine virtual machines with optimal amounts of virtual CPU and memory. Now coming to Google Cloud's IoT Core, which is a fully managed service to easily and securely connect, manage, and ingest data from globally dispersed devices. Now the next one is API platform ecosystem. So Google Cloud APIs allow you to automate your workflows by using your favorite language. The favorite programming language. So this Google Cloud API ecosystem consists of Compute API, Storage API, Data Analytics API, Networking API, and several others. Now it's big data analytics. So Google Cloud Smart Analytics solutions are fully managed. This multi-cloud analytics platform empowers everyone to get insights while eliminating constraints of scale, performance, and cost. So data analytics, big data analytics, I mean, use real-time insights and data apps to drive decisions and innovation. And now moving on to the next one, that is Cloud AI. So with Cloud AI, GCP Cloud Functions is the easiest way to run your code in the cloud. Now the last one, that is serverless. So due to serverless computing, Google Cloud Platform is highly available and fault tolerant. Now let's take a look at some building blocks of AI in Google Cloud. So there are four major building blocks. First one is site, second is language, then conversation, and structured data. So under site, we have multiple products. That is, first one is Vision API. With Vision API and machine learning model, which helps you in reading images. Suppose if I upload an image under Vision API, by just reading that image, the Google Cloud Platform can help you identify the data points which are related to the particular image. So it's very efficient for data processing. I mean, image data processing. Now the next one, that is Cloud Video Intelligence, which has pre-trained machine learning models that automatically recognize a vast number of objects, places, and actions in storing and streaming video, which offers like exceptional quality out of the box. Also, it's highly efficient for common use cases and improves over time as new concepts are introduced. Now the next is AutoML Vision, which enables you to train machine learning models to classify your images according to your own defined labels. Then AutoML Video Intelligence, which has a graphical interface that makes it easy to train your own custom models to classify and track objects within videos. Even if you have like minimal machine learning experience also, then also it can work very efficiently. It's ideal for projects that require custom labels that aren't covered by the pre-trained Video Intelligence API. Second category is language. So under language, we have the first product as a Cloud Translate, which like helps you in convert one particular language to another. Okay. So suppose you have something written in Japanese, you can feed that in Cloud Translate and it can get converted into English or like any other language of your choice. So the next one is like Cloud Natural Language, which is like a very famous product to send for doing sentiment analysis. Okay. Then we have with AutoML translation, like AutoML translation. So with AutoML translation, developers, translators, and localization experts with limited machine learning expertise can quickly create high quality and production ready models. So just upload translated image pairs, and like AutoML translation will train a custom model that you can scale and adapt to meet your domain specific needs. Last is AutoML natural language, which enables you to build and deploy custom machine learning models that analyze documents and like categorize them, identify entities with them, or assessing attitudes with them. Now the third main category is conversation. So under conversation, we have the first product as Dialogflow, which is a natural language understanding platform that makes it easy to design and integrate a conversational user interface into your mobile app, web application, or device, bot, interactive voice response system, and so on. So using Dialogflow, you can provide new and engaging ways for users to interact with your product. And Dialogflow can analyze multiple types of input from your customers, including text or audio inputs, like from a phone or voice recording. So it can also respond to your customers in a couple of ways, either through text or speech. Then we have speech to text API in under conversation, which helps in converting your speech. So suppose someone is speaking and at the same time you want that particular speech to be converted into text. Then in that case, this particular API and machine learning model comes handy and it helps you do that analysis. Similarly, we have text to speech API, which helps in converting given text to the speech at the same time. Now comes to the last building block, that is structured data. So first product in the structured data is AutoML tables, which enables your entire team of data scientists, analysts, and developers to automatically build and deploy state-of-the-art machine learning models on structured data at massively increased speed and scale, which in turn transform your business by leveraging your enterprise data to tackle mission critical tasks like supply chain management, fraud detection, lead conversion, optimization, and increasing customer lifetime value. Now coming to Cloud Inference API. So if you see time series analysis essential for day-to-day operation of many companies, most popular use cases including analyzing foot traffic conversion for retailers, detecting data anomalies, identifying correlations in real time over sensor data, or generating high quality recommendations. So with Cloud Inference API, you can gather insights in real time from your typed time series datasets. So moving on to the last product, that is the recommendations AI, which draws on the experience and expertise in machine learning to deliver personalized recommendations that suit each customer's taste and preferences across all your touch points. Now, finally, let's look at some of the solutions of AI provided by GCP. The first one is Contact Center AI. With this, you can lower cost and increase customer satisfaction with the best of Google AI technology. So customer service is being improved with AI that understands, interacts, and talks. So with Contact Center AI, you can create agents that are superheroes of your customers. Also, you can enable natural interactions with virtual agents and empower your teams with actionable insights. Moving on to the next one, that is AI Platform Unified. So AI Platform Unified brings AutoML and AI Platform Classic together into a unified API client library and user interface. With AI Platform Unified, both AutoML training and customer training are available options. So whichever option you choose for training, you can save models, deploying models, and request predictions with AI Platform Unified. Now the last major solution, that is Document AI. With Document AI, you can automate data capture to scale to reduce document processing costs. It is built on decades of AI innovation at Google, bringing powerful and useful solutions to these challenges. Under the hood are Google's industry-leading technologies like computer vision and natural language processing that create pre-trained models for high-volume documents. Document AI has already processed 10 billions of tens or billions of pages of documents across lending, insurance, government, and other industries. So now let's have a better understanding of Google Cloud AI platform by trying our hands on it. If you don't have an account on Google Cloud Platform, then create one. GCP is like a really good platform to have your account on. It will ask for your credit and debit card details just for the verification purpose. And you will get a free trial for 90 days with $300 credited in GCP account, and you can use that for the demo I'm showing you, for the exercises I'm showing you. Practice with that. So this is the dashboard of Google Cloud Platform, and we have to go for AI platform. So you can just type here AI platform. So basically, AI platform is used to train your machine learning model and then scale your machine learning model, and then you can take your trained model and deploy it on your AI platform. This is the dashboard where you can, if you upload your model or anything, so it will show all the predictions for it. Also, it will predict traffic on it and everything. Error rate will also show. Prediction latency it will also show. These kind of things are there. Right now, there's no model uploaded, so it's just showing the basic headings for it. So the first one, the first feature in this one is you can say we can come to notebooks. It is how to generate a notebook instance, just like you have Jupyter notebook, right? In that way only, you can just go to new instance here, and you can go to TensorFlow. These kind of options are there. Like you can upload your simple Python notebook also, which have scikit-learn or pandas or numpy, anything. Simple visualization or things are done, data analysis is done. Under that you can upload, or you can go for the heavy notebooks also, like TensorFlow or for PyTorch, another like Kaggle bit, like this IDE and Kaggle Python also. You can use a different kind of GPU in that. And here we are going with TensorFlow like enterprise with 2.1 with without GPU, and you also have option of NVIDIA Tesla. Okay, so without GPU and NVIDIA Tesla you can go for, but right now we are going with without GPUs. So here you can create your instance name and everything, or you can also go to the advanced options. Here you can choose the default one have four virtual CPUs, and the standard one, the standard one has 4 virtual CPUs, 15 GB RAM. And if you want more, you can select more RAM, and or if you want the less one, you can select for the less one. And then you can also select for GPU whichever you want. Okay, like Tesla K80, P100, V100, various options are there. Okay, and you can just and then create it. Okay, it takes time. So what I did is I already created one. So we can just go back and launch from here. You can just open Jupyter Notebook here. So naturally it comes with all the built-in packages of TensorFlow and everything. But if you want to install some specific package, you can just go to terminal. Here you can type pip install XGBoost. You can install okay. So it's downloading. Install that. Okay. We have this multiple options here, launching a notebook or a simple Python console or everything. So we can just go to notebook right now. You can select, or there are multiple languages you can select. Okay, you can also select Python to other languages also. Right now I've chosen Python. So we can check the version of XGBoost we have installed. Okay, so we can type just we can import XGBoost as XGB, then XGB for checking the version, XGB dot double underscore version double underscore. Okay, then we can also launch simple Python console also. So what you can do here is it's come as a simple Python So what you can do, you can go for like checking the TensorFlow version also. So just import TensorFlow as df, and then for checking the version, same df dot underscore underscore version underscore underscore. So this is the 2.1.3 version of TensorFlow. So this is how you can play with your Jupyter with this notebook, just like you play with a manual Jupyter notebook, right? So yeah. Now coming to the next service, that is AI Hub. So what AI Hub generally does is, if there is a like Google Cloud AI team is there, and Google Cloud team now, they just post the content here, the latest contents or whatever kind of content, whichever is useful for you, you can take that, and you can like, if you want to understand any model, you can get it from here, or if you want to run any RNN or something, you can understand and get a research content from here. So that's just one thing. Second thing AI Hub does is, if you working in an organization, they have separate teams or something, you can share your model here, and it will be, you can put the limitation of it, it will completely be private to your team, or certain to multiple teams. If you want to share your model with, that will be completely private. So that's a very good thing with AI Hub. Okay, you can get your model uploaded here and share it with the people you want to, with your customizations. Okay, so that is AI Hub. Then we have data labeling. So in data labeling, what happens is, you put your data set, be it of image or videos, in whichever manner, it gets annotated by the human annotators. So you can just create it here. You can insert your data set, whichever like image, video, text, or you can create, and then you can give your parameters or descriptions, whichever way you want your data to get annotated. So you can give a better description, it will give you a better results on the basis of that. The more your description is accurate, the more accurate will be the annotations. Okay, so that's how it can be done. Then we can go back to the other service, that is, you can go to jobs. The jobs here is, you can like create a new training job from here. We have option of built-in algorithm training, then a custom code training. Like custom code training, you can write your model, create your model, and you can upload it here, and whichever way you want to upload, or you want to give any kind of model, that is custom code. But its plus point is in built-in algorithm training. With built-in algorithm training, we get the option of like, you can select any kind of algorithm. These option, all the algorithms are given: XGBoost, distributed XGBoost, linear learner, wide and deep learner, image classification, image object detection. These are the new ones which Google Cloud introduced, like TabNet and NCF, all these things. You choose your algorithm, then you can give your training data, you can give, and then you can give your algorithm arguments also, and you can provide the split ratio also. Also, you can give other parameters also. On the basis of that parameter, the model will be analyzed and prepared. So that's a very plus point, as it like saves a lot of time. Instead of making the whole model, it just directly creates a model for you. You don't have to code and do everything. So that's a very plus point. And then we have pipelines. So what pipeline does is, pipeline addresses all your MLOps life cycle, starting from acquiring data, preparing data, analyzing data, and training the model, analyzing the model, deploying the model, and then tracking your like model artifacts, evaluating the model. It is like built on Kubeflow pipelines and TensorFlow extended modules. So it basically allows you to build an end-to-end pipeline, and at the same time deploying the end-to-end pipeline. So this is what the pipeline, AI platform pipeline is. So then we have like models. Models is something, if you want to do code wise, like command line programming, you have to do like command line model you have to make, or analyze it or deploy it. That's where model is used. So I just wanted to show you the demo thing for this. So this is how the Google Cloud AI platform works. So this is the general description for it.
What is Amazon SageMaker? Amazon SageMaker is a cloud machine learning platform that enables developers to build, train, and deploy ML models very quickly. It is basically a service that enables a developer to build and train machine learning models for predictive or analytical applications in the Amazon Web Services public cloud. Now you know that data science and machine learning models are in demand right now. So Amazon SageMaker is here to help you. Machine learning offers a variety of benefits for enterprises, such as advanced analytics for customer data or even back-end security threat detection, but it can be hard for IT professionals to deploy these models without prior expertise. So here is where Amazon SageMaker comes. Amazon SageMaker aims to address this challenge as it provides built-in and common machine learning algorithms along with other tools to simplify and accelerate the entire process. Amazon SageMaker supports Jupyter Notebooks, which are open source web applications that help developers share live code. Now, for SageMaker users, these notebooks include drivers, packages, and libraries for common deep learning platforms and frameworks. A developer can launch a pre-built notebook which AWS supplies for a variety of applications and use cases, then customize it according to the datasets and schema the developer wants to train. Developers can also obviously use custom-built algorithms written in one of the supported ML frameworks or any code that has been packaged as a Docker container image. SageMaker can basically pull data from Amazon Simple Storage Service that we'll be addressing later on in the session, and there is obviously no practical limit to the size of the data set here. So to get started, a developer logs into the SageMaker console and launches a notebook instance. SageMaker here provides a variety of built-in algorithms such as linear regression, image classification, or the developer can import his or her own algorithm. Then, when the developer is ready to train the model, he or she specifies the location of the data in S3 and the preferred instance type, and then eventually initiates the training process. SageMaker uses automatic model tuning to find the set of parameters, also called as hyperparameters, that best optimizes the algorithm. When the model is finally ready to deploy, the service automatically operates and scales cloud infrastructure using a set of SageMaker instance types that includes several with GPU accelerators and that have been optimized for ML workloads. SageMaker deploys across multiple availability zones, performs health checks, applies security patches, sets up auto-scaling, and establishes secure HTTPS endpoints to connect to an application. A developer can then track and trigger alarms for changes in production performance via Amazon CloudWatch metrics. Now that we know what is Amazon SageMaker and how the entire workflow really works in SageMaker, let's move on to the next part of the session and learn how to create your own AWS account. So I'm just going to go to my local web browser and I'm just going to Google for AWS. I'm just going to click the first link, which will redirect me to the official website of Amazon Web Services. And as you can see here, there's a navigation on top that will allow me to check the different and various products that Amazon, offer to us. There are Amazon EC2, there's Amazon Simple Storage Service, that is S3. We'll be using this later on in the session. The different solutions, there's pricing of all of the products that Amazon provide to their customers. There are also events that happen in AWS that you can participate or be a part of. And if you scroll down, you can see the solutions that Amazon provide in the form of icons. And this is just a summary of all of what they really do. So this is not really necessary for you to know right now. We're just going to create an account. So what I'm going to do is I'm just going to click on to sign into the console. And as you can see that this will redirect me to a sign-in page. If you already have an account, that's great. You can just type in your username and you can type in your password and then just log into your account. Else you will have to create a new AWS account. You can see that option right in the bottom. And once you click that, you will be redirected to a page where you'll have to provide some credentials like your email address, your password, confirm password, AWS account name. You will have a lot of steps that you'll have to go through. You'll have to give in your card details, your debit card or credit card details for this. You can also read the rules and regulations of their free tier account. They have some instances and products that they provide for some free amount. So you will have to read all of that. Just get an overall idea of how Amazon provides its services and what is free. So you can really maximize the use of their free services, right? So once that is done, you can just sign in to your existing AWS account. That's what I'm going to do. So once that is done, we'll meet on the other side. So this is what you will be able to see when you log in. You'll just be able to see your AWS management console. You can explore AWS. You can also build a solution. You can learn how to build, and you can see the recent services that you've been working on. You can also view all of the services that are currently present in Amazon Web Services. And with all of that said, let's go ahead and create your first notebook instance. So as you can see on the top, there is a navigation search bar. Here you can just look for Amazon SageMaker. Okay, and then you just click on the first service that pops up. And this will redirect you to your Amazon SageMaker. On the left-hand side, you can see you have your Amazon SageMaker Studio, dashboard, search images, ground truth, notebook, processing, training, inference, and Edge Manager, augmented AI, AWS Marketplace. You have a lot of options that you can really see in Amazon SageMaker. Now you can either do this project on Amazon SageMaker Studio, but we'll be creating this project on the Jupyter Notebook. So we'll be creating our first instance. You can just click on the drop down menu of Notebook and then click on the Notebook Instances option. And as you can already see, there's an instance that's currently running, which is named as Edureka Demo 16. Okay. And you can see there's a creation time, its status, and actions that you can currently take on it. So now we'll go ahead and create our own notebook instance. It's a pretty easy thing. You can just name your notebook instance anything you'd like. I'm just going to name it demo. Okay, you can pick a notebook instance type. You can also pick an elastic inference. I'm just going to let the instance type be ml.t2.medium. Okay, I'm just going to scroll down. So the IAM role is pretty interesting. So it is basically an AWS identity and access management entity with permissions to really make AWS service requests. Now, IAM roles cannot make direct requests to AWS services. They're basically just meant to be assumed by authorized entities such as IAM users, applications, or even, AWS services such as EC2. Okay. So what I'm going to do is I am going to create a new role here. So here the IAM role that you will create will provide access to the S3 buckets you specify. So for all of y'all who don't know what S3 buckets is, an Amazon S3 bucket is simply a public cloud storage resource that is available in AWS, which is simply termed as Simple Storage Service S3 and object storage offering. So basically it's very similar to, file folders or store objects. So S3 really just contains data and its descriptive metadata. So basically it's just like a database, okay? And now you can specify your S3 buckets that you'd like. So here I'm just going to pick any S3 bucket. Currently I have only one S3 bucket. So I'm just going to click on that and I'm going to create role. And you can see that there's a notification that says success. You created an IAM role. Once that is done, you're all set. You can go ahead and create your first notebook instance on Amazon SageMaker. So usually this takes some time before it creates. Right now the status is pending, as you can already see that. So once it's created, it'll just say the status is in service. So we'll just wait for it to get in service. Okay, now that you can see the status says in service, it'll take a while to get in service. Now there are two actions that you can perform. You can see that the first one is Open Jupyter, or you also have an option where you can open Jupyter Lab. I'm just going to click Open Jupyter. And you can see that the page is redirected. Now that you can see that, you'll be redirected to your first empty notebook, your Jupyter notebook. And here you can create your first file. And since we'll be creating a new notebook with Python 3, so I'm just going to click on that. See that your first file has been created, and you can name this whatever you'd like to. You can just name it demo, or you could just name it first project. Let's name it first project. And I'm just going to rename this. And if you want to save the file, you can just save and checkpoint. If you want to add cells, you can do that. If you want to remove cells, you can just click this scissor icon. You can also copy particular cells that you'd like to copy, and you can paste cells below too. If you want to move from one cell to another, you can use these arrow buttons to, switch up and down. If you want to, select and run a particular block of code, you can just press this button. If you want to interrupt the kernel, you can just press the pause button. If you want to restart the kernel, you can just press this refresh button. You can also restart the kernel and rerun the whole notebook. And you can also use this option for, specifying what kind of block you want to execute. If it's a code, you can just click code and you can just print whatever you'd like. I'm just going to print hello. And once I execute it, it will give me the output hello. And if I want to add headings, I can do that too. And I'm just going to run this. And you can just print this as a heading. If you want to mark them down, you can mark them down too. And you have many options. You can really do a lot of things with this. And you can also see there's a navigation bar here. You can save your files. You can open a new notebook. You can open the previous files if you have any. You can make a copy. If you know how Jupyter Notebook really works, this is going to be a piece of cake for you. And also you can view, you can insert, and you can also make manipulations with the cells that are currently present in your notebook. And there are a lot of options. You'll really get a hang of it once you start using Jupyter. Okay, now that we have an idea of how to create your first notebook instance, let's move on to the next part of the session. So what we're going to do first is we're going to download, explore, and transform a particular data set. So in this step, you load the adult census data to your notebook instance using the SHAP, that is the Shapley Additive Explanations Library. And we are also going to review the data set, transform it, and then upload it to Amazon S3. Okay. As you can already see, I have everything in place. So first, what we're going to do is we are going to install the SHAP library. Now, if the current Jupyter kernel does not have the SHAP library, install it by running the following conda command. That is conda install -c conda-forge SHAP. There's also a way to download SHAP on Jupyter Lab, and that's not necessary right now, so we're not going to discuss it. Now, if I go a little down to the next cell, now, if I scroll down a bit, you can see that using the SHAP library, I have imported the adult census data set. So you can see that import SHAP. As you can see, I have two variables, X and Y, and also X display, Y display. And also I'm going to display all of the feature names. So you can see that in the output, we have 12 different feature names, and that's printed for us: age, work class, education number, marital status, occupation, relationship, race, sex, capital gain, capital loss, hours per week, and country. Okay. So the feature name is basically a list object, and it should list the features of this data set. And that's what the output shows us. So now if I scroll down a little more, you will just have to run the following script to display the statistical overview of the data set and histograms of the numeric features. You can see that the figure size is 20 by 10, and it's just describing the entire data set. That's all. You have a proper repeat. So you have a good overview of the data set. This is great. Now, if we scroll down a little more, we are now splitting the data set into train, validation, and test data sets. Okay. Now, using sklearn, we are splitting the data set into a training set and a test set. And the data set is randomly sorted with the fixed random speed, and 20% of it for test set. Now, moving on to the next block of code, you're splitting the training set to separate out a validation set. That is 75% of the training set really becomes the final training set, and the rest is the validation set. Okay. Now, moving on to the next block of code, we are using the pandas package. I'm sure everyone knows the pandas package. It's one of the most important package in Python. And here we're going to use it to explicitly align each data set by concatenating the numeric features with the true labels. Okay. Once that is done, we are just going to check if the data set is split and structured as expected. So I'm just going to print train, and it's going to give me the training data set. And I'm going to also print validation, and it's going to give me an overview of the validation data set. And finally, I am going to also display the test data set, and it's just going to give me an overview of that. You can see the number of rows and columns too that is specified in the bottom of each of these outputs. That's great. Now, moving on to the 10th block of code, we're going to convert the train and validation data sets to CSV files. This is really important. So we're going to use CSV format to store the data, and the first column is expected to definitely be the output column. Okay. Now we're going to convert the train and validation data frame objects to CSV files to match the input file format for the XGBoost algorithm. We're going to be using that algorithm. We'll come to that later. Moving on to the 11th block of code, we are finally going to upload the data sets to Amazon S3. This is really important. Now, using the SageMaker and Boto 3, we have to upload the training and validation data sets to the default Amazon S3 bucket. And the datasets in the S3 bucket will be used by a compute optimized SageMaker instance on Amazon EC2 for training. Now, the following code, what it does is it sets up the default S3 bucket URI for your current SageMaker session, and it creates this new demo SageMaker XGBoost adult income prediction folder, and then it uploads the training and validation datasets to the data subfolder. Okay, I hope this is clear. Moving on, we have to run the following AWS CLI to check if the CSV files are successfully uploaded to the S3 bucket. Okay, and it should return this following output. And you can see that the train CSV file and the validation CSV files are the outcome. That's great. And that's right. So let's move on to the next part of the session. So now what we're going to do is we're going to train our model. Okay. Now to choose the right algorithm for your particular data set, you typically need to evaluate different models to really find the most suitable models for your data, right? Now for simplicity, the SageMaker XGBoost algorithm, that is a built-in algorithm, is used throughout this tutorial without the pre-evaluation of models. Now, if you want SageMaker to find an appropriate model for your tabular dataset, it is recommended to use Amazon SageMaker Autopilot that automates a machine learning solution. Okay, now let's switch back to our demo part. Now, after you've finally figured out which model to use, you can start constructing a SageMaker estimator for training. Now, here currently we're using the XGBoost built-in algorithm for the SageMaker generic estimator. So the first thing you have to do is you will have to run a model training job. So for that, you will have to import, you can see in the block 13, you will import the Amazon SageMaker Python SDK and start by retrieving the basic information from your current SageMaker session. Okay. And this returns two following information. The first one is the AWS region, the current AWS region where the SageMaker notebook instance is running. Currently, you can see that it's running in US East 2 region. And there's also another output that we have, that is the role. And this is the IMA role used by the notebook instance that we created, if you remember. Okay. Now, I just checked the SageMaker Python SDK version by running this command, that is SageMaker __version__. And this is because I wanted to know the version of SageMaker. If the SageMaker version is less than 2.20, then you will have to update it. Okay. You can update it by using !pip install -q uppercase U SageMaker. But if you have a version of SageMaker that is above 2.20, then you're good to go. Okay. Moving on to the next block of code. Now we're going to create an XGBoost estimator using the SageMaker.estimator.estimator class. Now in the following example code, the XGBoost estimator is named XGB_model. Okay, so we have used the name XGB model. Okay, so I hope that is clear. Now to construct the SageMaker estimator, you will have to specify some parameters. Okay, you can see all of these parameters here. We're going to discuss about each of these. Now, the first one is the image_URI, which specifies the training container image URI. Now, in this example, the SageMaker XGBoost training container URI is specified by using the command SageMaker.image_URIs.retrieve. Okay. And the role that we've specified here is the AWS identity and access management role that SageMaker uses to perform tasks on your behalf. Now, for example, reading training results, call model artifacts from Amazon S3, and writing, training results to Amazon S3. All of this is performed by the access management role. Okay. Now, the train instance count and train instance type is the type and number of Amazon EC2 ML compute instances to use for model training. Now, for this training exercise, you use an ml.m2.medium instance. Okay. And you can use anything you'd like to. Then moving on to the train volume size, this is simply just the size in GB of the EBS storage volume to attach to the training instance. And this must definitely be large enough to store training data if you use file mode. Okay, file mode is on by default, so you don't really have to worry about that. Okay, moving on to the output path. Now the output path is simply the path to the S3 bucket where SageMaker stores the model artifact and training results. SageMaker session, on the other hand, is the session object that manages interactions with SageMaker API operations and other AWS services that the training job uses. Rules, finally, is the last parameter, and it specifies a list of SageMaker debugger built-in rules. Now, in this example, we have used the create XGBoost report, which creates an XGBoost report that provides insights into the training progress and results. And we will check this report out later. Now, if we move to the next part of the code, we can see that we have set the hyperparameters for the XGBoost algorithm by calling the setHyperParameters function, by calling the setHyperParameters method of the estimator. And there's a complete list of XGBoost hyperparameters. You can also tune the hyperparameters using the SageMaker hyperparameter optimization features. Okay, moving on to the next block of code. So here you can see that we're using the training input class to configure a data input flow for training. Now the following code shows how to configure training input objects to use the training and validation datasets you uploaded to Amazon S3 in the split the dataset into train, validation, and test dataset section. Okay. Now, once we've configured that, so in the next block of code, we're finally going to train the model. So here we're going to call the estimator's fit method with the training and validation datasets. Now, by setting weight is equal to true, the fit method displays progress logs and also waits until training is complete. And once the training is done, you can see that the output is completed, training job completed, training seconds, and the billable seconds is given. Okay. Now, in the next block of code, we run the following code to specify the S3 bucket URI, where the debugger training reports are generated and checks if the reports exist. Okay. Now, in the next block of code, you will have to download the debugger XGBoost training and profiling reports to the current workspace. Then you'll have to run the following IPython script to get the file link of the XGBoost training report. Okay. Now, the following IPath script returns the file link of the debugger profiling report that really shows summaries and details of the EC2 instance, resource utilization, system bottleneck detection results, and also the Python operation profiling results. So once you run this particular block of code, you can just click below to view the profiler report. And as I've already mentioned, here you can just see all of the resource utilization, the bottleneck detection results, and all of the, really just a summary and statistics of the report. So here you have the rule summary where you can see the GPU memory increase, the CPU bottleneck, the max initialization time, the low GPU utilization, load balancing, etc., etc. You have a lot of things that are happening here. You can see the start time, the end time, the job duration, that's 56 seconds. Okay, let's move back. Now what we're going to do is we are going to get predictions, deploy our model to Amazon EC2 using Amazon SageMaker. Okay. Now, to host a model through Amazon EC2 using Amazon SageMaker, you will have to deploy the model that you trained in create and run a training job by calling the deploy method of the XGB model estimator. If you remember, we had declared the XGB model in the previous session. Okay. Now, when you call the deploy model, you must specify the number and type of EC2 ML instances that you want to use for hosting an endpoint. Okay, so you can see that we've used 3 different parameters here. The first one is the initial instance count, that is the int, the number of instances to deploy the model. The second parameter is the instance type, which is string, the type of instances that you want to operate your deployed model. And the last parameter is the serializer, which is int2, and it serializes input data of various formats, that is a NumPy array, list, file, or buffer, to a CSV formatted string. And we can use this because the XGBoost algorithm accepts input files in CSV format. Now, what the deploy method really does is it creates a deployable model and configures the SageMaker hosting services endpoint and eventually launches the endpoint to host the model. Now, we will have to retrieve the name of endpoint that was generated by this deploy method. Okay, so for that, we will have to run the following code. That is the XGB predictor.endpoint_name. Now, this should return the endpoint name of the XGB predictor, and the format of the endpoint name is SageMaker XGBoost and the date. That is in years and the month, the date, the hour, and the seconds, the minutes, the seconds, everything. Okay. So the deployment of model was pretty easy, right? Now let's move on to the next part of the session. Now that we have trained and deployed a model using Amazon SageMaker, evaluate the model to ensure that it generates accurate predictions on new data. Okay. Now to evaluate the model and use it in production, we have to invoke the endpoint with a test dataset and check whether the inferences you get returns a target accuracy you want to achieve. So in the 27 block of code, you set up the following function to predict each line of the test data. Here you can see in the code, the rows argument is to specify the number of lines to predict at a time. Then you can change the value of it to perform a batch inference that fully utilizes the instance's hardware resources. And in the next block of code, you run the following code to make predictions of the test datasets, and then you plot a histogram. So for obviously plotting histograms, we have to use matplotlib.pyplot, and it will display the histogram. Now, in the next block of code, the predicted values are float type. To determine true or false based on the float values, you need to set a cutoff value. You can see that we've used the scikit-learn library to return the output confusion metrics and classification report with a cutoff of 0.5. Once that is done, the output will return the following confusion matrix. Okay. Now, to find the best cutoff with the given test set, compute the log loss function of the logistic regression. Now, the log loss function is defined as the negative log likelihood of a logistic model that returns prediction probabilities for its ground truth levels. Now, the code numerically and iteratively calculates the log loss values. It returns a log loss versus cutoff graph. You can see that output here. So this is the log loss curve. Okay. Now, finally, we find the minimum points of the error curve using the NumPy augmin and min functions. So this should easily return log loss is minimized at a cutoff of 0.53 and the log loss value at the minimum is 4.34 and so on. Now, instead of computing and minimizing the log loss function, you can estimate a cost function as an alternative. For example, if you want to train a model to perform a binary classification for a business problem, such as a customer churn prediction problem, you can simply set weights to the elements of confusion matrix and calculate the cost function accordingly. I hope this demo section proved and helped you. Let's move on and check out the case study. So in the Amazon SageMaker case study, we'll be talking about Grammarly. Now, everyday Grammarly's algorithms help millions of people communicate more effectively by offering writing assistance on multiple platforms across devices and also through a combination of natural language processing and also advanced machine learning technologies. Amazon SageMaker makes it possible for Grammarly to develop their TensorFlow models in a distributed training environment. Here, workflows also integrate with Amazon EMR for pre-processing, so they can get the data from Amazon S3 filtered with EMR and Spark from a Jupyter notebook, and then eventually train in Amazon SageMaker with the same notebook. SageMaker is also flexible for their production requirements. They can run inferences on SageMaker itself, or if they need just the model, they can download it from S3 and run inferences for their mobile device implementation for iOS and Android customers. So this is how interesting and how helpful Amazon SageMaker is in today's world.
Let's start with the core interview questions. First thing, how will you explain machine learning to a school going kid? So in this case, the interviewer is interested to see how you can explain the concepts in machine learning in a very simple manner so that even a school going kid can understand. You can give an example to a kid saying that, okay, your friend has invited you to a party and you meet completely strangers there. So you have not seen them previously, they are just completely strangers to, and you're going to meet them. Since you have no idea about them previously, so you will try to classify them based on the available things that you can visualize. That is like what is the gender, what is the age group, so how are they dressed, how do they behave with you, like what is their attitude. So he will try to classify them based on those features. So this is a pure example of unsupervised learning. So in this case, we don't have any prior knowledge. So in this case, they are completely totally strangers. How is it different from the supervised learning? So in supervised learning, the benefit will be you will have some prior knowledge and based on that you will try to go. So you can explain to the kid that as you already got identified to those kids, in future you know their names, so you will try to classify them whenever you see them. So that will be the example of supervised learning. So let's move on to the next thing. What are various types of machine learning? So first of all, you have to say that the machine learning is categorized into majorly three components. First is the supervised learning, second is the unsupervised learning, and third is the reinforcement learning. So in the supervised learning, it is like learning with a teacher. So training data set is like a teacher is giving you like training the machine. So teacher is trying to train based on the whatever teacher knows. So model is like trained on this predefined data which you have, and it start to make decisions based on the again based on this rule that it has identified from the existing data. It will try to make some predictions and decisions on the new data. You can give some examples as we have here. In this case, when we have apples and bananas, we feed machine apples and bananas with the label saying that, okay, this is the apple, this is how it looks, this is the set of bananas, and this is how they look. So when you feed it to the machine learning supervised algorithm, so what it does is it tries to identify the patterns which are there with each category. So it will set the rule that, okay, apple looks like this, banana looks like this. So this is the training data that we have provided based on which our supervised learning learns it. And we use this model on the new data set. So for example, in this case, we are using this green apple, and based on the structure which is already there, the green apple is still going to be predicted as an apple based on the shape it has. Okay, so that is the example of supervised learning. Let's move to the next thing, which is unsupervised learning. So in this case, it is like learning without a teacher. So model learns through the observations which are there, and it tries to identify some patterns and structure which will be hidden within the data. So in this case, we are not labeling the data. So model is given a data and model is left on itself to learn the patterns and relationships out of the data by creating clusters. So clustering is one of the major techniques which are used in the unsupervised learning. There are many, but it is the most popularly used within the unsupervised. So for example, when we feed the apples, bananas, and the mangoes here again, but in this case, we are not labeling them. We are not telling the machine that, okay, these are the apples, these are the bananas. We're just giving it the data, saying, okay, this is what it is. We don't know anything about it. So when we feed it to the algorithm tries to learn the patterns out of it and tries to classify them. It won't say this is apple, this is banana, but it will say, okay, these are similar. So apples are similar, and it'll try to cluster them together. Bananas are similar, it will try to separate them in a different cluster. And mangoes are similar, it will try to cluster them in a separate cluster. So it will try to understand the patterns which are there within the data and give you the clusters out of it. So that is the unsupervised learning. Third part is reinforcement learning. So in this case, model learns with hit and trial method. So assume that we are playing the Mario game, and in the Mario game, the player is called as the agent in the reinforcement learning. We have an environment which is nothing but a game. There will be some predefined actions which agent can take. For example, in the game of Mario, it will be he can move forward, he can jump, he can go into the tunnels, he can fire the bombs. So those are the steps. And based on the steps, your environment will try to reward you. Either it will reward you or it will penalize you. Based on that, your model will get created, which will say, okay, these are the best actions, where when you do these actions, you will get your score more, which is like a reward. And when you don't, you do this kind of action, your score will get penalized. So based on this environment, your reinforcement learning will try to learn those things. So that is one example, and you can also give some examples related to the AlphaGo, which is a Go playing game which recently was developed by a Google-based company. And you can also say that chess-based games can be automated with the reinforcement learning. So there is one more category within machine learning which is not much talked about, which is the semi-supervised algorithm. So which are basically combination of supervised plus unsupervised. So in this case, what happens is you have a data set which is half of it is labeled and half of it is not labeled. So in this case, both supervised plus semi-supervised are used to create your models. So you can also give this so that there will be more confident on you. Okay, so let's move on to the next thing. What's your favorite algorithm and can you explain it in a minute? In this case, interview is trying to understand as how you can explain some complicated techniques and technologies in a very simple and simplistic manner to some higher up people or the clients or those kind of things. So make sure you have some choice and you can explain different algorithms in a simple manner. You keep for every example, try to keep some simple examples so that you can effectively and you can easily explain it so that even a small kid can understand as how you're explaining those things. So how deep learning is different from machine learning? In this case, first thing is you have to know that deep learning is not completely different from machine learning. You have to say that, okay, deep learning is a small part of machine learning. And in the core machine learning, based on the input, first you have to do the feature extractions. You have to classify the features which are the good, which are trying to explain your model better based on some exploratory data analysis, and based on that you will feed it to the algorithms, and those algorithms will try to identify the patterns within those and give you the output. In deep learning it is a bit simplified. What happens is, based on the input, the model will try to extract the features on itself and will try to create a model based on those. So it is trying to combine both the things of feature extraction and classification into a single thing, and it will give you the output. So that's why it is recently being very popular. So that is one thing. And deep learning is basically, if you know, the deep learning is constructed most of the neural networks. So and neural networks are basically borrowed from the idea of the human brain. So how the human brain works and how the neurons within the brain really works in a very complicated and effective manner. So those are the things which have been taken and being implemented in the deep learning. And machine learning is about the algorithms that basically parses and learns the data and tries to identify the patterns within the data, apply whatever pattern learned from the data to the new data whichever is coming. So that is the most of the thing which was related with the machine learning. But deep learning has come a bit more advanced to it. Okay. So explain classification and regression. So classification and regression is part of supervised learning. So you have to say this first, that this is part of the supervised learning. Supervised learning is broadly categorized into these two parts, and regression is mostly dealing with the continuous variable. So in continuous variable, it's like you're trying to predict the sales, you're trying to predict the stock market values. So wherever there are continuous predictions, you're trying to do the regression of your data. So classification is like you're trying to predict the different classes which are there within the data. So for example, the classes could be like, is the student going to pass or not? Is my customer going to buy my product or not? And is my salary is within like high, medium, low? So those are the different classes. And when we're dealing with the classes, we say it is classification. And we're dealing with the continuous values, we say it is regression. So in this case, if you see, the regression is like size of your house, area, and the location which are there. And classification is like when you're trying to give it a classes. So very cheap, cheap, affordable. So you're creating a 5 classes here, and that becomes the classification. What do you understand by selection bias? In the statistical term, sampling is basically trying to sample some data from your population. So you are trying to take some portion of the data from the population, and when you have some bias to some specific set of data. So let's assume we want to take a population of all the data scientists within India. When you're talking about India, you have to take data from all parts of India. But let's assume you just take the sample from the Gurgaon. So when you just take the sample from the Gurgaon, you're getting a selection bias. You're getting bias to the Gurgaon, and you're just selecting the data from there. So in this case, you're getting bias to those conclusions of your inaccurate conclusions of yours, and you're not making the accurate decisions based for the population. Okay, so that is the selection bias. So what do you understand by precision and recall? So in this case, let's go on with the example. So let's imagine that your girlfriend keep on giving you surprises from last 10 years of your birthdays, and one sudden day she comes to you and asks you, do you remember all birthday surprises from me? And you just get shocked. And in this case, to extend your life, what you do is you try to recall all the 10 surprising events that you had in your previous birthdays, and this recall that you're doing is nothing but the number of events you actually correctly trying to recall it, and the actual events which have happened. So this is the ratio that you're trying to capture of all the recalls that you're doing correctly and the number of the correct events which happened. So for example, if you are trying to recall out of 10 all the 10 correctly, then your recall ratio is nothing but 1. So which is again 100%. But if you're trying to recall only 7 events correctly, so as per the ratio, what will happen is the number of events you can correctly recall is 7, and the total number of events which are there is 10. So in this case, your ratio will be 0.7, which will be 70%. But let's assume you might be wrong in some answers. So for example, you answered you remember 15 times, but out of this only 10 were correct. and 5 events were actually wrong. So you remembered from some another events. So in this case, so you recall all the events which are there, but it's not completely precise. So in this case, the precision is the ratio that the number of events you are recalling correctly to the number of events you recall. So which is like out of 15, you are trying to recall the 10 as a correctly. So that is the precision which we have. So 10 real events and 15 answers. So the ratio is the 66% in this case, which is 10 divided by 15. Okay. In the formulas, you can represent all those things in a simple formula. So number of events you can correctly recall are called as the true positive. So which you said as true, you said as a positive, you are able to recall them correctly and they're actually there. So number of all correct events. So this is also again the true positive which you recall correctly plus the false negative which you didn't recall. Okay, and the next thing is the number of events you recall. So which is true positives plus the false positives. In this case, what's happening is the correct recall that you did, all the events that you correctly remembered, and some which are not correct. So you said, okay, I recall them. So for example, when we had it 15, so in that case, there were some like 10 were correct and 5 were the false positive, which was you didn't recall them correctly. So based on all this above, recall is true positive divided by true positive plus false negative. So true positive plus false negative is nothing but the number of correct events as we already saw that. So number of events you can correctly recall divided by number of correct events. And precision is true positive divided by true positive plus false positive, which is the number of events you can correctly recall divided by number of all events you recall. Okay. So the next question is explain false negative, false positive, true negative, and true positive with a simple example. So previously we just saw the example where we had an example of the birthday surprises. So you can also go with the example where it will be more realistic as it will give some impact to it. So for example, the true positive. So in this case, we can take some real example where what the model that we are trying to build, what it does is based on the fire is there or not, it will try to raise an alarm. So in the first case, it's true positive. So in true positive, what will happen is you said you have to do the alarm and there is actually a fire. So there is actual fire and you try to do it. It is the right condition. So that is the true positive. Second is the false positive. In this case, you raise an alarm, but there is no fire. So in this case, what will happen when you raise the alarm? There is no fire, but still people are running. So that is not a good thing, and that is called the false positive. Third example is false negative. So false negative, if you're not raising an alarm even when there is a fire. This is the worst condition that we have in all the situations. So your aim is to raise an alarm when there is actual fire. But this condition says when there is still a fire, you're not raising any alarm. So this is the most harmful thing which can be there and where your model is not working. So you have to be very careful with this thing one. And true negative is something where there is no fire and you have not raised any alarm, which is still good. Okay. What is confusion matrix? So to explain this confusion matrix to your interview, you can take some simple examples such as you want to create a model where what you are trying to look is you have a bank and that bank wants to identify who are the customers I should be giving loan to so that they won't default me. So I have a training data where I know that okay, these are the customers who were good, who didn't default, and these are the customers to whom I gave loan but they defaulted. So that data is used in making these predictions, and you have a model which has done this also. So assume that we have 165 people in the training set, and after doing the prediction, so in the training set, what we have got is in actual 105 people can be given loan who didn't defaulted, and 60 people who bank gave loan they defaulted. So what your model is predicting in this case is it says 110 people can be given loan who will not default and 55 people can be rejected so as they are going to default. But this is on a higher level. But when you look as a confusion matrix, what will happen is you will try to see, okay, how my model is performing and where are the true positives, true negatives, and how should I take care, not take care, but how is it performing at the part of the false positive and the false negative. So assume we have a true positive. So in actual, there are 105 people who the bank's training data says can be given loan who didn't default. But out of that, model has identified 100 people, so which is a good thing. And for the no case, for the rejection case, out of 60 people, the model says 50, which is again a good thing. But your model says for 10 people who are actually defaulters, but model says you should give them loan. So those are the things which can be looked into the future. But confusion matrix will help you to understand how your model is performing based on the predicted, the model output and the actual data which you have. So what is the difference between inductive and deductive learning? So to help this concept, you can give some good examples such as a father want to explain his son how the fire can burn him. So there are two ways that he can teach his kid as how he can get impacted from the fire. So first thing is he will show him some examples, like he will show him some videos or he will show some demo as how the fire will get him burned. So based on the observations, the kid will learn and make some conclusions out of it. So that is the example for inductive learning, where he will do the observation and see how the things are going to be and make some conclusions out of it. And for the deductive learning, it is like father is letting the kid play with the fire. So the father will wait till kid will get burned and try to make some conclusions out of it and have the observations after it. Like he will get himself burned and then he will say that okay, fire makes us burn. So that is the deductive learning, where what happens is first you will make some conclusions and then you draw the observations. Similarly, in the field of machine learning, it is like out of the data you will try to do some observations, and these observations are stored as a model, which is like you have observed all the things and kept it as a model. And the deductive learning is like you are giving it a data, and based on the previous inductive learning that it has already done, it will try to deduce the output of it. So how is KNN different from k-means clustering? One important thing happens is people are really confused with what is KNN. Sometimes like is KNN clustering or is k-means a clustering? In this question, the clustering is given to you as k-means clustering, but sometimes the interview will just ask you how is KNN different from k-means. First thing you have to do is you have to understand the difference as k-means is a unsupervised technique algorithm and KNN is a supervised technique. In KNN is used as a supervised algorithm. KNN is used for classification and regression, and K-means is used for clustering. As it's a clustering algorithm, it is used to create the clusters of your data. K within KNN basically means it tries to observe the K neighbors. So in the case of regression, it will try to identify the surrounding K neighbors and take the average and give you the output. And in the case of classification, what it will do is it will try to see the surrounding neighbors, K neighbors, and whatever the majority of the class is there, it will assign the class to that. So in this case, K is your neighbors based on which your regression and classification will be done. In the case of K means, it is the K clusters that you're going to create out of your data. So K in the both cases is different and you have to give this differences to the interviewer. So one thing is once you know that okay, K means is an unsupervised and KNN is a supervised, you can further go on top of that. Okay. Can you explain me what is ROC curve and what does it represent? So in this case, interviewer is interested to know how good you understand the ROC curve and how you can use it to understand your model's output. So interviewer is very much interested as how you are trying to use this in your model performance. So as ROC is also one of the performance parameters for your model, and this is used in the cases of binary classification. The full form for the ROC is Receiver Operating Characteristics Curve, and its fundamental use started with the diagnostic test evaluations. So in the medical field, its application started and it is used in the machine learning field to do the classification related algorithms performance evaluation. So in simplistic term, it is the plot of true positive rates, which is also called as the sensitivity, against the false positive rate. So what happens is once you get the output in the probabilities, you can use the different cutoffs and you can use the cutoffs to distinguish as what is going to be the true cases and what is going to go for a false cases. And you can plot the ROC curve, and ROC curve says when your curve is having 1, your model is good. And the plot with the 50%, like 0.5, which is nothing but this blue line, which is the worst case. It's like your model is saying you have a 50% chance in the prediction. It's just saying it's just a normal guessing work. So you're either guessing 1 or 2 with a 50% probability. The more closer to this and more area this curve is trying to cover, the better is the algorithm. So better you're trying to predict the true positive rates than the false negative rates. Your true positive rates should increase faster than the false positive rates in this case. So first we saw like what actually ROC curve does, and we will see like how you can interpret it now. So you can give the interviewer some idea about what is really ROC curve, give some details about it, and you can give the technical details like how you can interpret it. So first of all, it is like trade-off. There is always a trade-off between sensitivity and specificity, and one will increase in one will create a decrease in another. So it is really important with the ROC curve, you will see these differences as how they are getting impacted. The closer the curve follows to the true positive rate line and the more area it covers, such as the yellow one, as it is covering the highest area, that is more better than the pink one. And pink one is more better than the blue one. The blue one is, as we already said, is like just a random guessing with a 50% of probability. And the slope of the tangent line at the cut points gives you the likelihood ratio as how likelihood your model is. What's the difference between type 1 and type 2 error? So this is one of the very important concepts which you interviewers trying to understand as how you try to distinguish between the type of errors, or do you understand as how this type 1 and type 2 errors are impacting the performance of your model. So interview is trying to understand those things, so you can give some good examples to say how these are going to impact. So first thing is type 1 error is false positives. So when something is not true, which in actuality is not true, but your model is saying it is true. So as we have the example, if a doctor says to a male person that he's pregnant, so it is like something is not true, but you are saying it is true. So which is the false positive and is an example for the type 1 error. And the type 2 is a false negative. So when something you are saying is not there, but in actuality is there. So when you're saying negative, so you are saying it is not there, but in actuality it is false. So that is the false positive. Similar example comes to where female is pregnant and the doctor says she is not pregnant. So this is like your model says something is not true, which is in the negative case, but in reality it is there. Is it better to have too many false positives or too many false negatives? This case really depends on the domain and the type of problem that you are solving. So based on the different problems and the different business requirements, you have to decide on what to have. So there is always a trade-off. You have to maintain the trade-off between these false positives and false negatives, and you have to decide which one we can keep as a more. As we already saw in the previous case, where you can imagine that where a doctor says a male person that he is a pregnant person. So these kind of model is always going to be a problem, and you have to decide like how many of these cases you can manage. So is it like out of 100, can you say that you can manage 10 false positives, or how many you can consider for those and you can move on with the model. So similarly, there is example wherein the spam filtering. So can you say a good mail as a spam or not? So that trade-off you have to manage, and based on that it will go. So this you have to define beforehand which one you can go on with, and you have to create a model as per that. So these kind of questions are mostly related with the domain specific questions. So you cannot just select any one of it and just give example. So beforehand, just try to understand what domain you're trying to explain, and before that try to first be clear with what is false positives and what is false negatives. After that, select some specific domains and give the examples. So for example, in the medical testing, negatives may provide a false reassuring messages to the patients and physicians that some disease is absent, but you're actually saying it is present. So what will happen in this case is you are trying to give inadequate treatments to both the patients and the disease, which is not required. And these things will cost patients to the medical and the medical agencies, and these kind of things has to be managed. So it is desirable to have many false positives in this case. The other example could be the spam filtering. So in this case, a false positive occurs when spam filtering is blocking or wrongly classifying the legitimate emails. So you can't have that as many times. So users will get irritated when your actual mails are getting into the spam. So in this case, we prefer to many false negatives over the many false positives. So based on the domain, it differs and you have to give the example specific to those domains. Okay. So which is more important to you, the model accuracy or the model performance? This question, the interview is trying to understand how better you know these terms. So do you really know the differences between these terms? So first thing, try to understand what these terms are. In actually, the model accuracy is part of model performance. It is subset of the model performance. There are different model performance measures and model accuracy is one of them. So for example, let's consider the case of fraud detection. So in this case, what will happen is you will have millions of rows, and within those only very less percentage of rows will have actual frauds. So in those cases, if you look for the model accuracy, your model accuracy will mostly be higher and it won't give you a complete picture of your model performance. So model accuracy is just a subset of the model performance, and there are more metrics that you have to look to understand the model performance. So now we are done with the core machine learning, so which were mostly related to the theoretical aspects of the machine learning. Now we will start with the Python related questions with the machine learning. As machine learning can be done with different languages like R, Python, SAS, but currently we are more focusing on the Python, and we will start with our practical questions which are there with the machine learning. So first question is, name a few libraries in Python used for data analysis and scientific computations. In this case, interview is trying to understand. So in the initial level, he will try to ask you these questions to gauge you if you really know about the core libraries which are used for the data analysis in the Python or not. So the core libraries which are there within Python are NumPy, SciPy, Pandas, and Scikit. So first of all, NumPy. NumPy is a numerical library to deal with the data. So as the name suggests, it's a numerical pie. So it tries to deal with the numbers. So all the core libraries such as the SciPy, Panda, Scikit uses NumPy to store the data. So those are the core storage format for all the data in data analysis. So SciPy, its full form is basically scientific Python. So it basically gives you a library to deal with all the different kind of mathematical functions. So you can do Fourier transforms for the audio related data. You can go with the optimizations. You can go with the interpolation. So these are just a few examples, but all the mathematical related tasks you can go with the SciPy, and SciPy uses, as we already discussed, in a core NumPy to store the data. So Pandas is a data analysis library again where you can store the data in a tabular manner, which is called as a data frames, and data frames are very powerful function within Pandas. So data frames gives you a data manipulation access. You can access the CSVs, you can load the databases, you can load the Excel files, and you can do your operations on top of it. You can do the aggregations, merging, and all those kind of analysis related to the data you can do with the Pandas. Scikit is purely a machine learning library. What it gives you is access to the different machine learning models you can use. So it contains a different components. It contains a pre-processing component where you can do the pre-processing of your data. It provides a library for that, and it also provides you a different modeling library where you can access all the core machine learning models. So on top of that, we have Matplotlib, which is a purely a data visualization tool. So with the Matplotlib, you can visualize your data in a very efficient manner and in a faster manner. And Seaborn is something which is built on top of Matplotlib and gives you a more better visualization of the data and gives you different new kinds of visualizations which are not there within the Matplotlib. So you just can give this detail to the interviewer, just list them all and give a bit of the description about each of them. So that would be enough in this case. Which library would you prefer for plotting in Python language? Seaborn or Matplotlib or Bouquet. So all these three have their own applications. So preference is something would come based on the thing that you are currently performing with the data analysis stage. So for example, when you're doing a quick analysis within your data, so you want to have a quick access to the charts, then you can use the Matplotlib. For example, Matplotlib provides you a quick access to the bar charts, pie charts, histogram, line charts, scatter plot. So for the quick analysis and your data exploration, you can go with the Matplotlib. Seaborn is something which is built on top of the Matplotlib. And you can use this when you want to do a bit in-depth analysis of your data. For example, when you want to have a statistical analysis within the data, and Seaborn gives you a bit more types of graphs which are not there within the Matplotlib. So for example, when you want to have a distribution charts with a more detail, so Seaborn provides you charts such as the violin plots, it gives you a KD plots. So for the detailed explanation of your data, you can go with the Seaborn. Bouquet is something which is an interactive visualization. Bouquet you go when you want to present your data to something of the outside world, when you want to publish it on a web and you want your user to interact with the data, then you use Bouquet. So when you go to the outside and you want to publish your visualization to the outside public, you use Bouquet for that purpose. So how are NumPy and SciPy related to each other? So this thing you can give a bit of detail as what is really NumPy first and what is really SciPy. And the thing is SciPy is a bigger library and NumPy is part of it. So NumPy is a smaller part of SciPy. NumPy helps you to define arrays and you can perform some operations on top of those arrays using the NumPy libraries. So different types of operations are like indexing, sorting. You can change the shape of it. You can change the matrices. You can create a splits within your data. You can merge different arrays together. So NumPy will help you with all those. SciPy, you can go to a next level when you using on top of those NumPy arrays when you want to create some mathematical formulation. You can go with the SciPy. So when you want to do the optimization, you want to do the Fourier transform. If you have audio data, for those kind of applications, you can go with the SciPy. So what is the main difference between a Panda series and a single column data frame in Python? So interviewer, he would like to really understand if you know the core concepts within the Python or not. And pandas is something which is the core of the data analysis, as all your data is stored within pandas and you're dealing with pandas most of the time. So in this case, interviewer will try to gauge you as you know the basic terms which are there within the pandas or not. So first thing, data frame is something which can store multiple columns, but a series cannot store multiple columns. So series is just a single column, but with the data frame, even if it's a single column, you can go with the multiple columns, you can add the columns to it. And there are some limited functions which are there with the series, and data frame has additional functions on top of series. So for example, LOC is a function which is there on top of this. So data frame is the upper level layer on top of series and gives you more control to the data. But the basic difference is with the series, you just have a single column, but with the data frame, you still can add more columns to the data. How can you handle duplicate values in data set for a variable in Python? So in this case, you may have to write a code and show to the interviewer that how you can really achieve this thing. So you can just import the pandas library, show that you are just reading a random file using the pd.read_csv, and you use the build data frame.duplicated to get the list of all the duplicate values which are there within the data, and just show that you can also drop those columns if sometimes we want to drop those. They are by some mistake created by the collector. So the duplicate values can be removed using the drop_duplicate columns. So these two functions you can try to show and explain them what they do. That would help you in that. Write a basic machine learning program to check the accuracy of the data set, importing any data set using any classifier. So in this case, you're not limited with what data set you're loading, what data classifier. The important thing which you have to show is how you are loading your performance parameters, and things that the interviewer will gauge is how you are trying to use the performance metrics. Are you trying to use it on the test set or the training set? Or you're trying to use it on the trained data or just the test data? So you have to be very sure, as you don't have the computer to do the output, you just want to write it. So you have to be sure that you are using a test set to show the accuracy parameter. and you have to use both training Y and test Y in this case. So you have to start with the complete program. You have to show all the steps which are involved within the accuracy part. So you have to start importing your data. Just take some random data. You can just show that you are reading some data and try to separate your data into the X and Y, the target data and the predictor data, and try to create a split within the data of train and test validations. You can use whatever ratio you want to use. You can use 80%, 70%, 50% as you like, but you need to give some justification to that also if your interviewer asks for it. Once we have split our data into train and test set, the next task is to use the classifiers to train the data and create a model out of it. So you can use any classifiers here, but choose something which you already know better, because interviewer will ask you whatever model you're going to use in the next step. So you have to be sure whatever you're using, you know it better. So once you have created an instance, you can use it to fit it on the training data. So use the X train data and the Y train data, create a model. Once you have done that, you use it to make predictions on top of the test data. So you use the X test and create a predictions out of it. And accuracy tries to compare your data, like your original data and whatever predictions you have done, and give you a score out of it. So you will load the metric accuracy score from the sklearn metrics. Once you have done that, you use the print to use the accuracy score, and accuracy score will take two parameters. One is the original matrix, which is the y-test, comma, the predictions which you have currently made. So once you get that, it will create an accuracy measure for that. So accuracy will be nothing but the true positive plus true negative upon the all data. So it will calculate that and give you. The interviewer in next step may ask you like, how can you improve the accuracy score? So once you put the accuracy score, the next thing the interviewer may ask you is, how can you improve the accuracy score? So you can go for three simple steps where you can try to increase the accuracy of your model. First simple step would be try to see if you can make some tweaking into your probability cutoff. So the default probability cutoff is 50%. So the ones which are above the 50% is tagged as 1, and the ones below the 50% probabilities are tagged as 0. So if you are changing it to something like 0.8 and then checking the accuracy, if it makes changes to your model, it is still good. If it doesn't, the next step would be try to see if you can find out some better features using some feature importance algorithms, such as random forest, and different tree models are available which will give you the better features as per the target. So you can use those features and train a model so that you will have your accuracy increased. And next step would be create some new features and see if your model makes any improvement in your accuracy. You can make some new features or you can add some more data so that it will help your model to generalize better. For this part, we have completed with the Python related interview questions of the machine learning. So this was more of a technical part of it where we saw how we can code, how we can show the interviewer that interview is more interested to see how you can code the things and how confident you are with those things. Okay, so now we are done with that. We will now move on to the scenario based questions, where we will see some puzzle kind of things, and the other are real problems where the interview is related to understand as how you try to solve those problems. Let's start with those. So you are given a data set consisting of variables having more than 30% of missing values. Let's say out of 50 variables, 8 variables have missing values higher than 30%. How will you deal with them? So missing values could be of any reasons. So something like it's your data got corrupted while storing and you got a missing data. The person who collected the data may have done some mistakes and that data is treated as a missing data. Or it could be like there is nothing for those kind of values. So it's like it is supposed to be blank and it's supposed to be missing. So there are different conditions for those. So let's see how we can try to handle those things. First, we can create a new feature which will say, okay, this much of the part is non-missing and this much of the part is missing. So we can assign it 1 and 0. We can create a new binary variable. It's possible that this thing is trying to give you some idea about the data, and there will be some hidden pattern within your data because of this some missing values. So it's possible that creating this new feature will help your model to give the better accuracy and give the better performance. Second thing, we can remove that completely. If you have a high count of data, so for example, if you have a very good amount of data and you can say that, okay, I can leave with removing this 30% of the data, then you can blindly remove this. If it is not giving any value to you and you can't spend much time on trying to improve it or trying to impute it, then you can blindly remove it. Or you can check the distribution. So for example, there are different ways to check how your missing values are to the similar cluster. So some examples are, you can see your missing values are clustered on some other values. So can we give those cluster values to those missing values? So it's like identifying clusters, and based on those clusters, we give values to the missing data. Or the second thing is we use the distribution. So if they are continuous in nature, we can use the distribution to assign some data to them. So write an SQL query that makes recommendations using pages that your friends like. So assume you have two tables. First table is a column table of users and their friends. Second table is a two column table of users and the pages they like. It should not recommend pages you already like. So why would interviewer ask an SQL question in this case? So it is like he's trying to understand how better you know the recommendation engines from the database point of view. So it is like he's trying to understand your knowledge in a different term. So first thing, you have these two tables. So first table is including, you can assume, you have to make some assumptions and draw the picture of this two tables first. So first table will include a user ID and a friend ID. Second table will include a user ID, the page ID they have liked. And then once you have this structure of these two tables ready, the next step is to merge them together based on the friends. So as we are interested to know as which friends are liking which pages, and based on that we want to recommend it to the original user. So first thing is we have to combine these two tables using a unique key, which is the friends ID. So we join these two in the SQL using the friends ID. That is one condition. Second condition says it should not recommend pages you already like. So what you do, you have to have a way where you can exclude the pages which were already liked by that user. So this can be done by an inner query, which you can use here to select the pages which that user has already selected. And in the where condition, you can say the page should not include this. So if you look at the whole query again, we are first selecting the first table user ID, the friends table user ID, and the likes table page ID from friends F join like L. So we are trying to join them together on friend ID and the user ID. Second is, as we mentioned, that was the first thing. And the second thing is we try to remove the recommendations, the pages which he has already liked. So which we'll do by page ID, not in the pages which he has already liked. So this is the condition which is trying to do this. And this is how you can explain this thing to the interviewer. So there is a game where you are asked to roll two fair six-sided dice. If the sum of the values on the dice equals 7, then you win $21. However, you must pay $5 to play each time you roll both dice. Do you play this game? And in follow-up, what is the probability of making money from this game if you're playing it for 6 times? So the first condition says if the sum of the values on the dice equals 7, then you win $21. But for all other cases, you have to pay $5. So in this case, if we first assume all the possible cases, as we have fair six-sided dice and we have two of them. So there is 6 multiplied by 6. We have 36 different cases. And out of it, having two dices equal to 7 is like we have 1 and 6, we have 2 and 5, we have 3 and 4, we have 4 and 3, we have 5 and 2, and we have 1 and 6 again. So those are nothing but 6 possible chances are there out of 36. If we take a ratio, 6 by 36 will give us 1 by 6 ratio. So this says we have a chance of winning $21 1 in 6 games. So assume that we are playing 6 games and out of it we win 1 game of $21 and 5 games we lose. So in this case for 5 games we have to pay $5 and this will be $25 and we are winning one time, which is $21. In this case, if you see, there is a loss. So we are paying $25 and we are winning $21 in this case. So for the first question, do you play this game? This is no, as we are getting a loss as per the probability. The second question says, what is the probability of making money from this game when you are playing it for 6 times? If you assume in this case, we are making 6 games And out of that, the winning probability, if we just have a win in one case, it be a loss. If we win 2 games out of 6, we are going to win. If we win 3 games, it will be profitable again. So 2, 3, 4, 5, 6 are the cases where we will see a profit. So this case can be simulated with the binomial distribution. So binomial distribution takes 3 parameters. First is your probability of winning and losing. So that is in our case nothing but 1 by 6. The second is the number of plays, which is 6. And the third is the number of cases that we want to identify. So for example, in our case, we want to have a condition where the number of wins is greater than 2. So we want to identify. The first case is a failure where in the first case we are always losing. But in the second, if we win 2, 3, 4, 5, 6 times, we will always be winning. We will have a extra money. We have to find a probability where we will have more than 2 wins. So that can be simulated with the probability to get the answer for the second question. So the next question, we have 2 options for serving ads with newsfeed. So first is out of every 25 stories, one will be an ad. Second is every story has a 4% chance of being an ad. The question says for each option, what is the expected number of ads shown in 100 news stories? If we go with the option 2, what is the chance a user will be shown only a single ad in 100 stories? What about no ads at all? So in this question, if we look at the first part, which says for each option, what is the expected number of ads shown in 100 news stories? So let's check it for the first one. So for the first one, out of every 25 stories, one will be an ad. So this is like 1 out of 25. In the second case, every story has 4% chance of being an ad. So this is like 4 out of 100, and which is again nothing but when we divide 4 by 100, we will have 1 by 25. So for the first question, the answer is both are similar. So both the cases have expected number of ads in 100 similar, which is 1 by 25 or 4%. Both are equivalent to each other. For the second question, you have to see is the question asks what is the chance a user will be shown only a single ad in 100 stories. If you see this question, it is an example of binomial distribution. So as we just saw in the question 3, binomial distribution takes 3 parameters. First is the probability of success and failure, which is in our case is 4%. Second is the number of total cases, which as the question says 100 stories. Last is the case that we want to identify, means probability that we want to find out. So the question says, what is the chance a user will be shown only a single ad in 100 stories? So we want to have the 3 parameters as 4%, 100 stories as our n, and single ad as our probability chance. So if you see, the probability can be calculated as 0.96 is basically not getting selected, which is 1 minus 0.96 raised to 99. So 99 cases are not going to selected. Multiply the chance of selecting, which is 0.04 raised to 1. So we are calculating a probability of not getting selected of 99 samples and getting selected of 1 sample. So this is the binomial distribution for selecting one ad out of 100 stories. The second question just says what is the probability of no ad at all. So in that case 0 and 99 would become 100. So 100 multiplied by probability of one case. So it will become 7.03%. The only thing is you have to identify like which distribution is highlighted from your question. So sometimes you will see that normal distribution kind of questions will be there where you have mean, standard deviation, and based on that you have to identify different things. In this case it was binomial, so based on the parameters which are there in your question, you have to identify which distribution you can use for that and try to solve it. How would you predict who will renew their subscription next month? What data would you need to solve this? What analysis would you do? Would you build predictive models? If so, which algorithms? This question is very generic, and interviewer is really trying to understand how you try to approach your problem. So when you are given a problem, how you try to identify different components which are there within your problem, how you try to solve each of those confidently, as how much of your knowledge is there within each of it. So what you have to do is, let's assume something as first thing, how would you predict who will renew the subscription next month? Let's assume we are trying to predict the subscription for Dish TV subscription. So who is going to renew the subscription next month for the Dish TV? So that is the problem statement first. We define it. What data would you need to solve this? So in the case of Dish TV subscription, we would like to identify how many number of hours for that household the channels are active, how many number of kids are there in the home, how many number of adults are there in the home, which are the different channels they use, for how much time, and from previous month, how much increase or decrease has happened in this month. So this all variables would help you to understand if in the next month again that customer is going to buy or not. So if there are kids in the home, there are chances that because of kids, whenever there are kids, they will look for the TV, and kids will always help you in understanding if there will be subscription or not. And if the subscription has either increased or decreased from the previous month, will also help you to understand if that user usage has increased or decreased. So that will help you to understand the trend and make your prediction better. So what analysis would you do? So we would like to do the classification analysis in this case. We want to identify, okay, this customer is going to subscribe next month, this customer is not going to subscribe. So this is a pure classification related problem. Would you build predictive models? Yes. So for the classification related problem, we would like to build a predictive model. So we would already have a historical data. We will gather the data which is already existing and use that to train our model. So we can use any algorithm. So we can use any classification related algorithms in this case. So we can use random forest, we can use logistic regression, we can use neural networks, whichever. We can try different models and see which one performs better, and based on that we can continue with the model which performs better and tune it further. So you have to start with the step by step and show that, okay, this is the next step, this is the next step, till the end of your model. So even in this case, if so, which algorithm would not end the problem? Algorithm you have selected, after that you have to validate your algorithm. It will even go that in production, and within production you will also validate again and see in real life how it's working, make again changes to the model. So those things may change again as the interviewer may keep on asking you the further things, and you have to be ready for those things. Interviewer may start with few questions, but as you keep on solving the problem, interviewer would keep on digging further as what would you do next. So you have to be ready for all those things. So be prepared for those things. How do you map nicknames Pete, Andy, Nick, Rob, etc. to real names? So this is like understanding how you try to solve a problem where there is not much of data is there. So this example is just you have just a nicknames and you want to identify the real names to them. So this can have different answers. It is not related to a single answer and there is no generic fixed answer. But interview would be interested to know as how you are trying to approach the problem and solve it. So few things could be like, as you don't have any data, first you try to gather as to which components these things are related. So for example, if you are trying to understand these nicknames from a Twitter tweets, try to see who is trying to refer to who, and based on these nicknames, see the relation as which person is trying to talk with which person, and you can try to identify based on the NLP algorithms as what is the real names for those people. So similarly, you can try to identify in the Facebook, or if you have some customer feedbacks and within those customer feedbacks you want to understand this, you can do it that way. But this would be more like you have to understand in the context. So in which context people are talking to whom, and based on that, you can try to identify the real names. So this is just a one example, but it is not related to just single one. You can create your own, as I said, there is no single answer to this problem, but it mostly depends on how you are trying to approach that problem and solve it. A jar has 1,000 coins, of which 999 are fair and one is double-headed. Pick a coin at random and toss it 10 times. Given that you see 10 heads, what is the probability that the next toss of that coin is also a head? So let's first try to split the problem statement that we have. So the different components are, we have 1000 coins, of which 999 are fair. So for the fair case, we can say that, okay, there is 0.5% probability that it could be head or it could be tail. And one is double headed. So it is not having probability and it is just 100% probability that it's a head. We pick a coin at random out of this 1000 and toss it 10 times. So each time we select a coin, we toss it. We select a coin, we toss it. So we try to do it 10 times. Given that you see 10 heads, what is the probability that the next toss of that coin is also a head? So let's see what we can do in this case. So basically we have two types of coin which can be chosen in a two different ways basically, and there are probabilities associated with each and they are different. So for the first type of coin, which is fair, we have 999 out of 1000, so which is 0.999. And the chances of selecting the second coin, which is unfair in nature, is 1 out of 1000. So these are the probabilities that we have got first. Now, as the question says, we have already chosen 10 heads. We have already done some experiment and we have got 10 heads. So what is the probability of selecting those? So selecting 10 heads in a row is equal to the chances of selecting fair coin multiplied by getting 10 heads plus selecting an unfair coin. So if we see that, first thing is selecting 10 coins from the 999 fair coins is, we have the probability 0.999 multiplied by the fairness is basically probability 0.5 raised to 10, which will give us 0.999 multiplied by 1 by 1024. So when we multiply this, we will get a chance of selecting coin A, which is nothing but selecting the 10 coins from the fair coins. The second part is the probability of selecting the second coin, unfair coin, multiplied by 1, which is basically everything is head there, as we don't have anything, everything is head, so it is 1. So probability of here is 0.001. Probability of A says selecting the 10 coins from the fair coins. Probability of B says selecting the 10 coins from the double headed ones. Now the second question says, given probability of fair coins, what is the chance of selecting the coin from that? It is like a conditional probability, and in this conditional probability, what we are doing is we are dividing the probability of A given probability of A and B. So given both of them, what is the probability of selecting the coins from the fair coins? This is the probability. And the second part basically says, given double-headed sided coins, what is the probability of selecting from that? So these are the two individual cases. Once we have got that, we have to create a combined probability which will include the chances of selecting the coin from the fair coins multiplied by 0.5 plus the chances of selecting the coin given it is the double headed multiplied by 1, and this would create a combined probability and give you the output as 0.7531. So for this case, we have to go step by step, divide the problem into smaller parts and get to the answer of it. Suppose you are given a data set which has missing values spread along one standard deviation from the median. What percentage of data would remain unaffected and why? In this case, there is not much details about how is the distribution of data. It is just said that there is a one standard deviation from the mean which is missing data. So we have to make some assumptions. So as most of the data follows a normal distribution, we would assume that this data is also following a normal distribution. And we would say that, okay, a normal distribution has within one standard deviation a 68% of the values. So as per the normal distribution, within one standard deviation, around the mean, median and mode, as for the normal distribution, all are equal. All mean, median, mode are at the same location. And from the mean, around one standard deviation, we would have 68% of the values. And as the question says, missing values are spread along one standard deviation. So 68% of the values are basically missing, and question asks what percentage of data would remain unaffected and why. So everything left after the 68% would remain unaffected. So we would say 100 minus 68, that would be 32. So 32% of the values would remain unaffected by missing values. You are given a cancer detection data set. Let's suppose when you build a classification model, you achieved an accuracy of 96%. Why shouldn't you be happy with your model performance? What can you do about it? So first thing is, as this thing is mostly related to the domain of cancer detection, uh, interview is trying to gauge you as how better you know as so how the accuracy of the models works in a different data distributions. So if we look at the cancer detection domain, in the cancer detection domain, very few of your data points would have actual cancer. So for example, if you have a 1 million patients data, out of that you would have like around 1000 of them would be having cancer. So it's like a very small set of data is having actual cancer. So let's assume we are creating a confusion matrix. So when we create a confusion matrix, we see that in the true positive, which is just 1000 values. So even if our model tries to identify like 500 of them, so we'll get in the true positive 500. And let's assume in the true negative, we are getting all the negative values, which is 1 million minus 500, which went into the positives, and everything remaining will go into negative. So if you create the accuracy, it is like 500 divided by whatever is there in the remaining parts. So 500 is what you got a true positive values, and something you will get in the true negative. And when you divide it, you will have a bigger accuracy. So your model give like 98%, 96%. As your true positive is actually very small, your true negative would be very large, and small components will be there in the false positive and false negative. So when you try to divide them, you will have a bigger accuracy always. So accuracy is not used in those cases where your distribution of positive cases is very less. So in this case, accuracy won't be helpful for us to evaluate the performance of our model. So we have to go with other performance metrics which are available. So for example, we have recall, we have precision. Recall is again called as the sensitivity. Again, we have another as the specificity and F1 score. So this different performance metrics will try to identify the model performance based on different components. So accuracy is mostly useful when you have the classes which have some similar count. When you have some similar count but not very smaller classes, then your accuracy will be helpful. But when you have very small positive class, such as the cancer detection or the anomaly detection, so again anomaly detection is a similar case where fraud detection basically. So fraud detection is again a case of this case where we have very small number of values. So we can't use accuracy in that case and we have to use the different performance metrics. You are working on a time series dataset. Your manager has asked you to build a high accuracy model. You start with the decision tree algorithm since you know it works fairly well on all kinds of data. Later you tried a time series regression model and got higher accuracies on the decision tree model. Can this happen? Why? So first thing, as it is a time series data are mostly linear in nature. So as the next value would be related with the previous value. So let's assume we want to look at the stock prices. So stock prices which are today are related with the yesterday. So whatever value was there yesterday, it is the either higher or lower as compared to what was there in the yesterday. So as compared to this, what decision models would do, decision models would just try to identify some rules within your data. So they would just do some rules which is very non-linear in nature. If there is actually some proper patterns within rule, the decision tree would really helpful. But what the time series related regression should do it, they would try to regress it based on the historic value. As they are linearly correlated with the previous values, the time series regressions would work by regressing it on the historic values. So that's why time series regressions would be more accurate than the decision trees because we have a linearity available within the time series data. Suppose you found that your model is suffering from low bias and high variance. Which algorithm you think could tackle this situation and why? So first thing, so low bias and high variance. So bias and variance are the term mostly used when, so bias basically means you're getting bias to a specific set. So when you have a higher bias, your model is getting underfit. It's not preferring anything and it's just underfitting your data. And high variance is something where your model is very much overfitting to your data. So in our case, it says there is low bias and there is a high variance. So our model is doing a overfit. So first thing is we can use some kind of bagging algorithms. So what these bagging algorithms do is they try to divide your data into multiple samples. So those are samples with the replacement, and each sample is trained with a decision tree. So now what happens? We are creating multiple trees which are trying to understand different patterns within the data set. Whatever data you are feeding, whichever sample you are feeding, whatever the patterns available within that sample, each model is learning those things. So now you have a weak learners, and when you combine those weak learners, you create a strong learner which will also try to reduce your overfitting. And how it reduces the overfitting is as you're creating more and more models, if some of them is trying to overfit, the others will try to help to get balanced variance in this case. The other technique that we have is we can use the regularization technique. So regularization, there are two types of regularization. There is L1 regularization and there is L2 regularization. Those techniques we can use to penalize the model. So what happens? Those try to penalize whenever your model goes for a higher variance, it tries to penalize it by some parameters that we provided. So based on those parameters, it tries to restrict your model for going beyond the limited threshold of the overfitting. So the regularization is the second technique. And third is we can use the feature importance. So we can use the different tree based techniques, like we can use the random forest like feature importance techniques to select top features, and we can use those to create a model so that our model will try to fit with those important features. So when we try to add all the features, some features may make our model very much overfitted, and when we have a newer data, it may not generalize well. So when we try to identify which are the important features, then our model will try to generalize well to the actual patterns which are there within the data. So it's always better to go with feature importance, try to select the features which are important, then create our model on top of it. So these are the three techniques that we can use to reduce the variance. You are given a dataset. The dataset contains many variables, some of which are highly correlated and you know about it. Your manager has asked you to run PCA. Would you remove correlated variable first and why? So most of the people would say that, okay, PCA we are using to reduce the multicollinearity. So removing the collinear variables, we won't use the PCA. But what happens is we are with the PCA, we are not just interested with the multicollinearity of the variables. Sometimes we are also interested with the variance which is available within the data. So what happens is PCA tries to explain a complete variance available within your data. So variance is something which says like the distributions within your data. So once you know that, PC also gives you the eigenvector through this variance, and you can use this variance to reduce the features which are available to you even when there is no multicollinearity. Even if you have some thousand features, there is no collinearity within the variables. When you use the PCA, still in this case also, you will be able to reduce the size of your features to a lesser number. So PCA doesn't just has to be with the correlated variables. We can use it also just to reduce the columns length using the variances which are explained in the model. So you're asked to build a multiple regression model, but your model R square isn't as good as you wanted. For improvement, you remove the intercept term. Now your model R square becomes 0.8 from 0.3. Is it possible and how? So first thing, what is R square? So R square says how your linear regression model, how much of the variance out of the data it's trying to explain. So your data contains a variance and what percentage of variance your model is trying to explain. The more the variance it is trying to explain, the better is your model trying to represent your data. So the formula if we see for the R square is R square is equal to 1 minus summation of y minus y hat, which is the predicted values, square upon y minus y mean square. So intercept basically refers to the y mean. So in actual, the intercepts are representing the y mean and they're helping the model to maintain based on the y mean. So in the presence of it, we are creating a R square, which is something different. And when we are removing the y mean, so when we are removing the intercept, we are removing the y mean. In our case, as a denominator becomes small, our R square would become big. So as we remove the y main, our denominator would become small, and as we are dividing by that, our r square would become big. But one thing that you have to be very sure in this case is this: both the models are different. You cannot compare the model without the intercept and the model with the intercept. So both the models are different, and you have to tune them separately and you have to measure them separately. They cannot be compared, as the one with the intercept and without the intercept are completely different in nature. You are asked to build a random forest model with 10,000 trees. So during its training, you got training error as 0.0, but on testing, the validation error was 34.23. What is going on in this case? Haven't you trained your model perfectly? So this was very good. That right, got a 0.00, like 100% accuracy with the training data. But when we try on the validation data set, we say that there is an error of 34.23 of some metric. What this case basically says is you are getting very much good performance on the training data, but when you check it on the unseen data, this unseen data is showing some different performance. So this is a pure example of complete overfitting. So what you are doing is your model is trying to mimic actual data within the training set. It's just learning every pattern, every corner of your data, and it's trying to make actual and accurate predictions out of it. But when we go for a newer data, as it has got very much mimicking the training data, so newer data may get the outer bounds and may not get a better prediction. So we have to reduce the overfitting and try to make a model generalize. So we can use the things that we have discussed earlier to reduce the overfitting within the data. So we can use different techniques that we've already discussed, such as we can provide more data or we can reduce the number of trees which are there. So as we are using more and more trees, our model is getting overfitted to the data. So in our case, we have to use the lesser number of trees and see if our model gets generalized or not. So people who brought this also brought recommendations seen on Amazon is based on which algorithm. So we have all seen on Amazon that when we are looking at some product, we get that, okay, people have also brought this kind of product. What basically this means is, whatever you are currently looking, people who have brought that product or who have already viewed that product have also looked at the different products. So based on those, you are getting recommendations. So there are two types of recommendation systems. First is the collaborative filtering and second is the content-based filtering. In content-based filtering, what happens is whatever you have rated previously, so based on that, you will get a future recommendation. So for example, let's take an example of Netflix. In Netflix, you have watched some genre movie. You have watched romantic movie for 2 to 3 times and you have given a better rating. So what Netflix would do, based on whatever you have done, whatever the content we have viewed earlier, it will create a new recommendation for you. So based on whatever you have done previously, you will get a newer recommendations. So that is the content-based recommendation. What we are seeing currently for this example, it is collaborative filtering. In collaborative filtering, what happens is whatever you are doing or whatever you have done previously, based on that, you will be checked with the other users who have done similar activity, and it will also check what are all different activities they have done and you have not done that. It will try to recommend those things to you. So if you see the example which is here, it says that the user who's on bicycle has brought pizza and pasta. Similarly, he is trying to be compared with the user who has done similar activity. So in our case, there is this user who has brought pizza, pasta plus a Coke. So as this user has not brought Coke, he will be recommended this Coke. So this is the core of collaborative filtering. So this is the technique which all the major e-commerce related companies use to recommend products to the users. So even Netflix is just uses the content-based filtering for recommending the products based on the history that he have done. But also he'll be recommended based on the collaborative filtering as what all other users have done similarly and what they have done as additional things. So that's how the recommendation systems works. Just to summarize what we have done today, so basically we have started with the three components, three types of interview questions. We started with the core machine learning components, which involved more of a theoretical components in the machine learning. The second was we looked into the Python related questions on machine learning. We saw some practical aspects. What are the different components within Python? How we can write some Python code. How interviewer will try to gauge you. How you can write the code and those things. And the last part was scenario-based questions. So in that case, we were trying to understand how, based on the scenario which is given, how would we choose different models? How would we do the machine learning related tasks based on the scenario which is available to us?
And with this, we have come to an end to this full course on MLOps. If you enjoyed listening to this full course, please be kind enough to like it, and you can comment on any of your doubts and queries. We will reply to them at the earliest. And do look up for more videos and playlists, and subscribe to Edureka's YouTube channel to learn more. Thank you for watching and happy learning.